Okay, so I should be live on YouTube. We're going to start now. All
Yes, sir.
right. You guys share up the YouTube to everybody. The YouTube
Sir.
live. All right. Yeah. I'll do that from now.
Sharing it dinner, sir.
TikTok move stupid boy. You know the ban man until June the 3rd.
Serious?
No going on with TikTok boy. Yeah, boy, TikTok real playing up. I make a TikTok video.
Wait, you do a little compilation, sir.
So again.
You do a little compilation of past papers.
Yeah, so we're just gonna go till 2014 if we could. I believe it's possible. That's completely reasonable. You just repeat, so we can do that. That's not a problem.
And June, sir?
Nah, just June.
Nah,
okay.
it's June. I think June should have you for me.
Yeah, June should be fine. Alright, let me record this video quickly. You people on TikTok, I'm live on YouTube. I'll be going for around 10 hours. CSEC Physics, paper 1. Right? Go on YouTube, look up Math Vibes. Math Vibes. I'm live till like 1 a.m. or 12 p.m. at night. So go check that out. I'll can answer the first question in the meantime. That's just a maths question.
Yeah.
It's just be
3.14.
No, it's just
Oh,
be
wait, they say two significant figures.
3.1.
Yeah.
it's supposed to be
A question like this come where they ask you for 3, so I just thought it was the other one. But yeah, 2 is 3.1.
I feel I know why you put 3.14 now. Because you went after the point. You're supposed to count the one before.
Yeah. But it had a question like just like this, and they had asked you for decimal places.
I just posting this thing fast on TikTok. You see, TikTok is more up and my friend at the same time, you know. I don't know what to say about TikTok, no? All right, guys, let's go. So we have 3.141, whatever, expressed as two significant figures is. Okay, so where's the first significant figure? And by the way, we're starting off with May, June 2023. If you want to see 2025 and 2024, I posted that video on my YouTube channel. Just go look for it at the right day. Just go on live, you will see it. So what's the first significant figure here?
3.
3. What's the second significant figure?
1.
1. Number after 1 is
4.
4. 4 is less than 5. So we'll just say the answer is, what will the answer be?
3.1.
3.1. Everybody okay with that?
Yes, sir.
Badness.
Yes, sir.
Okay, and by the way, guys, I'll go share the live on the vibes, the physics vibes group chat.
Yes, sir.
Right. Right. An example of a vector quantity. So if you didn't know, a vector quantity it has a size and it has a direction. So resistance, no. Heat capacity, no. Density, no. Displacement, does I repeat? And if you're confused about that, let me give you a little example, right? Imagine I had this box here. That's not really a box, but imagine I had this box here. Let's just say this is the original position. If this is the original position, I could call this 0. And I could take the box and I could move it to this position. Wouldn't I have displaced it?
Yes,
Yes,
sir.
sir.
Since I displace it to the right, I could say it's positive 5. If I were to displace it to the left, I could say what?
Negative.
Negative 5. Good. So displacement has a size and a direction. So I hope you're okay with that one. So the answer is 2C. All right. This is a repeat as well. Which of the following is most suitable for measuring the diameter of a human hair? What's the
Micrometer,
answer?
screw gauge.
Screw gauge, sir.
Yeah, boy, the screw gauge.
Yeah.
Badness. Okay. So, Kelani, get this one I read from her.
All right, so item 4 refers to the following diagram, which shows two forces, X and Y, applied onto an object. So, what should be the magnitude and direction of a third force, which will cause the object to remain stationary? So, when they want the object to remain stationary, it means that you don't want the object to move away from where it originally is, right? You want the object to just stay in one position. So we need a force that will compensate to keep the object in one place. So you have X and Y going to the right. So in order to keep the object stationary, you would need the same force on the left. So I would choose B for this one.
That's a good explanation. So, if you have two forces pushing this to the right, you want the same forces in the other direction to counteract. So, it will be X plus Y. It will be X plus Y to the left. You said B, right?
So
Okay, good. Where was the girl that said physics was hard? Talk to me. Who was that again? Who was that that said physics hard? Or some girl was saying physics hard.
oh, I think you see it in the comment section.
No. No. Like when I was starting this live, somebody said, I have until today to tomorrow evening to show that physics not hard.
Oh,
Oh.
so that's me.
All right. So Mia, if you want this object to remain stationary, okay, if something's stationary, do you think any forces are acting on it?
No.
No,
Yeah.
like no, like okay, this stationary, right? Am I pushing it, or is it just here?
It's just there.
Okay, good. So here what? And I have another question for you, right? And you know about tug of war?
Sorry?
You know about tug of war, right? Tug of war.
Yeah.
Let me know if you know about tug of war. Okay. If both parties have the same strength and both of them pulling, will they move?
No.
No, so it's the same concept over here. We have this block over here. You have two forces pushing this to the right. So if you want it to stay there, you need a force to counteract this force to the right.
Yes, sir.
So I would want the same forces just pushing in one direction.
Was it?
To the left, right? To the left. So that's why I say an X plus Y to the left. Hope you understand that. Do you understand that or not?
Yes, sir.
Okay. Which of the following is a derived unit? Okay, a derived unit is just a unit you get from a formula. This is temperature in Kelvin. That is a fundamental unit. This represents time, fundamental unit as well. And this represents mass, fundamental unit as well. However, this is a unit for what? Anybody could tell me? It's in meter cube. What's that?
Volume, sir.
Volume.
That's volume. So remember, volume is just side by side by side. So isn't that a derived unit because of a meter by meter by meter?
Yes, sir.
Yes, sir.
Yeah.
Yes,
So this is a derived unit.
So basically,
Anything?
sir,
Yeah, talk to me.
a derived unit is a combination of base of fundamental quantities.
Correct. That's it. That's it. I don't like I'm ranting, you know. I'm feeling lonely here, boy. Way. Just me
Yes,
here.
sir.
Sir, not too long reach home.
Shania, I see you teaching people how to play badminton. Big up yourself.
Yes, sir.
Right? A block is allowed to fall freely towards the ground. As it falls, I repeat. What's the answer? Its gravitational potential energy gets converted to what? It starts to move.
Kinetic.
Kinetic.
Right. So Mia, don't you know on Earth we have gravity?
Yes, sir.
Right. And gravity would want to pull you downwards. That makes sense?
Yes, sir.
So anytime you place an object some height from the ground, you increase its gravitational potential energy. Because if I tilt this over, the gravity is going to cause it to accelerate downwards. Okay?
Yes, yes.
Now, gravitational potential energy is the energy something possesses by virtue of its position with respect to the ground. But if something is moving, it has kinetic energy. Kinetic energy is the energy a body possesses because it's moving. So here what? If you tip this ball over, what will happen to it? It will start what? Come on, Mia. It will start to
Falling.
what? It will start to fall, right? And if it's falling, it's what? It starts with M. What is it doing? If it's falling, what's happening to it? If it's falling.
In motion?
Motion, it's in motion. So it has kinetic energy. Right? Kinetic energy is just the energy an object possesses because it's moving, it's in motion. Right? Hope you understand that. Everybody okay with that, right? 6D.
Yes,
So,
sir.
Alright, cool. Let's move on. What is the reading shown on the thermometer? Alright. So Nikolai, help me with this one. Nikolai, how much spaces we have here?
5 spaces, sir.
We have 5 spaces, and that going from 80 to 90. What's the difference from 80 to 90?
Well, 2. Well, 10, basically.
10. So if five if five increments is equal to 10, what do you think one increment would be?
2.
Correct. One increment would be 2. So Nikolai, let me count, right? 82.
84, 86, and 88.
Ah, where's
yeah,
the answer?
yeah. Yeah, says it.
Mia, you see how easy? Mia, you can't tell me this hard. What do you think? You think this hard or this easy?
Easy.
So I say, right? Okay, we should be okay with that. Which of the following is the unit for momentum? If you guys forgot, momentum is just mass times velocity, right? P is equal to mv.
Yes, sir.
What do we measure mass in?
kg,
Kilograms. Well, kg.
Right.
Program.
And what do we measure velocity in?
meters per second.
Ms minus 1, right?
B.
So what looks like the unit? B,
B.
right?
B, sir.
So anytime you forget the units, just remember the formula. So momentum P is equal to mass times velocity. We measure mass in kg, and we measure velocity in ms minus 1. So kg ms minus 1. Hope you're okay with that. Right? Give me a second. Hey guys. I did the solutions for and
In the meantime, though, the people on YouTube, you know what to do? Like, subscribe.
that is it. That is what it's supposed to do, right? All right.
What Shania said. You don't know.
All right. The kinetic energy of a body of mass m and velocity. This is easy, right? What's the formula for kinetic energy?
mv squared
A
over
half
2.
mv squared.
A half
So
mv squared,
that'll be
which
D.
is just mv squared on 2. That's D.
Is it me or sir sticking very much?
Yeah, again, it's on my
I
side too.
second, let's see.
Yeah,
So,
you're sticking
Yes,
to
you.
that too.
Man. That's weird. Give me a second. Why the internet moving so, buddy? Give me a second.
yes, sir.
My internet is giving trouble. Are you all hearing me?
Yeah, you.
That's me, June 2023. Uh, network settings. Okay, I hope the Wi-Fi stop playing. I hope the Wi-Fi is right, but we're gonna keep moving onward. All right. I'll let guys, I'll let them know.
So we're hearing you, but we're not seeing the screen.
Nagana, I thought it was me alone.
Okay, we're
Yes,
now
sir.
seeing the screen then also.
Let's see the screen now.
Yeah.
Yes,
Yes,
sir.
sir.
Wait. Why the internet moving so way?
I don't know what it is because of I'm not using Wi-Fi, using data, and it giving real trouble too.
It's probably like a amplia thing.
Might be.
Might be. That had to be it. All right. Well, let me continue. A
Sure.
body initially moving at a constant speed is brought to rest at a uniform rate. Which of the following speed time graphs indicates the motion of the body? So guys, as I repeat as well, if we start off at a constant speed, the first part of the graph would be a what? What would the first part of the graph be?
Flat line, sir.
A
Flat
flat
line.
line.
And then they say it's brought to rest at a uniform rate. So that's what we're talking about over there.
A linear.
Right. If it's uniform rate, we're talking about a linear graph. And since it's being brought to rest, as time passes by, the speed is what? What's happening to the speed?
Then decreases.
It decreases, yes. So which graph represents that?
C.
Three.
See,
C, right? So you can see that this part over here, the speed isn't changing, suggesting it's constant speed. And as time passes by, my speed drops to 0. Right. I go on any TikTok live, it's not making sense. TikTok, like, I don't know why TikTok behaving so boy, like, it banned,
tell
like,
them
people,
jump across on YouTube.
they gotta do that. Because, like, every time I go live on TikTok, it's, like, it just give them a bunch of violations. Repeated violations. I don't understand what I'm doing wrong. It's upsetting. Yeah. I don't know what's wrong with TikTok. All right. A 4 kg mass is traveling with a constant. Does I repeat as well? Do you remember what the answer was?
10 newtons, sir.
10
It's
newtons.
10 newtons. Yeah. Killan, you see, we just do 3 papers and you see the amount of repeats.
Yes, sir.
Right? So here what? If you wanted me to calculate it, that's not a problem. So let's say you have a mass of 4 kilograms and it's traveling at a constant speed of 5 meters per second. It is brought to rest in 2 seconds. They want us to find the average force acting on the mass to bring it to rest. So they want us to find force. Do you all remember any formula for force?
Mass by acceleration, sir.
Mass by acceleration. Now we have the mass, the mass is 4, right? That was given to us. The mass is 4. We need to find the acceleration. Well, the quote-unquote acceleration, we're really dealing with deceleration because it's brought to rest over a time of 2 seconds. So here what? What is my speed?
5
The
meters per
speed is
second.
5 meters per second.
Right? So you should remember that acceleration is just the change in velocity with respect to time. That's what it is. Now they're using speed and velocity interchangeably here, so that's not a problem. So what was the change in velocity?
It's just 5. It's just
It's
It's
5.
just 5, right? It's just 5. And to make that change, it took how long?
2
2
seconds.
seconds.
Right. What's 5 over 2?
2.5.
2.5.
Aha. So that's 2.5. So we're going to multiply 4 by 2.5, and that's going to give us what?
The 10.
10.
That's going to give us the 10 newtons. Good. So 11C. All right, let's move on. 12. And I repeat as well. Oh, yeah. Physics easy, boy.
The
Nikolai, we just do
opposite
3 papers. And so far, how much repeats I count, Nikolai? How much
I
repeats I
count,
count so far?
I count 12 repeats, too.
So yeah, about 12 so far.
Right? Well, we're on question 12. So an ice cube sinks in liquid A, right? And it floats in liquid B. Which of the following statements is true of liquid A and liquid B? So our question, right? If it's sinking in liquid A, then the ice cube, okay, if it's sinking in something, the ice cube will be more dense or less dense than the liquid.
More denser.
More dense.
More than
Okay, and if it floated in liquid B, it would suggest that the ice cube is less dense or more dense.
Less dense.
less dense.
And if we're talking about upthrust, if something is floating, is it getting more upthrust or less upthrust?
More
More
upthrust.
upthrust.
More upthrust.
Because the upthrust is what's pushing it up, right? So for it to float in liquid B, it has to be getting a greater upthrust. So let's read through the options first. The upthrust is less in liquid A than in liquid B. That looking like it, you know.
Yes, sir. Is it? Because
Yeah.
B saying that the upthrust is greater than A than in
Yeah.
B.
If the upthrust is less, that means it will sink for sure.
Correct. So I hope I understand that, right? It's saying it sinks in liquid A. It sinks in liquid A. And it floats in liquid B, meaning that the upthrust in liquid A is less than in liquid B because liquid B is pushing it up more, causing it to float. Right. People on YouTube, physics just repeats. A bus with luggage on top is more likely to tip over when rounding a corner than the same bus with the luggage, without the luggage. The reason for this is that the luggage, what?
Right, there's a new
The
question. So
Let me give a little example, right? Let's consider two buildings over here. Which building is more likely to tip over? Building 1 or building 2?
building
One.
one, sir.
Right. Which one has a higher center of gravity? Building 1 or building 2?
2, sir.
2.
So I'm gonna ask a little question. When I add luggage onto the bus, the height is gonna increase. And if the height is increasing, it's going to cause my center of gravity
Lower. Well, to be centered. Raise.
to be raised.
Right.
Yeah. Are you okay with that?
Oh yeah.
Yes, sir.
So
Yes, sir.
the bus with the higher center of gravity would more likely to tip over.
Correct. So here what? Let me just say that this was the bus without the luggage, right? This was the bus without the luggage. And when I added on the luggage, so I have a bunch of luggage, the center of gravity now moved up. And so it's easier to tip over. That makes sense?
Yes, sir. Because
Yes, sir.
like it would be stable if it had like a narrower base. Okay, so like building one more skinnier now.
It'll be actually be less stable if you make it skinnier.
Less stable, yeah, because like if it tip it over, it's more likely to fall down.
Yeah, like okay, think about it. What would be more stable? This broad object or this skinny object?
The broad,
Yeah, the broad.
yeah,
But the main reason here is that it raises the center of gravity of the bus, causing it to tip over more easily.
yeah, makes sense.
So this wasn't exactly a full new question because from one of the other papers that had just tell us about a building instead.
Yeah, it's the same. This is really easy. It's really easy. And this is another repeat, right? What we're looking at here, we're looking at extension and force. So which law is this?
Hooke's law.
Flow.
Right. In this period over here, Hooke's law is observed. Obeyed. Because we know Hooke's law is a linear relationship. However, over here, what happened over there? What happened over there, guys?
The
It
elastic
is
limit
not
exceeded.
obeyed, sir.
It's not obeyed, which means that the elastic limit was.
Exceeded.
Yep. Okay, if this not making any sense for you, hear what? I surely stretched a spring before. I sure when I was boarding class and only making guns with your push with like your pens. You know, remove the pen, like you know, unscrew the pen, you know, take out the spring, and you know what I mean? And I'm sure you play with the spring. If you've stretched the spring too much, will it go back to its original position?
No, sir.
No, it would experience
No.
permanent deformation.
Exactly, permanent deformation. And so you see this period, this part of your graph here refers to that. This is the part over here where you stretch the spring and it extend more. And it went back to its original shape. Okay. Which of the following statements are true about the spring above? The elastic limit of the spring was exceeded. And we see that was true. Until I see that over here.
Yes, sir.
Yes, sir.
Here, the spring obeyed Hooke's law over its entire extension. That's a lie, 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 lie. Lie, 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 lie. The force per unit extension in the elastic region was 7.5 Newton per centimeter. That's correct. Watch. The force is 75 and the extension was 10 centimeters. What's 75 divided by 10?
7.5.
That's 7.5. And the units, we have newtons on top, and in the bottom we have centimeters. So that's going to be Newton cm minus 1. So this is correct as well. So 1 and 3. The answer is what?
That will be B, sir.
P. Cool. Power. We use a repeat. Power is just the rate at which work is done. Repeat. Okay. Power is just the rate at which work is done. So you would recall that the formula for power is just energy over
Time.
time. Now, if you're talking about this in terms of differentiation, because I know always you add maths, and I could say that this is just the change in E with respect to time.
Yes, sir.
Okay, so which answer looks the most sensible?
A.
A, no.
Oh, wait.
Power is not work done.
The rate of change of energy, sir.
Yep. Yeah. Because when you say rate of change of energy, anytime you say the word rate, it's changing with respect to what?
Time.
Time.
Time. Everybody okay with the answer being C?
Yes,
Yes,
sir.
sir. Yes, sir.
Work done, that's actually just energy. Total change of energy, that's just delta E, that's just change in energy. Right? Rate of change of momentum, what? That's impulse. All right? The answer is C. It's the rate at which energy changes. That's what power
sir.
is. Two forces of 8 newtons and 10 newtons cannot give a resultant of what?
1, sir.
1.
1. Let's go through the options, right? Okay. Let me run through all the options. Let me just say we have 8 newtons in this direction and 10 newtons in this direction. What would the sum of the forces be?
18.
Okay, that's one instance. Imagine I had 8 newtons in this direction and I had 10 newtons in this direction. What would the resultant be?
2.
2.
2 in which direction?
The
Well-
right.
Well, the right, yeah.
Okay, so far, 18 is a possible candidate. That's just a valid answer. 2 newtons is a valid answer. And additionally, we could have a force of 8 newtons going here. And we could have a force of 10 newtons going here. The resultant would just be given by the
Pythagoras.
diagonal line, right?
Oh,
Yeah. And what would that be? What is the square root of 8 squared plus 10 squared? Check that from the calculator first.
that would be
Square root of 81.
no.
Which square root of 81?
9.
9. Okay. I'm gonna run back this again to make sure nobody is confused. Here what? In this instance, let's just say we had the two forces acting perpendicular to each other. We had 8 newtons up, and then we had 10 newtons over here. That is not very to scale. Okay, cool. If I wanted to complete this diagram, wouldn't I have to replicate the forces parallel to it? Like I would say 8 newtons there, I would say 10 newtons here, and then I would draw the what?
The resultant line.
Correct. And to figure out this resultant, that would just be given by Pythagoras' theorem. So that would be the square root of 8 squared plus 10 squared. That's going to be 64.
Yeah, it's actually not 9.
It'd be 164, sir. Yeah.
And what's the square root of 164?
Again, 12.
I
12.
get
Let me just
12.80.
all right, 12.8 newtons. Okay, cool. That's not a problem. The point is, none of the answers are remotely close to 1. Are you guys seeing any answer remotely close to 1?
No.
Nah, 1 don't make any sense. This makes no sense at all. That don't make any sense at all. That 1, it cannot give a resultant of 1. It cannot give a resultant of 1.
So that's not legal.
That's not legal. Now, let me explain something. Maybe 8 newtons could be acting in this direction, and 10 newtons could be acting in this direction, and that would have changed your resultant. It'll probably make it close to 9 or something. But you're not gonna get 1. No matter how you take it, you're not gonna get 1. There's no way you could get 1. So that don't make any sense. Let me continue. Alright. Alright, Nicola, I believe this is the question he was talking about. Was it or no?
Sir. Yes, sir.
Alright, give it a read.
X, Y, and Z are 3 billiard. Am I
Yeah,
saying that
billiard
right?
balls.
Okay,
It's fine.
billiard balls
Billiard balls.
of equal masses whose centers lies in a straight line. Y and Z are touching one another. X traveling with a velocity of 20 meters per second impinges on Y, assuming that the spheres are perfectly elastic. The resultant motion after impact will be that A, X, Y, and Z remain stationary. B, X and Y remains stationary while Z moves on with a velocity of 20 meters per second. C, X, Y, and Z all move on together, each with a velocity of 10 meters per second. D, X remains stationary while Y and Z move on together, each with a velocity of 10 meters per second.
Alright, so Nikolai, we notice that in this question, the 3 billiard balls, all of them have the same what? All of them have the same what?
Mass.
And they are the exact same spheres, right? Exact same spheres. They have the same center. Okay, all of their center lies in a straight line. They're the same. They're the same balls. We spoke about this. Remember Newton's cradle? Do you remember Newton's cradle?
Lies with the glass balls, right? When one hit the other, it's like the movement passes through the others for the other side to hit.
Correct? Now, this only happens when you have the exact same balls with the same mass and the same center of gravity. That is the only time this occurs. So in this situation, it's the exact same thing we have. All the balls are the same size, same mass, same everything. So what's going to happen is X is going to hit Y and it's going to transfer the momentum to ball Z. So after X hits Y, X and Y are going to remain stationary, but all the momentum will be carried on to Z. So now Z will be moving at the 20 meters per second.
Ah, okay.
Just like this. So you see how the ball moves back, it hits, and the other one to the other end it moves?
Yes, sir.
That will happen. So what's the answer for this?
That would be B.
Let me know if you guys okay with that.
Yes, sir.
Everybody okay with that or no?
Yes,
Can
sir.
you all
Yes,
visualize it
yes,
though?
sir.
Can you all visualize it?
Yes, sir.
Right. 17B. What is that? Is that a repeat? Is that a repeat? The answer is 1,000,
1,000. Yeah, 1,000 one time.
So what was the answer for before?
The answer X and Y. So okay, imagine this ball is moving at a velocity, right? It'll hit Y and it'll transfer all the momentum to Z. So what's going to happen is X and Y are going to remain stationary while Z is going to move on with a velocity of 20 meters per second. So the answer was 17B, and this is why. All right, let's move on. Okay, why is the answer 1,000? Let me run through that fast. What's the formula for gravitational potential energy?
MGH, sir.
MGH.
Right?
And you give it the weight already.
What is the mass? Well, they give you the weight, right? We know that mass by gravity. What's mass by gravity?
Weight.
I'll be weight.
All right, cool. So we have the weight. Our weight is 200, right? Our height changed from 30 to 35. So what was our change in height?
5.
5.
Right, so our gain in potential energy would have been 200 by 5, which is
1,000, which is C.
1,000 joules. Yeah, man. 18C. Let's move on. So 18C, right? Cool. Which of the following quantities remains unchanged with an increase in temperature?
Mass.
Tell me, guys, what remains the same no matter what? Mass.
Mass.
Ah,
Exactly. Because mass, who is mass? Does anybody know what mass is?
It's just how heavy something is. So the amount
Not
of matter
quite.
contained in an object.
Exactly, the amount of matter contained in an object. So if I increase the temperature, the matter might want to expand, but the amount of matter is still remaining the same.
Yeah.
The matter is
so, yeah.
remaining the
Like
same.
So like if it was something in the sun, the matter might want to move, like increase the kinetic energy of the matter would increase, but it's still the same matter.
Yes, it's still the same matter. It might want to occupy more volume, but it would be the same matter. It'd be the same amount of matter. That's why the density actually decreases as you apply heat, because it
Yeah.
expands and it's the same amount of mass. The mass will change. Nikolai, I see you raise your hand. Talk to me.
And when you say the amount of matter inside an object, wouldn't that you be implying about volume? Instead, we should have said the amount of matter that make the amount of atoms or particles make up the matter.
Nah, you don't have to say all that. Mass is just the amount of matter an object has.
No, well, I understand that, sir, but when Kalani gave the definition of mass, he said that's inside the object. So that would be implying that it's volume.
Well, not quite, volume. Okay, so Nikolai, I could have the same amount of matter in an object. If I add kinetic energy by adding heat, the molecules, the same amount of molecules now, they will start to vibrate and move like expand. But it's gonna be the same amount of molecules. They're just expanding and it's taking up more volume. Volume is like a consequence of the amount of kinetic energy the matter has. If I apply loads of heat to an object, it's going to want to expand. The mass doesn't change, and that's why your density drops. If I reduce the temperature, the object is going to become more dense because it's going to shrink. So 19E.
So you know what make me understand that logic better, sir? Like what helped me remember the second law, the second gas law, that is Charles' law, sir. Imagine a balloon in the sun, right? When the heat get onto the balloon, the particles will want to expand. So that's why the balloon might get bigger. But if you have the balloon
Yep.
in a cool room, the
Shrink.
particles will move slower, so it would shrink and eventually it would pop.
I wouldn't say pop. It would just shrivel up.
Yeah.
Like have you ever seen that like yourself? Like I saw it myself.
I see like
Have
a
you?
balloon. I see a balloon pop by itself before, so I just thought it would just compress so much.
Actually, if it expands too much, it'll pop.
Yeah.
Compression might. Nah, more so expansion. Right. So Nikolai, read 20 from her. These are repeat as well.
The specific heat capacity of a substance is defined as the amount of thermal energy required to A. Raise the temperature of a substance by 1
Nope. Nope. Last time it was heat capacity. This time it's specific heat capacity. If
What was
you
D?
see the word specific, it has to deal with 1 kg. That is what specific means.
Okay,
So I would say it's D,
oh yeah, and
right?
that's because of the unit mass.
Right. If you see the word specific, just know you're dealing with a specific amount of mass. So it says raise the temperature of the substance by 1 Kelvin. This is actually just heat capacity, not specific heat capacity. That is heat capacity, not specific heat capacity. This one over here, liquid to vapor, that's latent heat of vaporization. Specific latent heat of vaporization to be precise. This one over here, this is specific latent heat of fusion. This one over here is the correct answer. It says raising the temperature of unit mass of the substance by 1 Kelvin. So we have the change in temperature, check. And we have mass, check. Specific heat capacity. Right. Guys, pay attention. Pay attention. If you see the word specific, you're looking out for what? What are you looking out for if you see the word
kg,
specific?
sir. 1 kg.
kg or
kg.
unit mass.
Correct. Right? Alright, cool. The specific latent heat of vaporization of water is 2.26 by 10 to the power 6 joule per kg. When 0.01 kg of water is converted into steam, it what? This I repeat as well.
Alright.
Alright, so here this, guys. Talk to me. Actually, talk to me, Kelani. Talk to me.
I feel like it's a repeat, but I feel like they bring it a little different. I think the last time
Nah,
it was
same thing.
freezing.
Same thing.
This,
Freezing?
this time they're saying steam. I think so, you know, I could be wrong, but I think the last time I see freezing.
Wonder boy. I swear I see that question before. The exact same thing. Mm, nah, it's the same question. Exact same.
Alright,
Change up nothing.
bet. Well, there we
So
go.
talk to me. How we gonna run? How we gonna attack this question?
So, no, they specifically, so you had to pull out the formula one time, E is equal to MLV, because this is the specific latent heat of vaporization we're dealing with, right? So, now the thing is, that 0.01 kg might be a little hard to work with, so you have to kind of put it in an easier form, right? The best way to put it is in a form where you could work with indices, because you already have a prefix there, right? 10 to the power 6. So you could actually convert that. So 0.01 is actually 1 over 100, and 1 over 100 is the same thing as 1 over 10 squared. And
Correct.
you could rewrite that as 10 to the minus 2, because if you bring the denominator up, you'll change the sign, right? So you would
Right.
have,
So I'm running back again. Which is 0.01. So like Ilani was saying, this is in the hundreds position. So that'll be 1 over 100. And like Ilani said, 100 is the same thing as 10 to the power 2. So it's really just 1 over 10 squared, which could be represented, if I take the 10 squared and I bring it up to the top, that would now become 1 multiplied by 10 to the power negative 2, which is just 10 to the power negative 2. So 0.01 is just 10 to the power negative 2. Right, so Kilani, continue.
all right, so 10 to
So
the
the
minus
mass
2,
is
all right, multiplied by the latent heat of vaporization, that is 2.26 by 10 to the power 6, all right? So what we have to do here now is just simply add the indices, because you have the same base there, right? So you could say negative 2 plus 6, and that will give you a total of positive 4. So it would be 2.26 by 10 to the power 4. Now the thing is, since the water is converted to steam, that means it's actually absorbing heat. So you have to be careful when you're doing the absorb versus giving out, right? So the answer would be A, absorbs, yeah.
and let me think about this logically, right? If you want to, okay, which one hotter? Okay, what would you think?
Steam.
What would you think has more heat, water or steam?
Steam.
Steam.
Steam. So if you want to make that transition, will you be giving out your heat, or will you want to be getting heat, absorbing heat?
Getting.
Yeah, so you'll be absorbing heat to get hotter to make that transition. Cool. But you should know if you're dealing with specifically on heat of vaporization, the temperature not changing it. You're actually using that energy to just rearrange your molecules.
Yeah.
Because if you recall, water is a liquid and steam is a gas. So you'll have to break some bonds there to make the state change. That's what the energy being used for.
You're just changing state, but no change in temperature. That is why the unit is joules per kilogram.
Yeah. Exactly. That's why the unit is joules per kilogram. You're not seeing any Kelvin or degrees Celsius. Right? So the answer for 21 is E. Absorbing heat because you're going from water to steam. Good. I move on.
The answer for 22 is 27.
This is a repeat as well.
27. I remember this one.
Yeah.
You had to use the combined gas law and just work with it.
Right? P1 V1 over T1 is equal to P2 V2 all over T2. So here what? When you read the question, you see that it initially occupies 2 meter cube. That can be V1. Big up all the boys fan. So you know the boys in like compound V1.
Oh yeah. Yes, sir. Yes, sir.
Yeah. This here is gonna be T1. Obviously we'll have to convert T1 to Kelvin. So you'll have to add 273 to this. So that'll be 300 Kelvin. Because I add 273 to it. The pressure is 1 atmosphere, so that's gonna be P1. This is P1 here. And they say you not have pressure of 2 atmospheres, so the pressure change. So this is gonna be P2. And it's telling you now occupying 1 meter cube, so that's V2. They want me to find a new pressure. I mean, what's saying? They want me to find a new temperature, right?
Yes, sir.
Right, they want me to find a new temperature, so they want me to find for T2. Let me plug in everything now. So I know that P1 was 1 atmosphere, so I can replace P1 with 1. V1 was 2. Sorry, replace V1 with 2. What was T1?
300 Kelvin.
300 Kelvin, right? What is P2?
2.
What was V2?
Well, 1.
Uh-huh. I'm going to find for T2 now.
Now let me show that a little hack, right? Look at this hack fast. 1 by 2 is 2. You're gonna put 2 over 300, yeah?
Yeah.
And over here, you're gonna put 2 over T2. Now pay attention to this, right? Pay attention to this. I don't know if you've seen it, but I've seen it. Aren't they like in the exact form?
Yeah.
So like we think T2 will be to make the left hand side equal to the right hand side.
300.
300.
Yeah? Watch. When you solve an equation, you want the left hand side to be equal to the right hand side. So you have the 2 on top already. And you have 300 here. So if you want to make the left hand side equal to the right hand side, the T2 will just be what?
300. They just had to convert it back to
300.
degrees Celsius by subtracting 273.
Correct. So T2 is 300. And you already know what the answer is. I mean, at the start, you start over 300. So what's the answer?
27.
Yeah.
All right, so T2 is just 27 degrees Celsius. If you want to convert from Celsius to Kelvin, you add 273. If you want to convert from Kelvin to Celsius, yeah, you're minus 273. Yeah, everybody okay with that?
Yes, sir.
And if you're worried, listen. I do 3 past papers with Nikolai and Kelani and them, right? And so far, we yet to see a new question. I do any paper in depth because I know some more never touched a physics paper yet, so I'll do any full working.
Yeah, true.
But if you did do papers already, this should be a walk in the park. Nikolai, read 23 for me.
Which of the following methods is the most suitable means of heating a brass bob in order to determine its specific heat capacity by the method of mixtures? A, subjecting it to an open flame for 10 minutes. B, subjecting it into a infrared beam for 10 minutes. C, placing it in boiling water bath for 10 minutes. D, placing it in contact with a electrical heater for 10 minutes. Wouldn't it be C?
Yeah, I think it's C.
Let me see. Which of the following methods is the most suitable means of heating a brass bulb? So you want to heat the brass bulb. That's going to be a circle. Subjecting it to an open flame for 10 minutes. Now, if you do that, I wouldn't recommend that. In different parts of the flame have a different temperature.
Yes,
Yes.
sir.
Yes, sir.
And also, how are you going to measure the energy? How are you going to measure the energy? That's my question.
I don't know, and it's plot is dangerous too.
I mean, how,
And plus, you don't know how far you're gonna hold it to, so that is not too much information.
no, the main issue, the main issue, right? Here what? And if I use something with an electrical heater, if I use electrical heater, and I could probably figure out the energy.
Yes, sir.
Yes, sir.
Yeah, I could do that. But for a situation like this, for E, could I figure out the energy I use?
Yes, sir.
No.
Nah, I can't do that. Can't do that, right? B, subjecting it to an infrared beam for 10 minutes. Again, how are you gonna measure the energy? And if it's a beam of light, then some parts of it might heat up unevenly, right? C, placing it in boiling water for 10 minutes. Okay, that's not a problem, right? That's not a problem. Let me explain why I say that though. So if you're using boiling water, you could possibly measure the initial temperature and the final temperature. That shouldn't be a problem. You could just stick a thermometer in. And if you want to heat the bulb, and if the bulb is fully immersed in water, wouldn't it be heated up evenly?
Yes, sir.
Listen. If you're confused, right? Mia, if you want to heat up a brass bulb, if you're using water, right, Mia, wouldn't the brass bulb be completely submerged in the hot water?
Yes, sir.
So wouldn't it receive heat from all angles, like everywhere?
Yes, sir.
Okay, good. Cool. So I would say the answer is C. All right, 23C.
But sir, you could just
Yes, sir.
repeat back the scenario with the thing there. It was kind of sticking for a second.
Which scenario? Like
The
this one over
scenario.
here?
Yeah, with the bulb in the water now.
Okay. If the bulb is in boiling water, now, okay, recall this. Boiling water, heat is mainly spread via convection currents, right? So you
Yes,
have
sir.
convection currents repeatedly um
In a
going through the
circle.
water, making sure that the water is kind of like an even temperature. So you have this ball in water, and the water is sort of like an even temperature, right? Throughout the water is an even temperature. The brass bulb is going to be completely immersed in the water, and it will receive heat from all directions uniformly.
Yes, sir.
I could also measure the temperature of the water before and after if I wanted to use it.
Initial and
So
final.
makes sense to say. Yeah,
Bet.
right? Uh all right. Shania, read this one for me. Can I hear Shania? Kimura, wanna give it a read for me? Can I hear Kimura? Nikolai, get a read for me. Oh, I see Kimura talking. Yeah, Kimura, give it a read.
Yes, sir. According to the kinetic theory, when a gas in a closed container is heated, the pressure rises because there are more molecules between the walls of the container.
Waiter, Kimura. Let me think for a minute. Isn't mass fixed? Okay, like mass is the amount of matter an object has, right? Where the more molecules coming from? Where the more molecules coming from? The first one is immediately wrong, right? Immediately wrong because mass doesn't change. Read part B for me.
The molecules move faster, hit each other harder.
That's not wrong, but it doesn't really explain the pressure part. So, nah. Read C for me.
The molecules expand and push harder on the walls of the container.
That's not a bad answer. But read part B for me.
Molecules move faster and hit the walls of the container harder and more often.
Right. This is the answer we're looking for. Let me ask that question, right? When we apply heat to a gas, the molecules gain what? What do the molecules gain?
Kinetic energy. Heat
So they will start to move what? They'll start to move what?
faster.
And if they start to move faster, they're gonna move and they're gonna hit the walls of the container harder and more often. So if you hit any walls of the container, what's gonna increase?
The pressure.
Yeah, the pressure. I'm gonna follow you okay with that.
Yes, sir.
All the answer were kind of close though. But I would say D. I would say D.
Too much words. Oh my God.
A bunch of words. I don't like that word thing.
Yeah, boy. Too much words.
Right. But I would say the answer is D. Because they mentioned that the molecules moving faster. So that's good. That's good. You know, if you add heat, the molecules gotta move faster. Then they're gonna start to hit the walls of the container. If they hit any walls of the container, they are going to exert a force on the walls of the container. And remember,
Yes, sir.
pressure is equal to force over area. So if the force increases, the pressure will
Increase as well.
right. So I'm looking for D. The molecules move faster and they hit the walls of the container harder. All right, this is a
Boy.
repeat as well.
Look at nice repeat question, boy. I see.
Right.
Oh,
So
no.
yeah, it's a C. Let me explain why. So molten naphthalene at 100 degrees Celsius is allowed to cool down to room temperature. The naphthalene has a melting point of 80 degrees Celsius. So guys, when it reaches the 80 degrees Celsius, what's gonna happen?
It gonna start to solidify, so
Yeah,
latent heat
and
diffusion.
that correct. And that process is going to take place for a short period of time. And in that short period of time, the temperature is not going to change.
It
So
will
let
be
me
constant.
explain. So in your graph, you're looking for a plateau at the 80 degrees Celsius, like a straight line almost. This doesn't make sense. This don't make any sense at all. This makes sense though. Let me explain. So we cooling it, we cooling it, we cooling it. When it reaches its melting point, it starts to the molecule starts to rearrange. So let me explain. Over here, what state was it?
100.
What state was it? No, I'm not talking about the temperature, I'm talking about the state.
Oh, liquid, sir.
It was a liquid, right? Okay, if you are confused, remember, we are dealing with a cooling curve and we start off at 100 degrees Celsius. It melts at 80 degrees Celsius. So if you're starting off at 100 degrees Celsius, wouldn't it be molten at that point in time?
Yes, sir.
Right. And if all you don't know, naphthalene is just camphor. You know, like when you're doing prayers, like Hindus don't know about naphthalene. Like it's like little white blocks. That's naphthalene. Yeah, camphor. I believe. I think so.
Yeah, that's it, sir.
Let me
Yes, sir.
verify that.
Yes, sir.
Okay, cool.
That's it.
So here what? It starts off at 100 degrees Celsius, right? So right now it's a liquid. When it reaches 80, the molecules are gonna start to rearrange. So over here, it's gonna start the conversion from a liquid to a what?
Solid, sir.
Right. And this period over here is latent heat or what?
Fusion.
Right, this is latent heat fusion. Because you're cooling it, right? You're cooling it from a liquid to a solid. And over here, at this point in time, it's completely a what?
A solid, sir.
Solid, sir.
Right, so you are looking for the plateau. The only graph that makes sense is C. So you're looking for that plateau. All right, let's move on. In which of the following is conduction the main method of heat transfer? Talk to me.
D.
I'm hungry.
Yeah, D. Food being cooked in a pot on an electric stove. Let me run through what the other options wrong now. Food heated in a microwave oven. If you didn't know, how that works is you have microwaves, and when you put on the microwave, the microwaves, they would vibrate the water molecules inside the food, and that would cause it to heat up because you know kinetic theory and matter. So this is not conduction. Energy transferred from the sun to earth. That is not conduction. What do you think that is?
Radiation.
Convection.
Radiation.
That's
No,
radiation.
my bad.
That's
Yeah,
radiation.
radiation.
Because the
So
heat is
isn't
radiating from the sun.
so isn't A radiation as well?
Um,
I think so.
I don't want to just say that. Let me look it
Because
up.
I
Let me
think
look it up.
so.
Right? I don't want to just say that.
And conduction is you transfer of heat through physical contact.
Correct. And well, the A, how that does work, right? Okay, the microwaves are going to vibrate the water molecules inside the food or whatever, and that's going to cause it to gain heat.
Yeah.
So I'm not really sure if that's radiation. I'm gonna look it up. I don't want to tell you anything that's wrong. Yeah, that's correct. So a microwave heats food using radiation. Specifically, it uses electromagnetic waves like radio waves to
Yeah.
penetrate the food and agitate water molecules, generating internal heat through friction. Through friction. Yeah. Now, the reason why I would not say C is the answer, let me ask you that question, right? When you're cooking food in a barbecue, don't you have like coals at the bottom and then you have like a grill here?
Yes, sir.
Yes, sir.
This heat, how does it actually hit the grill? Through what?
Convection.
Yeah.
Convection and radiation.
Yeah.
Convection and radiation. So the main heat transfer is not really conduction. I would say D. Right? Because when you're cooking food on a pot, isn't okay, let me just say cooking steak, right? And you have the heat here. Isn't the steak directly making contact with the pot, the hot surface of the pot?
Yes, sir.
Yes, sir.
Yeah,
Physical
so that's
contact.
conduction. Physical contact. 27. Which of the following are reasons why a hot liquid placed in a double-walled vacuum flask retains its heat for a long time? This I repeat as well. Silver inner walls reduce the loss of heat by radiation. That's correct. The silver outer wall will help to absorb. It's a lie. Would silver even absorb heat?
Nah,
Yes.
reflect.
Silver would reflect heat. Part 3. Evacuated space between the double walls reduces the loss of heat by conduction. This is true.
Yes, sir.
Because if you don't know what a vacuum flasks look like, it's look like this, right? Well, gosh, man. So you have an inner and an outer wall. And in this inner wall, you just have air. Let me ask you a question. Is air a good conductor of heat?
No.
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 No. So when you put the hot contents on the inside, the wall is going to get really hot. Now the heat is going to want to escape through, well, it's going to conduct the heat and it's going to radiate it outwards. But if you have air in the middle here, will the air conduct the heat?
No, sir.
No, the air inside here will not conduct the heat. It will conduct the heat really poorly. Yeah.
Is it the same way
So
when it's cold?
so that again?
Is it the same way when it's cold? Because I know when you have cold water, in the flask is get cold, but
It's the same concept, more or less. It's the same concept, but just in reverse. Because if something is cold, it would mean that it has an absence of heat.
So,
And it would just be working in a reverse process where, okay, all right, if you put something cold inside here, in other words, you want it to stay cold, so you don't want it to absorb heat from the surroundings, right? So, if you have air, if you have air pockets over here, like this whole thing is a vacuum, right? This whole thing here is a vacuum. So let me explain what happened, Nikolai. Nikolai, if I put a flame here, right? This is going to get really hot. But will the air on the inside conduct that heat?
no, sir.
No, so it will do a very poor job of transferring the heat to the inner part of the flask, thus keeping the cool contents cold. So the answer is 1 and 3. 1 and 3, B. Alright, let's move on to 27, B. So anytime this question comes, number 2 is wrong. Silver would never absorb heat, it would reflect heat actually. 28. A person coming out of the sea would feel cool because what?
that's a nice question, but
Convection and the thermal energy occurs into the air.
nah, I
Nah.
think it's CSEC.
Let's see. Nikolai, why do you feel cool? Let me explain, Nikolai. When you have water on your hand, the water is going to absorb the heat from your hand, and when it evaporates, it takes that heat and it leaves with the heat. And that gives you the cooling effect because it's taking the heat away from your body. So, seawater evaporates from the skin. The seawater on your skin is going to absorb the heat from your body, and when it evaporates, it takes that heat and it leaves. So, seawater evaporates from the skin. That's the answer you're looking for.
So the reason why I say that is because like when you're bathing and cold breezes, when the breezes hit you, you just feel cold.
Nah, I understand what you mean, but that doesn't it. The main reason here is because the seawater evaporates and takes the heat from your skin, making it cooler. Right, 29.
And that's
The
what the
kinetic
breeze.
theory of matter suggests that the molecules of a gas are, I would say D. I would say D.
Yeah, because gas don't really conduct. Well, the molecules in
Alright,
a gas far apart.
correct. So when you think of a gas, you think of a bunch of molecules far apart and it's just vibrating crazy and are moving around. The answer is D. Right? I don't like the vibe today. I find everybody dead. Is it because of the
So,
chemistry?
so when I swim to the beach and take a basin.
So
Long time. Very, very long.
Yes, sir. I feel it's because of the
I
chemistry.
I can't remember.
So let me tell you something. Right now, I get promised twice and me ain't going to take out the yet.
Hey boy. Well, here what? After the fourth, I go in. As soon as my car get fixed, I gonna be active. I gonna be outside. I promise myself I gonna be active. I'm not gonna be inside. Yeah. Yeah. How to leave my house. I didn't leave my house since I finished my exams in UE. I've just been in my room teaching. So I need to go and I need to go to the sea. Yeah. And I feel like it's the same thing for all because all just yeah. Okay, I feel like I lived through all the lens.
Yeah.
I feel like I live all the life
Yes, sir.
all over again.
All over
Because this is not the
again.
first time I lived this life. I lived it last year when I was doing 17 hour marathons back to back. I lived it the previous year and it was it's not the most glamorous life. Right, 30. This I repeat as well.
What is a
Basically this
coconut oil?
saying, right. They're saying like over here goes out of boil, but the ice will remain ice. The reason for that is because water is a poor conductor of heat because of its high specific heat capacity. So the answer we're looking for is A. That's why the ice gonna remain ice.
Halfway through, guys. Let's go.
Right?
so like how long we take to do 30 questions already?
I don't know, but like here what? We're moving real slow. That's because I explained in this question. As we start to pick up pace, you see we move real fast.
So I feel like we're moving quick actually.
Nah, I find moving real slow. 31. From the information about the frequency is. You can't find frequency from this. You
Unknown.
can't find
Unknown.
frequency from this. Alright. Remember, frequency is equal to 1 over a period. And period is just the time it takes for one oscillation. There's no, okay, unless you're in time in any one of these axes, unless you're in time anywhere.
No.
No, sir.
No. If it was time here, I could have probably
No.
measured the time for a period and then find frequency, but I don't have that. I have displacement and I have position. I don't have information to find frequency. So that's unknown. Let's move on. Right. Give that a read for me.
The sharp edges of shadows suggest that light A travels in straight lines, B travels very quickly, C is a form of energy, D has a wave nature.
All right.
I think in A, sir.
Is it? Yeah, it would be E. Would be E.
So wasn't there a theory that someone had that light was waves as well?
Yeah, yeah. I know you're talking about. I think that's the corpusculate. What that was again? So yeah, at a point in time, somebody had believed that, light was a particle. Yeah, somebody, wait, I think it was corpuscles or something. I was looking up corpuscles and I see Corpus Christi pop up.
Yes, sir. I could remember 35.
Yeah. Yeah, but the answer for 32 is A, right? Light travels in straight lines. That's why I see it. That's why I see it in sharp. If it wasn't travel in straight lines, chances I would not be so angular and sharp. Right?
So
33. An echo is quieter than the original sound that produced it. This shows that that compared to the original sound, the echo what? Wait, before we answer this question, right? Anytime we're talking about loudness, what are we talking about? Anytime we're talking about loudness, what are we
Amplitude, sir.
talking
The
about?
amplitude, magnitude.
Right. We are talking
Amplitude.
about amplitude. So if the wave, okay, if the echo, okay, if the sound wave, right? If the echo is less loud than the original, it suggests that it has a bigger amplitude or a smaller amplitude.
small amplitude.
Smaller.
Smaller amplitude, right? So the answer for 33 is B.
Smaller.
That was easy.
Yes,
Are they
sir.
okay with this, right?
And frequency
Yes,
is
sir.
pitch.
Yes, sir.
Good. And frequency is pitch. If you have a high frequency, you have a what?
High pitch.
High pitch.
If you have a low frequency, you have a what?
Low pitch.
Low pitch. Low
Pitch.
pitch.
Good. All right. Item 34 refers to the following diagram, which shows you two similar loudspeakers connected to the same audio frequency generator. These speakers are set up a few meters away from a path XY. This was the same question that come in I think it was 2025 June.
Yeah, I see this, sir.
So the reason for this, at some points along XY, no sound is heard. If you're not hearing any sound, that's because you have what type of interference? Constructive or destructive?
Destructive.
Destructive.
Destructive. So which answer would you recommend?
B.
B, sir.
Interference of the sound waves takes place.
I recommend
B, yeah.
that's the only answer that explains it. Right? And we know when the sound waves arrive 180 degrees out of phase, they completely cancel off. So there it has to be interference, specifically destructive interference. So 34B. Everybody okay with that? 34B?
Yes,
Yes,
sir.
Okay. I believe this I repeat as well. A
What's
ray
it?
of light, a ray of light leaving air enters glass at of a refractive index 1.6. The angle of refraction is 27 degrees. What is the sign of the angle of incidence? So here what? Initially, the ray of light leaves what? Where does it leave?
Glass. I mean,
Glass.
air. My bad. Air.
Air.
No, I keep making
So-
that mistake.
That means that the incident ray would have been in what medium?
A.
Yes, sir.
Let me draw the diagram first. So this is your boundary line. What's this?
The
The
normal.
normal.
Could do a better diagram than that. Bro. Come on.
Bruh.
Bruh. Bruh. Bruh. Right? And what do I call that dash line over there?
Normal.
The normal.
It's normal, right? Alright, so they say it leaves air. So we could call this air. And well, we could call this glass. If you're going from a less dense to a more dense medium, what happen?
Bend towards the
Bending
normal.
out, we're bending to. Right, it bends towards the normal. So here what happening, right? Our incident ray is in air. So that means Ni is just going to be 1. Do we have the angle of incidence?
No.
Now we don't have that. Okay, I'll leave that blank. Do I have my angular refraction?
Yes, sir.
Yes, sir.
27 degrees, right?
Mm-hmm.
Do I have the refractive index for glass?
Yes, sir.
Yeah. 1.5.
Right? So that will be refractive index for the refracted ray, as your refracted ray is in glass, so that'll be 1.6. So let me jump into it. So Ni sin I is equal to Nr sin R. The refractive index for the incident ray, it's an A. So Ni is just going to be 1. We don't know what the angular incidence is. I'll leave that blank. The refractive index for glass, which is where the refracted ray is 1.6. So I'll say 1.6. And the angle of refraction is 27. You don't have to put all these brackets, you know. I don't know why I do that. I guess as a sharp trauma I had. For you know. I know what I'm talking about, right? Because like my whole life I had a sharp.
Yeah.
Yes, sir.
As a sharp trauma, I suppose. And we're gonna have 1 sin I, which is just sin I. So that's my answer. 1.6 sine 27. Which answer is that?
Here's D.
D.
Right, because they asked us for the sine of the angle of incidence. So they just want me to find sin I. That's what they want us to find, sin I. So that's D. Let me run it back one more time. In the question, they told us that it was leaving air. If it is leaving air, that's going to be what my incident ray is. So my incident ray is an air. The refractive index for the incident ray, therefore, is going to be 1 because we are in air. It then enters glass. If it enters glass, that's going to be the refracted ray. And the angular refraction is 27 degrees. And they told us the refractive index for glass is 1.6. So the refractive index for the refracted ray is going to be 1.6 because it's in glass. So 1 by sin I, again, because we start off in air. We don't know what the angle of incidence is, so I'll leave that blank. The refractive index for glass is 1.6, or I said 1.6. Sine the angular refraction. The angular refraction is 27. So 1 by sin I is just sin I, and you end up with sin I being 1.6 sine 27. So the answer is D. 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 Right? Can move on. Well, you're moving dead boy. That chemistry take all out.
No. Sorry, I with you, no, sir.
Okay, good. Which of the following waves travel only longitudinally?
Sound waves.
Sound waves.
Right? So the answer is just what?
A.
A.
Right? A. Right? Water waves and radio waves, they are example of transverse waves.
In the electromagnetic spectrum.
Well, water waves are in the electromagnetic spectrum, but radio waves are.
Well, okay.
Okay, cool. Let's move on. 37. Which of the following can produce a diminished virtual image? Diminished virtual image. Tell me fast what that is.
A smaller
A.
that it's like a smaller image, but it's not real, so that's why I call it virtual. That would be a divergent lens. Because what I'm
Correct.
saying, sir, you know how convergent lens the rays will converge to a point given a real image, right?
It converge after the lens.
Yeah. But what I'm saying is right, the a convergent lens could produce a diminished real object, but not virtual.
Correct, because it will always converge after the lens. If you understand what I mean, watch.
I think Kalani need to say divergent. Did you
No,
or
I just put an example. I just put an example.
oh my bad.
Wait a give me a second. See if you have a convergent lens, it'll happen. Wait till I should probably just scoot this thing. Yeah, let me do that. It's kind of like a bar diagram to kind of prove my point. Trying to prove my point here, but all right, the point I'm trying to make is for a convergent lens, it's going to converge some point after the lens. So what I'm trying to say is for a convergent lens, it will always form an image that is after the lens. So if it's forming an image after the lens, it has to always be real. However, for a divergent lens, let me show you what is happening with a divergent lens. Check this out, right? All right, so that's my first rule. My second rule would be like this. Let's just say that this is the focal point over here. What would happen is I would take my ruler, I would line it up like so. And where you see the intersection? Behind the lens or in front of the lens?
In
Behind,
front.
sir.
No, my bad, behind.
Behind, right? Let's see in that.
Yes, sir.
This would be real. Convergent lens produce real images because it's formed in front of the lens. However, divergent lens always produce virtual images. Why? Because it's behind the lens on the same side as the object. Hopefully you understand that.
A good way to
So
think about it too is like a plane mirror is an example of it would produce a virtual image, right? Because if you watch yourself in the mirror, you would see your reflection behind, but it's not actually behind. It actually, the light actually reflecting in your eye. But it do have an actual person behind the mirror, so that's why I call it a virtual, because it's not real.
yeah, but you gotta be careful how you say that, right? Because with a mirror, like with a mirror, right? Okay, so you see how a divergent lens would always produce a diminished virtual. A plane mirror actually produces a virtual scale to scale image.
Yes, it upright. It's the same like length and stuff.
Yeah, right. All right, so let's move on. So anytime you see diminished virtual, just know you're dealing with a divergent lens. A divergent lens is the only type of lens that will create a diminished virtual image. Good. Let's
Yeah.
move on. Total internal reflection in glass occurs when, right? Wait, before we even read anything, this occurs when it exceed the what? When it exceed the what? The what angle?
Critical angle.
Critical.
Yeah. So where's the answer? Tell me immediately. Where's the answer?
C.
C is the answer. Anytime you surpass the critical angle, total internal reflection happens. Check this fast. Real fast. And so remember that question with Bruce? The shark that on teeth?
Yes, sir. Now say you have teeth. It's gold teeth.
Well, we add teeth for him. We give him a free dentist appointment. Check this, right? Let me just say that this is the critical angle. At the critical angle, the angular refraction will be how much degrees from the normal?
90 degrees.
90.
Now, if I were to exceed the critical angle, it's going to dip into the same medium. So like I'll show you what I mean. If I were to exceed the critical angle, this is now going to dip into the same medium, and at that point, total internal reflection happens. Like so. This is total internal reflection. And that this happens when when the angle of incidence is more than the critical angle.
Yes, sir.
So the answer is just 38C. Alright, cool. Let's move on.
Yes, sir.
39. A ray of light in air strikes a glass block at an angle of incidence of 0 degrees. On entering the glass block, the light will be what?
Undeviated. A or
Yeah, be undeviated. Let me think about this though. Think about this though. Come on a second, right? Let me just draw a diagram quickly. I'll draw a diagram for it to make sense. So we can understand what happened in here. So it says that we're going from air to glass. No problem. We're going from air to glass. And they're telling us it has an angle of incidence of 0 degrees. No problem. So if it has an angle of incidence of 0 degrees, we measure this angle with respect to the normal, right?
Yes, sir.
yes, sir.
Yeah. So the 0 degrees will be over here. So if it's at 0 degrees, it would just go straight through, undeviated. So what's the answer?
Undeviated.
It would be A. Undeviated.
Yeah. Totally reflected doesn't make any sense. Refracted at 90 degrees to the normal doesn't make sense because that only happens at the what?
At the critical angle.
Yeah.
And that have to have an angle.
Correct. And then for D, I've seen refracted at an unknown angle. But you see in here, like, okay. Well, let me think, right? I think it'll be E, right? Because when we're dealing with lenses, right? When we're dealing with lenses, I'm not sure if I'll remember this. Give me a second. Let me show you something fast, real fast. Yeah, the answer is E. I want to show you guys something. Check this, right? The laser is in what medium here? What medium is the laser in?
Principal axis. Well, yeah.
No, it's in air. It's in air, right? It enters the glass lens and then it comes out what?
Undeviated, sir.
Undeviated. Yeah. Now, I'm gonna blow all your mind, right? Check this. Let me just say, for instance, that, well, this is technically the boundary line, right? That's technically the boundary line. But let me just assume for a bit that this was the boundary line, right? Wouldn't
Yeah.
the normal look like this? Think about that for a moment. Think about that for a moment.
Or if that was the boundary line. Oh.
Yeah. So the boundary line just separates the two mediums, and well, this is air and this is glass. So let's just assume for a second that this was the boundary line. If that's the boundary line, any normal would exist perpendicular to that,
Yeah, it would.
Yes, sir.
and the normal would lie on the what axis?
The x-axis, horizontal, principal
The
axis.
principal axis, yes.
Yeah.
And this just goes straight through. So I would say the answer is, yeah, the answer is A.
Yeah.
Without a doubt, the answer is A.
Yes.
I think the 0 degrees is the key, you know, because if it passed through one,
Yeah.
if it passed through one medium and go through the next with 0 degrees, it's just undeviated.
Yeah, undeviated.
So when you look through these answers,
Right.
all of them have to have an angle. But when you see 0, that is not an angle.
Nah, that don't make sense. And let me give you another practical explanation, right? And you guys remember the formula Ni sin I is equal to Nr sin R? I remember this,
Yeah.
right? So check this out for a bit. They're saying it goes from air to glass, right? So one, and they said that the angle of incidence was 0. So the I could just be 0. Let me just say for a moment that, you know, glass is, I think we can just say glass is 1.6. It shouldn't really matter. And they want me to find angular refraction. No problem. I'm asking a question, right? What is sine 0? What is sine 0?
0? Oh no, 1.
Zero.
No, 0.
Sine 0 is just 0. Remember what the sine graph looks like. The sine graph looks like this, so it's going to be 0, 0.
Mm-hmm.
So
So,
why I was
okay,
taking 1, I don't know.
that's the cosine graph. So 1 sine 0 is just 0. Like what, no? 1 sine 0 is just 0, yeah?
Mm-hmm. Yeah.
Look how the math's going to prove itself. You end up with 1.6 sine r. Stay with me. Then you divide both sides by 1.6. So you just end up with sine r is equal to what? With 0 divided by 1.6.
0.
0. So
And
just
when
because
and when you find sine inverse of 0, what are you gonna get?
0, because sine
0.
was already sine is 0.
Yeah, so the angular refraction gonna be what?
4 degrees.
Undeviated.
Oh, let's see, let's follow this. It's 0
0.
degrees. So if I enter at 0, if I enter at 0 degrees and I leave at 0 degrees, I was undeviated, right? Kilani, you seeing that like through the calculation part?
Yes, sir. Calculation, yeah.
Yeah, undeviated. You just go straight through. 40. The position of an image formed by a plane mirror depends on the what?
That's not it. The position of an image form, the distance of the object from the mirror.
And Nikolai, what will you say?
I would say A. Is either A or could be B.
So the position of an image formed by a plane mirror depends on, I would say is B. And you all are saying A. It doesn't have to do with A,
I
no.
say the
It
object.
doesn't have
I
to do with
say,
A.
yeah.
Here what? Let's read the question logically. It says the position of an image formed. The position of an image formed. Let me give you a explanation for this, right? A logical explanation. Let me just say I have a mirror there, right? If I place this ball in that position, this is going to be the image, right? I'm saying this is going to be the object. This is the object. If I place the object there, wouldn't the image be over here?
Yeah.
Okay. Nikolai, let's just say you now take the object, and you know where you place the object? You place the object over here. Where would the image now form? Wouldn't it now form over here?
Yes, sir.
So read the options and see which one making sense. So the position of the image formed by a plane mirror really depends on the what?
The object distance from the mirror.
Yeah. Oh, let's see, that or no?
Yes,
Yes,
sir.
sir.
And this is the distance. So the
Makes
answer is
sense.
B. 40B. Right? So the distance of the object from the mirror. Because think about it, if you're looking at yourself in the mirror, right? If you step back from the mirror, and your reflection is also going to step back.
Yeah.
Yes, sir.
Yeah.
The A and B is the same answer or no?
Nah. A is saying distance of the observer from the mirror. Nah, I wouldn't say it's the same thing. I wouldn't say it's the same thing. Like, okay, let me explain something, right? Karina, let me just say you are over here and you are looking at this object. And when you look at it in the mirror, you go see it over here.
Yeah.
Okay, Karina, let me just say you move over here now. You move to a different position. And the object would still be here, and this object would still, and the image would still be here.
Yeah.
The object not changing, no. The object not changing. The object not changing. Okay, here what, right? Let me just say you have a mirror in your room, right? Let's just say you have a mirror in your room. Will your bed, okay, and you're looking at your bed in the mirror. Will the position of your bed ever change?
No.
No. No matter where you look, your bed is going to remain the same spot in the mirror. So, does the distance of the observer from the mirror does it really affect the image formed?
No.
No, however, the distance of the object from the mirror affects that. Because if I move the object to a new position, the image will change. So the answer is 40B, distance of the object from the mirror. Everybody understand that, right?
Yeah, so that's a very
Yes,
good
sir.
explanation. So
Right.
real nice explanation.
Thank you, thank you. Which of the following expressions would represent the formula for linear magnification? Alright, so we're dealing with magnification here. So which ones are looking correct?
Magnification. Oh, so that's like the image getting bigger, sir.
Well, it doesn't have to be that, but we're essentially comparing the image to the object.
Oh, so it's looking like you would divide the height of the image over the height of the object.
Yeah. Okay, if you're confused, right, let me explain this in a way that makes sense. And a way that in like a maths way, right? Like a maths way fail. Let me just say the length here is 2. Alright, stay with me. And let me just say it's 4. If I wanted to find the magnification, okay, so this is the image, this is the object. What would you do? Tamakilani, what would you do?
You would say 4 divided by 2 or image over object.
You would say image over object, right?
Yeah.
So is 1 correct?
Yeah, 1 correct, sir, for sure.
1 correct for sure.
It's
Would
like
2 be correct?
it's like the scale factor.
This is exactly the scale factor. That's what it is. It's exactly the scale factor. Does 2 make any sense?
2 not making any sense, sir.
And like I was saying, you're comparing the image, which is a new thing, to the original thing, which is the object. So it's always image over object. So do you think 3 is correct?
Nah, there's only 1 alone. So A.
Only 1 alone. A. It would have been correct if it was image distance,
Well, object distance here.
because you're comparing the new image to the original object.
Yes, sir. So you could have like an image factor and a distance factor.
Yeah. So does everybody understand why the answer is 1 only? Because like you're comparing the image to the object. So it's always image over object, not the other way around.
Yes, sir.
I wonder
Yes,
if we have
sir.
anybody on YouTube, boy. You have 216 people on YouTube? Wait,
Yo,
boy.
don't forget to subscribe.
I got the thing.
Don't forget to subscribe, all there. 219 people. Don't forget to subscribe.
We hit
You know what?
6K tonight.
I find it is work better when all tell them. So all they do all the thing. All they sticking, boy. All they sticking, bad boy. Come
Like
on.
and
Guys, come
subscribe. Like and
on.
subscribe.
I done talk
Everybody
already.
Usual
subscribe
thing. Usual
right
thing.
now.
Yeah,
Stop
subscribe.
what you're doing and press that button.
That is what we're talking about. Alright, so let me continue. Item 42 refers to the following graph showing the variations of alternating current with time. So just from looking at this, right? I1 looking like the what? I1 looking like
The
The amplitude.
this looking like the amplitude, right? And the okay. Let me see if I can figure this out. What do you think is the answer? A, B, C, or D?
That's not. I didn't read the top part. Let's go back up the top.
D.
D, sir.
D. Yeah, it would be D.
Oh yeah. It's actually the peak value. Yes.
Nikolai, can you see that at T1 it's the crest, also known as the peak, the pinnacle?
Yes, sir.
Bridgerton fans go get that joke.
Repeat.
You wouldn't get that, Nikolai.
So-
Nikolai, you wouldn't
so-
get that. You wouldn't get that. You wouldn't get that.
All the other answers not making no sense. Sir.
Nah, none of the answers making none of the other answers making sense.
So what B means? What is senior dual value means? Sir?
I don't know. I'm being real with you, I don't know. Root mean square, I can tell you what root mean square means. So like root mean square is just like an average. It's like an average. So like you're combining like the positive half cycles and the negative half cycles, so you get like an average. Right?
Sometimes the best answer is just the best sounding answer. You know?
Yeah, like Olia, Karina, and just see now this is the highest it goes up to I1.
Yes, sir.
So this is the peak value.
That's it.
As a peak value, what else you gonna say? Yeah, peak value, right? When a polythene rod is rubbed with a cloth, it becomes so You're rubbing a polythene rod with a cloth. So we talked about this experiment already. You have a polythene rod and you have a cloth. If you guys recall, the polythene rod would actually lose electrons and the cloth would gain electrons. So if the cloth gain any electrons, the cloth will become what?
Negatively
Positive.
charged.
It would
Or
gain electrons.
negatively.
Has to be
Nikolai,
negatively charged.
all they do chemistry today. Come on, guys. If you gain any
Negatively charged.
electrons, Alia, you're becoming positively charged or
Negative.
negatively.
Negative.
Negatively charged.
So the cloth is going to be negatively charged, and the polythene rod is going to become what?
Positively charged.
Positively charged.
Positive.
All right, and there's something called the triboelectric series. I'm not sure if you all know about that. Don't you all hear about that in school?
No, I hear about that one too.
So like check it out here, right?
Mm-hmm.
Not really seeing
So,
polythene rod.
so it's like a list of stuff that have charge tendencies.
Yeah.
Okay, so
So I'm not really seeing polythene. That's fine. But they're saying when a polythene rod is rubbed with a cloth, so polythene rod. So they're really talking about the polythene rod. The polythene rod itself would become what?
Positively charged, sir.
positively
Positively
charged.
charged. By gaining your. Wait, what?
So when the cloth rubbing on the rod, sir, the
Wait.
cloth.
Wait, let me just verify this. Let me look up the triboelectric series. Give me a second. Because like all the other options kind of sus. Give me a second. Because our custom with the silk rod, what's the silk rod? I are custom with the glass rod and the silk cloth. I'm not sure if it's different between the polythene rod and the cloth. Might be a bit different. It depends on where it falls in the triboelectric series.
Actually, so one question.
So wait, it's actually the other way around, right? The one we are custom with is the glass rod and the silk cloth. But it's the other way around here. Very, very
My
sneaky.
God.
Yeah, it's the other way around here. This is one of those things you just have to memorize. Alright? It's one of those things you have to memorize.
Let me look it in there.
Yeah. Because like I said, the one we are custom with, let me show you the one we are custom with. This is the one we are custom with. The glass rod and the silk cloth. So I presume it'll be the same now, but it's actually the opposite.
Mm-hmm.
So if it is a polythene rod is rubbed against a cloth, what actually happens is you have electrons from the cloth being rubbed off against the polythene rod. And so this is going to gain electrons.
Become
it gain-
negative.
Yeah. Negatively charged.
Yeah, but they're real sneaky for this question, boy.
Yeah, boy. Because again, like I said, we are custom with the glass rod and the silk cloth.
Yeah.
And then change it up here. So the answer is what?
B.
B.
Let me
Right.
look in the answer one time there. Negatively charged by gaining electrons. So when a polythene rod is rubbed with a cloth, it becomes negatively charged. Right? The rod becomes negatively charged by gaining electrons from the cloth. Good.
Good. And if it is a glass rod now, if it's a glass rod and a silk cloth, what happens?
The opposite, so it will become positively charged, right? And the
Yeah.
cloth would actually lose electrons.
Correct. Yeah. So I had to look out for that, right? You had to look out for what it's specifying.
Yeah.
So, sir, in a way, I was correct.
Yeah, it was correct.
I didn't even know that.
We done look at it already long time there, so.
Right. So if it's polythene rod and cloth, when you rub the cloth against the polythene rod, some of the electrons from the cloth are going to be transferred to the polythene rod. And if that's the case, the cloth is going to become positively charged because it's losing electrons. And the polythene rod is gaining electrons, so it's going to become more negative. If you see a glass rod and a silk cloth is going to be the opposite. Remember that.
Yes, sir.
Yes, sir.
Okay, cool. So the answer is B. Let me lock this in, right? So polythene rod, the polythene rod is going to gain electrons. So it become negatively charged. Good. All right. I'm moving on, right? 43B. And let me just take a screenshot of this on page here one time. So if this come, you know what to do. Because I saw a custom with this one, eh? One second. Right. So if it is glass rod on silk cloth, it's opposite.
That was
I
real
move on.
satisfying to see it crop that down. So
Thank you. Which of the following diagram shows the magnetic field formed between a bar magnet and a piece of iron? All right. So, do you all have any suggestions?
which of the following diagram show the magnetic field from bag magnet?
C.
Yes.
Was
The
it
C,
repel each other?
maybe C.
It would be
Looking
C.
at it,
Now,
looking like C, yeah.
let me
Mm.
explain why. I'm actually explain why. So, in iron, you have a bunch of dipoles, like small magnetic dipoles, and these are gonna act like very, very small. Well, all matter actually has dipoles, eh? Now, when you bring a magnet close by, we actually did this question, something similar to it. Let me get you the diagram so you will see what I'm talking about. Magnetic induction. That's what it is. Where is the diagram? Where is it? Diagram is supposed to be here somewhere. Here it is. So all materials technically have magnetic dipoles, but some just have it. Some just have more. So if I were to take a permanent magnet and bring it in contact with a material, the magnetic dipoles are going to align. Now, what is going to happen is, if I bring a magnet in contact with an ion, it's going to induce a north pole over here. And remind me, we always go from north to what?
So
North to south.
North to south. So I hope it makes sense.
Yes, sir.
And this is magnetic induction. It would cause the dipoles to align. And let me ask you a question, right? I think about this logically. This is real simple. If I take a magnet and I bring it close to iron, doesn't the iron get pulled towards the magnet?
just say that again.
Okay, Kilani, if you have a magnet and you have
Right?
iron, you bring them close by, wouldn't the iron move towards the magnet?
Yeah,
Yeah.
yes. I see
Now,
it, yeah.
Kilani, ask yourself, why would that have happened? Well, we know for magnets to be attracted, it must have a south and a north pole, and
Yes, sir.
so logically, Kilani, you understand why this would be induced and it would be a north pole?
Yeah, because when you put the like the magnet towards the iron, it's like because it's like magnets retain their magnetism for a long time, so it will actually pull the iron towards it.
Yeah, well, even simpler than that, right? Like, okay, for two magnets to be attracted to each other, it must be a south and a north pole, right? Or a north and a south pole. So, and you know for a fact that the iron would be pulled towards the magnet?
Yeah.
Why is that? Why is that? For that to happen, it must have magnetically induced a north pole here. Because you know what a north and a south does do? It
It
attracted to each
attracts,
other.
yeah, it attracts, yeah.
Yeah. So this is the only answer that makes sense. Some people might be tempted to put this answer, but it doesn't make sense. Because again, if you have a south pole here, what pole would you have to induce here for it to be attracted?
Yeah, because if it was because the light poles is repelled, so that ain't making sense.
That not making sense. So it would
Yeah.
have to induce a north pole over here. But if this is a north pole, look at the direction of the magnetic field. That doesn't make any sense. We know that
Nah.
the magnetic field is supposed to go from north to south. So this wouldn't make any sense. This don't make any sense. You know that the magnets would attract the iron. So this don't make any sense. This is wrong. This don't make any sense either. This makes sense.
Yeah.
So one more time. Guys, if I bring an iron, okay, if I have an iron block and I put a magnet close to it, what happen? Anybody can tell me what happen?
Yeah, I will induce a north pole.
Well, the magnet, the permanent magnet, will induce a north pole on the iron bar. Nikolai, let's just say I were to switch this around, right? What pole do you think the permanent magnet would induce in the iron bar?
A south pole.
A south pole, and then it would look like this.
Yes, sir.
Do you understand that?
Yes, sir.
Okay, I hope so. I trust him.
Yeah, I believe I
Yes,
understand,
sir.
Because the iron is gonna be pulled towards the magnet. For that to happen, it must have formed a north pole because south and north will attract.
Yeah.
And they always go from north to south. So the answer is C.
Yep.
What is the resistance of R? So let's read the question. Item 45 refers to the following circuit where the ammeter reads 0.4 amps and the voltmeter reads 0.6 volts.
Isn't this a repeat also?
This I repeat, but since I'm doing this live on YouTube, I'm going over the full working. So we know that current goes from positive to negative. That's the conventional flow of current.
Mm-hmm.
You're probably saying, sir, and you're supposed to split the current. And you're supposed to split the current at this node? No, let me explain something. An ideal voltmeter has a very high resistance, a very low resistance. Has an infinite resistance. So if it has an infinite resistance, will any current pass through this node?
No.
No, no current will want to pass through here. So all of the current is just going to pass through the resistor. Since the current is passing through the ammeter, ideally I should have a resistance of what?
1.5.
Nah, ideally I should have a resistance of 0 ohms. Why does that make sense? Okay, resistance is the ability for a material to impede current,
Flow of current.
to like slow down the flow of current, like to block the flow of current, right? If I'm putting an ammeter in series in a circuit, do I want it to impede the flow of current?
No.
No, I want current to pass straight through. So ideally, it should have a resistance of 0 ohms. Current will pass straight through. I'm explaining this because you're gonna see questions like this just now. They're gonna ask you, how would you put an ammeter in a circuit? Should an ammeter have a high resistance or a low resistance? You'll see. Cool. So here what? As you can see, the current never splits. So the current we're dealing with here is the total current. So the current reading is 0.4 amps. So we have 0.4 amps flowing through the resistor. And the voltmeter reads 0.6 volts. So what is the potential difference across the resistor? Potential difference is just voltage, guys. 0.6.
Yes, 0.6.
So we have a current of 0.4 amps flowing through the resistor, and we have a potential difference of 0.6 volts across it. So we have current and we have voltage. They want us to find the resistance. Do you all know any formula that has V, I, and R in it?
Yes, sir. Ohm's law.
Ohm's law, right? V is equal to
Yes,
I
sir.
R. I have the
Transpose to R.
voltage, right? I have the voltage. What's the current?
0.4.
2.4 amps.
I don't know what the resistance is. I'll leave that blank. I'm trying to find for R though, so I'll divide both sides by what?
0.4.
Divide both sides by 0.4. And I should get 1.5. Because this was a repeat.
Yeah.
45B. So again, the voltage across the resistor is 0.6 and the current through it is 0.4. So you just had to use Ohm's law and you get an answer. So 1.5 ohms.
The key takeaway is that you're saying, so when you connect the ammeter in series, you want the current to flow ideally, so it should have a 0 ohms.
Yeah, that's why. I understand that, right? Like, okay, if I put in an ammeter in series in the circuit, wouldn't I want the current to pass straight through it unimpeded?
Yes, sir.
Sure.
So I would want to have a resistance of 0 ohms, ideally. And, well, for a voltmeter measures voltage. And you hook up a voltmeter in parallel to your circuit,
Yeah.
to the component you want to measure. I do not want my current to split at this node. I don't want it to split. If I don't want the current to split, I want an infinite resistance here. If it's an infinite resistance, then no current will be able to pass through this node over here. None.
Yeah.
None.
Yes, sir.
And so all the current will just pass through this resistor, which is what we want. So 45 is just going to be B. 45 is B. 1.5 ohms. Good. As I repeat as well, a conductor rotating in a uniform magnetic field induces maximum instantaneous current when a conductor cuts the magnetic field lines at
90 degrees.
C.
90 degrees.
90 degrees. When you all go in upper 6 physics, if you go and pursue electrical engineering, you learn about this equation here. F is equal to B I
BIL.
sine. Oh, wait, take a second. Sine theta. Do you know what B stands for?
Magnetic flux. Magnetic field strength.
Right, as in magnetic field strength. I is the current.
L is
And
length of wire.
R is the length of the conductor, length of the wire. And theta is just the angle between the magnetic flux and the conductor. Now, as you guys would see, and F is force, right? F is just the force you feel as a result of being in a magnetic field. So check this out. When would sine theta give me the biggest answer? When the angle is what?
90 degrees.
90. Because sine 90 gives us 1. Isn't that the highest value
One.
the sine graph could give me?
Yes, sir.
Sir.
Right. So that's why you have, okay, you'll have the maximum force, electromotive force, when it cuts it at 90 degrees. Right? Because sine 90 is 1. That's the biggest value you can get for the sine function. So the answer is 90 degrees. Obviously in CSEC physics you don't know this, but if any of you guys are going to pursue physics at a higher level, you'll see what I mean. The answer is C. 90 degrees. 90 degrees. This has come all the time as I repeat. 47. Which of the following relationships is correct for the combined resistance RT of resistors R1, R2, and R3 connected in parallel?
C.
C.
C, right? Yeah, I'll click on it, boy. Watch.
Easy.
1 over RT. That will be 1 over R1 plus 1 over R2 plus 1 over R3. And this is what would happen if you have resistors that are parallel to each other.
Parallel.
Answer. And
This
when
one
you
is what?
find like series.
Series, right?
Yeah.
Yeah. Tamakilani.
I was gonna say, right, so when you find for 1 over RT, right? And to find for RT itself, you have to invert the fraction.
Correct. You have to
Yes.
invert.
I reciprocate it. Okay.
That's why I just like, okay, the formula I just tell my students, just do this. So like RT could just be 1 over R1 plus 1 over R2, etc. to the power negative 1. You get answer one time.
Yeah, oh yeah.
B, I don't know what B is. I have no idea what B is. That looks like a combination of series and parallel, but that don't make any sense. B is definitely wrong. C is equal mine, right? That looks correct. D, some students might put D, but D is wrong. If you go to find the LCM here, it'll be R1, R2, R3, right? And when you actually work out the when you're working it out, you'll actually end up with R2, R3 plus R1, R3 plus R2, R1. And then you would reciprocate that. So they try to deceive you in part D, but this is not entirely correct. That's not entirely correct. So the answer is just 47C. Right? 47C, and that's for parallel circuits. Look. I just told you about this. A voltmeter has a very high resistance so that it can be placed in
Parallel.
Parallel.
right parallel and what? And what?
Not affect the circuit.
So that would
Not
be
affect the circuit. Because if it didn't have a very high resistance, it would the current, when it reaches this node over here, the current would split, and we don't want that. Do we want the voltmeter to be taking up any current from the circuit?
No.
No.
No, sir.
I want the current, I want the total current to pass through R. I don't want it to take current from the circuit. So that's why I wanted to have a very high resistance. So I could place it in parallel to a component and not affect the circuit. It's 48E. 49. Which of the following graphs illustrates an alternating current? Alternating current.
D.
D.
I need to explain why though, because some students
Positive,
might be confused.
positive to negative, positive to negative.
Yeah.
Right? Can you guys see that it's a, well, this is actually a square wave, right? Positive here,
Yeah.
then it dips down to negative. Positive here, then it dips down to negative. If you look at all the other options are remaining above the x-axis, implying that they're always positive. If they're always positive, they're always going in one direction. However, D is wrong because as you could see, positive, negative. It's changing direction. The current is changing direction. Everybody okay with that?
Yes, sir.
Sir.
Yes, sir.
Which of the following circuit arrangements is best suited for measuring a lamp's voltage? Here, what? If
Good
you
question.
yeah, talk to Mikelani.
And the question basically asking you, which diagram best represents the voltage over the lamp only.
Yeah,
Yeah.
and if you want to measure voltage across a component, you hook up the component. I see Simon raise his hand. Simon, talk to me.
Yes, sir. They just wanted to see if you know that you should put a voltmeter in parallel and not in
Yep.
series.
That is it. Simon, it sounds like you like electrical.
Yeah, it's nice, sir. It's nice.
So, guys, we just spoke about this. A voltmeter has a very high resistance. So you can hook it up in what?
Parallel.
Parallel. Right. Does this look like a parallel configuration?
Nope.
No, that's not parallel. Why? Because it's like the current will pass straight through it without being split. Nope, this is not correct. You know why this isn't correct?
Yeah,
The
because
voltmeter. Yeah, tell me.
because it that is the voltage over the battery, but I don't want that. You want over the lamp.
Correct. Yes, Kelani. Nikolai, can you see that the voltmeter here is measuring the voltage across the battery?
Yes, sir.
Right, this is not correct. C.
That's
Yes,
looking
sir.
correct. Yeah, that's looking correct.
Yes, sir.
Yeah, this looking like it. You know why? Let me explain something, right? So, how could you identify a parallel circuit? If you want to identify a parallel circuit, just know that current would split at the node. Are you seeing the current? Are you seeing the current splitting?
Say said load or node.
Yes, sir.
Node. This is a node. This is a node.
NODE?
Yeah, node.
Oh, alright.
Current would split. No, this is not correct. If anything, you're just measuring the voltage of the battery according to Kirchhoff's voltage law. If you do this, you're measuring the voltage across the resistor and the lamp. You don't want to do that. You just want to measure the lamp's voltage, not the voltage drop across the resistor and the lamp. This is wrong. This will be measuring the resistor, the voltage drop across the resistor and the lamp. This is wrong, guys. This is wrong. This is the only correct answer. Can you guys literally see that the voltmeter is hooked across the lamp in this one?
Yes, sir.
Yes, sir.
Right. Good. Which of the following circuit diagrams best represents a series arrangement? Guys, if it's a series arrangement, will the current split?
No.
No, sir.
Right, current will not split. So this is real simple, you know, you're just gonna draw the path of the current, and if it ever splits at a node, it's not a series circuit. Alright, let me go.
You're wrong for sure.
This is wrong for sure, because when it reaches this node, it's gonna split. Are you seeing this splitting?
Yes,
Yes,
sir.
sir.
Are wrong. This one looking fine.
Yeah, be looking like it too.
Are you seeing current splitting anyway?
Yes, sir.
No, sir.
They just try where to try to trick you.
Yep.
See wrong.
C wrong, right? Because watch. Look how we're gonna happen when C. We're gonna happen when you reach this node.
Split.
No, split.
Current will split.
And over here, that's definitely wrong because split here.
Yeah.
And then they go split here as well.
Parallel circuit.
So that again?
That is the standard for the parallel circuit.
Yeah, like if it's a parallel circuit, the current will split. Current will divide. Everybody okay with that? 51 is B.
Yes,
Sir.
sir.
Yes, sir.
Ah. What kind of logic gate is this?
As a
And-
AND gate.
and-
AND gate.
These are repeater. And these are what?
Sure.
OR
Oh.
gate.
Or gate.
And these are and
Yeah.
Sure.
if you're talking about just pure logic and it multiplies the input or adds the
Add.
input.
Yeah.
So here what? They are telling us that they want me to find the output at C and D when an input of 0, 0 is made at A and B. So over here is 0 and over here is 0. If that's the case, 0, 0 is going to be fed to the AND gate. And they're going to multiply it. With 0 by 0.
0.
0.
0.
Good. And 0, 0 is being fed to this one as well. What's 0 plus 0?
0.
0.
Right. So the answer at C and D is 0. What's the answer?
A.
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 Occasionally, they
So-
could change up the letter to X and Y, but it will still be the same answer. Somebody was saying something?
This is IT all over again.
I just had to do some ITNs.
No.
Basic.
Something like this.
I never met
Not
it
really.
this.
No, this is basic because you got circuit components and stuff in IT.
You would do that like in K computer science.
Yeah. Okay.
Right, so let me continue. Right, so using the information given in the circuit diagram, which pair of values of I1 and I2 is correct? So here what? You have to use the current divider law here. So if I want to figure out the current through the 4 ohm resistor, look how I'm going to do it carefully. Could anybody tell me what the total current is entering the node?
6.
6 amps.
Right, that's the total current entering before it splits. This is the total current. If I want to find I2, that is just going to be, let me ask you that question, right? Think about this logically for me. In which branch is the resistance more?
The I2, sir.
I2.
Alright, if the resistance is more,
Less current.
less current. Right? Because it would block more current. It impede the flow of current more.
Yes, sir.
And hear what I'm saying, right? Okay, where do you think more current will flow? I1 or I2?
I1.
I1.
Part of
I1.
least resistance.
Correct. So if we treating this as a fraction, which one would receive the bigger fraction? I1 or I2?
I2.
No, I1.
I1.
Oh, my
I1.
bad.
Because more current will flow through I1. So the logic is a bit reversed here. So if I want to find I2, here's what I'm going to do. I'm actually going to put the 2 ohms, the 2 over the 4 plus the 2. And I'm going to multiply this by the total current. So when I work, I just write it one time. The total current is 6. So when I work this out, it's going to be 2 over 6 multiplied by 6. The 6 and the 6 is going to cancel off to leave us with how much amps?
2.
2
2.
amps.
2 amps, right? Now here what? If the 6 amps is splits at this node and 2 amps is flowing through this branch, how much current do you think is going to flow through here?
4.
4 amps.
4 amps. And of course, if you wanted to do the calculation, you could have done the calculation. So if I want to find I1, it's going to be what over what?
2. No, 4. 4.
4 over 4 plus 2 times 6.
I hope all you understand why we put in 4, right? We put in 4 because wouldn't this receive the larger share of current?
Yes, sir.
Yeah.
Yeah. So I say 4 over 4 plus 2 multiplied by the total current, which is 6. You're going to end up with 4 over 6 multiplied by 6. 6's are going to cancel off, and that's going to leave you with 4 what? 4 amperes, right?
Amps.
Good afternoon, sir.
Good afternoon.
Sir.
And this is a question that is repeat all the time. But see, now we just seen that, okay, I did this question with my students before, right? But since it's the first live that most people therefore are doing the full working, The answer is 4 and 2. So
So you
4
could
for
just, you could,
I1. Yeah, say that again, Kilani.
you could just say where you get the 4 plus 2 from.
No problem. So we're treating this as a ratio, right? We have a 2 ohm
Yeah.
resistor here, and we have a 4 ohm resistor. So if you're combining the two numbers, you get 4 plus 2, which is 6.
Oh, yeah. All right. I just didn't remember now.
No problem. So watch. If I want to find I1, I'm going to take the bigger number out of the 2, because it's a smaller resistor, more current going to pass through it. So I'll
Yeah.
say 4. I'll say 4 all over the sum, which is 6 multiplied by 6.
Oh, so
I
is
get
he yeah. So is the sum over the actual total resistance?
yeah. If I want to find I2, let me do I2 again, right? Tell me, Kilani, if I wanted to find I2, how I find it for I2?
I2, that would be well 2 over the 4 plus 2, because that is the total resistance.
And I multiply that
Multiply
by
the
what?
total current, so
Yep. And I'll give me 2. You understand it?
yes, sir.
Right.
You just take the total amps for one of the one of them and then put it over the total resistance.
Well, you're taking, okay, if I want to find the current for 2, I'm going to take this resistance and put it over the total resistance. I'm going to add it. 2 plus 4 is 6.
Yeah.
And I'm going to multiply that by the total current to find a fraction of the total current.
Yeah.
So I1 was 4 and I2 was 2.
Yes, sir.
As soon as we're done with this paper, we're going to speed through the rest. Trust me.
Repeats.
All right, sir.
54. This I repeat. Most suitable for the core of an electromagnets. We're looking
Soft
for
iron.
Soft iron,
Soft iron.
Soft iron.
temporary magnetized.
Yeah.
right. Right, soft iron core.
P is equal to
55.
E.
Wait, according to the Rutherford Bohr model of a neutral stable, this I repeat as well. Right? If it is stable, okay, think of it in terms of charges, right? For something to be neutral, the positive charges will be equal to the what?
Negative charges.
Negative charge.
Right. We know that electrons are the negative charges, quote unquote negative charges, and the protons will be the positive charges. So for this to be stable, then E is supposed to be equal to what?
E.
P.
Neutral.
Right. So the answer is B, right?
Yes,
Yes,
sir.
sir.
Because if it's neutral, then we're assuming that the positive and the negative charges would be equal. So they would cancel off to be neutral. So B. 55B. Which of the following symbols would be possible for an isotope of a nuclide represented by AZX? Wait, somebody just remind me, right? So the top number, what do we call the top number? This is the what?
The mass number.
Mass
Mass
number.
number.
And the mass number represents the what?
Protons and
Yes.
neutrons.
Protons
Plus
and
neutrons.
neutrons.
Yes, sir.
And this is the atomic number.
They're just
This
protons
is
alone.
protons alone.
Just proton.
Protons alone.
This is just the protons. Now, for something to be an isotope, it must contain the same amount of protons but different number of.
Neutrons.
Neutrons.
Right. So it must. Okay, Z is going to remain the same. That's going to remain the same because that represents protons. However, we could change up A. We could change up the A, right?
Yes, sir.
So,
Yes, sir.
hey, okay.
So
Just by elimination, you can figure out the answer. Like
D.
Kelani, you explain it to them.
Yeah, because as I say, like if you have three answers that looking similar, the one that is opposite is normally be the answer.
Yeah. Because like in all these answers, they're changing the atomic number. This is the one answer where the atomic number remained the same. So, Steve.
Yeah, and you could calculate neutrons by subtracting them.
Yeah, can't really do that here because it's letters.
Now we're just in general now.
Yeah, in general. Let me know if you guys understand that.
Yes, sir.
Yes, sir.
So
Yes, sir.
All right. So if it's an isotope,
I understand it. I'm gonna tell you how. It's because always remember that the mass number is always the proton plus the neutron, and the atomic number is just the number of protons.
And if it's an isotope, the number of protons had to remain the same. So Z had to remain the same,
Yes.
right?
Yes, it does.
Which of the following cannot be deflected by a magnetic field?
Gamma rays.
Gamma rays.
Gamma.
Gamma rays.
Because gamma
Rich
rays,
men in
Oh,
Vegas use
abbreviated.
expensive gadgets. I remember it.
Yes, Anisha, you don't know.
right? Gamma
There you go, man.
rays, they are not a particle, they're just radiation. They're just electromagnetic radiation, and they don't have a charge. If it's not charged, it will not be deflected by a magnetic field. All right, so the answer is C. 58. Right. Iron is easily magnetized, right? And steel actually retains its magnetism well. So where's the answer?
B, sir.
B.
Mm.
Right? Somebody
Oh,
say
my
A?
bad, my bad,
No,
my
it's
bad,
B.
my bad. B.
Iron is easily magnetized. However, steel might take a bit more convincing, but it's like it will retain its magnetism better.
My bad, sir. I thought it was still talking about iron. I didn't see the steel.
Oh, no.
Radium is mercury, sir.
Yeah, wait. I had to do this for my Guyanese people. I don't know the tradition,
Creamery.
right?
Murray, you don't know.
Maria.
Chicken curry. We say curry chicken. I say chicken curry.
Nah, Anisha lost me there.
It wasn't meant to be funny. Oh my gosh.
Lost me there, Anisha. I can't tell my mother I feel some chicken curry. What kind of language is that?
Because you feel it for chicken curry is my fault. Hey.
Bro, down here we say curry chicken, bro. Don't know about no chicken curry.
Real talk by Simon Boy.
Right, let's move on. 60. Which of the following equations is correct? This I repeat as well.
C.
See, rest
No,
of them make no
See.
sense.
no sense at all, right? For it to be correct, the left-hand side must be equal to the right-hand side. We know alpha
Yeah.
is just a helium nucleus of nature, which is
4,
4, 2.
2.
You don't know.
When you add up this way again,
26.
6.
226.
226.
88.
And when you
88.
add 2 to
88.
86, you'll get 88.
Hey, watch out for A. I was tempted to put A, but then I didn't see the beta part of that
Yeah,
first.
same.
That is why I skim through the question. I read the question, I skim through the answers. I play any, mini, miny, mo, and whichever one my finger land on, I correct. I put it.
what?
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 No.
Not really,
Nah,
not really,
something
sir.
wrong,
No.
something wrong.
So not
It don't
really,
work
not
like
really,
that,
not really.
Renisha.
No, that's not what I meant. I meant I skimming through the answers and I'll pick the one that's suitable. I
But
wouldn't
wait,
do that.
where are any mini miny more come from then?
Oh, that was just a thought in my head to make all the
Playing a
Nah,
laugh.
game
she
of
lying, she
probability,
lying, she
Renisha.
lying.
She's
Renisha, you
tell us,
playing
she
a
tell.
game.
Now she doing chem today.
Renisha, you,
No, I never do that in chem. You're mad. I study for my thing. I don't think.
Renisha, you,
Nah,
Renisha, you
already
playing a
she's
game
tell
of
us yourself that.
probability.
I never do that.
Hey, wait, tell people on YouTube that seeing it cooked. Oh yeah, it's just the same questions that's come over and over, you know. It's the same questions that has come over and over people
It's
on
physics,
YouTube.
dog. It's physics, not that
Like
hard.
it's not hard. Like it looking hard here, but like we don't know that paper, no? And you can see how easy
Let me
it
speed
is.
on. Let me speed on the next paper.
Yes, sir. Speed run, speed run.
There we go. This paper kinda arrange a bit funny.
Speed run, sir. I only come in that half of this paper. What if I ain't ready yet?
You're gonna be fine.
Okay.
We take it reading at the bottom of the meniscus. That like like
7.5, sir.
Yeah,
Yes,
7.5.
sir.
5.
You don't know.
Alright, 7.5. This I repeat as well. Mass
kg
is
meter per second squared.
Oh,
Just to be C. No. D.
D.
D. Yeah.
right. Remember, we measure mass in kg. We measure acceleration in ms minus 2. So kg ms minus
MS
2.
minus 2. Yes, sir.
Right. 2d. Right. This I repeat. We
X
just
plus
did
y to
it.
the left. B.
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 Right.
C.
Because I want you to stay still now. If I want you to stay
So
still, I
I'm
want the
taking-
net supposed to be 0.
Yes, we
Don't
want
know.
to put forces. Yes, sir.
Proper.
Right.
Sir.
We do this already, Kilani. Like,
Wait.
okay. The deeper something goes, the greater the
Depth.
pressure is gonna be on it. The
Pressure.
pressure is gonna be on it. So if I make the wall thin, what happens to the diamond ball?
The water pressure increases with the depth, so
And it will ram to it.
it would
Implode
it
it.
would it would like go down more, like sink.
No, it would implode.
Oh, my bad.
Wait, peak knowledge here.
No, bruv. Jaja.
That is what will
Gotcha.
happen. No, this is a good example because like this is what will happen. This is what gonna happen, you know. Kelani, the
Yes,
deeper
sir.
you go, the deeper you go in the ocean, the pressure is going to increase.
Yeah. Because it come like if you go deeper, your airs would have more air like pressure.
Well,
It would gain pressure.
the reason for that is because more water pressing down on you.
Oh,
That is why. Think about it, right? Think about it. Deeper you go, it like isn't the volume of water pressing down on you a lot more?
yes, sir.
Yeah. So the reason it has to have a thick wall is because the deeper you go, the pressure on the ball is going to increase. You don't want it to implode,
No.
right? So the pressure gonna be high. So
You don't wait to collapse.
you don't want it to collapse on itself.
Yeah.
Yeah.
Jaja.
Oh no, sir's dying.
So that no, it's a joking. Cough, cough. Cough, 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 cough. You know what I mean? Oh, they don't get dark humor at all, boy.
Oh, I get it. I
We
get it.
get dark
Yeah.
humor, but you kind of sounded a little inhumane about our submarine, you know.
It's just like no, it's just I am sounding a bit inhumane, but it's a practical example of what could happen if you make the walls too thin, right? You want the walls to be thick so it doesn't implode on itself. You want it to be able to withstand the pressure.
Yeah.
Yeah.
The pressure
Is
is
that-
getting worse,
it-
sir.
It's a sad example, but I don't think that was a logical. That wasn't really logical. I think this was logical.
Rich
You
people
well,
doing
yeah.
rich things,
Yeah.
sir.
So, you know what I was thinking at that time? I was thinking, what kind of smart person would do that kind of nonsense?
Exactly.
Somebody that not smart, simple. But rest in peace, their souls. No matter what kind of person, that's not a good way to go. That's a really sad way to go.
Yeah, that's
And
a
I
sad
really-
way to go, especially underwater. That hurt my
Yeah.
heart.
What you could do, right?
Press F in the chat. Press F in the chat to pay respect.
Fail.
All right. This we do this already. Is a velocity time graph. Over here is a constant. Over here is constant. Over here is what? The velocity.
Deceleration.
Acceleration.
Right, over here is
Constant.
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 Acceleration.
Acceleration.
The other side will be
Constant.
constant. I remember this
It
before.
not going to its starting point, so one wrong.
This is definitely wrong.
That's wrong. It's 2 and 3.
The only way you could figure this out is if you have a displacement time graph, and we clearly don't have a displacement time graph.
No. Just velocity.
Right? So it has zero acceleration between times t2 and t3. It has zero acceleration between it's accelerating here. Is it accelerating it?
No.
No.
Constant velocity.
Constant. So this is correct. It's not accelerating, it's just flat. Its velocity at t4 is the same as the initial velocity. That's true.
True.
That's true. So 2 and 3. This I repeat as well. Right? 2 and 3. This I repeat again.
Momentum is kg ms minus 1, so
Right? Because it's mass by velocity. So kg ms minus 1. The answer is
B.
In Batman.
So what happened there in A, the part that just to fool us, but they don't know. We know their joke. We know their
I know their game.
I played these games before.
exactly my point.
The next one is 10 newtons, guys.
so I repeat as well.
Yeah, that's a
Because-
repeat.
Because remember, acceleration is 5/2. Acceleration will be 2.5. force is equal to mass times acceleration. So 4 by 2.5, you're getting.
He says the goat, and
Yeah.
Sir still going through working, even though we know the answer. That's a goat.
Yeah, he's the greatest of all time. After
Don't
God,
know.
though.
You don't know.
Yeah. Godson, man, you know.
F1 D1 plus F2 D2, sir. You don't know.
Yeah, this I repeat,
Yeah.
this I repeat.
Yeah, repeat.
I'll go
Just
into
like
that.
that.
I'll go into for you people, just real fast. If this is the pivot, I want you to imagine what would happen if I push down on it on this force. What would happen is it would go like in this manner. Right? So this looking like a what type of rotation?
Clockwise.
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 Alright, this is a clockwise rotation. Again, this is the pivot. If I push down on it over here, it's gonna want to rotate like this. This is looking like a what kind of rotation?
Anti-clockwise.
Anti-clockwise.
Sorry, someone is asking about number 4 in the chat.
Number 4. Number 4, this one?
So I just wanted to see the answer. Thank you.
Oh, no problem. Right, so imagine you have a pivot here and you were to apply a downward force here. It would want to go in this direction, which is anti-clockwise. We're not interested in anti-clockwise. We want to find clockwise moment, so we don't care about this one over here. If you pull upwards, it's going to want to rotate in this direction. This looking like what kind of direction?
Clockwise, sir.
Clockwise. If you recall, if you want to find moments is just force by the perpendicular distance, right? From the pivot, of course. So this is the pivot here. The distance is d1 and the force is F1. So the moment would just be F1 d1. And that's not the only clockwise moment we have. We also have this one. So the pivot is here. It is a distance of d2 away from the pivot. So that's going to be d2 by the force, which is F2. So that will be F2 d2. So my answer is D. All right, let's move on. 8D.
Sir.
This I repeat. Earlier, if we're talking about fluids, the formula for pressure is height by density by gravity. So if the height increases, what's going to happen to my pressure?
Increase.
Pressure has to increase.
Correct. Earlier, where's the height the greatest?
Q.
Q.
Let's see now, right? The height is the greatest at Q.
Yes, sir.
Cool. I hear my son Nikolai. Nikolai, you okay?
Yeah, sir.
All right, Nikolai, help me with this one. This is also a repeat. We do this already.
C.
All right. This is Nikolai question. Nikolai, read it and try to understand.
A piece of string is tied onto a small stone and then the stone is totally immersed in water. The tension in the string will be less than the weight of the stone.
Right. Let me explain why fast. So if you're on air, you have a string here and you attach a stone to it. The stone will pull the string in what direction?
Upward.
No, downwards.
Oh no, sorry, man. I talking about the tension.
Oh, okay. The tension will be upwards, right? This is the tension. But why?
Yeah,
The
because
tension. Talk to me, Kelani. Talk to me.
opposing forces, because tension is an upward force and the stone actually pulling the weight downwards.
So that is why it balanced, right?
Yeah.
That's why it did. Now, if I were to submerge this in water, guys, anytime you put something in a fluid, the object would experience a what?
Buoyant force.
Right? It would experience a buoyant force. So that would push up on this. So if it pushes up on the stone, will the tension increase or will it drop?
The drop.
That's
It
the
will
drop because you're getting help from the fluid.
Yeah.
Yes, it gets any help from the fluid. The fluid kind of pushing it up a little bit, which will decrease the tension. Tension is going to drop because it's getting help from the fluid. The fluid is pushing it up, right? So the string will have to do less work. The tension is going to be less on the string. So it makes sense that this is the answer. It's going to be less. The tension is going to be less than the weight of the stone, because In air, it just have the weight of the stone, again ignoring wind resistance and whatnot. But if the stone is in water, you have the upthrust of the water, and that's going to reduce the weight of the stone. Well, it's gonna like simulate that. Okay, it's gonna make it feel like it's lighter because the water is pushing it up. So if the water is pushing it up, it's reducing the weight of the stone, making the tension less. So the answer is C, less than the weight of the stone. Why? Because if you're in a fluid, the fluid would push you upwards, and that kind of reduces your weight in a sense. But of course, once you come out back from the ocean, you're gonna be the same weight. Big up Fat Man Bob.
One time.
I have a theory, guys. A little thing Fat Man Bob. Why Fat Man Bob is moto moto? I think about that for a bit.
How we jump from Fat Man Bob to Moto Moto?
What if Fat Man Bob is moto moto?
What are you
That's
talking
the
about?
big
I
shot.
lost.
Is he talking about the hippo from Madagascar?
Yeah.
But Fat Man Bob, we thought
Oh,
Fat Man Bob was a human. I thought Fat Man Bob had a daughter. What?
Yeah, I thought he was human. I didn't know he turned hippo overnight.
Well, he looked like a hippo, so
so this one is master.
So that's not nice.
Shania, I feel like I don't mean the jokes in a bad way, it's just like I don't mean it, it's just
I
so
know,
jokes.
but sir, you just say it so dry and just
Sorry.
Man,
how
Bob. What I
you do
name
Fat
feelings.
Man Bob?
Fat Man Bob is a strong guy, He's a strong guy.
Plenty
Fat Man Bob real
muscle.
cool. I know Fat Man Bob is my partner, Fat Man Bob is my partner. So 11. Which of the following properties remains unchanged in a substance without increase in temperature? We just look at this. Is
Mass, you don't
mass.
know.
The amount of
Mass.
the amount of matter in an object never changes. When a ball is thrown vertically upwards and reaches its maximum height, it has what?
That's not. Let me just
Maximum
soak in this
potential
there.
energy.
Thrown vertically upwards. Or maximum height. That would be a maximum
Mm,
potential energy.
Correct.
And
So that would be
minimum
D.
kinetic energy.
Think
yeah,
about it
minimum kinetic.
logically earlier. Think about it logically. What increases with height?
Potential energy,
Potential energy.
gravitational potential energy.
Right. Gravitational potential energy increases with height. So if it reaches its maximum height, the potential energy is going to be the maximum. And when it starts to fall again, that will be converted to kinetic energy.
Yes, sir.
Are you understand that, right?
So
Yes,
because
sir,
when the
because even with
maximum
the formula,
Even with the formula, yes. The
yeah.
formula is mass by gravity by height. As you can see, is a product of mass, gravity, and height. So the height increase, the answer would increase.
and you could also make reference to the pendulum. So like if when the pendulum moves to the other side and reaches maximum height, that is the maximum potential energy right there.
Sir.
Yeah.
Yeah, you can say
And
that, yeah. Yeah, that's good.
and so it could be
Okay.
maximum kinetic energy because at
Yeah,
that
because of
point in
motion.
time,
It's
yeah,
stationary. It's
yeah,
station. And earlier, that is why in maths, when you're looking at these curves, you actually refer to this as a stationary point.
like
Ooh, good, yeah.
like there when
Well, no, that's
slope of the line
because when I see the
is
question, I just think about it like if it's a graph, like an actual graph that happening, because it have graphs like this that's similar for like the velocity time or the acceleration graphs.
Yeah, they are. Yeah. You have graphs. Because like when you throw an object, the general trajectory is like this. It's general trajectory, depending on how you throw it up. The angle at which you throw it up.
you find a tangent line at the top of the curve where it's
Yeah, you do
zero rate
that.
of instantaneous change.
Yeah, you do that. If you don't have the equation of the line that is, the equation of the curve. If you do have the equation, you gotta have to do that. Because they can't differentiate it.
I see.
Everybody okay with 12?
Yes, sir.
Because I could literally reach its maximum height, If it reaches maximum height, the potential energy gonna be the highest. Alright, move on. 13. The time period of a
Length
simple pendulum oscillating with a small amplitude depends on the what? Nikolai,
length
remember
of
this
the
one?
pendulum.
Nikolai.
See the length of the pendulum.
Right. I'm going to look with that. I can't do this real fast.
Polypod,
Have,
sir.
have our audience here. Not polypod. So I'll show them. Right, let me show the people them because I have our audience here. So I'll show you how this does work. Watch this, right? Oh, you see in your screen?
Yes, sir.
Yes, sir.
Right. So here what I'm going to do, right? I'm going to put it at its biggest length. So I'm going to displace it. All right. Let's see now it's moving, right?
Yes, sir.
Period trace. Okay. I'm going to change the mass, and I want you to tell me if anything's changing.
The speed. Is it?
Nothing
No,
really changing.
nothing
Watch.
changing.
Nothing changing. Are changing in mass? Are you seeing anything changing?
No, sir.
Okay, so the mass doesn't affect it, right? Here what? I'm going to change the length now. Whoa.
Oh, that's a spiral.
You spin my world right round. You know that song? Yeah. Watch. Right? Watch. I want to increase the length again. What happened to the it gets slower, right? It
Yes,
gets
sir.
slow. Whoa.
Whoa. My head's spinning. Just now. Slow on.
Everybody okay with the relationship?
Yes, sir. I
Okay,
don't
cool.
know.
It's like that song. You're spinning me
I
around.
feel like I
My
get
feet
dizzy
are off the
days.
ground. I don't know where. I can't remember the lyrics.
I'm trying to remember the name of that song. I think it's
Feel
like
like I
Imogen Heap. Is it Imogen Heap? Is that the singer?
feel like I drink
I'll
rum
look for
lately.
it. I'll look for it.
You're spinning me around. Yeah.
The name is Imogen.
Oh, sorry. She real tall, boy. Nearly like 1.9 meter tall. That's crazy. Well, close like 1.83. That real tall. Hey. But like, yeah. All right. So
Yeah, but the
everybody,
name of the song though is Sunday, and well, by the Cranberries.
oh, cranberries. Okay, cranberries are some good bangers, you know. Yeah. 13C. Length of the pendulum. I hope you can see it for yourself, right?
Yes, sir.
Yes, sir.
All right.
Repeat
Okay, this I
question.
repeat. This I
1 and
repeat.
3. 1 and
1
3.
and 3.
You don't know.
Yes.
Right? 1. The elastic limit was
Melanie.
exceeded. You see it now over here. These are like it stopped obeying it over here. It become naughty. And 75 over 10 is 7.5. So 1 and 3. Right? Cool. Kelani, somebody call your name?
Well, I don't know.
All right. Which of the following is our SI base unit?
C.
Amperes.
Ampere.
Amperes. Amperes is our SI unit. Current is our SI unit. Right? Cool. Like, okay, watch. If you're confused, watch. It literally have a formula for voltage, you know. V is equal to IR. Right? R is equal to V over I. Right?
Q
Cool.
equal IT.
But like what I'm trying to say is amperes is a SI is like a fundamental, like, you know what I mean? It's just there. It just there. It's a fundamental unit.
Yes, sir.
Can't be broken down. It's just there.
It can't be broken down. Which of the following implements are designed to take advantage of a large moment produced by a relatively small force? A crowbar is that one for sure, right? I don't know how a crowbar does work.
Yes, sir.
Where's our claw hammer, buddy?
So I know what this look is a kind of metal bar and it have something like a hook turn this way. Not really all the way down, but like
Let me look it up.
Tweezers.
Because I don't know what
Mouth.
claw hammer does look like. I don't know what that does look like. Claw hammer, what that is, but
I think you just see that in Papa Joe
oh
on the puppy
yes,
channel.
sir. All are we accustomed with that? All are we just see that growing up? Father, let's have it. Yeah. Watch, this is a claw hammer, guys. Wait, take a mask.
my grandfather had one.
Okay, watch. This we are accustomed with this. This. And all are accustomed with that. Are they seeing the
I
screen?
not seen anything.
Oh, are they seeing
Oh,
it?
yeah.
Oh,
Yeah.
I accustomed
yeah.
with that. I accustomed with that.
Oh, just a normal hammer.
I
That's how
just
it's
use
It's
used
just
in
we
the
we
the
not accustomed.
claw hammer because how the back have the two kind of like prongs. Like when a nail, when you're pounding it, if you want to pull it back out, you just slide it and then pull it.
And that would be an example of moments. Because
Yeah.
wait, give me 1 second.
So I realized one of the things to bring at all is levers. So
This is an example of levers.
yeah.
Alright, so
But
watch.
So, and now
Wait,
making sense, you know. And now scientifically making sense. Like, oh my gosh, they were showing me physics when we was younger, but we didn't think of it that way. Oh my god, oh my god.
physics is everything. So earlier, if I wanted to remove that nail, right? Enter would watch. This is some distance away from it, and I would apply a force here. Is that not
yes,
moments?
sir. Yep.
And a crowbar is like the same thing more or less, the same thing for a crowbar. I don't know how a pair of tweezers go be using moments. That don't make any sense.
No.
Right, 1 and 2. 1 and 2. Are you okay with that?
Yes,
Yes,
sir.
sir.
One of the things
Yes,
they do
sir.
test is like they doesn't test you on like first class levers, second class levers, third class
Oh, no,
levers.
they do that. They do that. Never see that.
Yeah.
17.
Done.
Gas. Yeah. There are no attractive
Haphazard.
forces between molecules in a gas. Yeah, because
Arrange
gases.
haphazardly.
Yeah, gases like move haphazardly. They're all over. They're like very far from each other. They don't want to be with each other. They're like they know they're fresh out of a divorce. Yeah. 17D. Which of the following statements about the pressure law are true? Earlier, it's literally the pressure law, right? Okay, anybody can tell me the pressure law?
What
Yes,
in
sir.
this concern?
P1 over T1 equal P2 over T2.
Right.
Oh, yeah.
Obviously, the
P1
pressure
over
can
2.
obviously the
So
pressure can be
volume is
constant, right?
constant.
Right? So in other words, pressure is directly proportional to temperature, granted that it is in Kelvin. So if pressure and
Absolute.
temperature changing, well, obviously the volume had to be constant, right? Like everybody
Yeah.
was saying,
Yes, sir.
the volume is constant. Right, so the ratio of the pressure to Kelvin temperature is constant, yeah.
It is true.
Right, pressure over temperature, right? Volume is constant, yeah. Nope. No, how? That don't make any sense, right? It's literally the pressure law. How the pressure gonna remain constant? You know what I mean?
It
1 and
makes
2.
no sense.
Okay with that?
So
Yes, sir.
you're a
Cool.
high frequency boy. Oh, good.
19.
35 to 44, you don't know.
Well, I don't know if it's Mrs. Matt vibes, 35 to 100. Yeah.
Oh, well, I guess
We
So
don't
you
get
go
it.
make somebody put on the test, you know. You could have make somebody put on the test.
But I don't know about Ollie, but Mrs. Matt vibes real hot. You know what I mean?
Oh my god.
100 degrees Celsius. 100 degrees Celsius right there.
And so we have officially entered the Queen's birthday month now. So you know.
Yeah. We have. I can't put a picture of Mrs. Matt vibes, but I'll just put that 10 out of 10. I've had it. I
Hey,
gotta
the
like
Riz,
clip
the
this.
Riz,
I
the
gotta clip
Riz.
this part and show shit.
Oh my god.
Hope she
What
watching
does
this.
these children say these days? So that was so cringe, but it was kind of cute though.
Exactly.
Oh, yeah, stop eating erase. The specific latent heat of vaporization of water is the energy required to change 1 kg of, 100 degrees Celsius.
No
It
change
had
in
to be
temperature. No change in temperature. So it's
no change in temperature, right? This is wrong. This is wrong. This is wrong. But it's the phrase, it kind of weird. You know, like when I think latent heat of vaporization, I'm thinking about, liquid to vapor.
yeah.
What do you mean 100 degrees Celsius to steam at? Kind of weird.
I think
Kind
they
of funny
mean like
sounding.
Well,
it's
because when
like
they said out, like, because how we're not changing exactly state, I would have think, MC delta theta. Not really. Not really this one.
Nah, it can't be
So
MC
when I read
delta
it,
theta. It can't be MC delta theta.
Sir, I'm thinking it's like 100 degrees liquid to
That had to be
steam
it.
at 100
Yeah,
degrees.
that had to be it.
No, but like that had to be it, right? But the phrase is kind of funny because I would have
Yeah,
say 100 degrees Celsius water to steam at 100 degrees Celsius. That's what I would have say. But this
yeah, true.
kind of funny.
Oh, hold on, sir. Because it said to change 1 kg
Oh,
of water at 100
oh,
degrees C.
this is what is
Oh yeah,
happening when you
that
don't
don't
read it
make
now.
more sense.
This is what is happening when you don't read it. Let me read it back now. The specific latent heat of vaporization of water is the energy required to change 1 kg of water at 100 degrees Celsius to steam at 100 degrees Celsius.
It makes
This
sense
is what is
also.
happening when you don't read. Right? But if you see latent heat of vaporization, just know no change in temperature, 100 degrees Celsius. If you see fusion, just know we're talking about 0 degrees Celsius and we're talking about ice. Let's move on. 21. These are repeat as well.
B doubled.
B
We
double.
doubled. But why? All right, so the energy required to change the state. So, okay, for this example, let me just use E is equal to MLV, right?
Yes, sir.
They say the mass of the substance is doubled. Okay, so I got to double the mass. If I double in the mass, I will say 2mLV. Now, we see MLV somewhere. What does MLV represent?
E, so it's just 2E.
Yeah, it's just 2E. So the energy is doubled. Everybody okay with that?
Yes, sir.
Yes, sir.
Badness. 22. A metal of mass M requires energy. These are repeats.
E over M by T2 minus T1.
B.
So that's D.
D. Right, and let me just run through the working for anybody that might be confused. Because it wasn't there when it was doing the lives. For what reason? I don't know. It should have been there. But we're talking about a change in temperature. So E will be equal to mc delta theta. I want to find specific heat capacity. So I want to make C the subject of the formula. So I would have to divide both sides by m delta theta. Why? Because I want to remain with C. So I have to cancel off everything that is not C. If I do it on one side, I'll have to do it on the other side. So C is going to be equal to E all over m delta theta. And delta theta is just T2 minus T1, not the other way around. So some of you guys would have put C. Anybody can tell me why putting C is wrong?
Because
Like,
it's
Because
T1
T1
take
cannot
away
minus
T2.
T2.
Exactly.
You get a
It's
negative.
highly illegal.
It's the
it's
final
supposed to
minus the
be,
initial.
yeah.
So 22D. Right. 23. Which of the following materials is both a good absorber and a good. Hey, we're looking for something that's black.
D.
Black surfaces are good
E.
absorbers and emitters.
D.
Anytime you see absorber and emitter, black. Right? So D.
Here we can agree one on the guys.
Why? If something is okay, if a surface is black, wouldn't it absorb a lot of heat?
Yes, sir.
If you absorb a lot of heat, wouldn't you become hot?
Mhm.
And if you become hot, wouldn't you have the ability to emit heat now because you're hot?
Yes, sir.
Yes, sir.
Okay.
So that makes sense. 23D.
So
A
it's just
flat.
kind of like if you go outside wearing something dark, you will pull in heat and you will become hot rather than if you wear like something that's white.
Correct, because the white would reflect the heat. 24. This is a repeat. We want to convert water to steam, so immediately you have to absorb heat, right? You have to absorb. Everybody understand, all right? Because you're going from water to steam.
Yes, sir.
Yes, sir.
Yes, sir.
And when you multiply this, we did this before, 2.26 by 10 to the power 6. Okay, if you're confused, we're looking at E is equal to MLV, right? Because we're looking at specific latent heat of vaporization, this formula here. Our mass is what's saying, boy? Our mass is 0.01 and our latent heat of vaporization is 2.26 by 10 to the power 6. Another way I could write the mass is just 10 to what power?
Minus 2.
Right. When I multiply this out, I'm going to end up with 2.26. And 6 minus 2 is just what?
4.
Right. Anytime you have the same base and you multiplying, you add the indices. So 6 plus minus 2 is just 4.
A.
So we're looking at absorbed heat, and we're looking at 2.26 by 10 to the power 4. So I'm looking at E. Are you okay with that?
Yes, sir.
Right,
Yes,
cool.
sir.
And I just
Right.
gonna be shitting. I just gonna be shitting like I'm going mad on that paper tomorrow.
Right? Okay.
Really?
Which of the following diagrams best illustrates convection current in a liquid? The answer
B.
is not
B.
E. Is not E. I know some of you might be tempted to put E. I'm looking at you. You. Yes, you. It's not E. It's B. It's B. B is the correct answer. Right?
Rises and falls.
All the others are false. Because here what, right? The bottom of the beaker is in direct contact with the flame. So the water at the bottom is gonna get hot. First, it's gonna get heated at a faster rate. If it heats up, it's gonna expand and it's gonna rise to the top. It's gonna cool down, and it's gonna get quote unquote heavier, and it's gonna sink back again. And this whole process is going to repeat itself, and that's gonna create the convection currents. Right. So 25B. 26 is a repeat, real easy.
Water is a poor conductor of heat.
Yeah.
Right. Water is a poor conductor of heat.
That's why the ice wouldn't conduct heat.
For a long time.
Right. Cool. We do this already. So they're saying her left hand feels hot. What type of EM wave carries heat?
Infrared.
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 So L is IR, right? And her right hand gets tanned. What do you wear to get? Where do you wear? What do you? Oh, guys, what do you wear to prevent yourself from getting tan?
Sunscreen.
Sunscreen. And sunscreen is block what kind of rays?
UV rays.
UV.
Right. So the answer is
D.
D.
E.
D.
Infrared and ultraviolet. By the way, if you didn't notice, ultraviolet is the long word for UV rays.
Yay, something new.
I didn't wait.
No,
Seriously, Vanessa, are you sure?
Seriously.
I didn't hear that in my life. You know, you serious?
Serious UV
What?
rays is
Never know
ultraviolet
that.
rays.
Anybody else know that?
Oh
No,
I
I
didn't know
never
that.
know that. Oh my gosh.
Oh
Well,
my
you see, it
God.
learned something new.
Thank you, Anisha. We appreciate you so much.
Thank you. Oh my god.
That is some extravagant news. That is some extravagant, life-changing news.
So they didn't recognize that?
I don't think so.
And did anybody know that IR stands for infrared?
What?
Oh,
I did.
yes.
That is
Mind
crazy.
blown.
I
What?
didn't know.
Mind blown.
No way.
It's shocking, right? It's shocking, right?
Yeah.
All right, let's move on. By the way, all the people in the class, tell the people on YouTube what to do.
Well, they know to
Subscribe.
subscribe. You
Subscribe
don't
your
know.
post
Subscribe.
notifications.
Subscribe and TikTok
Subscribe to
follow.
get our grade on in physics.
You're
Yes.
gonna
sir.
subscribe on YouTube. You're gonna subscribe on TikTok and all major platforms. You're gonna make that lovely subscribe button gray. We don't want it to be red. And turn on those notifications for when Sue is live.
Proper. Proper.
Send it to your friends.
Right. And don't unsubscribe, eh? Don't unsubscribe. And if you forget to tell them that part, don't unsubscribe.
Don't unsubscribe, eh? That is
No
having no
unsubscriptions
dumpling.
over here.
Become part
Right.
of history,
That's
guys.
having no dumpling. Don't unsubscribe. That's having no dumpling. Have dumpling.
Right. So this is a repeat too. A student carries out an experiment to determine the specific heat capacity of a solid using the electrical method. Which of the following equations should be used? I got speed run this real fast. We know that E is equal to MC delta theta, right?
Yes, sir.
Right, cool. We also know that energy, well, you know that power is equal to energy over time, right?
Yes, sir.
Yes,
And if we dealing with an electrical method, we'll be talking about voltage and current. So where are getting power from? Well, power is just what?
IV.
Power is IV, right? So here's what I'm gonna do. If power is equal to IV, then I can replace P with IV. And so IV is gonna be equal to E all over T. I'm trying to find for E so I can make a replacement for E, right? Because I'm getting my energy from a electrical means. So I'm going to multiply both sides by T to cancel off with this T to make energy the subject. So E will be equal to what?
IVT.
E will be equal to IVT. Good, good. So if E is equal to IVT, I could replace E with what?
IVT.
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 So IVT now is equal to MC delta theta. I am trying to find for C, so I gotta divide both sides by what?
MC delta theta.
No,
M
M delta.
delta theta, my bad. M delta theta.
Nah.
Nah.
If I'm money bag there, bro.
You formally bag.
Nah. I'm a redeem.
So where's the answer?
C.
C.
Yes, sir.
Next question is Simon, that's it.
Right. Right, next question is for Simon. I'll tell you, call it quarrel with them, and it instantly jump up to 867. I ain't even joking. Watch.
What?
6.
Yo. Badness.
That number.
People on YouTube, subscribe. Alright, Simon, this one is for Simon. Simon, ready, mister? By the way, this question has come all the time. They don't change it, right? IVT over M delta theta. IVT over M delta theta. Remember that.
Alright, sir.
Yeah?
PS.
You don't know.
Big up.
Proper.
Because
Redeem.
because the wavelength is the distance between two successive
points. Two successive points in phase. So crest to crest or trough to trough alignment.
Correct.
Fully redeemed, boy.
Good, sir.
I was asking for Aidan, and I was like, where Aidan there, boy?
We reach.
Good. I'm gonna let Simon help me with this question. Simon, help me with this one, Simon.
Oh, sir. You want me to read it?
Redeem yourself even more.
Alright, sir. Which of the following equations expresses the current relationship between the wavelength, lambda, speed, velocity, and frequency f of a wave? So I know that the velocity is equal to lambda f. So I want to find f. I divide both sides by lambda. So I get f equal lambda. No, v over lambda. My bad.
Almost fumbled.
No fumbling.
Next question for you. Simon, what's going on, boy? Simon, boy?
No, sir. I'm not fumbling. No fumbling.
So f is equal to v over lambda. F is equal to, remember that, don't change the question. The same question gonna come tomorrow. F is equal to v over lambda. F is equal to v over lambda. F is equal to v over lambda. Remember that. Have that locked in your head.
Yes, sir.
Cool. Right. Sorry, Pete. I will do this one, right? The answer is literally just B to the 1B. Right? It's a mirror, right? It's a mirror, Oliver. What else I will say is a mirror. It literally reflecting. Right? Okay. Oh, this is a nice question for Simon. Simon, talk to my Simon.
It refers to the following diagram, which shows a longitudinal wave where C and R represent compressions and refractions respectively. If lambda equal wavelength, the distance between C1 and R2, what is that? C1 and R2, that's 1.5.
C1 and R2.
Yeah, that's 1.5.
So C1 is over here, R2 is over here. Wait. Well, let me explain why. So talk to me, right? What would be one full wavelength? What would be one full wavelength?
From C1 to C2.
C1 to C2 would be a full wavelength.
Yes, sir.
But we go in to R2, which would be half of our wavelength.
Half a wavelength. So we add half and 1 and we get 1.5.
Correct. Everybody okay with that?
Yes, sir.
Good. W's in the chat for Simon. All the people on YouTube, W's in the chat for Simon. Right. I find like the YouTube, like I see that turn around to the one people, I see other how more people because you know the exam is literally tomorrow. Like, so that how more people. Physics people sticking, boy.
I feel like, I feel like they give up.
No, like give up, guys.
But it's real easy though.
So you're supposed to have 1,000 viewers right now.
That's why he's saying, wait there. People on YouTube, share the live with your auntie, your uncle, your brother, your sister, and then everybody. Share the live. let's share the live. We should put it on your status and thing. We still early into the night, you know. It's like 5 hours again, give or take.
I just
Right?
want to say, sir, because the
by
angle
the
of
by the time we finish today, Ole will get 60 out of 60. You will.
Believe,
you
You
don't
will.
know. You
believe.
don't know. You don't know.
Right. Law of reflection. If it's reflection, then the angle is gonna be same. The only
A.
one that look correct is literally A.
Yeah,
Right?
you don't know.
Excuse,
What?
sir. I know it off topic, but you know when you say reflection, you remember the Disney song One on saying reflection. Whose reflection is that I see?
Oh,
Performative A done working on by.
Top G
Yeah.
done today.
A don't get where the girls boy, where the girls.
I retire.
Boy.
Sorry, go kill me.
Everybody okay with this? Like the angles is really the same.
Yes, sir.
Right? All the
Yes,
others
sir.
make no sense, right? And the angles must be measured with respect to the incident ray and the refracted ray and the normal.
Normal.
Like, okay. Look, what is this? What is this?
So just to be clear, that is the normal is the dashed line between the
Yes.
incident ray and the refractive ray.
Yeah.
Yes.
Okay.
What the heck is this? What?
Pure madness.
That looking like
Ma-
a clock. The clock hands were just going all over the place.
You know what this is, no?
That dog looking familiar.
Wait, let me
Somebody
know.
use that.
Do you like the way I know?
that's it.
Let me know. This also don't make any sense. What's this? Right?
Madness.
The answer is obviously E. Right? Which of the following properties is true of both light waves and sound waves? All of them good. All of them
D.
experiencing wave phenomena.
So it's D.
Fraction, yeah.
Gotta be D, sir.
They undergo
Mhm.
refraction.
D.
Because longitudinal waves cannot be transmitted through a vacuum.
Hey, skilly bang, relax yourself.
When I don't grind me.
So what?
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 Well, then you
Nah.
Crocodile teeth.
Well, I never.
Nah. I never guessed that.
I went
I
to
never guessed that too.
I went to a Skilly Bang concert, you know.
What?
Yeah, boy.
Badness.
Yeah, boy.
We can say how much skilly bang we want. Just let we pass this physics first now. Yeah.
You don't know any shadow. We talk about
Right? So
proper.
to the 4D. The amplitude. What's the amplitude, chat?
4.
Oh,
4 centimeters. Don't forget your units, people.
You
It
don't know.
matters in this too.
You
Well,
don't
I
know.
mean, to be fair, like
I
it's only
mean,
said.
it's Friday.
Yeah, but you gotta make sure you say it. Not everybody could see that, you know.
Sure.
Also.
Everybody okay with this?
And if that's to find the wavelength, what that'll be?
Yes, sir.
The wavelength will be just be 21 divided by 3.
7. Don't know.
Yep.
7.
How come
Seven.
Lock
The
in.
answer would have be B if they did ask you to find the wavelength.
Correct. Let's move on. The refractive index of a transparent medium with a critical angle C for light
Yes.
traveling from the medium to air is it was B. It was
B, sir.
B. It was B.
Batman. Sine 90 over
B,
sine C.
Batman. Sine 90 over sine C.
Let me just do it real fast. Real
Always
fast.
90
Quick.
degrees over the critical angle, which is sine C.
Check this out, right? At the critical angle, okay, at C, what is the angular refraction?
90.
Right? And we are going from a medium to air. So our refracted ray is going to be in which medium? It's going from the medium. Okay, watch. A transparent medium with a critical angle, and they're telling you light traveling from the medium to air. So its incident ray is going to be in the medium. And the refracted. Right.
They're going from more dense to less dense.
Right. That's the only time critical angle could happen, when you go from more dense to less dense. So here we're gonna happen. As starting off in the medium, I don't really know what the refractive index on the medium is, so I'll leave it as Ni. I know that the angular incident is C, right? Because it's the critical angle we're dealing with. I know I'm going to air though, so NR is just gonna be 1. And
Sine 90.
Sine 90. What is sine 90, guys?
There's one.
I think it's Uno.
Here is 1. And so when you find for ni, right, and you make ni the subject of the formula, but here, let me leave it as sine 90 for now. Let me leave it as sine 90 for now. So you can see the option. If you want to find for ni, you'd have to divide both sides by what?
Sine C.
And
What's the answer?
B. Bob the Builder.
Hey, no signal lady lava here. Sorry.
What? What?
B for Bob the Builder, I don't know.
Right, so the answer is B. Right, the answer is B. Now that is physics vibes. Yeah, it's physics vibes today, apparently. Yeah.
You don't know, sir. There's no physics vibes without Mr. Mad Vibes. Period. Point blank.
And then
no.
Cassidy is chemistry vibes. Right, big up Cassidy.
Of course.
And either
We're
than
just
or
missing our social studies vibe.
Yeah. So the answer for 36 is B, right? Remember this. Right? Sine 90 over sine C. Sine 90 over sine C.
You don't
Sine
know.
90 over sine C. Cool.
Hey, sine 90
Of
over sine C.
course.
Sine 90 over sine C.
Right. An explosion causes the emission of the following types of waves. Light, sound, and this is real simple.
Yeah, I think it's light and
I know the
infrared
answer to this.
Light and infrared.
because they
Light
travel at the
and
same
infrared.
They
they
travel at
travel at the
light
same
speed.
rate.
Yeah.
They travel at light speed.
Proper,
Because
you know, proper.
both of them
Proper.
are EM waves.
EM waves.
All,
Electromagnetic waves.
and all EM waves travel at
Travel
the
at
speed
the
of light.
speed of light.
Sound is travel less.
Yeah.
Sound is
Sound is like
3 times 10 to the power of 8.
No. Sound
No.
is like 323 meters per second. Much more
Yeah.
slower.
Of course.
Okay.
All right.
That's
So
why
the answer is 1 and 3.
You don't know.
You don't know, sir?
All right.
Big
Cool.
Shack.
All right. To the 8. The note. What's the answer? Louder. You see louder.
Amplitude. You don't know. You don't
Amplitude.
know.
Anytime you see loudness, just know the amplitude, right? Anytime you see pitch, you're dealing with frequency.
So what
Don't know.
year this is?
This is
2022.
2022. We're going till 2014. I mean 2014. We're going till 2014.
That's the end of
What?
time, boy.
yes,
What?
sir.
Sir, I am
2014?
so glad. Thank you. You could have go up to 2013, but I ain't beggars can be choosers.
Calm yourself. let me see how things going. Which line lies along the principal axis? I repeat.
JK.
K.
You don't
JK,
know.
sir, I didn't realize it or something. Wait, JF Kennedy. It's right
Oh
there.
my God.
Excuse me.
What you saying that?
I mean,
Right?
what I doing there, boy?
So the answer is JK. Everybody okay with that? JK?
Just kidding.
Course.
Yeah.
Of course.
Right? Like you can literally see this is the principal axis and JK is along that. So the JK is the answer. Cool.
Mhm.
Rectification is best done by a what?
A diode.
Diode.
A diode. D for
Semiconductor
diode.
diode.
But why? I'm gonna explain this fast. A diode only allows the flow of current in one direction, right?
direction.
You don't know.
And if we want to rectify a wave, we want to convert it from AC to what?
DC.
DC, direct current.
You don't know.
And a
Yeah.
DC wave, the current only goes in one direction.
Only
So,
positive.
so let me just say, with the positive half cycle for alternating current, right? The positive half cycle. The positive half cycle, it would allow the current to pass through, right? And let me just say we're talking about the negative half cycle now. It would block the current from going. And so that's why you use a diode. Because the diode will only allow the current to flow in one direction, creating a DC waveform. Yeah.
Sir.
Alright, so 40D. Right? 40D. Oh, and when the current passes through, you refer to it as forward bias. When it's blocking the current, it's in reverse bias. And you can think of this like a door, it blocking the current.
Yes,
And you can think of this like an arrow.
Like I press play.
Yeah. Alright. Thank you, Daisy Kelman 1809. Appreciate it. Very, very enthusiastic here. Which of the following circuits is electrically the same as the circuit above? When you look at the circuit, is it a series circuit or a parallel circuit?
Series. You don't know.
It's a series circuit, but why? Well, in a
Because-
series circuit, the
There are
current
no
does not
branches.
split.
No splitting of current.
Watch. Remember, current goes from positive to negative. And so the
Conventional
current,
current.
conventional current, watch. Tell me, guys, does the current ever split here at any point in time?
Nah.
No, sir.
No, the current never splits. The current is just going in one direction and it never splits. Okay, over here though, remember positive to negative, right? Look. What's gonna happen over this node?
Let's
In a split.
Right.
That's a parallel.
This is not a series circuit. This is a series circuit, right? We are looking for a circuit that the current goes without splitting. It's split over here, so that's wrong.
Be
In
wrong
this
as well.
circuit, it's gonna split at this node, so this is wrong as well. It's splitting here. This is wrong. Right? Over here, this looking like it. Are you seeing any current splitting anywhere?
Nah.
No, sir.
It goes in
Ah,
one
so-
direction.
Over here though, watch. The current is splitting. Watch, when the current reaches over here, the current is splitting, so this is incorrect.
Mm-hmm.
So the answer is clearly C, because the current doesn't split. Right? Cool. I move on.
Sir.
42. The following truth table.
Good night, everybody.
Good night. Given the following truth table with inputs A and B and output C, which logic gate does it describe?
I could take away this one.
Right, Kilani, sure I get up now with this one.
Bet. So for AND gate, you know that you need two positive inputs to get one positive output, right? So obviously a NAND gate, it would be the complete opposite. If you check the last column, you would see you have two positive inputs, but you're actually getting zero. So that's the opposite of an AND gate, which we call it a
Correct.
NAND gate.
So here what, right? Like Kilani said, let me show you what an AND gate is do, right? An AND gate just multiplies the input. Check this out. Where's 0 by 0?
Zero.
Zero.
So check this out, right? Let me see what it would look like for an AND gate fast. So 0 by 0 is 0. Then it has 0 by 1. Where's 0 by 1?
Zero.
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 What is 1 by 0?
Zero.
Zero.
Where's 1 by 1? You multiply 1 by 1?
One.
1. And doesn't this just look like the opposite of this?
Yes, sir.
Sir.
Yeah, and if it's the opposite of that, then it's just a NAND gate. A NAND is just like the other version, like opposite version of an AND gate. It's like the complement. Right? So that's a NAND gate. So the answer is E. Alright? Everybody okay with this?
Yes, sir.
Yes, sir.
Of course.
Right. Which of the following is a repeat? What's the answer?
C.
Right? C is the answer.
Don't know.
Tell them again, Ethan.
You don't know.
Yeah, don't know.
Yes, I fully understand, sir.
I fully understand.
Right? So this is common, it's a repeat all the time. So it's just R over V squared. Right?
Hey, Ethan, you don't miss the math crash course, boy.
Yeah.
Wait. Froki. Yeah, NAND gates are just reversed AND gates. That's true. Right? So R over V squared, that's the wrong one there. Magnetic induction occurs when Nikolai. Tell me, Nikolai. I see your Nisha Reshian.
So that is for the next question. Next question.
Right, Nikolai's son.
Is it B?
Yeah, it is B. It is B. Right? So magnetic induction. Let me just say about magnets. And okay, Nikolai, you know how this is go, right? Watch again. Look at this, Nikolai. Let me just say that this is a north pole and it's a south pole, right? Yeah?
Yes, sir.
And let me just say I have an iron nail. I don't know what kind of iron nail this is, but let me just call it an iron nail, right? And
Yes,
let me
sir.
just say I'll put the iron nail in this orientation. Now the iron nail, wouldn't the magnet pull the iron nail towards it?
Mm-hmm.
Yeah, Nikolai, or no?
Yes, sir.
So then, Nikolai, the magnet would have to induce a what pole over here?
Not.
Exactly, and that's magnetic induction, right? And the field lines would look like this. Badness. W's in the chat for Nikolai.
You don't know, Nikolai. That
Big up.
proper.
I would say like this is something more like you had to remember, to be honest. It's more something this one over here is something more along the lines of something I had to remember. Unfortunately. Yeah. That's
Fuse.
what I can to explain it. It's something more so you had to remember. Right? 43. Like
Oh,
the obvious ones, like the obvious ones would be I squared R, right? We know P is equal to VI. Um this is the only one you might have trouble identifying though. Right? That's the only one you might have problem identifying. But it's V squared over R. Yeah. But P is equal to I squared R. And all of these like the main one is P is equal to VI. And to get the others, it's just some like okay, we know V is equal to IR, right? And you know V is equal to IR?
yeah.
Yes, sir.
Let me see if I could prove a couple for you guys. I hope you at least know that P is equal to VI, right? You at least know that?
Of course.
Well, let's show.
Yeah.
Alright, so stay with me, right? You know P is equal to VI, and you know that V is equal to what?
IR.
IR.
V is equal to IR, yeah? So stay with me,
Mm-hmm.
right? This is the main one. This is the main one. P is equal to VI. It's the main one. And this is Ohm's law over here. So here's what I'm going to do. If I were to directly substitute V with IR, let's see what's going to happen. Right? So the I is going to multiply and I'm going to turn to what?
I squared.
I
I
squared.
squared R.
Right? And that's how they get this formula, I squared R. Here's what we're going to do now. What if I made... I'm going to think. What if I made I the subject of the formula? Let's see what would happen. So let's make I the subject of the formula here. So we know that V is equal to IR. If I make I the subject of the formula, how would I do that?
Divide both sides by R.
So I would be equal to what?
V upon R.
V upon R, right? And now anywhere I see I could replace it for V over R. And P is going to be equal to V by, I replace an I with what?
I.
V upon R.
Right. Where's V by V?
U squared.
Square.
Right? So that's why you
R
get,
over R.
watch. So the main one is P is equal to VI. Using that on Ohm's law, I could come up with the other two. So people on YouTube, I hope that give you guys some sort of clarity, you know? Yeah, let me know if you're okay with that,
Yes, sir.
right? Cool, let's move on. Renisha, fine. Renisha, tell me, what's the answer? I see you're really excited.
B.
A fuse.
Big up Renisha. Doubles in the chat, guys.
As I repeat.
All right, W's in the chat for Renisha. Anybody can tell me what this is?
A diode.
What is this?
Bulb.
Put on it now.
All right, and what is this?
Galvanometer.
A galvanometer, right? Cool.
Galvanometer. Ooh,
No,
sorry.
galvanometer. Galvanometer.
Sorry.
Galvanometer.
All right. Which of the following current time graphs best represents a DC current? So here what the DC current is either always positive or always negative, right? The answer looking immediately like is A. Let me explain. When you look at this, it's swinging between positive and negative. No, that's wrong. Over here, this one is swinging between positive and negative. That's wrong. And this one is swinging between positive and negative. So this is wrong as well. Everybody okay with the answer, Beanie?
Yes, sir.
Because this one is always positive. It's always above the time axis. So it's always positive. Right. Cool. Which of the following materials is most desirable? Sorry, repeat. What's the answer?
Sulfide answered.
So fine. Alright, so fine. Cool. Let's move on. An ammeter has a very low resistance, so it could be placed in what? Ammeter this time. Ammeter.
Series are not affect the
Series.
circuit. So
Right.
ID.
Because you want the current to flow through the ammeter, right? And you don't want the ammeter to block the current, so you want a very low resistance. Right? I see. Right, 48. 48 B, everybody okay with that?
So
Okay.
Right. Sammy, what going on in the comment section there, boy?
what going on there, sir?
Well, let's check what going on in the YouTube section there.
Where's that boy?
Check what Sarah say. But don't say it out loud. But anyways, 48B. Alright, this I repeat, where's the answer?
3 amps, sir.
3 amps, right? I can explain this question real fast. So you see that it is a 1 to 3. It has a turns ratio of 1 to 3, right? So 1 is the primary and 3 is the secondary. So question, guys. Where does it have more turns? Any primary or the secondary?
Secondary.
Secondary, sir.
Secondary.
So therefore, the voltage would be higher where?
Secondary.
Well, in the secondary.
Right, because this is a step up. This is a step up, right? So in the secondary, the voltage will be three times of the primary, right?
Yeah.
The voltage. So let me show you what I mean. So like I can explain this question to you real easily. Let me just draw a transformer first. So I'm gonna draw 1 turn over here, and I'm gonna draw 3 over here. So this is the primary, this is the secondary.
All right, children who watching on YouTube, that is a transformer. Not, I know Optimus Prime is a transformer, but that is not the transformer you're talking about. This is the transformer you're talking about. I hope all you're taking notes. Good.
Pay attention, guys. Let's go.
Right, so Kilani, I ever tell you this song just like Keen. Sometimes I'll listen to honest, this song just like Keen.
No, honestly, sir, hey, I just only study because I hear, like, he's honestly giving me motivation to study. I can't, like,
If he had like a son and he didn't, and like nobody knew about it, I feel like you'd have be son in. I don't know. I'll talk to him about that. Yeah. Alright, so let me explain this. So guys, in the question it said it has an alternating potential difference of 200 volts applied to the primary, right? So across the primary, you have a voltage of what?
200.
Everybody okay with that, right? 200 volts in the primary, yeah?
Yes, sir.
So we have 200 volts across here. Yeah, it is, but I'm just explaining it. So a question, guys, if it's in a 1 to 3 ratio, then if you have 200 volts here, how much volts you would have across the resistor?
600.
600. And
Right,
then you have to divide the 600 by 2, and it would be 3.
No,
Right.
200.
Yeah, you're correct.
And in the question, they said they have a resistance of 200 ohms attached to the secondary coil. So here what? We have the voltage across the resistor, and we have the resistance. You know, V is equal to IR. So I could find for I would just be equal to V over R. So V is 600, and where's the resistance?
That will be 200, sir. So it's 3
200
amps.
to 1? All right, 3 amps. Cool. Everybody okay with that? 3 amps?
Yes, sir.
Yes, sir.
Oh, you were showing it the other way. We could use the NP over NS is VP over VS.
Yeah, but I feel like that's
That's too long. That's too long.
yeah, just multiply the voltage by 3 and work it out.
Yeah, and as I repeat, so we just gonna
It
show it
have
anyway.
another way I could do it, because that part, that NP over NS does confuse me sometimes.
Well, this is the easiest way, right? If it's a step up, the voltage is just gonna increase by 3 times.
Okay. Thank you.
Right? Let's move on. Which of the
One-
following represents an AND gate?
B.
Yeah.
Right?
B.
Yeah.
NAND gate is D. A NAND gate is D.
These are an AND gate. These are AND gate.
There's a
These
AND
are-
gate,
C is a OR
NOT
gate.
gate, and C is a OR gate.
Right.
One of
1.2
one
amps.
input, the
Is that
other
repeat?
half another input.
1.2. Because if it's more resistance, it's less current, so 1.2.
Yeah.
Right.
Yeah.
Well, I want to explain it again, right? One more time. More current will flow through the resistor with a smaller resistance. So if 1.8 amps is going through the 4 ohm, then naturally less current would go through the arm R1. So this would be less than 1.8 amps. Are they understand us or no?
Yes, sir.
Yes, sir.
Yes, sir.
Are they sure?
Yep.
And where's the only answer that is less than 1.8?
1.2.
Good. But I'm going to do the full working real fast just to make sure they understand the other way too. In a parallel circuit, the voltage across each component is T.
So you can just repeat that one more time.
Okay. In a parallel circuit, the voltage across each component is D.
The voltage across each component is the same.
Correct. So here what we could actually find the voltage across R2, right? Because V is equal to IR, right?
Yes, sir.
The current flowing through R2 is 1.8. So that's going to be 1.8 and the resistance is 4. So 1.8 by 4, that's going to give us 7.2 volts. So if 7.2 volts is across R2, that's also going to be across R1.
Yep, because you see.
Because both of them in parallel. So the potential difference here is 7.2 volts. So here's what. If I know the voltage across R1 and I know the resistance, I could just use V is equal to IR to find the current. If I divide both sides by R, I would just be V over R. Now we're talking about R1, right? So the voltage across R1 is 7.2 volts, that didn't change. And the resistance is 6. 7.2 over 6 is 1.2.
1.2.
But common sense, I don't like to use it with common sense. If you think logically, you know how to do all of this, right? You have 1.8 amps going through the smaller resistor. So obviously, less current would go through the bigger resistor. And the only answer that's smaller than 1.8 is 1.2. But
Oh,
if you
yes,
want
sir.
to do the full working, you can do the full working.
I think I
1.2
agree with
amps.
you. I agree with, like, if you say think logically, it sounds more like proper, like, innocent.
Yeah, like when you say use a common sense, it sounds like an insult.
Yeah.
I don't like that. Which device allows one circuit to switch another circuit on or off without any direct? What's the answer,
Magnetic
guys?
relay.
Magnetic relay.
If you don't know why, let me see if I can show you how magnetic relay fast. Basically, when you supply power to the primary circuit for the relay, it generates a magnetic field, and that causes a latch in the secondary circuit to switch on, and that would create a closed circuit in the secondary circuit. I'll just show you a diagram. Okay, just get a GIF. Any of you know what a relay does actually look like?
I saw like a drawing, but not like an actual
Yes, sir.
diagram, so.
I see one in cars.
Check it out. It's real bad. Watch. Are you seeing that?
No, sir.
No, sir.
Also,
Oh, they're not seeing it?
Yes,
Sorry.
we're not moving.
Oh, my bad. My bad, guys. Give me a second. You done? You there?
Oh,
If you had
yeah.
a camera, on, I'll lay flex here. I'll lay flex your aura. But then we come around.
so this is my
Okay.
laughter going into physics tomorrow. I watching the paper and I laughing.
That's good. Right, so this is a relay, guys. This is a relay. When you supply a current across this coil, it generates an electromagnetic field. Can you guys see that? When I supply electric, okay, when I supply this coil with current, can you see that it causes this metal to like snap to touch it?
Yes, sir.
And when that happens, watch it, watch. Can you see it like it pushes it and it makes contact?
Yes, sir.
Yes, sir.
So you're using this coil. Okay, so like you are supplying this with current and you're controlling this remotely, and that's going to generate a magnetic field, causing this latch to be attracted to it here, which is going to push on this armature to make it make contact with this over here to complete the circuit. Let me get an actual circuit for you all to see it though. Give me a second. want y'all to actually see it. Check it out. So when I close a circuit, you're going to generate a magnetic field here. And that magnetic field is going to cause this iron here to be attracted here, right? And that's going to cause this, that's going to push on this, thus completing the circuit. And when it completes the circuit, wouldn't current be able to flow now?
Yes, sir.
Yeah. So that's how it really does work.
So once you switch goes in the first circuit, what the flow of current could latch the next switch in the second circuit, sir.
Correct. Like watch. You see like watch this, right? Watch this. I want you to look at what happens to the latch when the electromagnet turns on. It like pushes this.
Yeah, I seen it.
It like pushes it and it makes contact. So like over here, it would it push it and it make contact, and that would allow the current to flow.
Yes, sir.
Yeah. So that's our electromagnetic relay. Cool. I move
So
on.
we could just touch on the difference between a generator and a motor as we want it.
All right. You could think of a generator as a motor that somebody's spinning.
Because
Right?
I know it has to deal with electrical energy versus mechanical.
Right. So with a motor, you're actually supplying the coil with DC current or AC current, and that would generate a magnetic field in the coil, and you would have permanent magnets around the coil, and that would generate a turning motion, a turning force. So with a motor, you're supplying electrical energy, and that gets converted to mechanical energy.
Right.
A generator is just the opposite. So with a generator, you supply okay, it come in on the exam, right? It come in on the exam. The water falling on the turbine, it causes the turbine to spin, so that's mechanical energy.
Yeah.
And when it causes the turbine to spin, that gets converted to electrical energy.
Yeah,
So
that was in the first question.
a generator is just a motor working in another way,
Yes, sir.
right? All right, this is
So
real easy.
it have places and things that is work with generators.
Real business is work with generators. Oh, this is really sharp question all day.
Oh no.
Yeah, it have places that is work with generators. For example, where I live, Bitum, they have their own generator and they use it when current gone. So it's like a substitute for light in a way. When current gone and it have no current at all, they could use the generator and they will still get light.
Well, yeah, but long story short, they just use a generator to convert. Okay, you put fuel, you start it up, it creates mechanical energy that converts to electrical energy, right? And you just use that to create electrical energy, which you could use. Right, this one really easy.
Yeah,
You
what
see,
Sir said. That's what I was trying to explain. What you know me.
Question.
yeah,
Oh, you know when it's a AC or when it's a DC, like with this.
okay. So a transformer will only work with alternating current. Do you know why?
Because it flows to and from back and forth. And positive and negative.
Because of Faraday's law of induction. So, like, for you to induce a current in a secondary coil, you need a change in magnetic field. If I use a direct current over here, if I use a direct current, right, the direction of the current will never change and the magnetic field will never change. And so it will never induce a current in the secondary. But if I use if I use an alternating current, the direction of the current is going to switch periodically, and that's going to cause a change in magnetic flux. And this secondary coil is going to experience a change in magnetic flux and is going to induce a EMF here, a voltage. So the whole point of it is, for a transformer to work, you must have a change in magnetic field. A direct current will not do that. You need an alternating current to do that, because in the alternating current, the direction of the current is switched periodically, and when the direction of the current changes, so does the direction of the magnetic field. So for a transformer to work, it's AC current, only AC current.
Oh, so they will put DC to trick us basically.
Yeah, it just uses AC current. Any option with DC is wrong. I see Simon has his hand raised. Yes, Simon, talk to me.
Yes, sir. I was gonna say that Faraday's law of electromagnetic induction in a changing magnetic field to induce EMF in the secondary coil.
Yeah.
So that's a step-up transformer, so with AC current.
Yeah, this is a step-up transformer. Why? Because you're seeing that we have more turns in the secondary.
Yes, sir.
Cool. So this is a step-up. This is a step-up transformer, and it must work with our AC input, right? It must work with our AC input. How do I know it's a step-up? I know it's a step-up because there are more turns in the secondary. More turns in the secondary means it's a step-up. Right. Right.
Classic.
So
So
it's,
say if they have more turns in the primary, it would be a step down.
yeah. So the answer is step-up transformer AC input. So if you have more turns in secondary is a step-up. And for a transformer to work, it must have a AC input, right? Must have a AC input. Otherwise, it will not work. Otherwise, you'll create a short circuit and you'll melt the coil. All right, cool. 53C. All right, cool. Let me move on. 54. Which of the following describes two properties of an alpha particle?
Positive charge, and it's not very penetrating.
That's correct, because an alpha particle is a helium nucleus in nature, right? So it's positive and it's not very penetrating. All right, half-life. Half-life is
Easy.
real easy, right? What's half-life?
Like the time it takes half of your radioactive atoms in a sample to decay.
Yes, correct, Amundo. Very correct.
Wait, so let me read through the option, right? Which answer did you all say?
A, sir.
A. Half-life is defined as the time it takes half of the radioactive atoms in a sample to decay. Let me read through the other options. The time it takes the radioactive ice. Nope, this is wrong. The time it takes. This is wrong. Nah. Yeah, definitely A. Half-life is just the time it takes for something to be halved. That's all. Right, so everybody okay with that? 55A?
So we reached 55 already?
Yeah.
Way, moving real fast.
Right, so activity was originally 400. It was initially 400, right? So the half-life for that would just be 200.
2 days.
Yeah.
2 days.
Approximately 2 days. Approximately. B. Yeah. 56B.
We've got that line looking real bad, boy.
It is.
Oh, sir,
That's
that
why
question there. You
approximately.
see the question where they will ask you which of them will add up to the amount they give you. Let's get problem with that question, you know. That question is trying to test my patience.
Which question?
This one, 57.
Oh, well, that's not hard. So the nuclide 2 to the 490 TH contains, all right, so here what, right? The 2 to the 4 here is the number what plus what? What's
The
that?
number of protons
Neutrons.
plus
Protons plus neutrons.
And that
90.
one will be proton.
Good.
Yes,
So,
still got
so
it.
if I wanted to find the number of neutrons, what would I do?
Number of neutrons, you say. Would you have to plus the protons plus the electrons? I'm sorry.
Nah. Anybody want to tell us how you'd find the
You would say 2 to the 4 minus 90.
Yeah, you'd say
Oh,
2 to the 4 minus
okay.
90.
So instead of plus, it will be subtract.
Yeah,
Subtract
yeah,
proton
because
from
you have
electrons.
you have protons plus neutrons here and you have protons here. So if I wanted to find neutrons, I would take away the 90 from this to leave me with neutrons. So that would
Oh,
be
makes sense. Well, sorry, I didn't know, but now I know.
right. So what is 2 to the 4 minus 90, guys?
144, sir.
144.
Right, that's gonna be 144. So my answer is
C.
right, that's going to be C.
Yeah.
That's gonna be 90, 144.
Because the 90 is staying the same, is the only thing that changing is the number of neutrons.
Yeah. So
Yep.
you wouldn't believe it. I only understand these atomic physics because of KGH using them.
Yeah, you're real good.
That's telling it, boy.
All right,
So
so
he's a
Saved my life.
lifesaver.
let me know if you guys
Thanks,
okay with
sir.
this.
Thanks, sir. Thanks. Yeah, buddy. He's a lifesaver.
You're welcome.
Yes, sir. Also, sir,
So
don't forget to check the charge on your pen.
yeah, it dying. So we have 90 protons and we have 144 neutrons. Right? Cool. Let's move on. 58. Which of the following statements about radioactive decay are correct? The number first one is wrong, right? It
Yeah,
is
because
actually it's actually inside the nucleus. The
yeah.
conditions inside the nucleus, not external. It is a random process and it is due to changes in the nuclei of the atom. So 2 and 3.
And
2
the
and 3.
external is just like background radiation, so but I don't want that.
No. No, like we're talking about two different things. Like the main reason radioactive decay has happened is when like the proton to neutron ratio is not stable. So it would undergo decay for it to become more stable. So it's really
Yeah.
just within the nucleus. So 2
Okay.
and 3. 58C. Which of the following statements about a proton is not true?
C.
Are you sure?
It's
Me
D.
too.
It's
It's
D.
B. It's
Oh,
B. Guys, a proton has a lot more mass than an electron. An electron is very light,
But
right?
one,
So to say, if you say that it has the same mass as an electron, that's a big lie. That's a big lie, right? A proton has a lot more mass than the electron, so it's B.
Yeah, that's why an electron is easy to be lost. Well,
All right, so it's
wait.
59B. Are you all okay with that?
yes, sir.
All right, cool. Let's move on. So you're looking out. Okay, they said not true. They said not true. So if it is not true, then we're looking for something that's false, obviously. 60. An isotope of uranium, which is 23492U, changes to thorium, right? Which is 23090TH.
Alpha
This is,
particle.
yeah, this is looking like alpha. Why am I saying that? We know that alpha is 42. To get back the 234, I'll have to say 230 plus 4, which is 234. To get back 92, I'll say 90 plus 2, which is 92. So let me know if you guys okay with that.
Yes, sir. Hey, big up.
yes,
We done
sir.
first and next paper already.
Is that a alpha decay or beta?
This is alpha decay because alpha is 42. Alpha is 42.
Right.
Yeah,
Okay. I was just making sure because like I recognize it as soon as you write it in.
nice. Right? Let me know if all okay.
Yes, sir.
All right, so we finished 2 past papers.
Bet.
And in depth 2. So let me keep the ball rolling.
There we go.
I'll aim up a pencil charge for a bit. Now we're going to move on to 2021. All right, 2021, let's go. I'll aim up a pencil charge a bit though. Apple pencil charge and the I'll let it charge. I wonder what the subscriber count is, boy.
On
Wait,
that
what?
note,
Sir.
on YouTube and all other platforms, subscribe, turn on those notifications. Sis always doing videos, so make sure those notifications are on.
That is what I was saying.
So, quick question.
Yeah?
So alpha particles, right? They could be stopped by a sheet of paper. Beta particles could be stopped by aluminum foil. And it can't be stopped by anything or that wrong.
Lead.
Wait, say that again?
Now I was talking about how alpha particles could be stopped by a sheet of paper, right?
Right?
And then beta particles could be stopped by a sheet of foil. But
Mm-hmm.
what about the gamma
Lead.
particles?
Like somebody said lead.
Oh
Lead.
yeah, lead. Yeah, okay, thanks.
That's like last live when we had physics. I was saying a good boy gives paper, something along that lines, and then a
Yep.
certain somebody here went
Where Nikolai
the
there, boy?
other
Where
route.
Nikolai? Where Nikolai? Nikolai here?
Yes, sir.
Nikolai not here? Oh, you know, I thought Nikolai wasn't here. Yeah, Nikolai. Here Nikolai now. Lead. So, what percent of Apple Pencil reach, boy? I gotta get a new Apple Pencil, yes? I really gotta get a new Apple Pencil.
So I using
Really?
mine right now. Not my Apple
So,
Pencil, my fake one, but like the charger running down right now.
Wait, boy.
so where will let us buy the Apple Pencil and thing? Because I couldn't get one. Hopefully for me
And
to take.
Same. I need one.
you can buy it in the Apple Store.
For mine, because mine is not an Apple Pen, I got mine in
Why is thing giving trouble for, boy? Here, what? Let me find my fake Apple Pencil. Does that have a charge? 1 second. Not sure what the fake Apple Pencil is. All right, we're just gonna go. Let's see what we can do. All right, let me go. Let's see what we can do.
Speed.
Finance. Oh, finance. I find the fake Apple Pencil. All right, let me go. Let me just. Are you ready? Are you ready for action?
There we go.
Right.
Yes.
Power. Where's the answer?
Turn it
Is
up,
that
turn it
repeat?
up, turn it up, turn it up, turn it up, turn it up.
Where's the answer? Where's the answer?
See,
Wait,
sir.
let me time ourselves. Let me time ourselves. Go. See, right?
We've done overtime.
Wait, 1 moment. Stop share. Massacre. You guys will let me know when you see my screen. You all see my
Yes, sir, we've
screen now?
seen it. Yeah.
Seeing it, sir.
Like clear or like really bad?
Clear.
All right. Right. So the first answer is just work done over time. We know that power is just the rate at which work is done. So
Yes,
the
sir.
first answer, as the first answer. As I repeat, let's move on. Errors due to parallax. As I repeat. What's the
B.
answer?
B Batman.
B.
B. What is the explanation for this? Aha. Let me just say that this is a measuring a beaker or something, whatever you want to call this. When you're taking measurements, will you take measurements like that?
No, sir.
No, NT will take the measurement like this.
Yes, sir. 90 degrees.
90 degrees. So 2B. Alright, let's move on. Which of the following pairs consists of fundamental quantities? Mass and weight. Nope. Mass and length. Time and
time and
current.
current. Two and
Yes.
3. 2 and 3.
Right? Everybody okay with that?
Sir.
Of course.
Yes, sir. Yes, sir.
Yes,
All
I
right.
fully
Badness.
understand, sir.
Right, cool. This is a repeat, right? If you want the object to remain stationary, you want the net forces to be 0. So if I'm pushing to the right with XY, I will push to the left with XY. So
Yeah.
X plus
To
Y
the
to
left,
the
to the left,
B.
what Beyonce say.
B, 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 B. B as in Blanche.
Nah.
You okay? You all right?
B as in Bukurif.
What?
All right. Item 5 refers to the following diagram, which shows 3 forces of magnitude L, M, and N, all in the same plane and applied on a ring. Which of the following equations must be true in order for the ring to remain stationary? So
I would
here
say
one.
B, sir. The resultant vector.
B.
Yeah. It's supposed to be N squared equals L squared plus M squared.
Proper.
But I need to explain why. Hear this, right? Could everybody see that we're pulling the ball in this direction N?
Yes, sir.
Good. So here what? I'm also pulling it up with an upward force of L and a force to the right M. Here's what we could do. We could actually find a resultant here. Now, if you want this ball to remain stationary, then the resultant should be the same as this, but just in the opposite direction. So let me see how the badnesses go.
Draw your
Right.
diagonal one time. You don't know.
Right. So this is M. This is L. You know, if this is L as well, because it's a parallelogram. And if I want to find the hypotenuse, I'm just going to use Pythagoras theorem. Call this R. So R squared would be equal to L squared plus M squared. Everybody okay with that?
Yes, sir.
Right? And so this force over here, R squared is just actually L squared plus M squared. So question, if R squared is equal to L squared plus M squared, right? If I want this object to remain stationary, wouldn't these two forces have to like cancel out almost?
Yeah.
Yeah. So if that's the case, what do you think? Okay, it would just be n squared is equal to L squared plus M squared. But I'm not sure if you know why I'm saying that.
Pythagoras theorem.
Yes,
Is that right?
sir.
Well,
Is a right angle
the-
triangle?
wait, and the reason I'm saying that is because R would have to be the same as N for it to,
Cancel
cancel.
out.
Yeah.
So I'm going to go over this one more time. I'm going to draw my diagonal to find the resultant. It's going to be M over here, and it's going to be L over here. Good. You're going to use Pythagoras theorem to find the resultant. The resultant is going to be R squared is equal to L squared plus M squared. Now, for this ball to remain stationary, these forces here must be the what? These forces here must be the what?
You see him.
The same. So if this is N, then the resultant here should also be N.
Yeah.
Oh,
So that's why I'm saying N squared is equal to L squared plus M squared. So the answer is B, right? I mean, if you're okay with that. So as you can see, it's the same force, it's just in the up other what? It's just in the other what?
Direction.
Other direction. You're okay with that?
Yes, sir.
Okay, good. Let's move on. 6. Which of the following changes can be caused by a force acting on our body?
All of them
Let
is
me
the
ask you
same.
that question. If I were to press on a foil aluminum ball or something, what would happen to the shape?
it
It
changed
Fasten
will,
it.
shape.
it
I
will
will change the shape.
change shape. It wouldn't be a ball anymore. It would just be squished in.
Right. If I
Mm,
have this Apple Pencil stationary here and I apply a force, it will start to move. So
yes.
motion
Yeah.
and density. Think of this, right? The more I compress our aluminum foil, like you just have I have a bunch of foil in my hand, right? If I compress it, if I apply a force and I compress it, what happens to the density?
It will decrease.
It will decrease.
It will increase.
Oh,
Increase.
increase. Sorry.
Yeah, because mass per unit volume, so you're squishing it to get it more compacted.
Yeah.
Right. Thanks,
Oh, yeah,
Simon.
yeah, yeah,
Thanks.
yeah, yeah. Because like if it's a
Um,
wide sheet, is less density.
Oh, so this one is all of the above.
Correct.
Yeah.
Because density isn't density mass over volume.
Yes, sir.
And so if you remember the amount of mass doesn't change, right? But if you compress it, it occupying less space. So the volume would decrease and so your density would what?
The density would increase.
Density would increase. Good. So your answer is 6D.
Yes,
6D.
sir.
All right, cool.
Repeat question.
Everybody okay with that?
Yeah.
All right. When the tap is open, water will flow from P to Q until
Both of them are equal. D.
both are equal. You're
Because for
probably
the
wondering.
first one, atmospheric pressure would flow more.
So a lot of you guys don't know this, but you have atmospheric pressure acting down on both of these liquids. Now the atmospheric pressure is gonna wait. Let me explain something, right? Let me explain something. So you have the atmospheric pressure pressing down on this, and additionally, the height here is more than the height here. So remember, pressure is equal to height by density. What's in H rho g, right? This is what pressure is equal to.
Yes,
Because
sir.
the height here is more significant, wouldn't the pressure of the water at the
Exert
base
it be
be a lot
more.
more? It would
Yeah,
be
because
more.
yeah.
It's going to be more than over here. So for it to be at equilibrium, the pressure is going to act on it, and eventually it's okay, when the pressure acts on it, it's going to push the liquid into P, and it's going to fill Q until both of them are at the
Equal level.
right. Both of them are the equal level. So do you guys understand that the pressure acting on this liquid here is more than the pressure on this liquid? So when you open the tap, the pressure causes the liquid to go into P, go into the tap, and it flows into Q until they reach the same level.
Yes, sir.
Yeah. So the answer is 7D. I don't know if you guys understand that.
Yes, sir.
All right, cool. 7D. Nice. This I repeat. What's the answer?
1 and 3.
Right, so the elastic limit of the spring was exceeded. Yeah, that's true. Spring is a lie. Force per unit extension is 7.5 Newton per centimeter. Correct. So 1 and 3, that looking like B. Everybody okay with that?
Yes, sir.
Yes.
Let's go.
Right, let's go. 9. Kinetic energy. Does I repeat? What's the formula for
D.
kinetic
D for
energy?
dog. Half mv squared.
That's a half mv squared, right? Everybody okay with that?
Let's see about question 8, please.
Give me a second, right? Question 8. Question 8 was 1 and 3. Right?
Okay.
Yeah.
So
I didn't.
can you explain how it is D in number 9?
Okay, so the formula for kinetic energy is equal to a half mv squared. 1 by mv squared is just mv squared. So that'll be mv squared on 2.
Okay, sir. Thank you.
No problem. So the answer is 9D. Everybody okay with that?
Yes, sir.
Yes,
Aidan,
sir.
Aidan, help me with this one.
Which of the following will be constant if a constant net force is applied to a body? Velocity.
Acceleration.
Wait.
Because
Aidan,
force equal to mass times acceleration, so it would be acceleration.
Ah,
Direct proportionality.
I was
Wait, what
thinking
you
that, but I
say?
said the wrong thing.
Is it
okay, watch.
acceleration?
If you make acceleration the subject of the formula, you divide both sides by m, you're gonna end up with A is equal to F over m. So question, if the force doesn't change, and well, we know mass never changes, right? Mass never changes.
Acceleration will be constant, yeah.
Correct. Because if the
Yeah, the
force remains the same
acceleration.
and mass remains the same, then the ratio F over m will remain the same. So
Yeah,
acceleration will
so
be the same.
yes, I understand. So yeah, I was gonna say velocity. I was gonna say acceleration, but like I have brain fart now.
Hey, redeem yourself, but redeem yourself. Next
I
question.
Redeem yourself.
already myself here.
The pressure in a liquid can be calculated using the formula P is rho by G by H. Which of the following sets of units will result in the SI unit of pressure? Okay.
So here what
Height
I'll
is,
SI unit,
underline
huh?
SI one time. SI one time.
height is
Formula.
obviously in meters.
Right. So that is that between these two, right? Because height is measured in meters. So
Yeah.
what are these two? What next?
What and rho's density.
What's the formula for density?
Isn't
Mass divided by
M over V?
velocity.
Right. What do we measure mass in? In
So
SI
in
units.
kg, and volume will be in meters cubed.
So kg m what?
Kg m minus 3. So I can like
Right.
B.
Yeah. I mean, just from looking at this,
Yeah.
right? Aaron, just from looking at this, meters, immediately meters. Right? These
But
two
it's
are the
just
same.
the density part would kind of confuse me, to be honest.
Well, here what, right? It's simpler than it looks like. We dealing with SI units. Shante, if we know what SI units, what is the SI unit for mass?
kg,
What is the SI unit for length?
meters cube.
No, for length. Length is meter, right? So the volume will be meter cube. So here what? When you're comparing this, which one looking like the correct answer? SI units. Which one looking like it? 1 or 2?
B.
B, right? For sure, because kg and meter cube. This is definitely wrong. All right. Everybody okay with this question?
Yes, sir. Hey, I could just point out the gravity, sir. And so you're taking consideration W is equal to mg, right? So you had to make G the subject, and you would get weight over mass. Weight over mass, right? So weight is measured in newtons and mass is kg. That's why they have newtons, kg.
W's in the chat for Kilani.
Rolling,
You got Kilani one time.
rolling.
Because it's SI units.
And for those of you who don't know, N is short for newtons.
Thank
What?
you.
You serious, Renisha?
No way.
I
No
have
way.
been enlightened.
I'm kidding. I'm kidding.
I never know that.
Oh gosh, well, I can't take a joke at all, boy. That one.
NIP question. A.
Yeah.
A repeat question. The upthrust is less in
It don't
liquid
know.
A than B. Yeah.
Proper.
Right, because
Sir,
yeah.
for the one with the was it a bubbles? Could you explain it because I don't understand it?
What this one over here?
Soda and it's kind of similar because you have upthrust. But you know which question I'm talking?
Wait, let me get the question you're talking about. I know which one you're talking about. Wait,
Sir, you good notes. Have they been good?
reasonably.
Okay.
Either way, he can't switch because he already has so much things.
Actually, I'm using good notes right now and I'm working real good.
I have an
I'm
M2. I
using
feel like
good
it's
notes.
supposed to be working good.
Using the traditional pen and paper.
Wow.
Yeah,
I mean,
boy.
it's working or it's work.
Hey,
I
look,
looking
Sarah joining.
big up, big up. I looking for
So
that
I
question.
switch in
Shanti said she
between.
would. Shanti, where that question there, boy? I know the question I'm talking
Sarah.
about. You know.
Sarah, what going on?
Oh my days, I just joined. Hi
She
guys.
here?
Sorry. All right,
Yes.
gotta
Yup,
do some physics.
Sarah.
It's been
Welcome,
years.
Sister Sarah. You
It's
know how
been
long I see you,
years.
Hi.
girl? I miss you.
I
You're
miss you
very
too,
late,
man. I miss you
Sarah.
too. I'm
You're baking some
sorry.
cookies or you bake some cookies for me?
Yeah, where the brownies?
Oh my gosh, okay. I'll send y'all the brownies and I'll send y'all the cake. Okay, so y'all go stop. I ain't
Or you
even
have
make
to, or you have to
Wait,
Sarah now wake up, you know.
Yes,
waiter.
sir, that question.
All right. So let me explain this question for Shanti. By the way, big up Sarah. I'll using the chat for Sarah. Right?
Hi, sir.
All right. So Shanti, a bubble of gas rises to the surface of a soft drink. This is because the upthrust on the bubble is greater than the weight of the bubble. Let me explain, right? So Shanti, let me just say the upthrust. Okay, by the way, upthrust is a force that acts upwards. Upthrust. Let me just say the upthrust was 5 newtons, right? And let me just say the weight was 2 newtons. Which force will win here? The 5 or the 2?
The 5.
The 5.
And
5 is
when you
more than
work,
2.
right? And talking to Shanti here. Shanti, when you work it out, what would the result on force be? So you have 5 up and 2 down. What the result on go be?
3.
3 in one direction.
Upward.
Tell me. 3 upwards, right? So if you remain with 3 newtons upwards, wouldn't that be the force pushing the bubble up?
Repeat. I didn't hear.
Okay. So Shanti, if you end up with a force of 3 newtons that is in an upward direction, you have that force of 3 newtons pushing the bubble up.
Yes, sir.
And if you're pushing the bubble up, what will happen to the bubble? It will what?
Go up.
It will rise, it will rise, it will rise. It will rise. So a bubble of gas rises to the surface of a soft drink because the upthrust on the bubble is greater than the weight. If the upthrust is more, you end up with a net upward force, and it will keep pushing the bubble upwards, which will cause it to rise.
Okay, sir. I understand now. Thank you.
If the weight was more than the upthrust, it'll sink because it'll end up with a net downward force. All right, let me continue. So they're saying an ice cube sinks in liquid A. If it's sinking in liquid A, then the upthrust on the ice cube is not enough. Then they're saying it floats in liquid B, suggesting that the upthrust in liquid B is a lot more. So the upthrust is less in liquid A because it's sinking than in liquid B. So 12A. I'll move on. This I repeat. Where's the main factor here? In
The
charge of
depth
pressure.
of
The depth of the water, sir.
the depth of the water.
Right, because pressure as a result of a liquid is height by density by gravity. The height is really the depth. And this will play the most significant role in the pressure. So it's the depth of the water. Everybody okay with that?
Yes, sir.
Tip,
Of
sir.
course.
Yes, sir.
Okay, good. Let's move on. Which of the following is an SI base unit? SI
Amperes.
base unit,
C.
right? Amperes, yeah.
Ampere.
All right,
I
let's move
think
on.
that's a repeat.
All right, this is a repeat. Okay, from the graph. Okay, so wait, let me read the question. Item 15 refers to the following graph, which shows how the displacement of a runner from a starting line varies with time. From the graph, it can be deduced that the runner is
A steady speed,
Going
sir.
at a steady speed.
right. Because, okay, you have a displacement time graph. What does the gradient of a displacement time graph give you?
Velocity.
Yes,
Yeah, the
sir.
gradient gives you velocity. And if it's a linear graph, it suggests that it has a constant velocity or a constant speed.
Yes,
Right?
sir.
If you're confused, look at this fast. We know that velocity is just displacement over time. So the displacement is 12 and the time is 50. Where's 12 over 50?
0.24, sir.
So 0.24 meters per second, ms minus 1. What would this be over here at this point?
It be the
So
same.
be the exact same. So as you could see, the person is running at the same what?
Speed.
Same velocity.
Same
Speed
speed
and
or velocity,
velocity.
that's fine. So he's going at a steady speed. Because the speed isn't changing. I understand that, right?
Yes,
Sir.
sir. I was saying that in my head, you know. I was like, gotta be B. If it's not B, I don't know what to do. Gotta be B.
Yeah.
Gotta be.
It is B. Everybody okay with that, right?
Yes, sir.
All right, cool. Sarah, you doing physics?
Sarah's a physician, no, sir.
Oh, I didn't know that. Right, 16. Two forces of 8 newtons, so 8 newtons and 10 newtons cannot have a resultant of what? Does I repeat?
1 Newton, sir.
1 newton, that don't make any sense.
1 Newton.
Badness.
That don't make no
Badness.
sense.
10 minus 8 is 2, that could happen. 9 newtons could happen, and if both of them go in the same direction, that'll be 18, that could happen. That 1
Yeah.
newton makes
If you
sense.
add though, if you add
Yeah.
10 and 8, you'll get 18.
You done
Right.
Renisha.
And if you divide 18 by 2, you'll get 9. Wait,
Well,
hold on,
I mean,
wait.
That
Wait,
logic
wait.
not wrong, you know. I mean, that logic is fine, it's fine.
All
Yeah.
you
Yes.
Right? A
I'm
piece of
trying to
string.
make sense.
Is that repeat? What's the answer?
C.
See,
You
less
don't
than
know.
the weight of the stone.
You don't know.
Let me see if
Anything
Sarah.
less than water,
Wait,
go
let me
beneath
see if
that.
Sarah could understand this one. So, Sarah, give me the question already.
Oh Lord God, okay. A piece of string is tied onto a small stone and the stone is then suspended, totally immersed in the water. The tension in the string will be A close to 0, B equal to the weight of the stone, C less than the weight of the stone, D more than the weight of the stone.
Right, so let me explain this. Sarah, where do you feel lighter? On land or in the beach, like in the sea?
In the sea.
Exactly. That's because the water actually pushing up on you, right?
Yes,
Like
sir.
right. So here what? Imagine I have a string here and I have a
Mhm.
stone attached to the string. Wouldn't the stone have some weight?
Mm-hmm.
So the
It
weight
would.
the weight of the stone will be pulling down on the string. Now, for the stone to remain there, the string would have to exert an upwards force, and we call that the tension on the string. Now, on air, the tension is going to be equal to the weight of the stone. However, if I were to dip the stone in a cup of water or something, what is gonna happen to the well, watch this, right? We have the weight here, and they also have the what? Well, we have acting on the stone as well.
The string?
Nah, the string is actually what's holding up the stone. But like, if I place the stone in water,
Mm-hmm.
the water will do what to the stone? Think about it. Where do you feel lighter? Do you feel lighter on land or in the sea?
In the sea, yeah.
Why
So,
do you think you feel lighter in the sea?
because of the salt, like
Right?
something.
Because it has salt in the water, it making the water
Less
kind of
dense.
pushing you. The water kind of pushing you what? I kind of giving you a what?
Upthrust.
Okay.
Yeah. Big up. You don't know.
You don't
Right.
know, Sarah. Proud of
Sarah, one time.
So Sarah, when I put the stone in the water is going to push up on the stone and it's going to give it a up thrust. So
Uh-huh.
if it's pushing up on the stone, will the tension increase or will it decrease?
Decrease.
Because it come like the water kind of reducing the load, right?
Mm-hmm.
Right. So that's why we're saying it will be less than the weight of the stone.
Yeah, okay. I understand that.
Because the weight, okay, the force here, the force is going to be the weight minus the up thrust.
Mm-hmm.
And that would reduce the tension because now the tension will be equal to W minus U. But over here it was equal to the weight of the object. So that's why I say any tension in the string will be less than the weight of the stone because the water can helping it being pushed upwards.
Yes,
Right.
sir.
This I repeat. What's the answer, guys?
1,000.
1,000 joules.
All right, because it's just 200 by 5,000. Watch 200. 30 from 35 is 5 by 200, 1,000. Bam, easy. 19 now. Who was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy?
From the time you
Joule.
see energy, it's just joule.
From the
D.
time you see energy is joules.
Wait, let me just verify. I know, but like, I think we had this discussion like some other time.
Yeah, we do this in the 2025 paper, so
It was the exact same question.
the exact
Yeah,
same
they bring
question.
back the same thing. That it's
Yes,
like the
sir.
copy and the paste it in this question. Yeah.
The
When I
lazy, the
see
lazy.
this, when I see this, I just think about Rumford and all because Rumford did the Cannon-Boren experiment and he showed that energy could be converted from one form to the next.
So it
But
could
it-
potentially be Rumford.
Nah,
or
he drink too
Joule.
much rum. He drink too much rum.
Hey.
Danny, calm
I
down.
go say that about the man, boy.
Boy, you
Right,
have no this a dumpling, boy.
That's not dumpling.
right, 19. Hey, and every time I look at Renisha, there's just see KP. I was just see KP.
What?
Oh, wait, and this KP, right? From I don't know what I'm talking about.
Yes, sir, I see what you mean. Renisha is okay.
Uncheerful.
It's a
All right.
compliment. It's okay.
So this I repeat. What's the answer?
Diesel. You don't know.
D.
D for
Earlier,
dog.
earlier.
You don't pay attention.
Delta theta means what does it mean? What does delta theta mean?
Change in temperature.
Change in temperature.
Right. So does that mean T1 minus T2 or T2 minus T1?
Second one, sir.
T2 minus
Second
T1.
Hey,
T2 minus
just
T1.
from knowing that, you'll figure out the answer. Just from knowing that. This is clearly wrong, right? Because it had to be T2 minus T1. This is clearly wrong because it's T1 minus T2. And this is clearly wrong because it's T1 minus T2. So it had
The
to be
answer
what?
is D. D.
The answer had to be D, right? T2 minus T1. Mm-hmm. Everybody okay with that?
Yes,
Yes,
sir.
sir.
Yes, sir.
Right. If we're talking about specific heat capacity, we're talking about change in temperature. So delta theta is T2 minus T1. If you're not seeing T2 minus T1, it's wrong. D. All right. 21. These I repeat. What's the answer? Or what is
A. It absorbs 2.26 by 10 to the power 4.
And I'm gonna be back fast, just so everybody's on the same page. I have 2 point. Wait, the formula is E is equal to MLV, right?
Yes, sir.
The mass is 0.01. I could write this as 10 to the power negative 2. So we have 10 to the power negative 2 multiplied by 2.26 by 10 to the power 6. You have the same base and you're multiplying, so you add the powers. Minus 2 plus 6 is just 4. So your answer will be 2.26 by 10 to the power 4 joules. And since you're going from water to steam, you have to absorb heat. So 21. Are you okay with that?
Yes, sir.
Right. Cool.
27
20.
degrees.
Yeah, this I repeat. Yeah, customer this.
27. Combined gas law.
Right? Combined gas law, right? Look the working, like I'm not even joking, look the working right here. Was it this question? Well, the working will be somewhere right here. Why not go back? But yeah, we did it already. I'm gonna do it real fast. Just I have no idea how much it just scare me when I feel like a student don't understand.
Yeah, I could tell. I could feel it. I could literally feel it through the screen, though.
Yeah, so this is V1. This is T1, obviously I had to convert it to Kelvin by adding 273. And this is P1, right? The new pressure is 2, so that's P2. The new volume is 1, that's V2. And the way to find a new temperature, that's T2. So P1 V1 all over T1 is equal to P2 V2 all over T2. Our working is fast. Initial pressure is 1. Initial volume is 2, 1 by 2. The initial temperature is 300. P2 is 2. V2 is 1. And we don't know what T2 is, leave that blank. When you work it out, you're going to get 2 over 300. 2 by 1 is 2, 2 over T2. So you want the left-hand side to be equal to the right-hand side. So it's clear that T2 is 300. If T2 is 300 Kelvin, you want to find that in degrees Celsius, you take away 273. So that'll give you 27 degrees Celsius.
Yeah. Left hand side equal to the right hand side.
All right, cool. Let's move on. Which of the following statements about evaporation is false?
D. D for dog.
Right? Evaporation could happen at any temperature, right? Let me ask you that question. If you spill water in your room, even if you have AC on in your room, any water will eventually evaporate?
Yeah.
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 It's
Water,
scientifically proven too.
right, water evaporates at nearly any temperature. Obviously, like, I think it even happens at like cold temperatures as well. Yeah. Because you have like freeze drying. Right? So evaporation. So the one that's false is evaporation occurs at room temperature. It could occur at a bunch of different temperatures. 24. Which one is the porous? This one real easy. Porous conductor.
Sir.
This is real easy, boy.
Yeah.
Porous conductor of thermal energy. Sarah, do you know this? Sarah, you're not doing you're not doing physics, but you know the answer?
Yeah, definitely. We do this in science.
Okay, good. This answer. This
The answer
repeat.
is
What's the
C.
answer?
C. C.
Because if they're saying that the melting point is 80 degrees Celsius and it cooling it, when you reach the 80 degrees Celsius, it's going to start a transition from a liquid to a solid.
Yeah.
And it's going to be a flat period.
Latent fusion.
Right? So this is what we're talking about. Over here, it's starting to go from a liquid to a what?
Solid.
Right, cool. So you're looking out for this period in the graph. Right, let's move on. 26. An electric kettle full of water is plugged into the mains. The major process by which heat travels through the water is?
Convection.
Convection, yes. Let me just draw a kettle here first. Right, I'm heating it up. The hot water will be at the bottom. That's going to expand. It's going to rise to the top. Then it's going to cool down and it's going to come heavier and it's going to sink to the bottom.
What
That's
question?
convection. Yeah, talk to me.
Oh, you could tell the difference between conduction and convection.
All right, conduction requires physical contact. So like, let me just say you touch a metal, something that's hot. That's conduction. Convection, yeah, convection happens in fluids.
Okay.
And
Fluid
water
like
is an example of a fluid.
water?
Yeah.
Water. Okay.
Water is an example of a fluid.
If you're cooking food on the stove, you touch the hot stove, that's conduction already.
Yeah, I know. I get burned from that already.
Oh no, I hope you're okay.
I'm okay.
But
But thanks
at
for
least
explaining, sir.
at least you know what conduction is, though. That's
Yeah.
conduction.
Yeah.
Conduction requires physical contact. Convection just requires a medium. All right,
Thanks.
26.
Well, he done there by Sarah.
All right, let's move on.
He locking in.
Aidan, tell me, what's the answer for 27? Aidan, talk to me fast. Aidan.
The silver was 2 and 1.
What?
What?
No, he correct. I just
You always do that, you know, sir. You always do that.
W face on the chat, guys. In the chat.
So when you do that, when you do people that you just get them frightened, like they say something wrong. Oh my god.
So you see how you just go sleep and you just be scared that you get that the child didn't understand. You making them feel scared in the moment. That's what you making them feel.
Let's read it back, right, Aidan? So, 1. Evacuated space between double walls reduce loss of heat by conduction. That's true. Silvered inner walls reduce loss of heat by radiation. That's true because, if it's silver on the inside, it will cause the heat to reflect and bounce back, trapping it on the inside. And 3. The silvered outer wall helped to absorb heat. This is rubbish. That rubbish there. So 1 and 2. Everybody okay with that?
Yes, sir.
Yes, sir.
Yeah.
Alright, cool. Let's move on. Are they read all the question or no? They'll just assume, because in this question, typically they'd have the wrong answer in the middle.
Oh yeah, that's true. That's true. They
That's
does do
what I
that for
always say.
almost all the subjects.
Sir, and that's why I'm glad you explained it, because if like I was watching YouTube video, they said B, and when I go in the exam, it's at C, and I'll get confused.
That's why you need to
That's
understand
why,
it.
yeah, that's why you shouldn't memorize the letter, but memorize the actual answer itself.
Yeah,
And I
that's
know
why
the
it's better to scope out the answer instead of look at what letter they play it at, so you could know which answer is the correct answer. Because potentially they could change up the letters and put the same answers, so that could
Correct.
get you tied up.
Right? So
yeah, and that's why sure.
Memorize, understand.
that's why I'm making sure they understand. I don't do that memorization thing here at Math Vibes. Right? Guys, would a silver outer wall absorb heat?
Nah, it would reflect.
It would reflect.
It would reflect. Come on, we better than this. It will not absorb, it will reflect. That don't make any sense. Ozzy, Nikolai, I ain't hearing my son Nikolai. Nikolai, talk to me, Nikolai. Tell me. Sunrise.
Yes, sir.
Sunrise.
Wouldn't it be B?
Yeah, it would be B.
Pick up Nikolai one
Good
time,
job,
guys.
my brother. Good job. God is blessing you.
You cannot catch Nikolai lacking. Nikolai got you. He's 2 steps ahead of you.
Yes,
Right?
sir. You're 2 steps ahead of you.
So when you apply heat to a liquid, the molecules in the liquid they gain kinetic energy. Yeah, that's literally it. What I was saying. Kinetic area matter.
Yeah.
Right. Nikolai, this I repeat as well. I'm not sure if you remember this one, but this I repeat too. But it's okay, we'll do the question back. So Nikolai, give it a read. You gotta read from Nikolai.
Yes, sir. A light bulb is filled with with a gas at a temperature of 293 Kelvin. If the initial pressure of the gas is P, what will be the temperature? What will the temperature be when the temperature increases to 360 degrees Kelvin? Well, 360 Kelvin.
Don't tell Nikolai anything. Nikolai is the man for this job. He will figure it out. So Nikolai, which law are you using here? Pressure, Boyle, Charles.
Pressure.
Right. So P1 over T1 is equal to what?
T1 is equal to P2 over T2.
Right. Do we know what the initial pressure is?
No. It's
Well,
considered as P.
right. Well, we're gonna use that anyways. We're gonna call it P, right? The initial pressure is P. That's the initial pressure. Do I know what the initial temperature is?
It was 293.
Right, that's T1. Do I know what the new pressure is?
360.
No. That's the new temperature.
Wait, we gotta add it.
No. They want us to find what will the pressure be? So they actually want us to find P2. That's what they want us to find in the question, Nikolai. Nikolai, let me just examine the question again. So they're saying a light bulb is filled with a gas at a temperature of 293 Kelvin. So that part over there, tell them what? What that part tell them?
That is the initial temperature.
That's T1, good. And then they're saying the initial pressure is
P.
Right, so that's the initial pressure, P. That's P1. And then they're saying, what will the pressure be? So you see now, what will the pressure be? So they wait to find for what? What they wait to find for?
P2.
Good. When the temperature increases to 360 Kelvin. So 360 Kelvin, that would be what?
T2.
Good. So here what? P1 is P. Where's T1?
293.
What is P2?
We
I
don't
don't
know.
know. I don't know what that P2 is. What is T2?
360.
I want to find for P2, right? That's what we want to know. So what would I do to find for P2?
Cross multiply.
Yeah, you could cross multiply. If you cross multiply, we're gonna put
360p is equals to 293p2.
what I'm trying to find for.
P.
I'm not trying to find for P. I'm trying to find for P2.
Oh yeah, p2. My bad.
So how would I find for P2?
Divide by 293 to cross it out.
Right. So P2 is just going to be 360 over 293 multiplied by what?
By p.
Right. What's the answer?
D.
Everybody okay with that, right?
Yes, sir.
Yes, sir.
Right. Remember, 360 over 293 by P.
Lucky.
360 over 293
By P.
But here what? Let me go through the options and I'll show you how to eliminate some, right? That don't make any sense. The temperatures they gave me were 293 and 360, right? 293 and 360, yeah? Earlier, they gave me 293 Kelvin and they gave me 360 Kelvin, yeah?
Yes, sir.
Yes, sir.
Gosh, where them pull out 393 from?
Pure madness.
Right? Let's check the other one. Again, where they pull out this 393 from? Right?
Madness.
This one could be a possible answer. But when you work it out, you get 360 over 293. So at least in the exam, if you had to choose, you'd have to choose between C and D. If you didn't know anything. Right? But Nikolai, remember, Nikolai, 360 over 293 by P, right? 360 over 293 by P. Right, Nikolai?
Yes, sir.
Good. Everybody go with that one, right?
Yes, sir.
Alright,
Yes,
let me move on.
sir.
What's the answer for this one? Is that repeat?
Water is a poor conductor of heat.
What are the poor conductor?
Right, well, water is a poor conductor of heat. If it was a good conductor, then this would have melt. But it did not melt, and so that poor conductor heat. Because of its high specific heat capacity, that's why. Reflection. What's the answer, guys? That real easy. Reflection.
They must be equal, sir.
A.
A.
Yeah.
Nikolai. I feel like I want to hear from Nikolai more. Nikolai, you okay with A, right?
Yes, sir.
Because Nikolai, I'm just seeing that this angle and this angle are equal.
Yes, sir.
Good. So if it's reflection, then the angle of incidence will be equal to the angle of reflection. Nikolai, let me answer a couple of questions. I find you a bit too quiet. I hearing you too much. I hearing you enough. Nikolai, read 32 for me.
The human ear is incapable of hearing a silent dog whistle because the frequency. No. Is it C? Well,
Yeah, just see. Guys, we actually can't hear that, because
That's our ultrasound, sir.
Over
Because the range of
20,000
humans is
hertz.
like 20 to 20 kilohertz.
Yeah.
let me look it up.
20,000.
20
dog-
hertz to 20 kilohertz, I think.
A dog whistle is actually an ultrasound then.
Let me see. So like dogs hear frequencies, but people that say man is dog, so but
Nah.
I don't be hearing no I don't be hearing no 45,000 hertz. So 65 to 45,000 hertz and humans, I'm talking about man. I was gonna write man here for dog. Humans is 20 to what?
20,000.
20
20,000.
kilo.
Right. So a dog whistle is actually exceeds the upper threshold of human ears. So it's above 20,000. So you're not hearing the dog whistle because the frequency of the waves are above the range detected by the human ear. Right? Hope you guys are okay with that.
Yes, sir.
Sir.
Yes, sir.
I move on to the tree. The
Small
echo, this I repeat.
amplitude. Small amplitude.
If you're talking about quiet, loudness, anything like that, amplitude, one time.
Frequency is pitch.
Yeah, frequency is pitch. Nikolai,
Sir.
help me with this one. Help me with this one, Nikolai.
Was it 1.5?
Yeah, boy, it was 1.5. You can't catch Nikolai, boy.
You don't know.
Don't know.
We too good.
Right? Because a full wavelength would have been between a compression and a compression here. But then you go on from C2 to R2, which is half a wavelength. So altogether, that would be 1.5. Are they gonna get 60 out of 60, boy? Are they gonna get 60 out of 60
Lock
for
it
sure?
in, lock it
You
in,
don't
lock it
know.
in.
You
Big up,
don't know.
big up.
This I
Okay,
repeat.
go on.
What's the answer? This I
D,
repeat.
sir. D.
You like that letter, boy?
You and
Hey,
this
hey,
machine gun
Yo, hey,
so
yo,
yo,
yo.
hey, yo,
You done,
hey,
you done,
yo,
man.
Yo.
You
hey,
done, you
Oh
done.
yo,
gosh. Oh my
Hey,
gosh.
You done. You relax
Yo.
yourself, G. You relax yourself.
hey, yo.
More like
Take
bottom,
a
G.
pad down. Take a
You
chillax.
know, you
Chillax.
can't put your tongue, man. When you're talking, hey, yo.
I'm gonna do back this question real fast. Remember, is Ni sin I is equal to Nr sin R. Bam, bam, bam. All right. They're saying it entering and leaving A and entering glass, which means that it was an A originally, so the incident ray will be an A. So the refractive index for I would just be 1. Did they mention what the angular incidence was? Nope. Didn't say what that was. The refractive index of glass, they told us it was 1.6. And they gave us the angular refraction, that's 27. So if you want to find for sin I, well, sin I is what the way to find for. That's just 1.6 sine 27. Yeah, the answer is D. Are you okay with that, right? 1.6 sine
Yeah.
27. 1.6 sine 27. Remember that.
Yes, sir.
Nikolai, help me with this one. Nikolai, forget what Kalani just said. Forget about it.
Sir.
What's the answer, Nikolai? What's the answer?
I don't know, sir.
You don't want to say A because if you say A, I will be like, wait, boy, you copy Kalani answer, boy, wait.
So your son no answer.
Yeah. So the answer is A. And this question actually coming in January 2026. Watch January 2026. Watch.
So you did January?
Yeah, the January 2026. Check. Oh no, I didn't do January 2026 paper one. I don't
Oh,
have it.
Oh
If I
Shanti.
find it, I'll leave submit, right?
Shanti was like, what?
But like watch this. Like it literally come in January 2026. So like we're looking for something that looks like this, right? Circular wave fronts. So this is the answer, right? This is the answer. The answer is E.
I'll be looking like an egg, so.
Probably it is an egg. It is an egg, probably. Right? Which of the following statements about waves is true? Somebody tell me.
C.
All waves undergo wave phenomena like refraction, diffraction, reflection, Everybody okay with that one?
Yes, sir.
Alright, cool.
Yes,
Let's move on.
sir.
Which of the following objects can detect as I repeat?
Photographic film.
Photographic film.
Photographic.
Right. This had to be the easiest paper one I'll ever do.
These physics students ready now. They're walking out with
Speed.
60 out of
Yes,
60.
it's repeat after repeat, so it's like, oh my
Undeviated.
God.
Undeviated, don't know. This I repeat.
Undeviated.
I don't know.
A ray of light in
Yes.
air, and I read it back anyways. A ray of light in air strikes a glass block at an angle of incidence of 0 degrees. The light will be undeviated, right? If the angular incidence is 0 degrees, then the angular refraction will also be 0 degrees, which means that it was undeviated. So 39A, undeviated. Are you okay with that, right?
Say on and know something funny.
What's that?
That question repeating since 2006. Mind you, I was not even.
You serious?
That's
Since I
I
wasn't even a
literally,
thought.
I'm so serious, right? I'm literally doing the January 2006 paper, and that was the
Why
exact
you
question I.
why you
That's
going so
crazy.
far?
Hold on, I done do all the recent ones from 2015, Jan and June.
Oh, I want to know.
Anna who? What?
Olha, leave Shania is she's a scholar. You're allowed,
Girl, I don't blame you, girl. I went from
Scholar.
2005 straight down to 2015.
What?
Rolling.
Mm-hmm.
Okay.
Why you doing that to yourself?
Because
let me get
I
back on track.
like to learn.
Look at physical
Overachieving
there.
much.
Okay, physics back. Time to
Look
get
at
Right.
your
to
physical
physics.
there, fellas.
Enough of balling. Good.
So wait, remind me, if the angular incidence
Man,
is
repeat.
if the angular incidence is 0, is the angular refraction?
Zero.
Zero,
No.
zero.
Right. So an undeviated. What's the answer
Logic.
for 40?
B, sir?
B, yeah. They even
B.
changed up the order. That's crazy.
B for
They just-
baby.
Right?
Yeah.
Distance of the object from the mirror, right? And I explained that earlier. Right?
Just
So
check my lies, guys.
the position of an image formed by a plane mirror depends on the distance of the object from the mirror,
Not the observer.
not the observer. Because the observer could go anywhere he wants. The object
Yeah.
not gone. The object wouldn't move then. Right, these I repeat. What's the answer?
Sine 90 over
Sine
sine
90
C.
over sine
Sine
C.
90 over sine C. Absolute cinema.
Physical. Boom, boom, boom. You don't know.
know.
One physics bad.
Wait, let me see if I get a picture of me.
The thing goes good. Skibbity papa.
It's how I
Yeah,
say it, and then so
boom.
look for the sticker.
Skia.
Well, yeah, easy.
Yeah, they finish it right here, done, boy.
2 plus 2 is 4, minus 1 is 3.
I know all of that part.
Everyday man to the block. Smoking physics.
Don't
Yes.
know.
Smoking physics.
As a matter of fact,
This
smoking
thing unlocked.
nothing. Smoking nothing. We're not smoking.
Just shade it.
Blast
We're drinking physics water, only physics water.
Tell them, Manisha. Tell them. Kelani, get yourself an auto.
Oh, Mom has
Chicken
spoken.
soup. We're drinking chicken soup.
Okay, the next one, chicken.
Exactly.
See?
Absolute cinema. You don't know.
Absolute uncle.
Hey, we're
What? I don't remove him.
Yo.
I can't put Aidan in the waiting room.
No, there's a dumpling. None.
I put him in the waiting room.
No.
Nah, so you're real evil.
I will leave him in the waiting room for a little 1 minute.
Like the timeout.
Co-host, don't let me, eh?
I wish I could have seen your reaction though. I wish I could have seen your reaction.
Banana.
No,
No, Banana asked if you could do that.
And record our video and send it in the group later.
So I'm tiffing those stickers from you. Thank you very much.
He texted the group chat.
I see, right? I see.
Right, cool. Absolute cinema. There we go. I'll add them back in, right?
Yeah.
Hey, don't put them stunts in on my boy. Alright, let me go back. The refractive index of a transparent medium with a critical angle C for light traveling from medium to air is, we know that the answer is C back and running back fast for anybody that don't know. So Ni sin I is equal to Nr sin R. You leave any medium and you go into air. We don't know what the refractive index of the medium is, so I'll leave that as Ni. We're dealing with the critical angle here, so I'll replace I with C. We go into air, so the refractive index for air is 1. And at the critical angle, the angular refraction is 90. So you're gonna end up with Ni sin C is equal to sin 90. when you divide both sides by sine c to find for ni, you're gonna see that you end up with option C. So ni is equal to sine 90 all over sine c. Easy. All right, 41C. Let's move on. Which of the following diagrams is a graphical representation of current versus potential difference for a metallic conductor at a constant temperature? This is wrong. No, this is wrong. This is wrong. The answer is B. Right? I don't know. I don't know what this is. I don't know what this is, right? This look like a semiconductor diode. Right? Like this looking like the breakdown, like a pass the breakdown voltage and it conducting there. This looking like a filament almost. And this looking like an ohmic conductor. Right? The answer is D. You know why? Because V is equal to IR. So in other words,
Proportionality.
voltage is proportional to current. So it's supposed to be a straight line graph. Are you okay with that?
Yes, sir.
So,
And the gradient supposed to give you what?
well, it would give you
Well,
resistance.
this wouldn't give you resistance. It'll give you 1 over R, which is conductance, I believe.
Uh-huh.
I'm gonna verify that. Yeah, boy, about 1 over R is conductance. Yeah.
Big up, big up. So the first one not even on the graph.
Yeah, this don't make any sense. Right? This I repeat, a polythene rod. It's rub against a cloth,
Or polythene, not the glass rod, right?
not the glass rod.
Oh, so the other way around. So that would be negatively charged.
That BB.
Yeah, B, yeah.
Yeah. So when you rub the cloth against the polythene rod, it's actually gonna gain electrons. Nikolai, if it gain electrons, it's gonna become what? Someone, Nikolai, if it's gaining electrons, it's gonna become what?
Negatively charged.
Negatively charged. I don't know, right? Nikolai, are you negatively charged?
No.
You're looking, Nikolai looking negatively charged. Check Nikolai. No.
I just look like he's tired, bro. Like he just want to go sleep and then get over the physics exam.
No.
You look tired.
Okay, we had to make Nikolai smile. Somebody bust a joke, bust a joke.
Though, Nicola, you
Nikolai,
can't be
you going
negatively
back to
charged when you can't do
Okay,
that.
Nikolai.
How much you going back
Nikolai.
for? The whole 25
Alright.
or just 5? Which
What
one?
does the glass rod stay to the silk cloth?
Oh.
Rub.
Nikolai, have a
Man,
joke
bro.
first.
Yeah, because it's
Nikolai.
after the cloth after rub on the glass
Yeah,
rod.
Risha, you relax yourself.
Oh.
I said, make a joke. I'm trying to make somebody laugh.
Nikolai was
Like, it didn't work. Nikolai didn't laugh at all. Oh my gosh. Straight face.
44. Nikolai, read 44 for me.
Which of the following relationships between electrical quantities is correct?
Nobody tell Nikolai the answer. Nikolai have it. Nikolai have it in the bag.
you have it, dog, you have it.
One Nikolai badness.
Never two.
Nikolai badness.
Is it C?
Yes!
You don't know, Nicola. You don't know.
Bad.
You got
Right.
Nikolai on time.
This supposed to be P is equal to what, Nikolai?
P is equal to I over V. Or no,
IV. What is supposed to be? V is equal to what?
IR.
Sorry, a sleepy girl.
Right? And well,
Hope you're not killing me. You go first.
I'm not sure what this one's supposed to be. Yeah. Right? Alright, let's move on.
A big yawn from some.
Is I repeat, what's the answer?
1.5.
1.5. And if you're doubtful, they tell you the ammeter reading 0.4 amps. So you have 0.4 amps flowing through the resistor, and they tell you the voltmeter reads 0.6 volts. So you have 0.6 volts across it. Remember, V is equal to IR, and I would just be equal to V over R. The voltage is 0.6, and the resistance is 0.4. Why is 0.6 about 0.4?
1.5.
Why is he in, boy? Sorry about that. My brain tweaking. The way to find for resistance. R is equal to V over I. V is 0.6, current is 0.4. You get the 1.5 ohms. Yeah, sorry about that. Everybody okay with that now?
Si, senor.
All in physics. The worry said this happened to all of we.
Yeah, boy.
This happened to all of we.
Let's repeat. What's the answer?
Electrostatic.
Electrostatic.
Right? And that would mean that this, if this is positively charged, wait, what charge do you think this have?
Negative, sir.
Negative.
No. If both of them have the same charge.
Positive, same charge. Yeah.
Because okay, do they look like they're attracted to each other, or do they look like they're repelling each other?
They're repelling.
Yeah. If they're repelling, they must have the what?
The same charge.
Same charge.
Must have the same charge. Must have the same charge, right? So I'll read back the question again. Two light aluminum spheres A and B are suspended by insulating threads. Right? If it's insulating threads, any charge can't go nowhere. If they come to rest, as shown in the diagram, the force keeping them apart is clearly electrostatic. Guys, are aluminum spheres magnetic?
No.
Nah.
Centripetal force? No. Centripetal
No.
force is the force you have by something spinning around. They're not spinning around.
Like a whirlpool.
Gravitational? No. Gravitational would cause them to like meet in the middle. I see Kimura raise her hand. Kimura, talk to me.
Yes, sir. I was just gonna ask, when we get a break, because I kind of hungry.
Okay, I'll give you a break after this paper. Right, these
Okay,
are
sir.
repeat. What's the answer?
A, sir.
A.
Right? Because DC current means that we're not changing. So like remaining positive, fine, cool. All the others are going positive and negative, positive and negative, positive and negative, right?
Just to be clear, DC means what? Direct,
Direct current.
So I don't know where you tell me. I wanted to figure it out for myself. But anyway, thank you.
You're welcome. This can I step up or step down?
Step up, sir.
I think it's all step up.
That's a
It
step
has-
up.
With
It's a
AC
step
It
up,
have more coils in the secondary than
right?
the primary.
And it would supply this with alternating current for it to work.
Of course.
So step up AC input.
C.
Don't know.
C for
C for
chocolate.
CXC. Don't know we because we getting a one in physics.
Okay. I never see that one coming, but you
brawling.
did.
Smooth criminal.
Well, then
Remember,
it
buddy.
is. Rectification is best done by a what?
A diode.
Diode. D for
Right,
dog. Or Dominica.
Or for diode.
D
Oh,
for
no,
diode.
we can finish this on time. The
for the
parts
seductive.
labeled X in the diagram are known as the what? What's that?
Slip rings.
Slip
rings.
Right? Earlier, if even if Ollie didn't know, right? Look at this. What's
Now
it
I
looking
see
like,
two.
Ollie?
Two
What's it
rings.
looking like?
a ring.
Slip ring, a ring.
It's looking like a ring, Ollie. Hey.
So I
I
saw
want the
that
ring
in
from the
a
finger.
paper, and I was like, how
Sir,
to be
Simon
stupid?
have a twist
Because
hand.
it literally looking like a ring. So how it could not
It
be
literally
a ring?
It
Sir,
literally
I will
But somebody have a
be
plan. Simon have a plan.
Simon, talk to me.
Oh yes, sir. I was saying if some people might get confused, but because the AC generator is a slip ring and not a split ring, because a DC motor.
Good. That's a good point. So AC generators, they use slip rings, and a DC motor uses a tell them
Split ring.
So that's
What's the difference between the both?
Alright, so
And that split ring is also known as a commutator.
yeah, commutator, yeah.
Split ring commutator.
So, can I know what's the difference between both?
Start with scuba diving and go physics diving.
The split ring breaks the cycle every half turn.
Yep. To keep
To
keep it going.
keep it going, yeah. Because the Lorentz force will act
Scuba
downward.
diving.
That's
Yeah.
why it is called a split ring.
Yeah. I mean, look, it literally has split ring. You know why? Because look, it literally splits. Right? It splits in
Split
the
in the
middle.
middle.
Oh,
Hey, I know that song, sir. Hey, you never hear that song?
It's split in the middle. I didn't mean to be funny. Oh my gosh. Science amuses me. I like it.
right?
So
And
I'm taking a screenshot.
sure.
You? Okay. All right. Wait. Oh God, how that going so quick?
All right,
So I
cool.
wasn't finished.
Hey, hard locks. We gotta move on. Time
It's
pass on by
okay.
there. Time pass on by there. Which of the following best represents a series arrangement? I'll look at this.
B.
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 Right? In all the others, the current is splitting. If the current is splitting, then it is not a series circuit. Series just means one after the other. And the current never splits. Watch, look at this one for instance. The current is gonna split at this node here. We can't have that happening. Look at this one over here. Current splitting here. Can't have that. Look at this one. Current splitting here. Can't have that. Right? Cool. Which of the following diagrams best represents the magnetic field around the wire? So in the question they're saying it represents a straight wire carrying a current into the plane of the paper. So let me show you how we're gonna do this, right? You're gonna use your right hand grip rule. So stop share. Okay. Are you seeing this, right?
Yes, sir.
Here we're gonna do. So they're telling us that the current is going what? Its current is going what?
Into the paper.
Into the paper, right? So you're gonna take your right hand. I don't know the difference between your right hand and left hand.
Nah, I don't think so, sir.
I don't know, sir.
So can you educate me, please?
No. No.
Oh, no.
You know the difference. You know the difference. You big on assets. This is my right hand. I'm going to point it going into the paper. Gosh. Into the paper. Like this. And I'm gonna observe how my hands are curling. So it's going like in this direction.
Clockwise.
Alright, watch. Are you seeing that, right?
Yes, sir.
Devani, you study Kelani. Kelani, he knows the left and right, you know. He just playing a fool there. And telling only meme with the Indian and I was like, don't try to play a fool with me, Pukesh. Don't try to play a fool with me. Yeah.
Yes, sir.
Mazaka.
Thank you so much, Devani. You're so kind.
Kelani, you just wicked.
You're welcome.
Devani, don't study Kelani.
At least Devani want to help her. Come on.
Kelani, you just wicked. Be quiet and focus.
Right, so where's my answer?
D?
D's my answer, right? Everybody okay with that?
Yeah.
Yes, sir.
Alright, cool. Let's move on.
So X is
Which are
always
the
in and a dot is out.
Right? This is an gate, right?
Yeah.
These are not. This is an. These are what?
Oh.
These are what?
A NAND.
None. They just take N and put it in front of and. None.
It actually stands for not and.
Yes. That's what it means.
Okay.
Which of the following is most suitable for the core of electromagnet? I repeat.
Soft iron. Soft iron.
Soft iron.
Right.
Hold on. I think a
soft iron,
question
battery
like
bind.
this was in chemistry.
Oh, go. I
You
hate these type of questions.
You should be able to mash up this then.
Alright, so there we go, right? So Mazakan. Let me just make this a bit bigger. Mazakan. Alright, cool. So helium is 1, 2, 3, 4, 5. Ollie, I don't like chemistry, eh? Ollie, will tell me if I'm doing something wrong.
We know
So
this.
don't make Cassidy here, you know. If Cassidy
Wait,
here,
wait,
you
wait,
Yeah, I was
wait,
gonna
wait,
say where's
Cassidy boy.
Cassidy?
Wanna come in the next class.
Wait, Cassidy boy.
So, like, if I remember correctly, 1, 2, 3, 4, 5, 6. How many protons does element B have?
So you have that wrong, sir.
Sir,
I don't do chemistry, Ollie. I don't do
No, it's wrong.
chemistry.
All right, sir,
I
let me
don't
tell
do
you, sir. Hold on,
chemistry.
sir. Hold on.
Chemistry.
Sir, it will be,
Chemistry.
that's fluorine, right? Beside it is oxygen.
Right.
So that's
Oxygen
8.
is
That
that
is
is
8.
8. Oh,
Yes,
yes,
and then
yes,
we have
yes.
Yeah,
nitrogen.
oxygen is 8.
Oh, you had to go
Then we have
backwards.
carbon,
You gotta go
6.
backwards.
Then we have
Right.
boron,
Ollie, I
5.
don't do chemistry. I don't do
It's
chemistry.
5.
But
Yeah.
5.
sir, and your
Cinco.
daughter is a
Sí,
chemist. And
5.
one of your daughters is a chemist, and you don't do chemistry. Look at the
I
disrespect.
don't do
That is
chemistry. I don't do
crazy.
chemistry. Any
Cassidy
diagram?
is so disappointing.
NA is short for neon, and A is short for
Yeah.
neon, and N is nitrogen. Yeah.
And then B is
Cassidy,
boron.
Anisha.
Boron.
B is
Right.
boron.
So N would be 10 and
Beryllium,
helium
go
would be 11.
BBE.
Wait till
Yeah,
you.
BE.
Yeah, boron has 5 protons. Right? And don't get confused, right? In the periodic table, this number over here is actually an atomic number. I cannot sus, but yeah. All right, chemistry.
Usually in a stable atom, the protons and electrons are same.
Well, the ratio. I think for it
Yeah,
to
the
be,
ratio.
I think it's like a 1:2 ratio or something. Let me check it. Stable ratio. I don't do chem though. I don't do chem. No me and chem. Okay, so for lighter elements, it should be a 1:1 ratio. And as atoms get larger, electrostatic repulsion requires a higher proportion of neutrons to stabilize the nucleus, eventually scaling up to a 1.5 to 1 ratio. Okay.
Neutrons are electrons, sir. Electrons the protons, I'm saying.
Well, we're comparing protons and neutrons here. Yeah. It's mainly the proton to neutron ratio we're looking at. Right? But the answer is 5.
Okay, sir.
Yeah. Alright, so 55. Yeah. Cool. Yo like Cassidy, see, man. Do this.
Too late, sir.
Cassidy will come from.
You're on live. She go see the live.
My thing is maths and physics. Yeah, I don't really know this chemistry. Not really chemistry thing. I
Yeah, but
really
sir, you went to her class. You should have paid attention.
should. That was my day off. That was my one day off.
Sir
That was
didn't
my one
stay
day.
too long. Sir was just there to see us start off, and then he left.
Yeah. I had to support my children, you know? Yeah.
Mm-hmm.
Right? The number of neutrons present in the nucleus in the nuclide. Okay, this one not bad.
Subtract it.
This is P plus N. And this over here is just P. So
Yeah.
if I want to find
136.
neutrons, 222 minus 86, that would be Renisha.
Okay.
Renisha, why are you looking at us like that?
Oh, sorry. Okay. Now is not the time to fool around, Renisha. Stop
It's
it.
136. 136. Until I get out,
Yeah.
136.
136.
Alright,
Isn't the
cool.
puzzle answer? You can't minus it and get 308. You can't minus it and get back 86. So it has
No, that's not making no sense. That is no nonsense.
That is not legal.
And illegal. Alright, let me follow. Okay with that.
See,
Yes,
senor.
sir.
Which of the following cannot be deflected by, sorry, repeat. The answer
Gamma
is
rays. Gamma rays.
Gamma rays.
right, because that's actually
X-Men only
EM
use
radiation.
expensive gadgets. Keep on remembering that.
I wouldn't really say that so much, but gamma
No.
rays is an EM spectrum and
Gamma
is
is gadget.
right and is EM radiation,
Yeah.
which is not a particle, so it's not charged. Sodium 24 decays into magnesium 24 with the emission of a beta particle and can be represented by the following equation. Which of the following options should be placed in a box to complete the equation? So beta particles are what in nature?
Fast moving electrons.
Right, a fast moving electron. So I could write that as what?
E0 -1.
Yeah.
Yeah.
So we're looking for something like that.
B.
Where's the answer?
Batman.
Batman. Right, because beta is a fast-moving electron in nature, so 0 minus 1e.
I
0
love
minus
that
1.
man.
I move
Yes,
on.
sir.
Which of the
Oh, you-
following scientists Marie Curie?
Marie Curie.
Marie Curie.
Curie.
Apparently, they get offended when I say the term chicken curry, so I wouldn't say it.
All right.
Hmm.
All right. Nikolai gonna help me with this one. Oh, Nikolai love these type of questions. Nikolai, my boy, he loves these type of questions. Nikolai, get us a read from.
The radioactive isotope has a half-life of 20 days. How many days will it take for a given sample to have its activity reduced to 1/8 of its initial value?
Right. So Nikolai, in 1/8, how much half-lives you have?
20.
Nah. So like, okay, Nikolai, in one half-life, the quantity is reduced by, okay, you half the quantity, right? Okay, let me explain what I mean, right, Nikolai? So in one half-life, right, Nikolai, it would drop it by a half. In the next half-life, you'd find a half over half, which would be a
quarter.
Right? And in the other half-life, it go turn down to you find half of that again, and that'll give you what?
1/8.
So how much half-lives is 1/8?
3.
Right, 3 half-lives. So if that is 3 half-lives, what is 1 half-life?
20 days.
Right. So if 1 half-life is 20 days and 1/8 is 3 half-lives, how much half-lives? Okay, how long will it take for that to happen?
It'll take 60 days.
Yeah, 60 days. Are you understand that?
Yes, sir.
Good job, Nikolai. Good job.
All right. So here what? That is a day.
That is in the chat for Nikolai.
So,
Yeah.
you can just run back up to the beta question real quick. What you see, what used to confuse me, sir, is it have a negative one, but it's still the number at the bottom adding. You can just explain
No
that.
problem. What is right? What's 24 plus 0?
0.
Not 24. 0 plus 24 is 24.
Oh no, my bad. We're going with my brain, right?
And
24.
what is 12 plus negative 1?
12 plus negative 1, or that is 11. Yeah.
Yeah. You okay?
Oh. I see the connection. You're saying 24 plus 0 and then 12 minus 1.
Yeah.
All right, I get it.
Also, sir, the subtracting at the top as well as the bottom, as well as
No,
the bottom.
no subtraction. Watch. No, just 24. Watch. 24 plus 0 is 24.
Oh, so it's addition on top, subtraction below.
Both is addition. Watch. 24 plus 0 is 24. 12 plus negative 1 is 11. When you work this
Oh,
out,
right.
a positive and negative is a negative. And I put 12 minus 1, which is 11.
Also,
So
yeah,
you see
understand.
like I'm making mistake and say 24 plus 0 is 0.
Yeah, why?
I feel like you when you say half as 4 is 2.5.
It has happened to me, It has happened to me, so it has
I
happened to
just
all of
wanted
us.
to make sure I see it correctly because I don't want to go and put the wrong thing in the paper. So.
Alright. So I'm gonna give all a little break, but press F in the chat to pay respect to Kilani boy. Kilani, that happened to all of us. So we're gonna come back in like 20 minutes and we're gonna rock 2020.
Yeah, I have one thing to say, sir.
Did you sir do exam?
Yeah.
I
Yeah, Nikolai,
can't wait to see the question.
talk to my son.
You remember I was talking about dad jokes?
Yeah.
What did the carpet tell the floor, sir?
I've got you covered.
Okay, oh yeah, basically.
He done it a long
The
time.
master of dad jokes. The master of
I
dad
know
jokes,
they're
my
talking
guy.
about me. Oh my god. Oh my
Bro,
god.
you can't dad joke your father, dog.
Good, my father always yet.
Wait, then Nicola, ask me back the joke then. Ask me back the joke.
What did the carpet tell you for?
I've got you covered.
Okay.
So I agree with you, yeah.
Nah,
You
you
take
can't
off
for that
your
one, dog.
you take off your respectable spectacles to put on the shades.
Uh,
I'm missing my shades, yes.
Hey, sir, let me get that joke there.
I'm good. Here this one.
Why don't skeletons fight each other?
why?
Because they don't have the guts.
I thought he was gonna say bones, you know, but that's not better.
Yeah. Why
So,
can't you? Why can't you give Elsa a balloon?
Oh, because she will freeze it.
no,
Nah,
what?
no. Let me ask again. Why can't
Because
you
she will
give?
let go. She
Let's
will
let she
let
let
go.
it go.
She will let it go.
Yeah.
Let
Oh
go.
God, I wanted to. Oh God, that was
Those
my
kind
fault.
of
My
jokes,
fault.
boy.
Okay,
Wow.
okay, okay. I'm sorry. Jeez. Oh my God. I crashed out twice for the day.
Uh,
Hey, so we thought about 180 questions or something.
more than that, because we did 3 papers in the first live,
Oh yeah,
and
yeah,
we
yeah.
just finished 3 papers, so like
About
this is
240 or
performance.
something.
This peak. Yeah,
300, about 300 questions in a sir.
yeah, boy.
Yeah,
We
more
ain't
than
reached
ready for physics, man.
667 yet.
Hey,
You
hey,
reach
hey,
this.
hey, hey.
What? I
Calm
never
down,
said the
calm
67.
word.
down. Calm down.
What I say? I
Aiden, take
counted.
off them shades. Take off them shades. He was distracted during physics.
Oh,
Oh, you want to hear a dumb joke?
yes, sir. Let me hear.
There you go.
There was a break-in at a wig factory. The police are still combing the area.
What?
What?
I rate that A plus.
I read that.
You know the expression combing the area. I mean, like the station for something, and it's a wig factory. So here, like
Yeah, the comb in the area.
The community area under the graph?
defining distance travel. Here, what? I give it another 20-minute break. When we come back, level action.
Under the curve.
10.
There's a jungle out
So have a
there and
joke
the
for
fun
have a
is
joke for so
on. We're
it's a
gonna
physics
hunt you
joke.
down. We're gonna hunt you down.
Right.
Oh, good. Sorry, there's not here happening.
So have a joke for
Talk to me. Talk to me.
physics joke. So you know my favorite kind of pastry is?
What?
I mean, I call it a ampere roll, but I hear people call it a current roll.
Good one, good one. People that in the chat, you know.
Hey,
People that
let
in
me
the
get
chat.
that physics joke there. Hey, why can't you trust an atom?
Why? I don't know why. I can't.
Why?
Because they make up everything.
Oh,
Oh!
that's a good one. That's a good one. That's a
Hey,
good
it's only physics people who understand that joke, yes?
Yes.
Nah, physics and chem people, don't worry.
You know,
Oh
I would tell
yeah,
you.
don't forget Chem.
Nah, that joke I was going to tell you was too dark. It's too dark.
Nah, sir, tell we not, sir.
No.
Yes, sir, Tawina.
No.
All
What
right,
tomorrow
all
doing
right.
there, boy?
Kimura
All right,
always
sir.
like
I have one. I have one. I
wait,
have
like
one.
Kimura always put on she camera and you wear it like she told me what food she eating like
No, but
she
she really said she was hungry, and so she said she was hungry, and she making some fried egg there.
I know because this is making egg.
If you
Okay,
think about it,
let me give Renisha a chance.
All right. The teacher say, why are you late? The student say, because Einstein's theory of relativity. How does that explain being late? To me, it felt like 5 minutes.
Like no, like with Renisha, like I don't find it so funny, it's just like the delivery. Like it's you saying it. So it automatically funny.
I remember that from Spider-Man.
Yeah.
Spider-Verse.
Renita girl, I love you, but you're reading from the screen like your aunt and them when you hand them the phone. Auntie, look at this.
None taken.
Renisha is trying to move like an auntie.
What? You see me? I don't, yes.
absolute seminar.
Hey, all you hear this, eh? What did one traffic light say to the other?
What color you
Look,
turning?
no, no, it said, "Look away, I am changing."
No, no.
That's it.
Oh, I get it.
This is Comedy Central.
Yes,
So
comedian.
you ever hear about Aidan's law?
No.
Aidan law states that aura is directly proportional to Aidan's presence.
Oh, the huzz.
Oh,
Hey, Aaron, you know about Bobby? Do you know about Bobby?
Who?
The guy on TikTok, like the chubby boy, and he be like, Bobby trying to get the horse.
Yeah.
Yeah, you just remind me of him. And like
Dang.
Bobby
So
look
what
like
about this one? What is interior? The reason my body remains at rest when my alarm goes off.
what?
Oh,
What?
Renisha, what you talking about?
It's best I stick to normal jokes. This ain't making no sense.
Yeah.
Okay, guys, while
You're
we on this
fumbling.
break, people on YouTube, don't forget to subscribe. We
A little bit
don't want
close.
we don't
Wait,
want that button red. We want it gray. Turn on those notifications.
watch it.
Yay.
So you can't say I don't advertise for you, right?
I appreciate it. W.
And it's advertised too.
Guys, just
Okay.
remember, there's a reason they're passing physics and maths.
Yeah.
So charge your pen.
Tell them Rondell.
The charging right now as we speak.
All right. What do you call a sleeping chicken? No, not that one, not that one. Hey.
I just be
I'm
scared.
gonna,
I just be
I'm
scared when
gonna get
Renisha
good luck.
talking, you know. I just be
Yeah, me
scared to hear
too.
what Renisha gonna say.
Me too.
Me too, you know, so I just be in class,
Oh
I just be
yeah.
quiet, yeah, but I get a little scared sometimes when she's been talking, so.
Yeah, like I don't know if she
Yeah,
can
she and
anticipate.
Nikolai, because
So
sometimes Nikolai know, man,
was
sometimes
our
she
union
do weird
end?
thing.
Nikolai just be moving like a man 6 boy. Yeah, lead.
Aidan, what is our union? MSC, I ram.
what happened to my
Yo,
brother?
you on
The
YouTube,
man.
bro. We on YouTube, bro. Chill out.
Yeah, we can't get demonetized.
It's
Kim,
our
on
union
a long
end.
good day.
Who eating
I
good
hope,
day?
I hope you put enough salt, eh?
Ole, don't say anything. Don't say anything.
Exactly.
Don't say anything inappropriate. And when I say that, I'm looking at Renisha while I go on. Renisha, looking at
That's
Renisha.
crazy.
Right,
Why
Renisha?
me? What me you doing that?
You know why, right? I'm going to make some
Wait.
cup noodles. I'm coming back. Try not to blow up the YouTube channel, right? Try not to make sure I
Children
tell people
ban.
to subscribe and
Blow
thing.
up the
Yeah, subscribe, guys.
subscribe account.
Subscribe for
In the
vibes.
meantime, Ole could probably explain these questions to the good people on YouTube.
I'll go with number one.
Go ahead on. Let me see what all that paying attention he was doing. But okay.
The measurement of an external diameter of a measuring cylinder is most accurately done using, I would use a pair of vernier calipers. Now, I don't know if that's correct or wrong. Somebody back me up on that.
Why would you use it?
I think so
Let it be
too.
a tape measure.
Because they cannot
Okay,
use
so
a tape
I'm gonna tell
measure.
you why,
And
right?
Nikolai Kirk,
So they say we measure in a cylinder. If we think about it, a cylinder is a solid. They want the external diameter, which refers to the outside. So
That's
think
basically
about it.
this.
The vernier caliper is really used for smaller things, like if you're trying to measure the inside diameter of a test tube. But they didn't say that. They said a cylinder, which is usually a bigger solid.
Yeah.
so probably
It's
like
not
that.
How
the
big are measuring cylinders be? Wait, is it
It's
all right,
between
let me show
small
you.
and
Let
big.
me show you. Hold on. Wait.
The only
You should know you
hold
have
on.
one.
my sensor scale kind of thrown off right
I
now?
think it could still
Wait.
be the
Let me
vernier
show you.
caliper.
I
A
was
test tube.
thinking of the long tube thing, is it not that?
This is a test tube. Oh, I don't know if you can
Nice.
see.
The
Oh yeah,
test
you can
tube
see this.
is the skinny one, but the measuring
Yeah,
cylinder is like it
It's
have
a
it's like a
test tube.
25
lumbar one.
pm
Those
and
are
it have
measurements on it.
100 pm
It
and
have
whatnot.
this one and then it have the longer one.
I was thinking like the skinny tall one or the skinny short one.
But
But
hold
that's the
on, let me
one that
think
is
of hold
mostly
on.
in the labs.
I wonder wait. I wonder so you know what we're going to erase it after. Hold on. Hold on, let me figure this out.
What are people on YouTube saying?
Right.
Yeah,
If
we'll
this
do
is
it.
the
Just I got check.
measuring cylinder,
I
right?
got check after
It not fancy looking, but are we measuring cylinder? If we're trying to measure here, this outside piece, because that's the rim. So the thickness, because they say the diameter, we would still use the vernier caliper.
So we canceling out A, B, and C.
Cool.
Yeah, think about it. This could be used to measure perhaps the length of a string. This could be used to measure the distance of a table. This could be used to do
You
distance
keep saying D, boy.
for
Everybody
something
saying D?
smaller. So the
You keep
only
saying D.
option is D.
Given that force is equal to mass times acceleration, then a unit of force could be written as.
Well, we know this thing. How people is do this?
We know mass is kg.
Yeah, we know mass is kg.
Acceleration
So we
is
just put it over each other and what do cancel out this
acceleration is ms minus 2.
minus
So it's D.
And we know the units for mass. We know the units for acceleration. We know which option.
kg ms minus 2.
With me, if I
That's
say the
D.
answer is D.
Wait, no. Yeah, that's D.
Well, it's a little light, so I can't see too
Yeah, I
good.
can't tell.
Yeah, it's a little hard to see.
I have on glasses
What
and
will
I
YouTube saying?
YouTube saying C for this one.
C?
Okay, well, they probably seeing it better.
Actually, I can check on YouTube.
This one, you move the
it would be
point.
D. It would be D.
Yeah, I think it's
It would be
D.
D. Not C.
Because when they're explaining the number, say minus 1 close to the M, they say ms minus 2.
Yeah, it's kg ms minus 2.
Would. Okay.
Well, look at your physics students, boy. Clock it. Good job. This is a whole show
That
for me, boy.
okay, yeah. That number is expressed in the standard form is. So this is 1, 2,
It'll be 4.62 to the power of negative 4.
4, 5.
Wait, no, not 4.
I
5.
think in
Yeah,
A.
it'll be 5.
I think in A it'll be
Yeah,
minus 5.
A.
Minus 5, negative
I was
5.
counting
Yeah.
the decimal points to 4.
I counted and I get 5. So
Yeah, I'll get 5. So it'll be
Even
A.
if you wasn't sure, right? Even if you wasn't sure, when you watch all the options, it only have 5 and 4. And if you wasn't sure and you counted 4 decimal places, you would see it would stop at a 0. So
Yeah,
you
it would
know
stop like right in front.
automatically that B and C would not work. So then you would have to look at A and you'd have to look at D. The
Also,
difference with A,
No,
go
you
ahead.
have to look at A and D because the rest would have been positive. You'll end up with a bigger number.
I don't know if
Exactly.
I don't know, depending on what kind of calculator you have. You could just multiply out each answer. It would take
Yeah.
calculator to see
Yeah,
if they
that's
get
true.
good.
That's true.
That
But
too.
is the power supposed to be positive or negative?
Negative.
Negative because you're going backwards. If it was a
Right,
bigger
so-
number, it would have been positive.
Right. So if it's negative, then we shouldn't look at D.
Yeah.
Well, yeah, that's what I'm saying. If we want to go like the process of elimination and you wasn't sure, that's how you do it.
Yeah, you'd have be narrowed down to A and B and you'd have just make a educated guess.
What going on here?
We got which
Good,
question,
ready
sorry?
for
They got
questions.
themselves.
Yeah,
They're doing
reach
real
5.
good. Real good.
And
Yes,
we're
we're teaching.
reasoning. We're reasoning good. We're
Yes, sir.
reasoning
Yes,
good.
sir.
Oh, let's teach them, all right? I eating food here. All right,
Yes,
so,
sir.
Alright, so
all right.
Hello, Big Buck, yes?
What's the answer for 1?
D.
We concluded to
D,
D.
the vernier
We conclude
caliper.
to
We
D.
went with vernier calipers.
Vernier calipers. Cool.
Yeah.
That's
The
correct.
reasoning we went with D was we drew a little diagram and we discussed it and we came to the conclusion.
We came to the
Yeah.
conclusion because nothing else would work.
Yeah, nothing else would work basically.
Also,
length-
you said D.
We
Ah,
scrap
you
out A,
know
B,
that.
and C, and we went with D.
That's correct because a vernier caliper could like clamp down on like diameter or something.
Mhm.
So isn't that why it had the kind of screw thing on top to screw it in to hold the object in
I think
place?
you're talking about a micrometer screw gauge.
Oh, wait, hold on. I know for the vernier caliper, it have something you had to tighten for the object not to move.
When you
She
caliper
talking
shape like
about
a
like
wrench.
the claw
Yeah.
and
Yeah, the
the
claw.
vernier
Shape like
caliper
this.
to adjust it.
Yeah, that.
Yeah. It have this bit. I'm gonna show you it have. Like it have this little thing
That.
over here.
Yeah, that is what I was talking about.
Yeah. But as you can see, we could put something here and we could directly measure the diameter.
So we use the example of a test tube.
That's good. That's good.
My drawing skills wasn't all that though.
What answer what two will be?
D.
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 We use you divide it like, and you know it's
We
per
wrote out
kg
we
No,
over
wrote
mass.
out the formula and we
yeah.
say that
Yeah.
kg, well, mass was kg, and we say
Mass is
what
kg,
acceleration
acceleration
was.
is ms minus
And
2.
then we came to the conclusion, kg ms minus 2.
Right, that's correct.
Yeah.
3. What is?
A. Count the
A.
decimal
You
points.
count the decimal places going
Yeah,
back.
Right, that's
going
correct.
back.
And you need to be
So
a
And then we
negative. Because if it's a positive,
4.62
you're
times 10 to the power of negative 5. Because it's negative. So we
yeah.
can't use D.
Since it's a point, it would be a negative.
and
If it's a
then
positive, you
we
end up with a
even
bigger
say
number.
we even
Mhm.
say with the process of elimination, when you watch the options, the powers is only 4s and 5s. So if you was to shift the point 4 places, you would stop at a 0. So you know automatically B and C would not work.
Correct. Cool.
Cool.
4.
Well, we didn't see
This
this
was
one
cut off.
because
We didn't reach
it was
there
cut
yet.
off.
Yeah, we didn't get
Yeah,
cut
we
off.
was cut off. You just came
Right.
back and
I think the
joined
answer to this is D though.
Yeah.
70 kg standing on the moon. When you
Because
return
weight
to
is
Earth.
Hey.
equal to
Wait,
mg,
let
which
her
is
explain.
mass.
Let her explain.
Yeah.
Go ahead.
No, I was just reading, you know.
No, go ahead. Explain, girl. We listening.
I was saying weight is equal to mass by gravity.
Right.
We were given the mass, which is in kg, and we know that he returns to Earth, and the gravity on Earth is relatively 10. So 70 multiplied by 10 will give you 700 newtons, which would be D.
Exactly.
Right.
Exactly.
Yeah, exactly.
They put our first part over there to tie up, right? They put out there just to tie up. Right. We have 5 minutes again. Oh my! And I even eating food yet. Oh my god.
So
Damn.
go ahead and eat your
So eat
food.
your
So just
food,
zoom back
eat
out
your
how you
food.
had it. We go explain and you eat.
Yes, just
Yes,
shift it a little more so we can see. I don't know how you're doing that.
I know.
All right, who wants to do number 5?
I'll do
That's
this
so
one.
eat.
I can't even see that.
All right, go
I
ahead.
can
Go
see
ahead,
it.
I'm listening. Go ahead.
So
Which
I
paper is
know
this?
This is 2020. Yeah,
2020.
right. Yeah, right.
COVID. COVID, yeah.
I believe the answer for this is C. Because
Why? May I ask you why you
I
think
mean
it's that?
the given definition for a moment of a force is the force multiplied by its perpendicular distance to the pivot. And
All
C
right.
looks like the closest answer to that.
That's
Okay,
correct.
very
That is
good.
true.
Who want to
And
do number 6?
even if you wasn't sure, if you knew the formula tells you roughly an idea, the definition.
Yeah.
Everybody else seen this properly?
It kind of looking finished, but I could still make out a few words or something.
6 is D.
For 6,
Yeah, 6 is D because it's
unit of moment is
is
NM.
NM because
Moment.
yeah, moment
Momentum.
Yeah,
yeah, it could be
or
Newton, which is
momentum.
the force
Yeah,
by the distance
momentum.
covered.
But I take all the time, right? Momentum.
No, momentum is Newton
Mass of
seconds.
velocity and mass of kg.
Momentum is mass times velocity. Mass is
Yeah, so
kg.
it wouldn't
Velocity
be
ms
D.
minus 1.
That would be
All right, so
Newton
the
seconds.
Yeah,
Or
so what's the answer?
it'll be A.
answer
D.
B.
B.
Honestly, I can't tell you between B and C because
Yeah,
I
you
can't
can
see
look,
the
it's
Yes,
hard
board.
to
it's
see
so
it.
blurry.
All right,
C is the power to minus 2.
so the person who answered
Okay, then it's B.
the answer is B. Km s to the power of negative 1.
Allez, map up and child. What percent reach? 97, that's cool.
97.
97 minus.
Which
7.
of the following remains unchanged with an increase in its temperature?
So which
Mass is
answer is it?
repeated.
Mass.
Yeah, we got
Mass.
this.
That is a
previous.
repeat question.
Yeah.
Next one is
10.
10.
10.0.
This is also a repeat.
As a repeat.
Is it?
Yeah, it is.
They change it from 1,000 to 10.
All right, so let me explain this. Well, this is the way I would do it, right? I don't know if I'm correct, but came out. I was going to multiply the 4 by the 5 and get 20, and then divide
By the 2.
by the 2.
So
and
it
get 10.
works that way also because that's what I did first and then you
So
explained.
that would be the correct way?
Yeah.
Well, okay,
No,
so
the correct
the
way.
formula would be force equals mass by acceleration, but we don't have the acceleration, but we do have the mass, which is 4. To get the acceleration, it would be 5 divided by 2, which you'll get 2.5, which we would use as the acceleration. So it will now become 4 multiplied by 2.5, and that's how you'll get the 10.
Okay, I heard that way, but
Right?
I will go
I'll be
with
10.
that way instead of the way that I thought of.
Both is fine.
Okay.
Hey, what? I go on. Let me take a little break. Let me bring the rest for a little bit, and then go resume.
Okay.
Right?
No problem.
I go say at 10. I'll listen like all have energy, so we could go. Maybe we could start back at 10.
10. Okay, no problem.
No
Right?
problem,
Because
sir.
I still eating my.
Yeah, let's eat the
Anybody want some cup noodles?
Raymond.
yeah.
I
Yes, sir.
love
Pass,
Raymond.
master.
Flavor, what flavor?
Ooh.
Thank you.
Yes, sir. I taken. You're passing.
No, but sir, check
What's that?
tomorrow.
Okay,
You're
Nikolai. I got
making me
drop
feel
the
for
bang.
cup soup, you know.
So at the fork.
What are you eating?
Ooh.
Sir,
Sir,
I
this
get
cup
it.
is
I
for
get it
you.
for ready.
Eh?
I will get the pass through. I get it for ready.
Sir, this cup is for you.
Ronald ready, boy.
Hey, boy.
We're going to eat up that physics exam tomorrow,
Of
just like our
course.
sir is eating his cup soup.
Of course.
Period.
Yes.
Hey, look, Rondell. Rondell, what was your plan?
I get to.
That was good. And you was in the art math class?
Yeah.
Sir,
Yeah.
he was asking for some noodles, but you didn't give it to him.
My God, you
That's kinda
guys, I
sad.
forgot to ask. Oh, wait, never mind. How hard maths paper 2 was?
It was good.
Okay, good to know.
How chemistry was, guys?
It was okay.
It was
Out
okay.
of
I'll go
10,
it was okay.
Nah, I agree.
out of 10, I would rate it a 9, okay?
I,
A 9.
So
Guys,
I'll go like a
Cassidy will
7.
help
I'll go
you.
like
I'll
a
give that
7.
7 as well.
Yeah.
I'll
I
give it
think me
that
and
for
Ronald
you.
on
I'll
the
give it
same
that for you.
wavelength.
I kind of
Or
forgot
you
why
just
this
mean to
vibe
say,
for
or you want to
physics.
say 6, 7, eh?
No, I
No,
was trying to say that.
not real.
It was nice that we get some repeats and stuff like that.
That's
But
why I
like
like
at
it.
at the same time, I don't think I do as well as I wanted myself to do.
Yeah.
Like, you understand what I'm saying?
Yeah, same.
I have a
I
question
see,
for
I
everybody.
answer the repeat questions correct though, but
Wait,
the
there's some.
questions that new, I don't think I would really.
What's your question? Whoever this is.
Where people say it was like
Right.
repeats, but like
So
repeats from
tell
like
me if it was just
2016.
me alone, right? And some of the questions, the print, 1 minute, the letters space out wide, and then the next minute, the letters jumble. Was it just me or was it print
No,
a
I
little
saw it
weird?
too.
Yeah, me too. I saw it. It was kind of weird.
I saw
I
it.
started to feel like I was genuinely losing my marbles trying to read and understand what I read and when the letters, like if I read in the alphabet.
So I have a question. Your eyes just be playing tricks on you. 1 minute you're seeing something, and when you turn back to make sure it's the correct thing, you see you're
It's
watching it
not the
like
right thing.
hours there.
Yeah, that's so
Sometimes I
true.
feel like I had the wrong
It
prescription in
happened
my
to
glasses.
me.
Okay, physics students, I'm gonna take my leave. Y'all got this. Enjoy your break. Y'all will mash up the exam tomorrow.
Of
Bye,
course.
guys.
Good luck.
Later, Sarah. We love you.
Bye.
It's probably the easiest paper one, you know.
Nah, IT was level food, sir.
Nah,
Tomorrow, did you make
agree.
your egg?
Not English. I feel like English was pretty
Yeah,
good.
long time.
English. Well, I'm glad you all say English was good because I didn't do it this year, so that'll be good.
What do you mean you didn't do it?
Because I passed the subject.
Oh, you're sitting over. Oh.
Yeah.
I'll never forget
Agree.
Renisha's older
Yeah,
than most
I
of us.
Hey,
forgot.
So
don't
obviously
make me sound
writing.
so old.
No,
My
I don't
God.
mean it
Don't
like
worry,
that. Hold on,
Nikolai is like
I
30
don't
80 or
mean it
something
like
this
that.
year.
I mean it as in like you're not
What?
doing the
Yeah,
full
Nikolai turning
subject
18,
as
sir.
us.
I think Simon is the oldest.
Nikolai, how old are you, son? I should know, but
He's 17 turning 18.
I'll let Nikolai
Dang.
talk. Nikolai, come from Nikolai.
Think
What's it?
he AFK. Oh no, he here.
He might have gone to get something to eat. Probably.
Yes, sir. Here.
Nikolai, are you turning 18?
It's not 18, I'm 17.
You're turning 18 by August.
Yeah, but I'm 17 right now.
I say you're turning 18, not your is 18, bro. Shit.
Hey, I thought you do English, and you're supposed to know better. You're big and you have sense. Speak proper English.
Whoa.
Shucks.
Whoa.
Ben Simon is
So
19.
But some people in the Zoom chat saying they're turning 17 next year.
somebody is 16 in this
Troy is
thing here.
16.
Yeah, somebody saying
I'm
they're 16.
16 too.
I so
I'm
What?
happy.
16
My
too.
Right
birthday,
now,
I
I
feel
I
old.
turning 17 after
Sir,
Christmas.
this trend
It's
making me feel
17.
old, you know.
Renisha,
This trend.
I write an exam
I
at
am
16.
18. Remember, my birthday is later down in the year, and I born in
Same.
2007. I born in November, so
Oh, me
I would
too.
have turned 18 last year. I was
Then,
17 during
Ain't no
CSEC
way,
last
boy.
year and turned
Renisha,
18 in November,
what day in November?
the 6th.
Before me.
Scorpio. Yeah.
What comes after 6?
No, we ain't
No,
getting
Seven.
I
no,
know
no,
guys,
Kalan. Does
no,
Kalan you
guys,
say
no.
that?
guys,
Does Kalan you say
we
that?
getting called old in the chat.
Hey, all you know is all thing is the throw, yeah? No, all you please.
Okay.
Whoa.
Renisha, I gotta complete all your dog.
I ain't no old. At least
My
I just look
birthday, I
like
kid
some
you or
all your
not, my
parents, but
birthday
I'm not.
is in the next 14 days, and my birthday is after my exam. I chilling,
Oh,
I home, and I happy.
you home? Well, girl, we go celebrate together because my own is during the new school term.
Kimura eating good, boy.
Same.
Tomorrow you can boy.
What you eating?
She eating
Gun
bread
oil,
and
gun
fried egg,
oil.
and she drinking tea.
I like
Tomorrow.
it.
Tomorrow always showing me showing us what she eating.
So, and your birthday is in December?
Yeah.
Well, yours is during the Christmas season or the Christmas
That's a
break or
nice thing to
something.
have.
However,
Let
We
me
however,
overlook
Queen's
stay.
November
birthday
birthdays.
is in
You
December.
home for your
However,
birthday? You know I
the
had to be
Queen's
doing.
birthday is just now.
Oh, of course, of course.
Renisha,
Somebody
you
birthday
happen.
is Boxing Day.
That's
No
tough.
way. My birthday is the
Yeah.
13th of December.
Oh, well, my mother is the day after you.
That real
Big up
December, December,
December,
you
because
say,
one time.
boy.
Yeah,
That real
I love my
December, you
mother,
say.
yes.
For your
And
uni.
my uncle is the 8th.
Okay.
That's about
Good. Oh.
Yeah, gun oil.
90 body gun oil.
What? What are they talking about?
You know that,
What is
sir?
this?
Them talk
Oh
about
yeah.
food.
I
I went
hope it's
on that.
crude oil all they're talking about
No,
and not
no, no.
oil.
When good box lunches come in school, yeah, I showed that.
No, I don't know about that.
Hey, Leo, we don't get a box lunch again, no.
Yeah,
We
for
Oh
real,
my
eh?
Oh
God.
yeah,
You gonna miss
man.
that soup.
Unless I'm doing A levels, you know. If somebody doing A levels, yeah, like they get some box lunch.
Not
dog,
gonna
that
lie, eh?
roti
What's the best
boy.
So
thing
don't
that's
blame
coming in
me.
box
Don't blame me
lunches?
for
Pizza,
this.
eh?
Roti,
This.
Roti.
roti.
Oh, well, I could eat that pizza, boy. I never did
The
like
pizza
that
does taste
pizza.
stink. The pizza does
The
taste
pizza
very
just
Nah,
stink.
tastes
It's
what?
normal, but
nasty.
Baji
Nah.
pie. Ole,
No, there's
Baji pie
some
does taste
pizza,
good.
boy.
Baji pie does taste good. I don't know
Yeah.
about
The
that.
Yeah,
what are you
Baji
talking
pie does
about?
yeah.
taste real,
What
So
boss.
are you
talking
talking
some truth.
So,
Oh, I
you see the
remember when they
veggie
used to bring
roti?
cornflakes and thing.
Oh, yeah. They used to bring the small box of cornflakes and like the box
That
of milk
Yeah.
that is come
that
on
chicken
there.
Yeah.
sandwich that I bring at time, that was lashing.
Yeah, that was
Yeah.
last year. Another time they bring cheese paste and bread and all too.
The pie,
Nah, I
the
didn't like it.
pizza,
I
the
didn't like
pizza is
it.
just the worst, dog.
The
Can I
pizza is
say
the
something?
worst. I rather
And I
eat the
wanna know.
roti.
That pizza not bad.
Nah, you don't. You can't tell me that. As a chef, dog, you should know better than that.
Yeah, it's the expansion of my palate, so
Let the
yeah,
girl
to be
talk. What she
open
was
to
gonna
all
say?
flavors.
Yeah, the experience
So
everything, so.
yeah, that's right. When I was in primary school and up until earlier 4 months, I used to think, all the school children getting the same lunch. Turns out, different days, different district, everybody getting different thing, as in
Yeah.
completely different thing. And
Yeah,
I found out
real.
I was like so devastated.
Because I in a school in the Port of Spain district and what some schools will get, we wouldn't get that. So if them get soup, we might get either roti
Yeah,
or
just soup.
macaroni pie,
That's
red
why I tell
Oh, let
beans,
us
you,
and
get
kids,
saffron
soup.
I
rice
never get soup in
and
my life.
chicken.
Oh, let us get soup.
Like,
Yeah,
Yeah, we
corn
don't get
soup.
them
soup.
small
Other
container,
time corn
Come in a
soup they
cup,
come.
styrofoam containers.
in like a cup, a
In a
Yeah,
paper.
like
kind of
that.
cup with a clear cover. Yeah.
Oh, like one of them
Never
display
get
You
that.
know
things,
what's
what?
yours? That porridge is yours. What is
Nah,
coming
not
from
Porridge?
us?
porridge. It wasn't catching
Them
me
let's
drink
get
it.
with the
Alright,
porridge.
what are you talking about?
Porridge,
No way,
yes.
boy.
Well, they don't get like breakfast in the morning. You see
No.
No, we
box
don't
lunch
get
people.
porridge. We don't get soup either. We don't get no liquid
I just get
cornflakes.
soup.
But here I was saying, I
We
was
just
kind of
get things like
skeptical.
we just get things like pizza, muffin, and cinnamon roll, like
Yeah.
a bootleg
Oh,
cinnamon
you know
roll.
the
Yeah,
muffin?
exactly.
I
Never
forget
porridge.
which
That
place
at
does
that
make it,
time,
but
that
blueberry
time they bring
muffin.
pancakes and jelly, and
What?
men
Let's get
really
that.
stuff
What?
that down.
You
What the
lie.
hell?
I don't get
Nah.
that. We
You
just
in a private
get
school or?
What
No,
school you going to?
we just
sir,
get thing, boy.
sir, I feel that favoritism in this thing, you know.
Mm-hmm.
Oh,
Now
I
we
oh,
get
was
some of them
thing.
getting them good food.
You
I
get
was real skeptical
you get
about
good
Oxford ever
box lunch
since
in the east here.
Manon.
Hey, sir, remember when they used to bring juice with it?
Yeah.
Oh
I
yeah.
The
remember.
Kool-Aid
No,
orange juice.
no, they don't bring
Yes.
none to drink.
Now they don't
That
bring
does
nothing
only
at all.
water.
It was
Nothing,
either
nothing,
that
nothing.
or water. And sometimes for breakfast,
Yeah,
they used to
boy.
bring the cornbread and a water.
They just only bring water for breakfast.
Yeah, the rice tastes real good.
But I remember when
Water?
I lived
We
in box
does
lunch.
for breakfast. We does get a juice sometimes, but some kind of healthy juice, like with
Isn't
I think it
Trinidad they
has no
talking about
sugar.
it?
Yeah, Trinidad.
I'm making sure. I feel it's we Prime Minister, you know, or the Ministry of Education. They
Oh,
didn't
you
like
make
how
that
we
health.
had the intake of sugar, like it was high, so the blessing down on the juice and thing.
Yeah.
So
Yeah.
it was either water or nothing at all. And just the breakfast.
You
I
guys would
remember.
be surprised by
Yeah,
the amount of sugar them things have, boy.
yeah,
Them things
boy.
Yeah.
Yeah, I was watching it and it was real sugar.
I never wanted to eat roti again ever since I see the lizard in the box lunch, you know. Ways, boy.
You see a
What?
lizard and I
What?
was
Oh my
What?
gosh,
Yeah,
what?
lizard in a box lunch?
What?
Lie!
Which
Or,
which
did you remember that
lunch
was
they
trending?
come?
But that
Oh
was trending that time.
yeah.
Yeah, but which
I
lunch that
remember
was?
that.
Not the roti, was it?
It was the roti.
Oh
yeah.
God, why?
I remember
I
that.
was trained that way.
By the way, I had a ruined roti for my boy.
Roti just oh no, I still eating roti.
I still eating it. I'm just
Bust up
looking
short,
around to make sure it have a lizard
So
in it.
roti or
bust up short or
sauce?
dal curry. Aidan, bust up short or dal curry.
Boss up shot.
Bust
You
up
don't
shot.
know, my
Bust
G.
up
Oh,
short.
sorry, I will
But
stand on a
Don't
hill,
forget my
and
chicken.
my
What if
hill
you
is
about
very
Sarah?
green.
Salad is last, dog. Salad is last.
Exactly. Thank you.
So you know I make that time and it will taste
Yeah.
good.
You see salad and pumpkin? Oh, good.
Yo,
That is
yes.
Salad
Wait,
and
what?
saltfish.
I don't eat pumpkin.
Saltfish.
I don't eat pumpkin.
What about bhaji?
So you know you
Smoke her
pumpkin
in.
wise, sir.
Okay, and this tastes good.
Yes. If you cook it good.
Okay.
Hey,
So long
salad
you
and
need smoke
pumpkin by
Chicken
here.
and
Sir,
choker.
boy.
Salad and choker, that's the best thing. Sunday
Choka,
morning.
Which choker?
tomato choka.
Bygone
I hear
choker.
people let's eat tomato choka.
All them
Right,
things.
wait, are you ready to start back?
Of
We go now,
course.
sir.
Let's
Yeah.
get physical.
Let's start back.
How we feeling, Irie?
Don't know.
Just
Aidan
as I
probably
done.
feeling auraful right now.
You feel for some cry,
Nah.
You don't see Riley?
Yeah.
Corrally is not it, Ollie. Corrally is
Ew!
not it.
Disgusting.
Ollie, let me
Please
hey,
not a force
let
me
me
to
lock
that.
back in. Let me lock back in,
Yeah,
Ollie.
so
Let me
them
lock
they
back
get
in.
physical.
Physics. Focus.
And you said YouTube wanna know what time we finishing?
Let me focus like I
1
learn.
o'clock in the morning, about 1 o'clock in the morning or something.
No,
Oh,
man.
Thank
okay.
God the exam is in the afternoon.
Them people,
So it's
I
in
don't
the
know people.
afternoon.
Yeah, 1
Ollie
o'clock.
had time.
I thought physics was in the morning.
Nah, it's in the
No,
afternoon.
it's in the evening.
It's in the evening. I had
Physics and
Chem
bio
today
in
is
the
afternoon and bio is in the evening as well.
So we had
The
320
only paper that is in
viewers
the morning would be art
on
maths.
YouTube.
And social.
That's
Social
a,
is in the
I thought it'd be more, you know. That's the
I expected more for physics.
yeah.
Now, so they probably think because it's a paper one, they could just like willy nilly.
Probably.
Like 30% matters. That's what they're not clocking. The 30% really matters.
But like last year, okay, if I compare my growth from last year to this year, like this year was like exponential. Like last year, I mean, I was doing 17-hour marathons and you know, but like I wasn't getting much traction. But like this year,
I'm happy to be
So
honest.
I am number one.
No,
I
That's
am
a
number
good
one
thing or a
marketing
bad thing?
assistant.
I'm happy
That's
to be
all
on
I
the
was
journey with
telling
you,
you.
sir.
Just subscribe.
we go Matt Vibes gonna make it, you know. And I don't person like crazy like me, you know. But yeah, but I go
Yeah.
to the morning. You know what I mean? I
Happy to be
can't
on
crazy. Cannot
Yeah,
crazy.
we happy to be on the journey with you, sir.
I appreciate
Yeah.
it.
So what paper this is YouTube one?
We do in 2020, May June.
COVID-19 paper.
Hopefully we go till 2014.
Okay, cool. I see
There
my
we go.
sister both the same one.
Right. The measurement of the external diameter of a measuring cylinder is most accurately done by a pair of vernier calipers.
Calipers. You don't know.
So we was correct on it. High five.
Right?
Yeah.
You guys, I hope you all know what ours look like. If you don't, this is what it looks like. So what I could do is, I could actually take the measuring cylinder and measure its diameter by clamping it right there. And I'll get a really accurate reading. So it
Excuse
makes
sir,
sense if you
and
doing
they're
it.
supposed to have a vernier caliper in the lab,
Supposed
in
to.
schools? Supposed to, right? Okay.
Yeah. Alright, so let me try not to chit chat. I want to speed run this thing. We could do it, right? Reset, go. So force is equal to mass times acceleration. We measure mass in kg. We measure acceleration in
ms
Meters per
minus
second
2.
squared.
Minutes per second squared.
meter ms minus 2 meters per second squared. So kg ms minus 2. Which one is the answer?
D.
D.
There's the answer. Cool. 3. We want to write this in standard form. So we have to shift the decimal place right after the first significant number. So 1, 2, 3, 4, 5. So I went 5 spaces to the right. So it's going to be 4.62 by 10 to what power? I went
Negative 5. Minus 5.
Negative
Minus
5.
and think about it, right? Why would you put a positive number? If you put a positive number, you can end up with 4.62 by 10 to the power 5. And I think if you have 5 zeros is 100,000, yeah. That'll be 4.62 100,000. That don't make any sense, right? The original number was a very small decimal. So we have to use negative power. You have to use a negative power. Because think about it, right? I don't think all they understand. All they know how much this is, right? 4.62 by 10 to the power 5. That's a big number. Was our number initially big or small?
Small.
Small.
So negative powers make sense here. So the answer is going to be E. Is there anybody confused by this?
No.
No,
No,
sir.
sir.
I'm going to open the YouTube chat.
No, sir. Everybody seems to get it correct on YouTube.
Okay, good. The mass of an astronaut is 70 kg when standing on the moon. As a trick question, the mass never changes, right? Mass never changes. When he returns to Earth, his approximate weight will be, right? So weight is equal to what? What's the formula for weight?
mg.
J. Mass times
Mass by
gravity.
gravity.
Mass and gravity, yeah.
And gravity on Earth is approximately 10 ms minus 2.
Yeah.
So the mass that never changes, that's the 70 kg. So we're going to say 70 by 10, and that's going to be 700. What's the answer?
D.
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 Cool, let's move on.
Cake.
The moment of a force. The formula for this is just F by D. M is equal to F by D. And that distance has to be the perpendicular distance from the pivot. So what's the answer?
C.
D.
Right.
D.
It's the product of the force and its perpendicular distance from the turning point to the force. That's correct.
Oh.
Right? The unit for momentum. What's the formula for momentum?
Mass by velocity.
What do we measure mass in?
kg.
Kg.
What do we measure velocity in?
Meters per second.
Meters per
Meters
second.
per second.
Right? So which one to shade?
B.
B.
B, right. Nice. Which of the following remains unchanged with an increase in temperature? This I repeat.
Mass.
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 Mass. Right? Let me keep the ball rolling. Mass. This I repeat, the answer is 10.
10.
Then yeah.
Right? Because we know F is equal to mass times acceleration. We have the mass. The mass is 4 kg. We just have to find the acceleration. Acceleration is just going to be the speed over time. That's just going to be 5 over 2. That's going to be 2.5 ms minus 2. Multiply 4 by 2.5, and what you get?
10.
10.
10.
Right, so
That way and it the other way.
8C. Cool, let's move on. Which of the following measures may be classified as a scalar quantity? Guys, can we go back in time? We could go back in time.
Yeah.
No.
If you can go back in time, it's a scalar, right?
Yeah.
It's a scalar.
Right, speed. In your car, it have negative 5 kilometers per hour, aren't it?
No.
No.
One and two only. A.
Right? Displacement, however.
That's a
Okay.
vector.
Right? People on YouTube, I feel like a lot of people confused, but if you are confused right now, chances are you didn't do any work and you just come in here and you didn't do any work at all. So, because when we started live, we went through everything in detail, and if you attended the previous sessions I had, we went over everything in detail. So now we're just speedrunning. Displacement This is actually a vector quantity. You know why? Because a vector quantity has size and it has direction. Let me explain something. If I have a box here, and I can move it 5 spaces to the right.
Yeah.
Yeah. And let me just say that positive 5. And I could also move it 5 spaces to the left.
Yeah.
Yes, sir.
Yes, sir.
I could say that's negative 5. Displacement just means that I'm moving it to a different position. And I can move it in different directions. So the sign would indicate the direction. So displacement is a vector quantity. So time and speed, the answer is
A.
A. 1 and 2.
1 and 2 only.
1 and 2. Nice. Let's move on. The graph above shows how the displacement of a runner from a starting line varies with time. This I repeat, right?
Steady
Yes,
speed.
sir.
Guys, it's a straight line. Remind me, for a displacement time graph, what does the gradient give you?
Velocity.
The velocity.
Velocity or
Speed.
right? Now, if it's a straight line, it suggests that we're going up at a linear rate, like a constant rate.
Constant.
It's a constant speed. What's the answer?
B. Batman.
B.
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 B. Right? This means that we're going at a steady speed. Cool, let's move on. Steady speed.
11 is a
Nice.
repeat.
Let's move on. This I repeat.
D.
D.
Right? So the vectors act at point O and are perpendicular to each other, which of the following pairs represents both the magnitude and direction of their resultant. All you have to do is just use a little bit of Pythagoras theorem. Right? This is B. Right? This is A. So this would just be the square root of what?
A squared plus B squared.
A squared.
Good. And the direction will be from where to where? Where to where?
OC.
O to C.
O to C.
Alright, so where's the answer then, guys?
D.
D.
Everybody agree with that?
Yeah.
Yes, sir.
Alright, cool. Big up the people on YouTube. All they look like all they have it. Good job. 12. Nikolai, help me with this one.
Yes, sir. The acceleration due to gravity g is to be determined by measuring the time t taken for a small metal ball to fall through a specific height. Which of the following activities is unnecessary?
It's actually a repeat. I don't know if I remember that. We did this question before.
Yes, sir. I remember.
Finding the no.
Yeah.
Oh, it is. Okay.
Remember, we had this discussion.
So what the this question was from?
I don't know, but we're doing 2020 right now.
Okay.
Hear what I'm saying, eh? No matter what your mass is, once you're on Earth, what will the acceleration due to gravity be?
10 meters per square
10.
second.
Good, that never changes, right? Every object on Earth is going to experience the same gravitational field strength of 10. Really 9.81, but I'll probably understand. Finding mass is irrelevant. Anybody here does watch Veritasium? People on YouTube, anybody know about Veritasium?
I believe so. Yes.
He did an experiment where he dropped like a steel ball and a feather. I think it was a steel ball and a feather in a complete vacuum, and both of it fell at the same rate, suggesting
Oh, yeah. Yes, I
both
see that video.
suggesting that gravity, that no matter the mass of the object, it experiences gravity the same.
The same is the only thing that's affected is air resistance.
Yeah. So it was a big vacuum chamber, right?
Yes, the big
Yeah,
vacuum
my
chamber.
teacher showed me that video.
Yeah. The truth of the matter is, mass doesn't affect gravity. It doesn't. On which of the following features does the pressure at a point in a liquid depend? I read on the formula one time. Pressure is equal to what?
Rho
by
by
H.
G by H.
Good. So does it depend on the density of the liquid?
Yes.
Yes, sir.
Yes,
Does
sir.
it depend on the depth from the surface?
Yes.
sir.
Yes, sir.
Nah, not part 3. Well, let's see in A anywhere here.
No, sir.
Nah.
No. 1 on 2. Sitting A. Everybody okay with that?
Yeah.
Yes, sir.
Alright, cool. This I repeat. The elastic limit of the spring was exceeded, that's true. As you can see over here, the spring obeyed Hooke's law over its entire extension. A lie again. The force per unit extension, this is correct, because
Yes.
75 over 10 is,
Is 7.5.
right? So 1 and 3. 14b.
Still a question.
Right. Talk to me.
Wouldn't it be true that it obey the law of its entire extension?
Nah.
Because like what I think in here.
So then the box is the elastic limit, and the curve extends beyond that, so it doesn't obey.
Yeah, but
Yes.
it states how provided the elastic limit is not exceeded, it will stay at a constant, and it stay at a constant until the elastic limit was exceeded.
But watch. This is also part of the graph, suggesting that I applied some force that caused the elastic limit to be surpassed.
Oh.
If this was just the graph, then you could have said, you know, it obeyed Hooke's law over its entire extension. But this is also part of the graph, which means that I extended it with this amount of force, and that caused it to break the spring.
Okay, so understand.
So I think I don't know if it's just me, but like how I interpret what he said was like Hooke's law kind of like they expecting it to exceed the limits, if that makes sense. Like I understand the question and everything, but when he bring it up, like it makes me feel like the Hooke's law is expecting the limit to exceed. You know that kind of I don't know how to explain it.
Well, you typically do an experiment until you break the elastic limit to like see the region for which the elastic limit is obeyed. I think that's what I mean. Like when you do this experiment, you keep applying weight until the elastic limit is surpassed, and you draw the graph so you can see at which point the elastic limit was exceeded. So the answer is 1 and 3. Hope everybody's okay. Hope everybody's okay with that. 1 and 3. 15 is a repeat. What's the answer?
Depth of the
The
water.
depth of the water, D.
D.
Right, because we know pressure is equal to height by density by gravity. So the height of the water would affect the pressure. Good. 16.
A repeat.
A bubble of gas rises to the surface of a soft drink. This is because what?
D.
Somebody say D.
B as in bat.
Right. I was explaining this to somebody. Was it Kimura? Or was it like Shanti?
Yes, it was Shanti, sir.
Alright, so
But I'm
Shanti. A bubble of gas rises to the surface. Now in the bubble you have gas. So wouldn't the bubble have, okay, the bubble would have what then? What the bubble have? Oh wait, let me make a mistake. The answer is A. The answer is A. The answer is A. Alright, the answer is A. Not B.
My bad, sir.
Yeah.
The change the placement of the answer.
This is why you need to know the answer, right? So, Shanti, the bubble is gonna have a weight, right? You agree?
yes, sir.
And because the bubble is in a liquid, the liquid is gonna give the bubble an upthrust. It's gonna push up on the bubble. Now, if the upthrust is more than the weight, you're gonna end up with a net force that is going in which direction?
Upwards.
Right, and that will cause the bubble to
Rise.
good. So for it to rise, the upthrust on the bubble is greater than the weight of the bubble. So let me know if you understand that.
Yes, sir, I understand.
Yeah, so sorry people on YouTube. You gotta be careful on what answer they tell me, right? You gotta think about it very carefully. So 16A. Let me move on. 17. There are no attractive forces between the molecules in a
gas.
Gas.
Right. Good. Which of the following statements about the pressure law are true? These I repeat. If it's the pressure law. Wait, if it's the pressure law, what constant?
Not the pressure.
Volume.
Volume.
And we know that the pressure
Because
law says
pressure
that,
and temperature changing.
and we know that pressure and temperature are directly proportional. And we also know that it is P1 over T1 is equal to P2 over T2. So the first one is correct, the ratio of pressure to temperature, right? P1 over T1. Volume is constant, this is true. Pressure is constant, that's a big lie because it's literally called the pressure law. So it's 1 and 2. 1 and 2 is A. Are you okay with that?
Yes, sir.
Yes, sir.
Yes, sir.
Good notes only playing up by.
So you can look at it as like, if you just know if the volume is constant, you can just cross off any answer with 3 in it because that will automatically be wrong.
That's correct. Any answer which will be wrong. What's the answer for this one?
35 to 44.
Yes, sir.
I want to later take a screenshot of this.
I want for
Miss
a lab
Bud
thermometer. No. Is it?
Miss Bud Spice. Oh,
Yeah, because last time he put 10 out of 10.
Oh.
so you serious?
Take a picture and send it on the chat.
So you really have me taking screenshot? I think it is a
Wait,
serious thing.
Wait, sir, you had to do
take
a
a
little
screenshot.
pose. Right.
I thought it was going to put a definition in.
This is a
Serious
definition.
thing.
This is a fact. This is a fact.
This is the definition.
Wait, as Ian Allen would say, this is not alleged. This is the fact. You know, something like that. He says something like that along those lines. But anyways,
Sir.
let me go. Right, but the answer is D, 35 to 44. But Mrs. Mark 5s are 100 degrees Celsius. Real. Molten naphthalene. This I repeat.
The graph
At
will be
80
C.
degrees, at 80 degrees Celsius, you're looking for like a plateau. What's the answer?
C. There is never change your like this one, boy.
C, right? So you see you're looking for a plateau, this plateau over here. All the others are wrong. So 20C. 20C. Is a repeat as well. If the mass is double, what happens to the energy?
It will be doubled. Because
Right.
it was the word for it? Proportional.
Here. But watch. If I tell you E is equal to MLV, right? And I'll double the mass. Remind me, what does MLV mean?
Latent heat of vaporization.
This is energy, right?
It's a guess. Yes, sir.
Watch, so by doubling the mass, the energy increased by 2 times. I don't know if you're seeing that.
It will be doubled.
Yeah, watch, you're seeing 2 times the energy. Think of it like this, right? If I increase the mass, okay, if I double the mass of the substance, right? And I need 2 times the energy, because I need 2
Yes,
times.
sir.
I mean, it make logical sense, right? If I
Yeah,
double the
too.
mass, then I need 2 times the energy to convert it.
I was thinking also, if you have one chicken that laying 2 eggs, if you want 4 eggs, you need 2 chicken.
Now we talk about, bro.
What?
Let me get physical.
So it's like pushing Fatman Bob.
Yeah.
360 over 293 by P, sir.
Yay, I'll have it, boy.
You don't know.
B, right?
You don't know.
All right.
And it's already in Kelvin, so you're good to go.
Good. I gotta explain back the question real fast. I will just eliminate some ones, right? So they given us the temperatures 293 and 360 Kelvin. If you're seeing anything other than 293 and 360 that are wrong one time, this is immediately wrong. Where they get 393 from? This is wrong as well. Where did they get 393 from? So the only answers are making sense is one of these two. Let's actually go through the working very, very fast. So they're telling us that the initial temperature is 293 and the initial pressure is P. So that will be P1 over what?
293.
P1 over T1 is equal to P2 over T2. The initial pressure is P. The initial temperature is 293. The pressure, they actually want me to find for the new pressure. So P2, that's what they want me to find for. And the temperature increases to 360. So what you're gonna do is you're going to cross multiply here if you like. But like, truth be told, I would have just multiply both sides by 360. I don't know why I'm doing that. Anybody can tell me why I'm multiplying both sides by 360?
You'll cancel.
Yeah, you cancel. And so your answer is just 360 over 293. Yeah, this is a repeat, people on YouTube, but I just showing you for working briefly. Yeah, so that's the answer. 360 over 293 by P. So remember that. Please, please, guys, this question has never changed. Remember this. 360 over 293 by P. 360 over 293 by P. Good. Let's move on.
Yeah.
23. Which of the following materials is both a good absorber and a good emitter? You're looking for something as what? What color?
Black. Black.
Black.
Black.
Black.
What's the answer?
Not. D.
D.
Right, D. 24. What's the answer? Is that a repeat?
Isn't it
C.
C?
C.
C.
Latent heat of vaporization. That means we're going from water to steam. And the temperature will remain the same as 100.
Because it can't change temperature and state at the same time.
Exactly, exactly. A person who thinks. Supposed to finish it.
Has nothing to think but
But
thoughts.
thoughts. So where's the answer for 25? Is that repeat as well?
That is a poor conductor of heat.
I find out only here in Nikolai, or not even here in Nikolai, I find out only here in Eden and Kelani. I do just have Eden and Kelani here.
I apologize, sir.
Why Nikolai looking at me like that? Nikolai like, Nikolai, you okay, son? Nikolai, unmute and talk to me, Nikolai. You can't be giving me the silent treatment, bro. You know you and me go way back.
Sir, I listen, you know, sir.
I was there when you was a baby, Nikolai. I was there, right? I am your father.
Okay, okay.
Star Wars reference.
Yeah, that's a Star Wars reference. Alright, so Nikolai, what's your answer for 26?
C.
Right, PTS. Crest to crest. Everybody okay with that, right?
Yes, sir.
Yes, sir.
Good. I want to hear everybody. Come on, man.
Yes, sir.
Unknown.
Unknown D.
I don't. If I want to find frequency, I need the period. How I gonna find period? Look at the axis here. It have position and displacement. Are they same time anywhere?
Nah.
Sir.
So I can't figure out the frequency. Right? Good, good. Let's move on. 28. An echo is quieter. Anytime you see quieter and thing, immediately. What is?
Amplitude.
If you didn't know, amplitude refers to loudness. So if you see quieter, it means a smaller amplitude. The amplitude decreased. We did this question before. Okay, which one have a bigger amplitude?
Q.
And P.
If it have a bigger amplitude,
Higher frequency.
if it have a bigger amplitude, it could be more what?
Loud.
Yeah.
And if you're confused about the amplitude, this is the amplitude, right? The maximum displacement. So this is louder. Which one has a higher frequency?
P.
P.
So this one have a higher pitch, right? If you're confused, in the same time, which one had more oscillations?
P.
P. Which means it was more frequent, so it has a higher frequency. You know what I mean?
Don't know. We vibrated on a high frequency, sir.
Yeah. That is it. What's the answer?
Q is louder than P, but P has a higher pitch.
Don't know.
Yeah.
Q is louder than P. That is true. And P has a higher pitch. That's true as well. Let's move on.
Physical.
V is equal to F lambda. If I
F is
make
equal to V over lambda.
F is equal to V over lambda. Come on, man. They're not even trying at this point. The answer is
Physical.
Yes, E.
Boyle's law for a gas can be tested experimentally. Which of the following are held constant? With Boyle's law?
P1, V1 is equal to P2, V2, sir.
So what must be constant then?
The temperature and the mass.
The temperature.
The pressure are constant.
The temperature and the mass must be constant.
Of course.
I don't know, 6 mass of gas. That's true.
Right? Obviously, it have pressure in it. That can remain constant. So temperature and mass, 1 and 3. 31B. Everybody okay with that?
Of
Yes,
course.
sir.
Yes, sir.
So,
Good, let me move on. 32. Sorry.
JK.
JK.
Right?
Do
If
we
you
not do
didn't
we not
know,
read?
this is the principal axis chart. And the line that lies along it is literally JK. Watch, JK is on the principal axis. So 32A.
They rare repeats, boy.
Physics is the easiest thing.
They
And
more
33.
repeats than IT, sir.
I know
33A.
CSEC just needs
hey.
IT had level repeats.
Maybe read for
33A,
the
right?
chat.
Everybody okay with this?
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
Hey, Ole, this is Kimura right here. This is Kimura right here. If you know, you know. If you know, you know.
Just so?
Oh, the
Yeah,
egg.
because Kimura just eat egg. It literally looking like
Oh,
eggs.
egg.
Oh.
Hey,
Oh.
sir, so
Okay.
you notice something? You could draw like a little face with them two last circles in.
It
Oh, the
looking like a
smiley
praying
face.
mantis. It looking like a praying mantis, like.
Mad Renega.
They have an
So I
imaginative
thought
mind.
there was somebody with cookie eye.
So it be looking
Way
like a
boy.
Renegan.
A Renegon? Yeah. But that's a weird Renegon, boy. It's a weird Renegon.
Weird
The
Renegan.
formed one,
This
sir. The
looking like
formed
a Renegon. This looking like a Renegon.
Yeah, that one.
Right? And this is when your eye too big. That's what this is.
Oh, the
Right?
creative boy.
How do you spell cookie eye, boy?
I don't even know.
I can't.
Koki, like
C
Koki,
Yeah, like
bro.
COO.
And then
and
I.
I
I
think it's double O. Isn't it double O?
Were you spelling cookie? It's
like
not cookie, bro. It's
yeah,
No,
Koki.
it's
cookie.
1-0, it's 1-0.
Hey, Ole. Hey, imagine if Homelander was cookie eye, boy. One laser in this direction, the other laser in this direction.
So you're not being funny right now.
No, people
I
who
don't
watch
think
the
they.
boys will get it.
I don't. Yes, sir. I understand.
Yeah.
So
Open the
you
bad and
remember?
alright.
So you remember the deep from the paper two beaten.
Yeah.
Nah. What did happen to the deep?
Now, so every question you say when you see in the deep, I would, I would know you was talking about.
Nah, I don't understand.
Something about the tentacle or something.
Oh, hey.
RIP the good though, RIP the good though.
Yeah. Like this man, but like, what's really he powers like? He can't really control the
No,
animals.
sir.
No, he's
No,
just
Like
Aquaman. He's Aquaman, but he can't
no,
control them.
sir. Fish don't have a neurocortex, so like he don't speak to fish. The past schizophrenia, he could control fish. He projecting his thoughts on the fish. Like he has schizophrenia, but they don't have the ability of conscious thought. No,
So
just a
he killed
theory.
himself. He killed himself. Killed himself.
Yeah,
Yeah,
technically,
basically.
Ah,
due to his depression and mental unwell-being.
yeah, he's kind of fried in
Oh,
the
nah,
head.
his powers lame, man.
hey, Aura for Aaron. He was into it too deep.
I read that one.
All right, this are repeat as well. Bright.
In phase.
If it's bright fringes, it is constructive interference, and the crescent
Yes.
troughs are in
Yeah.
phase along these points. Everybody
Easy.
okay with that?
Of
Yes,
course.
Sir.
If it was dark fringes, what I mean.
Destructive
Destructive
interference.
interference.
Destructive.
Right. Good.
Minimums.
35. An object O is viewed in a plane mirror PQ. So the object O is viewed in a plane mirror. Which of the following diagrams correctly shows the formation of the image?
I would say
Now
A,
here,
sir.
wait, here
I
what
would
I
say
see, right? Okay, here what I see. Actually, you gotta be careful, You gotta be real careful. So let me run through the options, guys. So the person is viewing. Okay, so an object O is viewed in a plane mirror PQ. First of all, if it's a plane mirror, then the object distance supposed to be equal to the what?
Image
The image distance.
Image distance.
Does it look like it's the same way?
Nah.
No, sir.
No, sir.
Wrong. Now let me ask you that
Answer.
question.
Mm-hmm.
Wait, like, bro, what? Nah,
That
Yes,
nah,
sir.
confusing.
nah. This
It's
is wrong.
supposed to be solid lines coming from O, right?
Yeah.
Correct. It's
And
supposed
it
to be
gotta be
solid lines.
going to the eye. Can't be
I
going
is
from
the
the eye
image, so it's supposed
outward.
to be dotted lines.
This is supposed to be dashed lines in.
The
Arrows
eye
in the
can
wrong
go to the
direction.
object. Yeah,
Arrows in the wrong direction.
Wrong
it
direction.
can't be pointing to
Wait,
each other.
Light's not
Is
coming
this
from the eye. It's
is this
going to the
Homelander
eye.
we're seeing here? Is this Homelander we're seeing here? It might be Homelander, you know, or affiliate on us. Like he's shooting laser beams. Man shooting laser beams, boy. This is wrong as well. How you go? Tell me something, guys. How light go be coming from your eye, boy? How light go be
Making
coming
its
from your
own
eye?
light.
Well,
Really?
you's not human, you's a superhero, cause no way it would be.
That is Superman Day, sir.
Yeah.
This is the only answer that makes sense, right? Watch. So like
Also,
the object hits the mirror, it creates the image, and then you see that image.
Yes, sir.
So, which brings to my explanation. Remember, the object would be reflected in the mirror.
What?
No, never mind. I want to say it, but it's how to place it. Oh my gosh.
I feel your pain, Marinish, again. I feel your pain.
The right is kicking in.
Well, let me continue. I don't understand why this is wrong, right? On this,
Yes, sir.
yes, sir.
Yes, sir.
Yes,
this
sir.
is Homelander, boy.
And the object is deep.
Yeah.
Bro, deep. Have some real fear for Homelander. Bro. Oh my days.
Scorched.
Yo. Also, you know the thing, sir? I thought you was laughing the boys.
Nah. I watch a good bit of the boys.
Or drinking the apple tea and laughing at Homelander.
No, I drinking club soda here, my guy.
So that is a stink.
People just drink that
You
by
could drink
itself.
that. People that's only drink that for upset stomach, eh, people?
I know people
But there are
just
some
drink that
people
with
who like it.
I like it.
people
I
just
like
drink that with our union.
My, my granny usually
Hey,
drink
Ian,
that
whoa,
because she's
whoa,
pregnant.
Ian, whoa.
That was
No,
a long time remedy.
I think
Oh,
people just
let
use that. People
me
just
look
drink
back
that to break gas.
Yeah. Alright,
Let me
little
look
lucky
back.
there. Little lucky.
Let me look
Right.
back in.
Which diagram best shows the path taken by a ray of light through a rectangular glass block? This don't make any sense.
That wrong.
So I can see the rest of the options, please.
This don't make any We
Nah,
didn't
that don't
go
make no
into it.
sense.
Hey, how does it make any sense, right? Like
It's
enter
supposed yes, sir. It's
and
supposed to
if
bend towards the normal.
right, if I go in air to glass, and it's supposed to bend.
Towards the normal.
It's supposed to bend towards the normal, right? But it just went straight through. This is wrong.
Isn't the normal in the middle?
Normal is that perpendicular line by the boundary.
It's the normal.
Okay.
This is wrong as well. Probably wondering why. Actually, let me check the other one. Actually, this is the correct answer. This is the correct answer. Let's go.
Oh, sir. Yeah, mistake there.
This is the correct answer. I thought like the other one would be more perfect. But this is wrong, right? Let me explain something. A good way to check. It enters here, it gets refracted, and it comes back out virtually. What's the invite? It comes out
Lateral
laterally inverted.
displacement. Yeah, lateral inverted. Yeah.
Watch. Like, okay, let me explain. Check this out. Stay with me, right? Like, okay, the best way for you to see this, let me just show you like a straw in water.
So what you're trying to say, sir, it comes out the same angle as the incident, right?
Yeah. That's what I'm trying to say. Like, look at this. If somehow it was able to go back onto air, it'll look like that. Like, you see how the straw was over here? If somehow it was able to like come back on out into air, it'll look like that. So I'm trying to say.
Yes, sir.
But in the water is what reflecting the straw for it to look like that?
Not reflecting, refracting.
Refracted.
So like a good way to check if your answer is correct.
Lateral displacement.
Right, lateral displacement. And it should be
perpendicular.
No, parallel. Should be
Yeah,
parallel.
that's the word I was looking for, my bad.
Watch. If I were to this don't make sense. This don't make any sense. That don't make any sense. So to check if your answer is correct, what you could do is you could extend the line here, and the ray that emerges, it's supposed to be shifted. It's supposed to be shifted, right? But it is still supposed to be parallel to the incident ray. I'm wondering if I understand that. Can you all see that they are parallel?
Yes, sir.
Yeah.
Yes, sir.
Only don't go allow me to make little doodles in the paper just to make sure
Yes, that your paper,
Yeah,
right?
but like they don't mark this paper, they'll mark it just like your answer sheet. So
Correct.
anything you can do anything in the question
They just
paper.
use this to recycle the questions.
Yeah.
Right? So there we go. And everybody feel like they okay with this?
Yes, sir.
sir.
Yes, sir.
Yes,
Yes, sir.
sir.
So
Okay.
see, just looking like the best, sir. See, looking like the best.
Right. An explosion causes the emission of, this I repeat, which
One
of
and three.
these
Lisa Batman.
will receive
Light,
first?
light and infrared.
Light
Because they
and
Good.
travel at the same, they
infrared,
travel at the
one
same
What
and
I
speed.
speed at
three.
light?
Both
3.3
EM waves
times 10 to
that
the
travel at the
12.
speed of light.
Right.
Okay.
Both are EM waves, and all of
It
these waves
says B
travel at the
by
speed of
way.
light. They
It
travel
says
at the
B.
speed of light. 3
3 by
by
10 to
20.
the 8.
So your answer
And,
is 1
and
and
2.
3.
I mean 3, my bad.
B.
B.
So is B. Everybody
And
okay with that?
sound is slower than light.
Yes, sir.
Right. See the speed of sound
330.
around 330 ms minus 1. Hey, Aaron, is how Homelander was moving so fast, and like then all of a sudden, so you started moving the end, boy.
So I like the ending. So let me not get technical
All
about
right,
the ending. I like the ending.
all right. So at some point along XY, no sound is heard because
Some ways are
Di-
destructive.
Destructive interference.
destructive interference.
right. If no sound was heard, then destructive interference would have had to happen.
They cancel out.
So the point is, interference happened, and so that is why C is the best answer.
Mhm.
Interference of the sound waves takes place. And when you're walking along some areas will actually sound really loud because over there, constructive interference will take place. Everybody okay with 38C?
Yes, sir.
Sir.
Yes, sir.
All right, 38C. Cool. Magnetic induction occurs when? Is I repeat.
The iron nails.
Right, and we understand this,
Yeah,
right? Because
yeah.
if I have a magnet here, the iron, okay, if I have a magnet here and I have an iron nail close to it, what would the magnet do to the iron nail?
Magnetize it
Attracted.
temporarily.
It'll attract it, right? It'll attract it. So imagine this is my nail and I take the orientation and I flip it around like this. Just for like explanation's sake. Just for explanation's sake. We know that the magnet is going to cause it, is going to pull the iron nail towards it. So for that to happen, it would have to induce a what pole over here?
A North Pole.
A North Pole, sir.
Right. So iron nails near a magnet become magnetized. That is an example of magnetic induction. Good. Rectification can be
A
best
diode.
done.
Diode.
Right, because a diode only allow current to flow in
One
One
direction.
direction.
Direct current.
Harry Styles.
Good. They're saying carrying current into the plane of a piece of paper.
Use
So
use your thumb.
and when you do it correctly, you
Clockwise
should see
direction.
this.
Should be clockwise.
Clockwise.
The answer
So
is
the
D.
answer is
D.
So and the dot mean it coming out the paper.
Yeah.
Alright.
yeah.
Cool.
So again, if you want to figure this one out, you're gonna take your right hand, you're gonna point your thumb into the paper because it said current into the plane of a piece of paper, and you're gonna see how your fingers curling in what direction, and you're just going to put those arrows over here, and that's going to be D. Y'all okay with this one?
Yes, sir.
Yes, sir.
Yes, sir.
Let's move on. Which of the following diagram represents the magnetic field existing between two opposite magnetic poles?
So I can see nothing.
I can't see nothing either, but it looked like it was this one.
Yeah, because the arrow's pointing from
Yeah, looking like it's from north to
outer
south.
north into south.
Oh, they remember I write this here, so I cannot remember. That joking. I don't remember.
You got one in physics?
I get distinction. The only thing I didn't get distinction in was for Spanish.
You asking questions, of course, sir, past physics. What wrong with all you?
Like
I didn't ask him if we failed, no ask him if we got one. I don't know.
the only thing I didn't get distinction in was Spanish, but Spanish.
So you should have said something. It would have been your one and only Spanish tutor.
The merit list.
And I do 10, was it 10 or 11 subjects, boy?
How you get to do that? What school you went to?
I did some on the outside.
Oh, okay. Makes
Yeah.
sense.
42A. Everybody okay with that?
Yes, sir.
Yes, sir.
Right? As you can see, the arrows here like it going in the other direction now. That wrong. Because we know it's supposed okay, if it let me get this outside of you, right? If it opposite, what will it do? Repel or attract?
Attract.
Attract.
Opposites attract, so it would attract.
And it will go from north to north to what, guys? North to south.
South.
Cool, let's move on. 43. Which of the following equations cannot be used to determine the power dissipated in a
C.
radius?
C.
Right. And if
That's the only formula that don't make sense or exist.
watch, like if you want to prove it fast, it's real simple. Watch, real simple. So you're using P is equal to IV and you're using V is equal to IR. I could replace V with IR, right?
Yes, sir.
You're gonna get P is equal to what?
I squared R.
And then if you want, you could make R the subject of the formula. If you make R the subject of the formula, what that would be equal to? Actually, don't do that. I make I the subject of the formula. If you make I the subject of the formula, you could divide both sides by what?
R.
R. And you're gonna put V over. I'll find out, let's take it now. Talk to me. If I make I the subject of the formula A, then I'm going to divide by on both sides.
R.
I will divide both sides by R. Yeah. I want to do that. I'll get that I is equal to V over R. And then I could plug that into here. So anywhere I see I could write what instead?
I squared.
No, I could write V over R.
My bad.
And you're going to end up with V by V, which is V squared over R.
My brain lagging.
So, as you can see, this is valid, and this is valid. R over V squared don't make any sense. Right? Cool, let's move on. Which one is our fuse?
The B, sir.
B.
These are our fuse. Cool. Which of the following represents a series arrangement? Look at it. Does I repeat?
B, sir.
Right. And we know the reason why, because the current never splits. If the current never splits, it is a series circuit, right?
Try and trick you a little bit by making it funny shaped.
But if you draw the path of current and it never splits, it's a series circuit. But all the others, the current is going to split at some point. Are you seeing this, right?
Yes, sir.
Yes, sir.
Cool. So the answer is 45B. Right. This looks like our what kind of transformer?
Step up.
And they will take out what input to work.
Alternating current.
Alternating current.
So step up AC input. See, right? Step up AC input. Everybody okay with that?
Of course.
Yes, sir.
47. Which are the following electromagnets?
Soft
iron.
Fine.
Right?
Because easy to magnetize and demagnetize.
Correct.
Next one is B.
If I wanted to make a permanent magnet, though, which one I would use?
Steel.
Changes
Because you can't
magnetism very well.
demagnetize.
Good. Well, bad boy. Big up on
48,
yourself.
48 is B, sir.
48 is B. That's correct. Remember, guys. So they say in which of the following diagrams is a representation of the current relationship for a metallic conductor at a constant temperature. So we know V is equal to IR. So V is actually proportional to I. So whether it's V versus I or I versus V, it's supposed to be a linear graph that looks like this. And if you extend it backwards, it would look like that. So it looks like, which option?
B.
Batman.
B, right? Cool. This looks like a filament lamp. And this looking like a semiconductor diode. Sort of. A bad semiconductor diode. But semiconductor diodes actually have forward bias voltages and whatnot. Like they only some of them. They only start conducting at a specific voltage. But the answer for 48 is B, right? B. Everybody okay with
Yes,
that?
sir. Very
Yes,
good.
sir.
Yes, sir.
Yes, sir.
Right. Cool. 48B, remember that. 49. An ideal. I'm pretty
3
sure
amps. 3
yeah,
amps.
3
these are repeats.
amps.
These are repeats.
Mm-hmm.
And if you want to do it real fast, all right. If any primary is 200, how much you got in the secondary?
600.
And that 600 volts could be a quarter resistor.
The secondary.
The 200 ohm resistor. So your current, that would just be V over R. The voltage is 600. And the resistance is 200. Wait, 600 over 200.
3.
3.
3.
All right, 49D. All right, let's move on. In which of the following circuits will the lamp light up?
Positive to conventional current flow, so that could be B.
Well, let me see, right? Let me see. So remember, you have a diode here. The diode only allows current to go in one direction. And remember, this is like the gate. It's will block it. So this is positive. This is negative, right?
Yep.
It wouldn't work.
Will it work?
No,
No, it
sir.
won't.
Kelani, you can see that the diode would block the flow of current there, right?
Yes, sir. Like a wall. Come like a wall.
No. Let's check out C. Nope. Yeah,
That's not
didn't
making
work.
any sense. Not making it. How you could have 2 diodes?
If you have two diodes in this manner, no matter how you do it, it will block,
Yeah.
right? Because like we just say the current pass through, right? Then you get blocked over here, so it will not light here. No. Let me see if this one works. What?
What is
That
that?
don't make no sense.
A
Positive,
positive and a
positive.
positive here. Right? Let's check out this one out. Positive here, negative here. Ah. So let's see. Am I seeing?
It's looking like the proper
Nice.
thing.
Nice. Physical. Active.
Physical.
Element 2 hyper boy.
You don't know.
The answer is B. Everybody okay with that?
Of course.
Si, senor.
Right.
Yes, sir.
Okay. Tell the people on YouTube what to do. Tell the people on
Hey.
YouTube what to do.
Subscribe,
You know,
like,
public sign
ring
there, you know.
and
Public
ring
sign.
that bell.
Public sign there,
Share
you know.
this YouTube channel to everybody you know across the face of the earth, so we can bring up that subscriber count. One match vibes to the world.
Never two.
Never 2.
Right.
On top.
Alright, cool. Everybody okay with the answer being B?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
I little better get full marks on this physics paper. I want to know.
I swear, I swear.
Sir.
I swear.
Sir.
You can't make no promises, but
Easily
obviously
easily magnetized and retain this magnetism well. You don't know.
Renisha, you could do it. You
Okay.
could do it, Renisha. You could do it. Yes, Renisha, you could do it. So iron. Iron is easily magnetized and steel retains its magnetism well. Which is the answer?
C, sir.
C.
B.
So iron is easily magnetized, easily demagnetized. Steel, when it is hard to magnetize, when it gets magnetized, it retains its
Demagnetized.
but
Yeah. It's fine.
right? Everybody okay with 51C?
Yes, sir.
Yes, sir.
Yes, sir.
Right. This I
A
repeat
NAND
for the
gate.
answer.
A NAND gate. NAND.
And
Right.
can you multiply and you flip?
If you forget, right, watch. If it's an AND gate,
Multiply
0 by
and
0, 0, 0 by 1 is 0, 1 by 0, 0, 1 by 1 is 1. But in NAND,
flips it.
1, 1, 1, 0. It's an AND gate. Are you okay with
This is
this?
the only logic gates question they bring.
Wouldn't our input give you an output in this case?
Well, yeah. All of those are outputs.
Okay.
Yeah.
So this is the only logic gate question they bring. I find this is the only one we've seen.
It had another one.
It does have ones where it's actually for the input and the output or something.
It
Oh,
had,
yeah,
it had
yeah.
one. It had one like this. Some it had one like
I thought
And
we
like,
had to bring a question like what's to do in there. I
Yeah, and
remember
then
now.
one where you
Oh yeah, I
identify
remember this one too.
This is a really old paper.
0, you get 0, 0.
Yeah.
yeah, and it was 0, 0. I said I want to see. All right. The part labeled X in the diagram.
Slip
What is that?
ring. Slip
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 ring.
ring.
rings.
Right.
Not a split ring,
That's
guys, a
the
slip ring.
that's a slip ring. That is
I just
as the correct me if I'm wrong. Don't tell me. I know what I'm talking about. That is the AC.
AC, yeah. This is for the This is
W
the
for
AC
Elisha.
generator,
W for
right?
Elisha.
But until you've seen it looking like a ring though, I can't help but
Yeah,
it.
it looks so far diamond on it.
So this is for Mrs. Mad Vibes.
Somebody screenshotted for Mrs. Mad Vibes.
Mrs.
So
Pata
it's,
has a bigger one, boy. A bigger diamond, a small
Ah,
diamond. No, but
So
so
you
you
have
can
to make sure anybody could see the diamond from far.
yes, yes.
so you can
But
really
like,
draw it.
Bling
but
bling.
this is why I need to support Matt Vibes, so I'll be able to get Mrs. Matt Vibes the ring she deserves.
of course, sir,
Yeah,
of
to like,
course.
Diamonds are a girl's best friend.
If you like
yeah,
it, then they should have put a ring on it.
ring on it. Do the dance to you don't do the
Whoa,
dance.
Nah, nah, still, nah, still,
Nah,
nah.
nah, 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 nah.
Come
I
on,
Let
don't
see
me
you
cook.
do it.
Hey, I don't cook. I don't clean. But let me tell you, I got this
Whoa, whoa,
ring.
whoa.
Hey,
That
hey,
song
hey,
is
hey,
not
hey.
PG.
Too
That song
explicit
ain't
for this.
PG, bro. We
Too
keep it family
explicit.
Whoa,
friendly.
whoa, whoa.
where's
Keep
the answer?
it
I'm 54.
PG-13.
Magnetic relay, magnetic
Magnetic
relay.
relay.
Right. Which device allows one circuit to switch another circuit on or off without any direct contact? That's a magnetic relay, right? Cool. 54A. Right. 55. Which of the following graphs activity? The answer had to be D.
The half-life graph. Yeah.
Until
We
that,
had a
Exponential
question like
decay.
this in our next paper that I did, and I
until
think I
that
get
question final.
confused between the two of these,
So,
between that one and the one that they have as A.
Nah,
You could
don't
explain.
get tired. This is you're looking for the half-life graph. You're looking for the half-life graph. You're
Okay.
looking for this one.
Exponential decay.
Yeah, exponential decay.
Okay. Thank you.
You're looking it never changes, always this one. Which of the following are two properties of an alpha particle? Alpha.
Positive charge, not very
positive charge,
penetrating.
not very penetrating.
B.
D.
Oh, wait.
Right.
D. Sorry.
Right. The nuclide 234 thorium contains
90
The
protons,
answer is
144
C.
neutrons.
This is a repeat too.
As I repeat,
It is
Boy,
full paper. It is this full paper just
lazy
repeats.
boy.
Yes, boy. Only repeats, boy.
What the dookie?
60 out of 60 tomorrow, fellas and ladies.
I
don't know.
sure hope so.
Assignment.
paper one we trust.
I hope CXC don't be experimental with my physics paper one. I go get
You telling
monstrous
me?
for them, boy.
It's
Telling me
they're
that done
not. Listen,
experimenting on the
they're not.
human brain.
They're not gonna experiment. It's gonna be easy, right?
Hey,
50
why I think they just take back the papers? So recycle the questions.
That is it.
Einstein.
Einstein.
I know this one.
Einstein.
Albert Einstein. Mr. Einstein.
Yeah, so probably sticker this.
So
Probably
please stick
sticker.
out.
Yeah,
Let me get
sticker.
Wait, take him a
Talk it tongue
second.
like Cardi B, yes?
Yeah.
These scientists have real tough names.
Telling me?
I wonder if anybody named Einstein any present day.
Nah, them name was like them 500 years ago one thing, you know.
Yeah,
Sure,
nobody
I'm
don't
sure it's how one
picture
person that name is.
Einstein anymore. Well,
It- it-
Einstein is the last name.
Even his name was
Yeah,
Albert too.
Albert. Albert all over the place. And Marie too. And
Right.
Isaac.
Let's move on. So 58. C. Which of the following statements about a proton is not true?
It has the same mass at
The
the
same
end.
mass
Yeah,
as an
that
electron.
not
Yeah.
true, sir.
Which one has
What
the
they
greater
said.
mass? A proton or the electron?
The
So you say
greater
that again?
mass?
The proton.
Proton.
Proton
Proton has the
greater
greater
mass,
mass.
yeah.
The proton is yeah.
The proton is like about 2,000 times more electron. About to be specific, like 18 electrons.
1840. 1840.
Yeah, but over here they just estimated 2,000, right? But a proton is heavier than an electron, right?
Mm-hmm.
Yes,
Remember when we was doing the Goldfall experiment. Remember some of the particles were completely deflected. That's because it encountered like the dense nucleus. The nucleus is like where almost of the mass of the atom is. So it makes sense that the proton is much heavier than the electron.
Yes, sir.
68 C. The answer for this is C.
Yeah.
Kind of hard to see, but yeah, you're right.
It have to be an alpha particle.
Another
Hey,
That,
paper
Kehlani has some
done.
crazy muscle memory there, boy.
that is
So let me tell you what to write, right? Put
right.
on top of RA, you have to put 226 and put 88
Yeah.
in the bottom, and then yeah, you know what to do after
You
that.
have a clear version of the paper.
No, I remember it from the last paper.
What?
So
Repeat.
He's just him. He just
222 plus 4, that's 226.
Sir, can I
86 plus
see
2 is
59?
80.
huh?
Can I see 59, please?
Can we explain 59?
No, I just wanted to see.
Well,
Okay, thank you.
Ole,
right.
we have this tomorrow.
Yeah, we have this. Right to
Proper.
mash up
Oh, yeah.
that paper. Of course.
Yeah, what? Next, let me do 2019 now, and let me try to do this as fast as we could, right?
Yes, sir.
Hey, we do it in 55 minutes. Good job, guys.
That's how we're gonna do it for the exam.
And we could have taken like way less
Nah,
time.
half an
So
hour.
I
Half an
can't
hour.
wait for
Talking about
tomorrow. So tomorrow is my
everything.
Less than
final
half an
CXC
hour.
exam,
So
you know,
you know
so
what has happened? That's why the pass rate is below. Because this student
This now
doesn't
math
take the time
question.
to do the paper. They just come out the exam too fast.
I cannot guilty, yeah, for that.
Yeah, but
I finished
Same.
writing in like 20
I finished
minutes.
chem in
me
exactly
too.
51 minutes.
Yeah, me too.
Same. I
So
I
the one
came like
I leave
flat
the
30
one man
minutes, bro.
say 15 minutes. Yeah, 15 minutes again. By the time 15 minutes come, I hand up the paper and I walk right out.
I feel like 10 minutes into that chem exam, people started to walk out the room. I was like,
Yeah. It was worse for
3.1. The answer for this is 3.1. You don't know.
So we'll just give up.
3.1. The first two digits. Significant.
All right, well, let me go now, guys. Let me go now, guys. So I'm going to test the stopwatch. Two significant figures. First significant figure is 3 seconds. Significant is
A.
1, right?
Yeah, 3.1. You don't know we.
3.1. Cool.
Yeah,
2,
vernier
3 external
calipers.
diameter.
D.
Pair of vernier calipers.
Vernier caliper. Repeat.
10
Sorry.
newtons.
10.
See.
10.
Wait, yo,
X
let's
plus Y to
speed
the
it,
left.
boy.
X plus Y to the left. X plus Y to the
Wait.
left.
To the left.
Speed in.
0.895 meters.
Wait. Wait, no. Wait. You
Wait,
don't know what
give
this
me
is.
time.
Like
Let me
that,
ask
brother.
another question, right? If you're in a laboratory and you
Yeah.
want to measure the height of a table, do you think the
Yes, sir.
table will be this small? The height of
Nah,
it?
sir.
Do you think
If
it'll
you're
be
using
this?
a meter rule, it wouldn't be that small. If you're using a meter rule, it can't extend past a meter.
Exactly. It must be
Just to
like
be clear, the
0.895.
meter rule
Process
is
of
the long ruler
elimination.
them teachers in
It's a
primary
meter.
school style,
It's a
right?
meter. It's a meter. Yeah. It's a meter.
Yeah.
It's a meter. 100
Imagine
centimeters.
a table 8.95 meters thick.
That's crazy.
A.
Let me read it, right? The diagram below, not drawn to scale, represent two forces, S and T acting at O. In which of the following is the resultant in direction OX? Let me go through the options, right? So looking at this one,
Yeah.
So there's a repeat from 2006.
Oh my
wow,
lord.
you really know
Since
things.
06.
Wow. You will know.
The physics syllabus
They,
never changed since
they
06.
could go back to question
Only
4
Nah,
for like
the
one
syllabus
I
changed
second.
like
sent the paper in
2015.
the group chat, by the way.
Say that again?
Can you go back to question 4 for like 1 second? So I know you put like X plus Y to the left, right? I don't know if it's just so, but like if you're putting an X plus Y, right? Wouldn't that be going like to the right? Because the first X plus Y already to the left, kind
You're
of.
gonna go in the
No,
opposite
no.
direction.
No, it's pushing
Watch,
to the
like,
right.
okay, if
Oh,
over
I'm
here,
pushing to the
watch, right?
right. Okay,
If
take
over here is if this is 50 newtons, right, and this is 200 newtons, right? Cumulatively, you'll be pushing this with a force of what?
250 newtons.
Right. So I'll have to,
Combat that with 250 newtons. So don't worry, sir. I understand. It's just the dyslexia, you know. I
small
clearly
thing,
don't know my sense of direction.
It has happened to everybody. Don't
Yeah.
worry.
right? So are you okay with this question here?
Yes,
So
sir.
let me keep it pumping.
Yeah, so we pumping. Going.
Let me just go through why the other options are wrong, right?
See, that don't make no sense.
So that don't make no sense.
Well,
That
so-
would have never work. That looking funny.
See, that don't make no sense.
That don't make no sense.
Funny thing looking here. Boy.
Isn't it supposed to be something shaped like a rhombus or something?
The X supposed to line up with the diagonal.
So yeah, but we find the answer already. So
Yeah,
that's just proving them things wrong.
yeah.
Yeah, because the resultant, we want the resultant to line up with OX. Is a result, okay. The resultant here is here. Obviously, that's not OX, right? This one is O to here. Obviously, that's not O to X. This one is here to here. Obviously, that's not O to X. However, with this one, you see lining up with O to X, so that's good.
Mm-hmm.
Right? Wrong, wrong, wrong. Lie, 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 lie.
That lie again.
So
700 newtons.
that's the sticker.
700.
700 newtons.
Right, 700 Newton. Nice.
70 times 10.
Which are the following rates will determine the power of a machine?
Doing work and combustion energy. 1 and 2.
Yeah.
Yep.
Yeah.
1 and 2.
What change in temperature had to do with power of a
That
machine,
has
guys?
nothing to do with power of a machine.
Nothing.
So that's wrong. It's anything with 3 in it is wrong.
We know that power
It's
is
1 and
equal to energy over
Time.
Time.
right. So doing work is energy, and converting energy, that's also energy. So right. Cool.
Low center of gravity.
Yep.
Wow.
Way.
Way.
A well-designed race car.
Kalani's racing car.
Yeah, bro.
When I turn in that corner, I don't want my car to flip over now, so I wait to have a low center of gravity. The
Yes,
lower the
sir.
center of the
The way
gravity
to-
is, the more stable it is.
Stabilize it,
Yes,
yeah.
sir. You know
Like
way
the
to go
racing
squirts.
cars.
You know way to go that way. So
That why
Length to the
short
pendulum.
people
Length to the
be able to
Length of the
fall over.
pendulum.
Length to the
Length.
pendulum.
The length of the pendulum.
enter the pendulum.
Of course, yeah.
B, 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 B.
Yeah, that be.
Hey,
You
boy.
know, where's
Hey,
the
boy.
Hey, you got a chance to read the question.
Well, actually,
Where, boy?
Read the question, answers who meaning.
Kelani, no, the Saddam plane, you know, none.
I set a pizza there.
Yeah, he
we
built
know.
different, boy.
They build
So-
different.
Right, height is meters. Gravity is Newton kg minus 1. Well, once you figure out this meter and meter, and you see that these two are the same, the next thing you're looking at is here and here. Obviously, if we're talking about SI unit, which is the SI unit? Kg or grams?
KG.
KG.
So this had to be the answer. Cool.
The P after the equal sign. That is just that is
Density.
That's supposed to be
okay.
row.
That was too
Row.
lazy. It's supposed to
Yeah,
be
it's too lazy.
supposed to look like
okay.
this.
Isn't it row? Isn't like that supposed to like cut into the P a little bit?
I don't know. I thought I was right.
My teacher
Because I
was
know
wrong.
you do the formula different from them. I thought the P was the row supposed to be in the middle of the G and the H.
No,
No.
multiplication.
The
was not-
orientation wouldn't matter.
Multiplication.
Commutative.
All right. Okay.
All right. Momentum.
KG,
Momentum is
KG,
equal to
KG, MS to the power.
KGMS
Batman.
minus
KG
It's equal
MS
to MV.
mass is kg.
minus 1.
P is ms
Velocity
minus.
is minus
Five.
MS minus 1. Shots fired. Boom.
Bam. We deal with micro here. Micro is 10 to what power?
Minus 6.
three.
Minus 6. Minus
Yeah,
6.
yeah,
Negative
minus
6.
Wait.
What's the answer?
T.
Sir,
D.
so here I was saying, I didn't make a whole song about prefixes in it. Go ahead.
Really?
Talk to me. Wait, sir.
Talk to
Pour
me.
the camera, pour the camera. Let me see it.
Weird.
Oh, I don't join my. Give me a second. I don't join my phone to come my camera. Hold on, eh?
Sir, pause the timer, sir. Pause the timer, sir.
Pause the timer.
I pause the time.
Oh, that's not, eh?
Wait, tell me when you start, I will record this. I'm
You
gonna
look
listen
like
to
you're
it.
good. I didn't hear from you on a little bit. I find you quiet today, boy.
No, I good.
Yeah. Cool.
Yeah, I have real energy, boy.
Here, real energy.
For me,
That coffee.
I drink coffee. I real tired, honestly, you know. I had 2 tests today.
What you just? Buy one or no?
I do an HSB instead of bio. So I HSB in the morning and Kevin even.
Hey boy. We are tomorrow. Or learn
Tomorrow
physics.
physics.
Just physics.
Yeah.
Just
That my
physics
last
alone.
test, sir. That my last test.
Well, good job, Aiden. Good
Thanks,
job.
sir.
The man
So
punch shades and things
I
for
had
relation, yes?
I had physics today.
So Pin Kalani did.
Give
You
me
had physics
physics.
today?
No, not physics.
Kelani.
Sorry.
Kelani, look here.
You're sideways, boy.
All right. You're sideways,
I
but
break
sing
my
your
neck.
song.
Kelani, go and get the horse.
Get this song. Micromillicenti kilo mega. Micromillicenti kilo mega. Micromillicenti kilo mega. Micromillicenti kilo mega. 10 to the minus 6. 10 to the minus 3. Minus 2. Power 3. The power 6. And start again. Micromillicenti kilo mega.
Boop, 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 boop.
I rate it.
You don't know.
Okay.
To be
I
honest,
admit.
I hear half of the song.
So basically, it's just a list of, the prefixes and the powers. Micromillicenti, kilo mega, micro 10 to the minus 6, kilo. Now, milli is 10 to the minus 3, centi 10 to the minus 2, and kilo 10 to the power 2, and mega is 10 to the power 6. You don't know.
Right.
Oh,
Let me keep the ball moving. What's the answer for 14? Ampere, right?
Ampere.
That measures current. That measures current, right?
His favorite
Current
pastry
rule.
is ampere pie. Ampere pie.
What? No, it's current rule.
Current rule. Because amps is current.
What's the answer for this one?
B.
Steady one. Steady speed.
Steady speed.
Because
Steady
The only
speed,
one
right?
that making sense as far as
Straight
I'm
line.
concerned.
Steady
Straight
speed.
line.
Steady speed.
That's the only thing that making sense there.
An object is removed from the ground and placed on a shelf. You're based on a shelf. Your height increase.
Height is increased, so potential
energy.
increase.
Which of the following is the poorest conductor of thermal energy? Be honest.
Yeah.
No air.
They literally give you 3 metals, you know.
Yeah. Alright. This one. We're gonna remain constant for Boyle's law. Boyle's law is
Temperature and mass. Temperature and mass.
Temperature remaining
mass?
constant.
Mass and
remaining
temperature.
And pressure.
B.
Right? Is 1 and 3. 1 and 3 is B. Right. Because Boyle's law is P1, V1 is equal to P2, V2, the pressure changing.
Yes, of course.
19. Which of the following are characteristic features of a clinical thermometer?
35 to 44.
Range.
You have a narrow constriction in the tube just above the bulb, so like when you take it out, the mercury wouldn't flow back down. Limited range of temperatures, that's true. Large bore to make the mercury more visible.
Is that true?
Is that true?
That one someone can ask us.
Yeah.
Something kind of suspicious.
A bit tricky.
That's Claude.
I say we scrap the 3 and we go with 1 and 2. But just
I personally would go with 1 and 2. I would go with 1 and 2.
Yes,
because like I trust in that. I trust in.
Don't clinical thermometers use alcohol instead of mercury.
Yeah. Mercury.
It could be alcohol or mercury. Right?
But they use mercury in clinical thermometers. That seems
they do.
Remember, mercury is a kind of substance that is poisonous to humans. So therefore, when the thermometer is broken, not only humans alone, but therefore, when it's broken, you have to be careful of how you throw it away. You can't let it touch you.
They actually brought that in
It does have a
biopaper
bore,
too.
but it's just not a large bore. It's a narrow one.
Yeah. And that come in on the exam, you know.
Yeah, that came in the paper in one of the papers.
Came in chemistry.
It's
chemistry. That was the last question in chemistry.
They asked you
last
how to clean up the thingy.
With the fish, right?
Yeah, bioaccumulation.
You know what that means? We good and we think, y'all.
Lock in.
We in the lock.
So part 3 is a lie, right? That's a lie.
Understood.
Lie. 1 and 2.
Lie.
Narrow constriction in the tube just above the bulb and limited range of temperatures. You know, like 35 to 44. So 1
Yeah.
and 2. You delta theta, you're looking for T2 minus T1.
Delta T2 minus T1D.
If you're not
Don't
seeing
know.
T2 minus T1, it's wrong. This wrong. This wrong. This wrong. The answer is D.
They
Yeah.
literally place it back in the same place where it was last time.
Correct. And then move on. Keep the ball moving. Right. So 20, 21. It's got repeat.
Absorbs 2.26 by 10 to the power 4. You don't know.
It absorbs 2.26 times
Right, because
10
you
to the power 4.
wanna go from water to steam, so we'll have to absorb heat, right? 0.01 is 10 to the power negative 2, 10 to the power 6 by 10 to the power negative 2, that gives us 10 to the
10
power
to the
4.
power 4, because same base, you add your powers. And you
Yeah.
make 4.
Now that is steam.
Right?
By steam
really
Alicia.
sure what's going on.
This is physics.
27 degrees, they don't know.
Yeah, repeat.
Repeat, right? Repeat.
Yeah,
Very good.
repeat.
23, which of the following statements concerning the radiation of
1
heat
7.
is not true?
2 and 3, sir.
1
2
is
and
wrong.
2 and 3. One wrong.
If 1 wrong, obviously 2 and 3 is your best bet.
Of course, yes.
Yeah.
Wait, they're saying radiation can only take place in a material medium.
That's
What?
wrong. It
That
takes
makes
place
sense.
in
That don't make
space.
sense.
The sun is in space.
Radiation literally is in the EM spectrum. Like okay, radiation literally okay. The heat from the sun literally radiates through a vacuum. You know what I mean?
Exactly.
Yes, sir.
So it doesn't need a material medium. That's a big lie.
That's
A
a
good
big lie.
absorber. A good absorber is also a good emitter of radiation. That's true.
That is
Anytime you
true.
see that, what color are we looking at though?
Black.
Black.
Right?
That's
Dark,
part of our national flag, all you.
dark, dull surfaces are better emitters than shiny ones.
Mm-hmm.
Yep.
Yeah.
That's
Dark,
true.
right?
2 and
Because
2.
if it's dark and it's dull, it would absorb a lot of heat, so it would emit a lot of heat.
Mm-hmm.
So 23, 2 and 3. We starting to see some new questions. Okay.
So watch. This is black. This,
Yes, sir.
see this would absorb heat. This.
I seen that.
So that black or that blue? Which one?
That is black, boy.
Oh,
Black.
I didn't even know that.
Everybody okay with this, right?
Yes, sir.
Yes, sir.
So a good absorber is also a good emitter of radiation. Dark dull surfaces are better emitters than shiny ones. Radiation takes place, it can take place in a vacuum. So you don't need a material medium, and that's a lie. So 2 and 3 is the best bet. 23D. Which of the
Mass.
following quantities remains unchanged?
Mass.
Mass remains unchanged.
So that was in the same place from last time, or the changed around?
Yes, it's been
C. The naphthalene
C.
question.
I'll see this. I'll see this. I'll see
Sir,
this.
isn't
23.
Yeah, we
naphthalene
forgot to see that,
carcinogenic?
man.
Say that again?
Isn't naphthalene carcinogenic?
That is camphor, boy.
Yeah, I heard it's carcinogenic. My chem teacher told me that.
Probably. I don't think we should.
And like we do a physics lab on it, sir, and it smoke up the whole room.
I'm not sure. But like, I mean, like when you're doing prayers, like when Hindus doing prayers, I mean, nobody's died. So, and as you burning camphor, you know, I just, yeah.
Camphor
Right?
is not is a white powder.
No, that mud balls.
Oh, yeah, that's what I was talking
That
about.
thing is put in the corner of your wall.
That's thing you just put in your drawer.
Lizard and cockroach and thing.
My granny put it in the corner
My
of the
grandmother.
wardrobes.
Yeah, in your drawer and them too.
Oh, they
Oh,
never
on
see
top of your
this?
dressing table.
Oh, they never see this?
Does
Yes,
it not
sir.
sublimate?
Yes, it does sublimate.
Yes, sir.
I know
saw
thing.
it that way, and I saw it in the ball form.
Oh, are we lucky now?
We lucky. Come on. We are clicking on the top.
The answer is convection, right? Everybody okay with this?
Yes,
Yeah,
sir.
water and convection.
Any fluid.
Parallel to
So
the
any
next repeat.
Damn.
Next repeat question.
Yeah,
Very
parallel.
Never read it. In using a slinky to demonstrate longitudinal waves moving from point A to point B, the spring is made to vibrate. Remember, if it's a longitudinal wave, the direction of propagation is what?
Parallel.
Parallel. So the displacement of particles and the direction of propagation is parallel. Right? So you're looking for the only answer with parallel on it is E. So if it's a longitudinal wave, it is
Parallel.
if it's transverse is what?
Perpendicular.
Perpendicular.
To the propagation of the wave.
Yeah.
Cool. So 27E. Remember that, right? Longitudinal, parallel. Good. In which of the following is conduction the main method of energy transfer?
Food being cooked in a pot on an electric stove.
Right, because the food will be directly in contact with the hot bottom of the pot.
Yes, sir.
Yeah.
Yes, sir.
29. Which of the following statement does not provide evidence that sound waves can be reflected?
A.
Yeah,
Yeah,
A is actually more of an example of diffraction.
Diffraction, yeah.
Why not echoes can be heard when a person shouts in a large room? Just
Okay,
curious.
if an echo to happen, the sound wave needs to hit the wall and bounce back.
That's
Kind of
reflection, right?
reflected. Yeah, it is reflection. Because Aaron, think about it. Doesn't the echo sound like exactly like you?
Exactly, yeah.
Right? Speaking tubes can be used for passing messages in ships. That's true because the sound wave would reflect in the tube and come out the other end. The depth of the ocean can be measured using ultrasound. That's true.
That's reflection as well.
Yeah. Alright, so 29E.
So, question.
Thank
And
you,
for the
sir.
and for the one with the ultrasound, and they have to use the speed as 2D over T.
Yep.
Because
It's
think
twice.
about it, right?
You're
You
traveling
would
twice the
spend
distance.
watch. Because the sonar wave or whatever wave is like a very high frequency wave though. It would hit the surface of the seafloor and it would have to be reflected back. So it travels 2 times the distance.
Yes, sir.
Right, let's move on. 30, what's the answer?
What
Thank
is
you
a
for
core conductor of
explaining,
heat?
Water is
sir.
a poor conductor of heat.
Right, water
Same
is a poor
position
conductor
or
of heat.
kind of thing.
Yes, sir, thanks for explaining 29.
Out
No
of phase
problem.
by a half length.
Yeah. 31B. Whenever there is complete destructive interference between two coherent wave trains, the waves must be out of phase by half of a wavelength. Remember that. I'm gonna give you an example.
And that's 180.
Yep, that's a 180-degree phase difference. So I have this here. Check what I'm gonna do, right? What happened there, guys?
Destructive interference.
Complete destructive interference, right? So I don't know if you see what I just do, right? But I erase half a wavelength. And now, when I align it, watch. Is a crest here, this is a trough. Completely cancel off. This is a trough, this is a crest. Completely cancel off. This is a trough, this is a crest. Completely cancel off. So for 31, it must be out of phase by half of a wavelength. Must be out of phase by half of a wavelength. Remember that.
Yes, sir.
All you understand that, right?
Yes, sir.
Yes, sir.
That is complete destructive interference. Which of the following statements about the waves shown in the diagram are true? Points P, Q, and R are in phase.
Wrong, sir.
Q and R. I wouldn't say so.
ST are out of phase.
That's true.
P and R are in phase.
Yeah.
P and R are in phase. Right? Q on this point over here would be in phase. So this is a lie.
2 seems correct.
If you're confused, okay, I feel like some people still confused, right? Look at this. You start any wave here, and it finishes over here. So the starting point here would be the end point over here because a new wave starts at this point. So that's why we're saying that these points are in phase. This point would be in phase with this point. Are you sure you understand it?
Yes, sir.
Yes, sir.
And so, believe it or not, this
Yes,
is
sir.
another repeat from 2006.
Wow.
What?
Points S and T are out of phase. They are out of phase.
Well, 2 and 3 had to be the answer.
Yeah.
Right? Until you see now they're out of phase. S and T
Yes,
out of
sir.
phase.
Yeah.
Yes, sir.
Question, will these 2 points be in phase?
Yes.
Yeah,
Yes, sir.
The wavelength of the wave is the distance PR.
Yep.
That's correct.
Yeah.
Because P to R would be the length for one full oscillation. So this is correct. So 2 and 3.
2 and 3.
32C. Does everybody understand that P, Q, and R? P, Q, and R, they're not in phase, right? They're not in phase.
Yes, sir.
No.
Yes, sir.
Right, so remember, points S and T are out of phase, and the wavelength of the waves, the distance beta r. So we're looking at 32, C, 2 and 3. All right, 33 now. This was the answer. So I repeat.
Small amplitude.
Small amplitude.
Small amplitude because it's quieter. Amplitude corresponds to loudness. Which of the following can produce diminished virtual image of a real object?
Divergent lens.
Divergent lens. Divergent lens does only produce virtual images that are diminished. Divergent.
Divergent when like a thin in the
Hourglass.
middle, right? So
That's the kind
Yeah.
of hourglass figure
alright,
lens.
yeah.
That's why let's call it to remember.
Right? 35. What's the answer?
A.
OMG, such a repeat. Same position of anything.
Yeah.
Earlier, we are not Homelander. We cannot fire light rays from our eyes.
Rest in
Right?
peace, Homelander.
This don't make any sense because the object distance and the image distance are supposed to be the same. Something wrong here. Right? And this don't make any sense. Right? The object not supposed to be a dash line.
Solid lines.
36 is the answer.
A.
A. Cool.
So what's the reasoning behind 36? Is it because like each ring is equally spaced apart?
Okay, here what, right? Imagine you have like you ever see the process by which people create like artificial waves?
Yeah.
So like imagine like I can move in a bob in the water like up and down.
Yeah.
It would like okay when I pull up and pull down, it create like waves, like concentric waves.
Yeah, so
As I
each ring will be equally spaced apart.
right, because it's saying a constant frequency.
Okay, cool.
Yeah, they share a common
I just want
sense.
to make sure now, sir.
So and they come like if you drop a stone in the water. If you drop a stone, it will produce equal space.
I mean, like you're going up and down in the wave constantly.
Let me show you. Artificial.
Same might have a pause timer.
Why getting sleepy, boy?
Oh, the night is young, man. The night is young.
The coffee running out.
Okay, watch. This is what
Sorry,
I'm
bro.
talking about. This is what I'm talking about. Let's seen it.
Yes,
Yeah.
sir.
Yes.
Right. So like they would take this. You see this over here, and they would move it up and down at like a constant frequency, and that would create like the concentric.
So what they're looking for is a ripple effect.
Yeah.
Do you
Think
want
I
to
get
know a
better.
fun fact?
What's that?
So in the Navy, for because I have to do tests for like diving and stuff, they actually have a big pool with like this mechanism that is actually just shift around to actually make the waves, like if it's in the sea.
Like this, like what's shown on the screen or not? Different mechanism.
Not different mechanism, but the same effect, except they could mess around with like the intensity of the waves.
Okay, that's cool because I know like like in the military at least they have like training. Like if you're in Marine, it's like they have like these simulation pools where you have to like swim against the current and thing.
Yeah,
Right.
but
So
for
this
the Navy, they have some.
yeah, for the Navy.
See, sir.
And I hear in Shania. But if you're talking about waves, all of them undergo wave phenomena. So all of them would undergo reflection, refraction, and diffraction. 38, Roy G. Biv, and it splits.
Remember, it splits when it goes into the triangle.
This wrong. It's supposed to split, right? This is the correct answer, I believe, Roy G. Biv, and it's supposed to split. It is supposed to split upon entering the glass prism, and it would split into Roy G. Biv. Everybody okay with this?
Yes, sir.
Yeah.
This is Pink Floyd album.
Yeah, Pink Floyd album. Right, everybody okay with this one, right? 38 E.
Yes, sir.
Yes, sir.
Badness. Let me move
Let's
on.
see for this
39.
one.
See for this one, sir.
Opposite magnetic poles. So north to south, right? North to south.
Outer north into south.
Yes,
Arrows
sir.
facing south.
North to south. Right, cool. Very lucky. Let me move on. Metallic conductor. Metallic conductor. What's the answer?
D.
D is the answer, right? D is the answer. Bam. Level madness.
41C.
41
41C.
is
That's
C.
easy.
One see.
Step up AC input.
Because
The
for
number
transformer to
code,
work, yeah, talk to me.
the number code is more in the secondary.
Right. If you have more turns in the secondary, it's gonna increase the voltage.
Mm-hmm.
Right? So 41C, does I repeat?
This
See the
always
several
bring this
times.
one, sir. Way.
3142. The answer is A for that one.
Wait. Okay, I mean feel different, boy. Well, what is this? This is what?
A resistor.
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 What is this?
Diode.
Diode.
Conductible diode.
What is this?
Um,
Number
Alarm.
And is that
number two is a
Fuse.
fuse.
Resist.
is I repeat with the answer?
P is equal to arrow because we squared that wrong.
C is it? Yeah. Right, cool.
NAND gate for that one.
NAND gates.
NAND gate. Boy, they always get these. Whoa, look at all these. Give me this, boy.
1.5 ohms.
Everybody okay with this, right?
Yes, sir.
Yes, sir.
Good.
I hope CXC don't listen to this live saying, oh, they only bring in repeats and like for the people
telling
next
me?
year.
I was not thinking that, bro.
How will the
And
people
that's why
next year
all
go
they
get new
shouldn't say
questions?
anything.
Let me lock in. So this I repeat, right? 0.6 over 0.4 is just 1.5. This I repeat. You've seen
So,
it several times.
what's the answer for CD?
Huh?
What? No, never
Whoa,
mind. They continue.
Whoa.
Hey,
Can we
yo.
proceed?
Bro.
Stop all your foolishness. Let us
So
turn
when
in circle.
also from people
This
for
is
for
slip ring.
The answer.
slip
Slip
ring.
ring.
Slip
See.
ring.
If you like it, then you should.
I don't
Let's see
cook.
the
I don't clean. Let me tell you, I got this right.
Whoa.
Hey,
Kelani,
don't kick
calm
you out there.
yourself, Kelani, relax yourself.
Take a chill pill, boy.
Which of the following statements about alternating current is true?
B.
B.
B. It can be rectified by using a semiconductor diode.
It
And
don't.
how much? If I want to make a full bridge rectifier, I need how much diodes?
Cool.
Well,
I need four. I need four. I need four.
4 diodes.
Two
Right?
each. So it's 2 on each side, right?
Yeah, like this. Oh, I hope I remember that correctly. Right? So yeah, let me read the other options. Right? It can be changed into direct current by a transformer.
Nah.
Nah, I didn't know
No.
Bumblebee was doing that.
It can be used to recharge a battery. No, that's a lie. You always use direct current to charge a battery.
Exactly.
It is used to transmit electrical energy. What?
What? What travesty is this?
Yeah, boy.
Sorrow's prayers. That's just no.
I mean,
Even that-
I could kind of see what they mean, because you could use alternating current to induce a EMF in a coil, but the answer is clearly B, right? It can be rectified using a semiconductor diode.
Even that's what it's like the McQueen, boy.
Everybody okay with this? 47B?
Yes, sir.
Who against
Right. In which of the following diagrams are resistors P and Q in series with each other and parallel with R? If P and R are in series, then
and
they will
Q.
be. Hear what? If P and Q in series, they will be like one after the other, right? One after the other. So yeah, looking like P and Q in series, and they are parallel with R. Looking like A.
Looking like A, yeah.
Again, I swear this is a repeat from 2006.
Wow.
Way.
This one over here, this is a lie, because over here P and Q are what?
Parallel.
Parallel.
It's a
What a
lie again.
travesty.
But it's supposed to be in series, right? It's wrong.
It's supposed to be in series. The only thing that's supposed to be in parallel is R.
Right. So in C, you see not P and R in series. That's not what we want. We want P and Q in series. Over here, you see in what's in series?
P and R.
Yeah.
Right? So I understand why P and Q is in series here.
Yes, sir.
Yes, sir.
Because like they're one after the other, like literally in a series, and they are in parallel with R because the current splits at this node here. Cool. Hey, let me back to my boy. How do I buy a new chair? How do I buy a new chair, boy? Oof,
D
I need
for
to buy a
this
new
one,
Apple
sir.
Pencil for a new chair.
D for
D.
this one.
Alternating current. Alternating current. If it's alternating current, I had to go from positive to what?
Negative.
Negative.
Right. See. If you're confused, right, over here it's above the x-axis, so it's always positive. Over here it's always above the x-axis, so it's positive as well. It's always above the x-axis, so it's positive again. But over here it goes from positive to negative.
Mm-hmm.
So
Everybody
where
okay with
this
that?
called that kind of
Yes, sir.
that kind of graph here.
It's a square wave.
Square wave, okay.
Magnetic inductions, I repeat, was the answer.
Iron nails.
Yeah,
Iron nails near the magnetic
nails.
becomes magnetized.
I don't know.
Oh,
Right.
yeah.
50D.
You don't know, you can't keep up, boy.
These are repeat, these are repeat, these are repeat, these are repeat.
Easily
Yeah.
magnetized and
Easily
rotating
magnetized.
magnetism.
C. And the same position to C.
Easily
Yeah,
magnetized means
magnetism.
it retains its magnetism. Well, that is
Right.
absolute cinema.
These are repeat as well. What's the
Yeah.
answer?
The answer is D.
Clockwise.
It's still in the
Clock,
same place.
the clockwise one.
The clockwise one.
Somebody had a question?
So that's not this thing where you say
Yeah,
use your
yes,
finger
sir.
and make sure it's going in the same direction.
Wait,
What
tell
was the
let
answer for
Kamara
the
speak.
what was the answer for 49? I think it was 49.
49? 49
No,
was
40,
D.
48.
48 was A.
Okay.
Because what? P and Q, they're like literally in a series, right? Like watch the current. Like the same current goes through P and Q. So P and Q are in series, and then a separate current goes through R. So these two are in series and they're in parallel with R.
Okay.
I don't feel like you understand that.
Yeah.
Like watch. Over here the current is gonna split, right? You see in that? Like the current would split here.
Yes,
And
sir.
the same current going through P and going through what?
Q.
It going through P and it going through?
Q.
Right. If the same current going through P and Q, the same current, they in series, right? A different current, however, goes through R. So that tells us that R is in parallel to P and Q. All right, let's move on. So 52 was a repeat, that's just D. For which of the following does a repeat as well?
1 and 3, sir.
So if it is an isotope, then it has a different mass number. So the number on top is going to be different, right?
Yes,
Because they
sir.
have a different
Yeah.
number of neutrons.
Gotta be plus or minus.
So this could be different. Could change. This could change. This could change. So we're looking at this is fine. This is fine. Right? It can't change the atomic number though. Right? It must remain the same. If we could make it to 2014, that would be legendary. That would be legendary. 1 and 3.
Like a
B,
whole
right?
crash course here, boy.
This is a crash course. What do you mean?
Like
Everybody okay with that?
a real legendary crash course. It goes to 2014.
And we did crazy. 1 and 3, right? Everybody okay with that?
Every
Yes,
paper
sir.
in detail.
So technically, I crashed out already, but still here.
If if you can't make, I would suggest you go and take a rest. I know way to burn out yourself.
I'm not sleepy. I just saying I crashed out once. That was
We running on
it.
vibes.
What's the answer for this?
Sleep in the
Beta
morning.
particle.
C.
Yeah,
Because 14 plus 0 give back the 14, and where is 7 minus 1?
You get -1.
Whoa, where does numbers come from?
6,
Alright,
7.
you done. Oh, I was talking about. You have me thinking. You have me thinking that you confused. I was like concerned for it. Right? Everybody okay with the answer being
Sir,
C?
sir, I remember when you explained last
Yes.
question like this,
So it's
and
okay if you be
understand why
concerned
it's
either way.
beta.
Right?
Hey, yo.
Watch it again. 0 plus 14 is 14. 7 minus 1 is 6. 6, 7.
Hey, yo.
Hey, yo.
So you do that for spite.
Shame. Shame.
6,
Shame on you. No, man.
We should make that
Wait
stupid.
now. Hey,
Focus.
sir, I have a question. N67 is alternating current?
Yeah.
What?
What?
Oh.
Think about it for a second.
6.
Oh.
And look at like alternating current.
Okay. Make
Let me lock in and continue.
lucky.
Right. C is E. Where's C?
Speed of light.
Speed
Speed
of
of
Speed of
light.
light.
Delta M.
Um,
Delta M is mass of the atom. Something.
Nah,
right?
delta M is the mass loss.
Right? Yeah, delta M is the mass loss. The proper name for it is the mass defect. The mass defect.
Okay.
Because guys, and when you do these type of questions, and you go find the mass, you find the mass before,
If any mass after.
Any mass after.
and the mass loss will be converted to what? Energy, guys, energy.
Oh, okay. Sorry, my bad. I couldn't remember for a second.
That's alright.
Wow,
55B.
lagging.
C is the speed of light, delta M is mass lost. Mass defect.
Alright, guys, we're almost to the finish line.
Alright.
136. 136.
136.
136.
boy.
Right? If I want to find the
Right,
number of
next
neutrons,
question.
I just go and say 222 minus 86, and that should give me 136. I
You
pray.
don't drink more coffee.
Although, don't get
The
the man any.
answer. Positive, but not
I drink enough
very
coffee.
penetrating.
Not very penetrating.
Repeat.
Yeah. Repeat.
It's a repeat as well, man.
Yeah.
Beta particle.
Isn't that A with the zero on top
helium.
and the no, it's not
Negative
A.
one.
It's
B.
D. The
Negative.
zero on
B.
top and the negative one below with the
Because
E.
they literally saying it's a beta particle earlier.
Oh,
If it's a beta particle, and the beta particle exists as a fast moving electron.
my bad.
So I remember the numbers that's supposed to be in place, but I can't remember what those supposed to be aside.
And even if you forget, I mean, watch it right, Eden. You had to get back 11. What to do with 12 to get 11?
-1.
Right. Eden, I feel like you should go take a rest, boy.
No. Physics don't sleep.
Physical, physical active.
All of them know
they're
children. Just
Einstein.
tell them go in the bed.
Alberta Einstein.
Big up Einstein one time.
Albert Einstein, boy.
Big up Oppenheimer too.
Right,
60
brought
days,
the
60
bomb.
days, 60 days.
60 days. Big up Nikolai, because he introduced it.
Yeah, the way you talk for Nikolai, big up Nikolai one time.
Nikolai.
Because a half by half is 1/8, so this is 3 half-lives.
What's the time, sir?
And each half-life is 20, so 20 by 3 is 60. And we make it in less than, essentially less than half hour. Badness.
Hey, before 40 minutes.
So
And we
listen to
don't
this now.
talk to them.
So I don't know why I feel real sleepy.
Wait.
I
Here's how
wake
I
up this
keep-
morning thinking.
A.O. Kimura.
I thinking it had chem this morning. I wake up like 7
Why
o'clock. No,
everybody do
6
that,
o'clock in
boy?
the morning.
Same with me.
Same.
Oh,
I
you
got
up?
up 6 o'clock
I
this
wake up
morning.
6 this morning when I realized,
Same.
it's 1 in the evening.
You know something funny?
I couldn't go back and
Actually,
sleep.
I woke up 10 o'clock and I panicked. And then I checked my timetable. I was like, oh, okay, I went back to bed.
I genuinely thought.
Everybody panic.
I can imagine your face in there.
I literally, my heart dropped because my friend had messaged me and she was like, Shania, are you in school? And she messaged me 9:15. So I was panicking.
Shania, I don't blame you, girl, because my heart was literally palpitating out my chest, literally.
I was in the car already at 7:30, ready to go to school. I check in my timetable 1 o'clock. No way. I in the car dressed for school already. I went back upstairs.
You're like, Kimara, wait.
I thought physics was Friday or kind of thing.
That would be double whammy. No, triple whammy.
You tell
If they
me.
put 3 on the same day.
Is that a guy who thought IT was in the evening and he reached half an hour late for the test?
Oh,
Everybody finished that test in half an hour, by the way. So everybody just outside. We just see he running up the stairs. He still got to do the test, you know, sir. And he finished it in 20 minutes.
Well, happy he
No, you're allowed,
happy he
even
get through.
once they do cross being half an hour late, you're still allowed to sit your exam.
Yeah. They wouldn't get you extra time though. Would they?
Not
Ah,
not
those,
on.
No, they would
That's
not.
see,
So
see,
you
those
had to
nice.
work with what it have remaining.
yeah. Okay, I'm already ready to tackle.
2018. There we go.
Yes, sir.
Let's go.
Right. Oh yeah, under 30 minutes. Let me go.
The
What's the answer? What's the answer? What's the answer?
eye level,
B,
eye
B, B,
reading.
Can
B,
we do
B.
eye
Eye
level?
reading.
Eye level,
Eye level.
placing eye at the right angles to the mark being read.
Bread.
Be read.
Speeding, boy.
This is more like
had a weak
chemistry. This is more like chemistry. It's not
Yeah.
So I could say
but
something, right?
but
Like
come
you
on.
see for a burette, you would use it for like decimal, but like a pipette is more like for fixed values.
Wait, yeah.
Yeah,
I don't really
Keelan is correct.
That's true.
I don't really
That's
dabble in
true.
chemistry. Let me just see what long time I see what berettas look like. The berettas, you think it is used for titration or not?
Yes,
Yeah,
sir.
it
Yes,
is used
Yes,
for
sir.
sir. Yeah, let's
titration.
use a burette for titration.
Right. I see. I guess I
The
can muscle.
pipette,
I
let
guess
me
I can
explain to all
muscle.
you. The pipette is the thing you just put the solution in for the titration, and the burette is the one that it is used to measure how much ever it is that you have to measure for the
Wait, all I know is the burette is one of the most accurate instruments in
burette.
chemistry. That's all I know.
Yeah, that.
So I don't
Um,
know all of that, you know. I just need to know the answer. You know.
Yeah, man, Nicola, I feel you. Nicola, I feel
Nicola
you.
like he tired, boy.
Oh,
let me
Nikolai
know.
tired.
Hey, Nikolai, don't tell
Shadows
you. Hey,
just to
Nikolai,
hear
don't
that.
Nikolai,
know. Nikolai,
what's the
don't
answer for
say.
three? Nikolai, what's the answer for three? Tell me fast.
All? Isn't it all? D?
Hey,
Motion
sir,
and density.
Nikolai didn't finish chemistry. He don't want to hear about that, sir.
Nikolai, four. What's the answer for four?
700.
What's the answer for this one?
The product of its force by the perpendicular distance at the turning point
Right.
C.
What's the answer for this one?
B.
These are kind of newish questions. When
DC.
well, we will see. When a force F is applied to a spring of original length L, the new length becomes L plus X. What will be the length of the spring if a force of F over 2 is applied instead? So if I decrease the force by a half, the length it extends to would decrease by a half, right?
Yeah.
So it'd be L plus X over 2 in LCD, right?
Yeah, D.
Sir. And I
Let me
swear
get,
this was a repeat from 2006.
oh my, like the best we did 2006, right? So when a force F is applied to a spring, the new length is L plus X. So X is the extension, right? X is the extension. And we know that force is directly proportional to the what?
The extension.
Right, force is directly proportional to the extension. So if my force gets halved, my extension will be halved as well. So X over 2. The answer is B. Everybody okay with that?
Yes, sir. K.
So if I halve my force, my extension will be halved. Because they're directly proportional. So 7, remember, L plus X over 2. L plus X over 2. L plus X over 2. Right. Is that repeat? What's the answer?
12.26.
Right. If you're confused, watch. Over here, 12.2. Then it lines up over here. This is at 0.06. Add it up, 12.26. Nikolai, you go with this, right?
Yes, sir.
All right, good. Nikolai, help me with 9.
Which of the following measures may be classified as a scalar quantities? Speed and time.
Speed and time.
This vector.
Right, cool. I move on. Is that repeat? What's the answer?
D, sir.
D. Right? Height is meters, pressure is kg meter per meter cube, and gravity is Newton per kg. 10 is D. I move on. Keep it pushing.
11 is D, sir.
Right, that's D. Remember? It was literally just square root of A squared plus B squared. And I had to go from O to C. I put okay with that, right? 11D.
Yeah. Find any
Right.
mass of the ball. Unnecessary.
Right. Nikolai, do you know that finding the mass of the ball is unnecessary?
Yes, sir.
Alright, cool.
Bigger fet, sir. That the app you did use.
Right.
Steady speed.
Yes. Right. Because as you see, it's like a linear graph. Right? Everybody okay with that 13D?
Yeah.
Right, let's move on. Time period.
Length to the pendulum.
Length to the pendulum, right? Cool.
Potential
I place
energy.
it at a shelf. Potential energy.
Q.
Q.
Upthrust is less than the weight of the bubble.
Wait, I take your time. The upthrust on the bubble is greater than the weight of the bubble.
It's not less than, it's greater
my
than.
God. Nah, it's just because I
It's
Russian.
B.
I know the answer. Let's Russian.
Oh, okay. Good to know.
So the upthrust had to be more than the weight.
Yeah.
Everybody okay with 17B, right?
Yes, sir.
Yeah, all okay, right?
Yes,
Yep.
sir.
Yes,
Okay.
sir.
18. Which of the following statements about the pressure law are true?
1 and 2.
Is true.
1 and 2, 3 is not, it's irrelevant. It's irrelevant. 3 is
Right.
irrelevant.
19. Which of the following statements concerning the radiation of heat is all true? Is a lie.
2 and 3. Radiation can never be taken place in a material medium. That's wrong.
As a lie. It can take place in a vacuum, right?
Exactly.
20. Where's the answer? Come on fast, guys.
Convection.
Convection.
right?
Yeah, convection.
Right.
This is where the
These are
heat travels through the pot,
B
right?
double.
BBB doubled.
B double.
Double, right?
Double.
If I increase the mass, I gonna need 2 times the energy, right? Cool. 21B. These are what's it? Evaporation. The answer.
A.
Yeah, that
Yeah,
Evaporation. Evaporation can happen at almost any temperature, so A is wrong. It's saying evaporation occurs at room temperature only. That's a lie.
C.
C, right?
C.
Fed up, see this question. Fed up, see this question, right? Fed up.
C.
24. Is that repeat? What's the answer?
100 to 100.
C.
yeah.
100, right?
100, 100.
Looking for T2 minus T1. What's the answer?
D.
D is always T2 minus T1.
Right.
Over.
Substance
When
is changing
heat,
state.
right, when heat in a substance, a point is reached where no further change in temperature. No further change in temperature. That means a change in what?
State.
Right.
State.
Right. So they're talking about latent heat of fusion and latent heat of vaporization. Everybody okay with that, right? 26B.
Yeah.
Yes, sir.
27. Which of the
All.
following phenomena are exhibited by sound waves?
1, 2,
All.
and 3.
Yeah, all.
The all of the above.
Right. Let's move on to 28. Whenever there is complete destructive interference between two coherent waves, the waves must be out of phase by
Out of phase by half
Out of
wavelength.
phase by
half a
half
wavelength. Half a
a
wavelength, right?
wavelength.
And it would completely cancel off half a wavelength. Remember that, half a wavelength. We familiar with this one? What's the answer?
Q is louder than P, but P has a higher pitch.
Correct.
Right.
Yes.
All right. 29. What's the
A.
answer for this one?
A.
A. V is
As-
V is
F is
over.
equal to V over lambda.
F is equal to V over lambda.
Lam.
Right. Cool. It's really easy.
31B.
B.
It's supposed to be pointing upwards, but in the other direction, if you get what I'm
Wait,
saying.
what's in, boy?
Wait, no, wait. I want to know. Huh?
Yeah, everybody okay with that? 31, like, is a mirror or is a mirror? Is a mirror. It's literally a mirror. So,
So that's what I was
31,
trying to explain.
31B, are you okay with that?
Yeah.
Yeah.
Right.
JK.
JK.
JK. And 33
John
is A.
Kennedy.
JK.
John
Right,
Kennedy.
33, where's the answer?
A.
A, sir.
A.
Which of the following types of electromagnetic radiation cause tannin? Tannin.
Ultraviolet.
Ultraviolet.
You just
UV
literally,
rays.
you just literally wear sunscreen to avoid getting tan, so to prevent you from getting the
Yeah.
UV rays.
And
Right.
so just
What's the
to
answer?
clarify.
A, sir.
A.
A.
A. Roy G. Biv.
Yeah. Roy G.
Roy G.
Biv.
Biv. And when it enters, it must split into Roy G. Biv.
Yeah.
Roy G. Biv must split. It must split. Right?
C.
36. What's the answer for 36?
C.
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 C, right? Wrong, wrong, wrong. Remember, it must be laterally displaced.
And
Right?
you
And it
say you
must be
could draw
parallel.
the line to make sure that is
Yeah,
the correct thing.
yeah, you can do that. It must be parallel. It must be parallel, right?
I
Cool.
can do that.
Right. 36, 37. What was the
A.
answer?
37A.
Yeah, A.
Oh, that's all right.
Yes,
No,
sir.
wait, what? So
Let me just
wait,
do back the question first. So it leave the air and enter in the glass. So Ni sin I is equal to Nr sin R. So if it leave in air, then the incident ray would have be in air. So that'll be 1. And they want me to find the angular refraction. They tell me the angular incidence is 37. And they are they sure that E?
Yes,
They're looking
sir.
like E.
I'm looking like
And,
D.
and they tell me that it go into glass. So that'll be 1.5. Yeah, they're not looking like E. E is wrong.
See,
E is
I know
wrong.
that. I
Right?
was shocked when I only picked that.
And then you divide both sides by 1.5. So sin R is really sine 37 all over 1.5. I'll do all the work in, please, if you're not sure.
I had one like this, but they bring 1.6.
You gotta be careful. Right? So it said it leaves air and it enters the glass. So the incident ray is in air, so the refractive index at A is 1. So I say Ni was 1. The angular incidence is 37. So I said 1 by sine 37. The refractive index of the glass, which it went into, is 1.5. So I replace NR with 1.5 sin R. I'm trying to find for sin R, so I divide both sides by 1.5. 1.5's cancel off. I get sine 37 over 1.5. Good. Let's move on. What's the answer for this one?
Interference. I see.
Interference.
Interference
C.
of the sun.
Right, cool. The human head. What's the answer?
C.
Right? Cool.
Gamma
40.
rays.
Summary.
Right?
Gamma rays.
Right? Because rich radio waves have the longest wavelength. Rich men in Vegas use expensive gadgets. Yeah, gamma rays is to the end, so you got the shortest wavelength. 41. I had to go north to south. What's the answer?
C, sir.
C. Let me just make sure we understand this, right?
Yes, C.
If it's at south here and it will attract the iron, then it would create a north pole over here. This don't make any sense. Has to go from north to south. This don't make any sense. This makes sense, right? Because it would create a north pole over here and it go from north to south. So this is the answer, C. 42. Which one is a DC current?
A, sir.
A is a DC current,
Yes, sir.
right? Which, as I repeat, I want to measure the lamp's voltage. The lamp's voltage.
That'll be C.
C.
This don't make any sense. It does never hook up a voltmeter in series. This is wrong for sure. Over here, you measure any voltage for the battery. That's wrong. Over here, this is correct. I'm measuring the voltage across the lamp. You can see that. Anybody can tell me what I'm measuring over here?
Well, use just the resistor and the lamp.
Yeah, I'm measuring the voltage drop across the resistor and the lamp, which is wrong. I just want to measure the lamp. So I must put the voltmeter in parallel with that. So I hope you remember that. Remember that, please. The unit of potential difference is defined as
Joule per coulomb.
right. And if you don't know, remember V is equal to IR. Actually, don't remember it like that. I don't remember it like that. Give me a second. Let me just verify this.
Later, you know, C.
You can head out there.
Yes, later.
All right. You have a blessed night.
Bye,
Right.
everybody.
Right. So voltage, 1 volt is just equivalent to 1 joule per coulomb. So it's gonna be joule per what?
Cool.
Right, joule per coulomb. It's a good thing we do this. So if this comes tomorrow, right? So 1 volt is joule per coulomb, right? Joule per coulomb. Remember that. Joule per coulomb.
Yeah.
Joule per coulomb. Right. Series arrangement. What was the answer?
B, sir.
B.
B, right? Because the current would never split. It's the resistors are in series. 46.
12 minus 4 volts. So
Yep, 12 minus 4.
each of the resistors had the same voltage, but they had different
Right.
currents.
Because they're in parallel, right? Here what I was saying. If the battery is supplying 12 volts and across the filament lamp you have 4 volts, then across here would have to be what?
8.
8.
It have to be 8. And since all of these resistors are in series, all of them going to share the same what?
Voltage.
All of them going to share the same voltage. Well, they're going to have the same voltage across it, not share the same. Yeah, you get the point. Same voltage across it. So 12 minus 4 is 8. Cool. 46C. Remember that. 12 minus 4. NAND gate. What's the NAND gate?
D, sir. D.
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 Easy NAND gate. Nice. What's this?
That's an AND gate.
What's this?
Or.
Or gate.
What's this?
Not.
Not.
Cool. What's the output?
0,
0,
0.
0.
No, nope. I gotta take all the time. In the question, they're saying, what is the output at C and D when the input at A is 0? So they change it up. The input at A is 0 and the input at B is?
1. So it 0, 1.
Right. So this gonna multiply. What is 0 by 1?
0.
0.
Right. Over here, you're gonna have 0, 1. You're gonna add that. Where's 0 plus 1?
1.
1.
Ah. So what's the answer?
B.
Oh, you see why I had to take your time. I know I was going for 0, 0, you know. I know I was going for 0, 0 and move on. I knew that. If you're confused, over here is our AND gates. AND gates multiply. These are OR gates. OR gates add. So 0, 1, 0, right? 0, 0 plus 1 is 1. So C is 0 and D is 1. Remember this. Read your question. Read your question. These
3
are
amps.
repeat answer. 3
3.
amps, right?
3.
Ooh, let's move on. 49D, 3 amps. Good. What's the period of the current?
4 seconds.
4.
Right. The period is just the time it takes for what?
1 oscillation.
1
Right. 1 oscillation. Good. 1 oscillation, it takes 4 seconds. Which of the following circuits will the lamp light up?
Conventional current.
B.
Yeah, B.
Not gonna light up here because the diode will block it. Over here. Yeah. B. Good. 51B. Right? What's the answer?
A.
Yeah, A. 3142.
Right? This is a resistor. 4 is a resistor. 3 is a diode. 2 is a fuse.
2 is a fuse.
And 1 is a lamp. E. Good.
Next one is a
53.
slip ring.
Slip rings. D.
Half-life. What's that?
A, sir. Time it takes half of the radioactive atoms in a sample decay.
Once you don't see half in it, it's definitely wrong. They're saying half the time it takes a radioactive nucleus to decay. Half the lifetime of a radioactive sample. I would go with A. I try to tie you up here. Let me just verify this though. 1 second. Because I find like the answers are really similar. Let me just verify. Everybody alright? Are there still energy?
So we chilling, pumping.
Right on the vibes of physics.
Physical.
Well, good thing I go wake up late tomorrow. You don't know.
I have a question, Eden. You have Chinese, like okay, look at Asian.
So our mixer, like, so my mom is Indonesian, but my dad is Indian. He from here.
I see.
Yeah.
So the answer is A. Let's see why the others are wrong. B. The time it takes the radioactive atoms, no, that's a lie. That one really easy. Don't have half in that. C says half the time it takes a radioactive nucleus to decay, and the reason for why it's wrong, you cannot predict when a single nucleus will decay. Radioactive decay is random. And D, half the lifetime of a radioactive sample. A radioactive sample does not have a fixed lifetime. In theory, some nuclei remain forever. So that don't make sense. The answer is A. The time it takes half of the radioactive atoms in a sample to decay. The atoms is what's decaying to become more stable.
Cool.
55, what's the answer?
Einstein.
Yeah, Einstein.
Big up
Yeah,
Einstein.
Gamma rays, gamma rays.
Gamma rays.
Gamma rays, they don't have a charge. They are radiation, right? EM
They
radiation.
feel like Hulk.
90 protons, 144 neutrons.
Speed.
Right? If I want to find the neutrons, how am I going to do that? Someone fast.
Got a minus 90 from 234.
90 from 234.
What that will be?
The 144.
144.
Good. I keep it rolling. Which of the following statements of radioactivity are correct? It is a random process.
True.
It is dependent on conditions external to the
That's
nucleus.
false. Wrong.
It is due to changes in the nuclei of the atom.
1 and 3.
1 and 3.
Yeah.
B.
Everybody okay with that?
Yes, sir.
Yes, sir.
Well, you know 2 is wrong, right? Because it's within the nucleus. So any option with 2 in it is wrong. So that eliminates A, C, and D.
Yes, sir.
Are you okay with that, right?
Yes,
Yes,
sir.
sir.
50, that's the half-life graph. That's D.
Half-life graph we're looking at. That is
D.
half-life.
Exponential decay.
Right. We do this in 21 minutes. Let me go. Let's
Let me
go.
go.
Right? What's the answer?
That's not. I gotta be careful. Looking like C.
Yeah.
Let me
Right,
go.
because
21 minutes.
220, 2 plus 4 is 226, and 86 plus 2 is 88. Bam. Absolute cinema. There we go.
Hey, that was real quick.
You don't know.
Are you ready to go even faster?
Yeah. We feeling the feelings.
Oh yeah, baby.
I'm feeling like
What?
a alpha particle.
That's good, I suppose. Is that good?
Because I'm always positive.
2017, guys. Let me go.
I've seen a bunch of new questions. Well, most of it repeats. Right. What's your answer?
Our press is less in liquid and liquid BC.
Right. If it's sinking in liquid A, I mean again less upthrust on liquid A. So the upthrust is less in liquid A than in liquid B. Right?
Yeah.
One. Right.
Yeah.
To measure the external diameter, we're going to use
Vernier caliber.
caliper, right? What's your answer for this one?
10.
10. Which of the following measures has 3 significant figures? 3 significant figures you're looking at. A.
Zero
A.
don't count, so it's
0 doesn't count.
Unless it's between 2 numbers.
Yeah.
You don't
Is that the case?
Yeah, that is the case.
Yes, sir.
If it's in between 2 non-zero numbers. Right? So like watch, if you have 209, 0 is a significant number there.
Cool.
Right? This have 4 significant figures, guys. You can't tell me the answer is C. You can't do that. Cool, let's move on quickly.
Mass.
What's the answer?
Mass.
Mass no change. Mass change.
5.0.
The length of the rod.
5.0.
Yeah, 5.0.
Yeah. And I can explain why also because a ruler doesn't measure in hundreds, it's only measure in like 5.0, 5.1, 5.2, 5.3.
Are you sure it's 5.0?
And they're looking like 4.97. A little
Yeah,
before 5.
It's looking like
but here what I'm
4.97.
saying. A ruler. We're talking about degree of accuracy here.
Yeah,
Can a
I'm not
ruler
sure.
measure? Okay, I want us to literally pull out a ruler, right? Literally pull out a ruler. Pull out a ruler. Have a ruler.
So I also.
Sorry, I'm too far from my thing. I just want to finish so I can go and sleep
Ruler.
peacefully.
Watch this.
Yes, sir.
Watch. I could get something like 1.1, 1.2, 1.3, 1.4, 1.5, Nikolai. Could I get something like 1.45 or something?
No, sir.
That you right also.
Yeah, you're right.
What?
You're right.
It's not precise enough.
And not
Not precise
precise.
Yes, it's just 5.0.
5.0, right? Nikolai, you understand that? No.
Yes, sir.
Nikolai, your ruler can measure up to like 0.01.
No, sir.
Nah, ruler can't do that. So 5.0.
700.
I know a lot of people want to put 4.97, but it depends on the degree of accuracy of the ruler. This ruler only measures like 0.0. Like, if you see what I mean. Because like
700.
what 4.5? You know what I mean? Cool.
So, and
Is your
that's
answer?
probably why it's 0.0 and not 0.00.
700. Oh, sorry.
Correct. If you look at the ruler has a degree of accuracy to 4.5. So like it'll be 5.0 because like 0.0. Right, the answer is 700. 700.
Yeah, D.
So wait, which paper is this?
This is 2070.
70? Okay, cool.
Alright, let me keep it pushing.
Going down in numbers
What's the answer?
only.
Potential.
Potential energy.
Potential energy bomb.
Increases.
Low
Which
center
of
of
the following
gravity.
just
Lower
Low
center of
center
gravity.
of gravity.
right?
Center of gravity.
The answer
A.
is A.
Yeah.
Repeat.
I saw the stopwatch. Oof.
I see.
Which of the following expressions could be used to determine the speed of an object? Gotta take your time, right?
Distance over time.
D on T?
Distance over time.
Distance over time.
Distance traveled over time. Take a
You will not tell me A. A is for what?
Displacement.
Acceleration.
Acceleration.
Oh, my road.
Acceleration.
My bad.
What's B for? What's B for?
Velocity.
Velocity.
Yeah,
Right.
velocity.
If it's speed, we're talking about scalar quantity, so distance over time, right? 11c. What's the answer for 12?
KGMS minus 1.
Yeah, KGMS minus 1.
Right, 12b, right? Are we okay with that?
Yes,
Yes,
sir.
sir.
Yes, sir.
When two bodies collide, the momentum is conserved. This means that the total momentum of the bodies before impact is equal to the total momentum of the bodies after impact. D.
Wait. Like Eminem day, boy.
So you read real fast, boy.
Like Eminem day, sir.
I am.
That was Busta Rhymes.
Busta Rhymes.
Sometimes I was going to flow state. Sometimes I was going to a little flow state. You know what I mean? Every once in a while.
Yeah, flow state.
Right. 13D. Bam.
Moving on.
Oh, what can we define as?
Work done over
Work
time.
done over time.
Over time.
What you had to say that before?
100 to 100.
Yeah, 100 to 100.
Speeding.
Yeah.
Like air.
Yeah.
What's the answer?
B, sir. B.
Yeah, B.
It have to be going towards each other, then going up and then
up,
going this way.
sinks down.
That tricked me last time, but this time it didn't trick me.
Temperature and
Yeah,
mass.
temperature and
Well,
mass.
1 and 3 remain constant.
Right,
Keep
because
it rolling.
boils law is P1 V1 is equal to P2 V2.
P2 V2.
So the temperature constant and the mass is constant.
Yes.
So what's the answer?
B.
1 and 3.
One and
3.
Right, let me keep it moving.
340 kilojoules given out.
Yeah, given out.
Given out. D. Wait.
3400. 3400.
Yeah, it's 400.
D.
Alright, take all the time, right? Here what? E is equal to MLF. Your mass is 10. Latent theta, specifically latent heat,
340.
340.
Oh, yeah. Cool.
That would be 3400 on the units. Since it's kilojoules, it'll be kilojoules. Right? Kilojoules. And if you want to freeze, if you want to become ice, do you want to absorb heat or you want to give off heat?
Give out heat.
Right, you become an ice, you want to lose the heat, so you're giving out heat. 3400 kg.
Which explains it.
Moving like Drake. Iceman.
It's already 340. All he just do is multiply by 10 and you get 3400.
Right.
Of course.
Let's keep it rolling. As the temperature of a liquid rises,
Kinetic energy also.
Kinetic energy of its molecules increases.
wait, everybody understand this question, right? Like, I'm gonna give off my heat.
Yes,
Yeah, long time.
What's the answer for this? Specific heat capacity. What?
1 Kelvin.
1K.
Yeah, 1 Kelvin.
Wait, you're seeing specifics.
1 kg by 1
kg.
Kelvin.
Or you could go for unit mass too.
The last one.
Or I could say unit mass.
Right.
So it's kg and Kelvin?
Yeah, because
Yeah.
specific means kg and heat capacity is Kelvin.
Right,
Yeah.
right.
Oh.
Yeah.
The answer above there one time. The answer above there one time.
On my
Everybody
head.
okay with that, right?
Yes,
Change the
sir.
temperature of 1 kg of a material by 1 Kelvin. 21D.
1,000.
Yeah, 1,000.
Let me
1,000.
repeat. Because 5 by
So
200,
subtract
1,000.
30 by 35 and then he.
Right.
Yeah.
Alicia, we're moving with speed. We're moving with speed, Alicia. We're moving with
2 and
speed.
3. 2 and 3 for this
2
one,
and
sir.
3.
2 and 3. I did.
Yeah, that's why I didn't finish because they say I just took too long to the move again. But
I
that's
can't
it.
say that, but we move with speed here. Right? These are lie. It is take place in a vacuum. So 2 and 3. 2 and 3, ID. 23D.
Way boy.
Where's the answer for 20?
Convection.
Convection. That's
Convection,
with
right?
the electrical kettle. Your
Gas.
Right.
gas.
Gas, 25D. Gas, right. Let's move on.
38.8.
Wait, boy. Well, let me take
Is that
the
a
time
repeat
back.
question? Is that a repeat question?
Right,
It passed
35.
37, so that'll be 38 point something.
What are looking like, guys?
38.8.
38.8.
Let's see now, right?
Yeah.
Yeah, physics is truly amazing.
What?
Yeah.
35 to the 8.6 to the 8.7 to the 8.8, right? To the
Yes,
8.8. 26 to the 8.8.
Parallel.
Parallel. Longitudinal.
Longitudinal waves means it's parallel to AB.
Compressions followed by refractions.
Compression followed by rarefaction.
Yeah, rarefaction.
Rare fractions, not refraction.
Squishes and spreads.
Yeah.
Right, so sound waves propagated in a medium consists of compressions followed by rarefactions. Crest followed by trough is for transverse wave. Compression followed by trough, you're mixing the two. That don't make sense. Crest, nah, you're mixing the two. The answer is D.
Sense.
Right? Everybody okay with that? Sound waves,
Yes.
compression and
Yes,
rarefaction.
sir.
Sound waves. Right.
Yes, sir.
29.
Sound can be heard around a corner.
Yeah,
This is diffraction.
Rarefaction. The bending.
Right, cool. 29 done. 30 was the answer.
In phase of a half a wavelength. Sorry. In phase at all the points.
Right. All the crests and troughs are in phase along these points, right? Because it's constructive interference. 30 C. Are you okay with that, right?
Yes, sir.
31.
High frequency, low frequency.
Yeah.
Right? Let me just verify that. So, you remember Richmond and Vegas use expensive gadgets? Which one lower? Which one lower?
Visible light.
Visible light.
Yeah, visible light.
In terms of
See, I know they would
frequency.
have had to use the same one way or another. That's why I keep on saying it.
Thank you, Inisa.
Right.
Oh my God.
You're welcome.
Everything over here has the wavelength, big wavelength. Everything below here has a
Just now, say that again?
Shorter wavelength.
shorter wavelength.
Yeah, shorter wavelength.
Yeah.
It has like an inverse relationship, right? So
Understood.
if the wavelength is really large, then the frequency will be
low.
Low, yeah. Because like radio waves have a big wavelength but low frequency.
And this one and like gamma would have the what frequency?
The highest frequency.
Highest frequency.
Right. So X-rays over here and visible light with the visible light is quite over here. So which one will have a higher frequency?
The X-rays.
X-rays.
Right. So X-ray is gonna have a higher frequency, visible light gonna have a lower frequency. So the answer is 31B.
X-rays, literally seeing inside somebody.
Understood.
Alright, cool. Let's move on. So remember, X-rays, high frequency, visible light, lower frequency. Good. Which of the following in the 20th century provided evidence that light has a wave nature?
Young's double slit experiment.
Yeah, Young's.
Right. Because it showed that light could diffract and it had interference. Right?
Yeah.
Diffraction. And what else?
The Brighton and interference.
Interference. Right, cool. 32E. 33. Which of the following statements is not true of the image formed in a plane mirror?
C. Is a repeat question.
C?
Yeah.
Yeah, C.
Well,
C.
we know that the image is upright, we know the image is laterally inverted, and we know the image is the same distance behind the mirror, the answer had to be C.
Process of elimination.
Right, they say rays of light from the object pass through corresponding points of the image. If that was the case, then it would have suggest that it wasn't laterally inverted. Think about it. When you hold this hand in a mirror, and does this feel like I'll ever experience that?
Yeah, like the opposite hand.
Yeah. That means that the ray of light not passing through the corresponding points. But until then, I figure it's a true process of elimination.
Yeah.
Right.
Yes, sir.
Remember now, 33C. I move on. Which of the
Divergent
following can
lens.
produce a diminished virtual?
Divergent lens.
Yeah, divergence.
Divergent.
Right? Cool. Divergent lens.
We on speed, boy.
35, what's the answer?
Speed.
A.
Yeah.
35 here, right? 36. The diagram above shows the formation of an image by a
Magnifying
what?
glass.
This,
Magnifying
yeah.
glass.
Magnifying glass.
Because the image
Right?
bigger.
Yeah, the image is bigger. And it is also virtual.
Yeah.
Yeah. I'm pretty okay with that. Like,
Because think about it, right? If you want to use a magnifying glass to read words, the words is the object, but are way smaller because the magnifying glass will make the words bigger.
another thing, and this literally looks like the lens for a magnifying glass. I don't know if I'll ever open a magnifying glass. It's kind of
Yeah,
look like
advanced
this.
that
I can see it too.
Yeah.
Looking like the lens in my VR headset.
Yeah. Magnifying glass. Yeah. Right? And we know it's a magnifying glass because the image clearly is what?
Enlarged.
Larger.
Right, so it was magnified, right? Cool. 37. Which of the following statements about sound is not correct?
C.
Yeah, C.
As a lie, sound is transmitted as a what?
Longitudinal wave.
Longitudinal, right. A loud high-pitched note results from a wave of what's the
Large
level?
amplitude, high frequency.
Yeah, high.
Because if it's loud, it means a large amplitude, and if it's high-pitched, it means high frequency, right?
Yes, sir. I shall take our sleep today.
All right, let me go. Opposite.
North to south. C.
How to go from north to south? How to go from north to south, right? North to south. How to go from north to south? 0, 0.
This is 0.
A.
Right? 0, 0, 0, 0, 0, 0. We know this. Alright, cool. Everybody alright?
Yes, sir.
Yes, sir.
For the most part.
Step up AC. Step up AC.
Step up.
Yeah, step up and
AC input.
Right. It's only works to the AC, and you're seeing more coils in the secondary, which means it's stepping up. Right. What's the answer for 3 one time?
C.
Alright, C. Which one is the electrolyte?
This one is P.
P, sir. P.
Right?
Yeah, A.
P is actually a liquid. You can kind of see it's like a liquid. Electrolyte is a liquid with ions. Alright?
And R is a casing.
Yeah. And S is the electrode.
And where is Q?
It's probably like a. I'm not sure.
Insulator. Is it an insulator? Which
I'm not
holds
sure.
light?
Yeah, look like an insulation or something.
One second. I'm gonna tell you the exact thing. Dry cell, battery,
Stop
diagram.
the timer.
That's fine. It's fine.
So N cation positive and anion is negative.
Yeah.
Yeah.
Marsha, remember we do something like this where you can
Crazy. What would
So
you
when the electrolyte be Q?
Yeah.
Nah, boy. P.
but we use copper something.
It's another diagram.
Copper 2+.
Yeah, we use copper 2+.
Yeah, it looking like
Looking like Q.
Yeah.
So, cause I remember I do this.
Yeah, looking like
it
Q.
was Q, sir.
Let me verify with ChatGPT.
I'm looking for it because I did it
Because-
and I'm looking back for it now.
No,
Oh,
I think it's Q. It looking like it's Q. From all the diagrams you see it looking like Q.
I feel like It kind of, because when I do this, it was actually P, but I don't know.
Let me see.
Probably ask for a different thing.
Diagram,
Ask
the diagram will
Claude.
be different.
It is Q. It is Q. It is Q.
Okay, I'm
It
now
is
going
Q.
to tell you. So
It is Q.
in 2015, May, June, it was a repeat. So P was a carbon rod, Q was the electrolyte, R was the cathode, and S was a depolarizer.
Cool.
Yeah. So
So
the
it's,
answer
And the
is
funny thing
Q.
was,
Right?
here's
oh,
the
so it's
greatest
Q.
thing.
Yeah, it's
Yeah,
Q.
but the funny thing is, when it repeats in 2015, it repeats for the exact same question, same 42.
That's crazy.
I don't think we're gonna get this on the chat. This was years ago. They didn't bring this in a while.
This is a manganese. This is manganese dioxide. That's what it is.
Oh,
Q, right? The electrolyte is the base layer. This is the base layer and this is the electrolyte.
Thanks to physics, we gain a bit of chemistry and physics. And chemistry now.
R is the zinc container.
I used this yesterday.
And S is the carbon rod. Yeah.
Yeah, we
So
mightn't see this.
mightn't see it, but here what is a good thing we know what it is now. And it's a good
Yeah.
thing that we correct ourselves. So P is not the correct answer. The answer is Q. Q is
it's
the
Q.
electrolyte.
Everybody lock it in, guys. Lock it in.
Lock it
Q.
in.
So, sir, they wouldn't bring this question.
Well, what do we call this?
We'll go out by the electrolyte.
Right, the
Electrolyte.
electrolyte. Good. That's the electrolyte. Right.
44.
What do you call this?
The electrode.
The electrode.
Electrode.
Carbon rod. Cool, let's move on. What is the answer for this one?
A.
Yeah,
Nah, it
No,
was
it's C,
actually
C.
C.
They change the position.
Yeah, they
So you
change
see,
position.
what I was talking about, sir? They bring out questions
Numbers
like
have
this, but it was 1.5 instead.
Yeah.
Well, this show is
number.
I think it's D looking like.
Nah, when you do it, it was C.
Let me see. NI sin I is equal to NR sin R. It's eliminated leaving A and entering glass. So this is one.
Sin C.
I don't know what. No sin C.
Sorry, my bad.
We know that the refractive index of glass is 1.6, so go enter glass. And that will be sine 27. So this one is sneaky. Sin I is gonna be 1.6 sine 27. What was so different about the last one, boy?
Yeah.
So it was different numbers, I think, and
It
they
was
gave
different numbers.
they gave you the angle of incidence.
Yeah, different. You have to divide.
Yeah, they gave the refraction index.
Yeah, the refractive index.
Well, best of just do the work in any exam though. Best of just do the work in any exam.
Yeah, for real.
That would
So the main thing is NI sin R is equal to NR sin R.
And let me explain this. It's leaving air. So the incident ray would have been in air. So Ni is gonna be equal to what?
The sin I.
Yeah, sin I.
No. Where's your refractive index right here, guys?
1.
Oh, 1.
And it entering glass. So if it entering glass, the refracted ray, the refractive index for that would be 1.6. So NR is 1.6. They're giving you the angular refraction here. So R is 27 degrees. And the way to find sine of the angle of incidence. So here we're gonna plug everything in. So we know it was an air. So Ni is 1. So 1 sin I. I don't know what my angular incidence is. So I'm going to find that. What is an R?
1.6.
Yeah, 1.6.
1.6, right? The angular refraction is
Sin 27.
Sin 27.
right. So we end up with 1.6 sine 27. That's the answer. 44C. And they wanted me to find sine of the angle of incidence, which is a sine I. 1.6 sine 27. Are you okay with that?
Yes, sir.
Cool. Remember that, right?
Yes, sir.
In domestic insulation systems, which of the following components should be placed in the live wire?
1, 2, and 3.
Yeah, all 3.
You should
Okay.
place switches. You should put a circuit breaker, and you should put fuses. Yeah. Right. I just hardly see these types of questions in the syllabus.
So how a circuit breakers look like, sir?
Mister, you never see a circuit breaker?
I feel like if I see it, I would know, but I've never seen it in a long time.
I will show you. I sure you see a circuit breaker before, man.
Yeah. I just can't remember how it look. Yeah, I know them thing. Yeah. Yeah.
Right,
So
which of the
that
following
that
circuits
is the thing
electrically?
that has been the meter box for your house.
Yeah.
What's the answer?
C.
C, right? Because this is our kind of circuit, series or parallel?
Series.
Series. So we're looking for another series circuit. This is our series circuit here, 46C. When a large current passes through a fuse, the wire go out to get what first?
Hot.
Hot.
It'll get hot first, then it go what?
Melt.
And it will cut off and
No, it will melt first.
No, you gotta melt first.
Yeah, it go melt.
Melt and then cut off.
Hot off. I mean, melt then cut off. Yeah.
Gosh, man. Are they want to call it tonight after this paper?
No.
No?
Nah, so we had to do one more, sir.
So we had to do one more, sir.
Yeah, I agree.
Alright, so the wire get hot, the wire melt, and the current is cut off. So we're looking at the answer.
B, sir. Bat.
Right? Wire gets hot, wire melts, current is cut off. Cool, let me keep it pushing. Which of the following graph represents the current through R? Let me analyze this carefully. So, Ole, we have a battery here. Our battery, will the direction of current ever change in our battery?
No.
No.
No, sir.
So, this is going to be a purely DC wave.
Yes, sir.
Yes,
Direct
sir.
current.
The answer is C.
C. 49
I
is
would not.
1.2.
This over here, this is from a full wave rectifier.
So what does it look like?
It look like, yeah,
110.
it's a full wave rectifier. This over here is for a half wave rectifier. Right? This over here is just a battery. It's a battery. Because it's like as time passes by, the current remaining the same. Have you seen that?
Yes, sir.
Yes, sir.
So over here the current is 0. If the current is 0, is anything? Do we even have power?
Nope.
No.
Yes, sir.
Right? Good. I hope you understand that.
Yes, sir.
This is a battery. This is a battery. A battery is a DC waveform. DC waveform, right? Cool. What's the answer for this one? Is that repeats?
1.2.
1.2.
Obviously, because the larger current go past through the smaller resistor, so less current go past through the bigger resistor. The only answer smaller than 1.8 is 1.2. 50. Where will it light up? Light up, light up. Sketchers.
I like
your
Skechers. You like me, my Gucci shoes.
Too much energy, bro.
Light up my world. It's 51. 51 is what?
C, sir. C.
C.
Easily magnetized. Iron is easily magnetized. Steel retains its magnetism well. Right. 52.
Magnetic relay.
Really.
Easy. Light work, bro. Light work. Which of the following will be positive? I repeat again.
1 and 3. 1 and 3. 1 and 3.
1 and 3.
1 and 3. Remember, if it's an isotope, the atomic number can remain the same. So you see this number over here, it must be the same.
Yes, sir.
Must remain the same because it has the same number of protons. If you realize, like, these are the only things changing, but like these are remaining constant. Alright, so 1 and 3. Which answer for this one?
Beta particle.
Yeah, beta.
Beta.
Let's see, all right, 0 minus 1, 7 minus 1 is 6, 6, 7.
Hey, where the
Right,
numbers
so
coming
how
from?
to be a beta particle, right? How to be a beta particle? How to be a beta particle? Everybody okay with that?
Yes, sir.
Yeah.
All right, cool. J.J. Thomson discovered the electron. Which of the following physicists discovered the neutron?
Chadwick.
Chadwick.
Let me just verify that. Chadwick.
I sure about that.
Just want to verify it. I really don't want to go into the exam, put in wrong answers. I would hate that. That would not be how you say good in Spanish?
Bueno.
Bueno, yeah,
Muy
bueno.
buen.
All right. All right. In 1932, Chadwick bombarded beryllium with alpha particles and discovered a neutral particle with a mass similar to that of a proton. This particle was named the neutron. Yay!
Yay!
Right.
Good
So
job, Chad.
just in case they do anything sus, right? Thomson, he come with he electron, right? Rutherford,
Gold foil.
nucleus. Right. Bohr, energy levels.
I didn't even know that.
And Chadwick, neutron.
So question. What is
Yeah.
called this thing? The plum pudding model or something? What is that?
That's like, okay, at that point in time, they believe like our atom was just like it was just like this big sphere with positive and negatives in it. Let me see if I can share a
Oh.
diagram fast. Who come up with that, boy? What's his name again?
I think it was Bohr self,
JJ.
matter.
That was JJ Thomson. That was JJ
Oh.
Thomson.
Oh,
Yeah.
yeah, I think so, yeah.
That light up sketch song stuck in my head, boy.
Yeah.
Shawty bad with the sketches on. Wanna hold my hand, make you my girl. Light up my world.
That was COVID era, so.
Yeah, boy.
Watch, this is the plum pudding model. Exactly what I
Oh,
did.
yeah.
Right. 55D. Okay. What is this,
NAND gate,
guys?
NAND.
It's an AND gate. Right, an AND gate.
We gotta read 57 carefully, sir.
57, yes, indeed. In the scattering experiment conducted by Geiger and Marsden, some of the alpha particles were deflected. The explanation for this phenomenon is that the nuclear charge and mass are concentrated in a small volume.
Nah, I
Is
think
what
I
I
gotta
would
go
say.
over. I think I gotta go over that, so I ain't catching it. I ain't catching it.
Okay. So, give me a second, right? Let me show you the goal for the experiment and it will make sense.
Oh, that is a go for experiment.
Yeah.
Oh, I didn't know it as guys done and mace then or something.
Yeah, that's what it is.
Oh,
Yeah. Like I'm pretty sure I'm losing my mind. I'm pretty sure I'm losing my mind. The answer had to be D.
go for
Let me
experiment,
just
yeah.
because like remember, some were deflected.
Mm-hmm.
And like that's because most atoms, okay, number one, most atoms are made up of empty space. And like in the middle of the atom, you have like this dense region of the nucleus. And if you're using alpha particles, right? The alpha particles, watch, look, Kelani, they even talk about alpha particles. And in the whole for the experiment, they fire alpha, they use alpha, it's like alpha decay.
Yeah, they use alpha decay, yeah.
Right, so alpha particles are positive, right?
Mm-hmm.
If the alpha particle come into contact with the nucleus is positively charged, right?
Yeah.
If positive and positive, if I encounter a strong positive okay, if I positive and I encounter a very strongly positive sphere, wouldn't I want to be deflected?
Oh, maybe because it would be too strong.
Remember, like charges repel.
Repel, yeah. Repel.
And the experiment I'm talking about is wait, this one.
Yeah.
Right? Cool. You okay with this, right?
Yeah, I understand. So
Right.
thing repel.
Right, read it. Read this for me.
They perform an experiment known today as the Geiger-Marsden experiment or the gold foil experiment.
All right,
Yeah,
you
so it's
okay with
gold
that?
foil. Yeah, gold foil. Yeah.
Cool.
So the nuclear charge and mass were concentrated volume.
Yep. So nuclear charge and mass are concentrated in a small volume, and that's the nucleus. As a nucleus.
Yeah,
So if
because
an alpha particle went close to the nucleus, it's going to be deflected because like charges would repel, and the
yeah,
alpha particle is positive and the nucleus is positive. Right. 9, 8, 7, 6, 5.
5. That is A.
Answer is 5. Everybody okay with that?
Yes, sir.
Sir.
Right. In the periodic table, the number over here is not your mass number. This is actually an atomic number.
Yes, sir.
All right, that's 50. Let me keep it rolling. 59. The answer is D, right?
D.
D, right? Bam. Which of the
Yeah,
following
you
statements
reacted
concerning an alpha particle are true alpha particle? Alpha particle.
Well, 1 is correct.
2 looking like it's wrong.
Yeah, because it's actually 4 times, so 2 wrong, yeah. Because the alpha have 4 on top, that is the mass, so it's actually 4
Because it's a
times.
helium nucleus in nature. It's a helium nucleus in nature.
Yeah, so 2
Yeah.
wrong.
So it
There's
had
1
to
and
be
3.
1 and 3.
Yeah, 1 and 3, yeah.
Is B.
It has the same sign charge as a proton. Yeah. Because the alpha particle is positively charged. It's positively charged.
Yeah.
So it has twice the charge of a proton. That's correct because if you recall, an alpha particle is 42 Ag, right?
Yes, sir.
So the charge on this, well, a proton, right? A proton would just have a charge of +1, right? What is the charge on this?
4, no.
Nah, not 4, not 4, not 4.
2.
2, yeah.
Yeah, 2.
Because it has how much protons in it?
2.
Right, it has 2 protons. I understand that, right? It has
Yeah.
twice the charge of a proton because an alpha particle literally has how much protons in it?
Well, 2.
2.
It has 2 protons, right?
And proton is just positive 1.
Correct. It has twice the mass of a proton. I wouldn't say so. I wouldn't say so.
No, it's actually
Right?
4 times, sir, because the
4
mass
times.
number is 4, yeah.
Correct. So it actually be 4 times. It has the same sign charge as a proton. Yep, both of them are positively charged. So we're looking at 1 and 3. 6 dB. Everybody okay with that? 6 dB.
Yes, sir. We pumping, we pumping.
Badness, badness, badness. Right? Oh, I never thought anybody on YouTube, so boy. Yeah, you have 235 people on
Yes, sir.
YouTube.
I know. Check 230.
YouTube always have a lot of people on it.
Wait, boy. Okay, tell them what to do. Tell them what to do. Tell them what to do.
All you
Like and subscribe.
I don't know.
The notification bell. Send his YouTube to everybody across the nation. Now you know, we're bringing mad vibes to the world.
Hi, Nikolai, tell them what to do, Nikolai. Nikolai, tell them what to do.
Like and subscribe. Don't just
Alright.
watch the video and not subscribe and like the video.
What you doing? What you doing?
Don't be like some of them influencers and say 99.9% or you're not subscribing. Or you had to be that 99.9% that subscribed.
Correct, correct. Go subscribe. I want to reach 6K earlier. 6K. We can do it. We can do it.
Make it happen. Make it
But
happen.
I feel like we don't need to calculator, you know, sir.
Hey, the funny thing is, right? Or they could use all the calculator for this exam. They can't
But
use
not
it
for
in maths
maths.
exam.
But not
We
for
can't
maths.
use it in, we can't use it in the maths exam though. And you don't even need your calculator in the physics exam. How that make sense?
That's
How
real
that make
easy, though.
sense?
Same thing for chemistry.
Yeah, I literally do like 2 calculations on our chem paper.
You don't even need it to.
Even need it.
That's ridiculous.
They need to put the calculator for the maths, though.
Redonkulous.
Are they ready for Steam?
There we go. Steam.
Action.
Blazing hot.
Someone on the YouTube is asking you to go to question 57.
57.
Yeah.
Hey, boy, I already scroll here, boy.
Thank God it's not
I
6-7.
thought this person just say something else. Like I said, something
Oh.
I thought I hear 6-7.
Plus
Right,
10.
57. Right. So what they're talking about in 57 is just the gold foil experiment, right? Let me explain something. Atoms have electrons in the shells, in the orbitals, and at the center you have a nucleus. Now, in the nucleus, you have protons and you have neutrons. The protons are positively charged, and neutrons have a neutral charge. So what I'm trying to say is, most of your mass for the atom is mainly in the nucleus, and the nucleus will be what charge? The nucleus will be what charge? How? How will the nucleus be charged? I ain't not hearing nobody.
Well, positive, positive.
Positive, because it have a bunch of protons, right? Remember, the neutrons not charged, so just protons there. It just positively charged. It get any charge from the protons. The neutrons do have a charge, so just protons getting charged from. So here what? If you have a alpha particle, if this is positively charged and this alpha particle is positively charged, wouldn't it be deflected?
Yeah,
Because
it
like
repel.
charges, what do like charges do? This positive and this
Repel.
positive. They repel. So that's why it's deflecting. It deflecting because the nuclear charge and the mass are concentrated in a small volume, aka the nucleus of the atom. And in the nucleus of the atom, you have positively charged um, protons and you have neutral neutrons. So the nucleus is positively charged and the alpha particle positively charged. So they will repel each other and they'll deflect. Hope that makes sense. So the answer for 57 was D. Right? The nuclear charge and mass are concentrated in a small volume. Let me speed run. Although we can make it to 2014 now. We can do that.
Sorry, Renisha fall asleep.
She did?
Yes. And I came.
Oh.
Wait. Nah, I was gonna stop sharing spotlight shit, but I cannot evil. I cannot wicked. I don't wanna do that.
Nah, sir.
I don't wicked. I don't wicked.
For us in the class only.
So I can take off the camera or leave it?
Wait. You could leave it.
I don't think I could do that in here.
Wait.
No, well, I don't know.
Says
Yeah.
the GC.
I sent it in the group chat.
But she can't hear us. Can't she hear us?
Wait. You don't sing a song. Let's sing a song.
Twinkle, twinkle,
Little
little star.
How
I
wonder
wonder what you are.
up
Above the world.
Oh, like
Oh, all
a
right.
diamond in the sky.
You're gonna make the girl wake up instead of put you to sleep.
That's the point.
Hush, little baby, don't you cry.
That's
Everything's gonna be alright.
That's
I'm
how
a
y'all be
little
looking
crazy, pretty
my eye
baby,
half
but
open
I
in that
promise
picture.
mama's gonna be alright. And if you ask me to, daddy's gonna buy you a Mockingbird.
I'ma give you the world. I'ma buy diamond ring for you. I'ma sing for you. I'ma do anything to see you smile. I can't remember the lyrics.
Ooh, she could sing, boy.
Fire.
Eminem.
Wait, let me see if I can give out. And that's Mockingbird.
Yeah.
Yeah.
Ellie, I know you miss your mom and I know you miss your dad when I'm gone, but I'm trying to give you the
Answer
left
the
left
answer
ahead.
to that one is C.
I was going off. I can see you sad, even when you smile, even in your left. I can see it in your eyes. You're down. You want to cry. And never mind. Let me look. Let me look. What can you feel, sir?
Akasola. Bada. SMV.
Hey.
SMV.
So, in which of the following pair of points are in phase? Which one in phase, guys?
C.
SMV.
S and T in phase?
SMV.
I want to know what they're talking about. S and V. They are
I
in
said
phase. Watch.
T.
If you're confused, if any of you guys confused, watch. So I have a wave here. I make it over here. I make it back over here. That's what I mean, like in phase.
Wouldn't R and T be the same thing? Or no?
Yeah, R and T would be the same thing. Both of them would be in
Well,
phase.
let me tell you, this was a repeat from 2016 June because I now do it.
This is 2016 June.
Oh, shucks, well, I done halfway through the paper, like nearly done.
Well, that's good. That's good.
So
So
I
the
thought-
answer is S and V, right?
So I thought she was going to go back with the 2006 thing.
Me too, you know.
Me too.
Yeah.
We move on. I did 2005, and then I jumped to the recent years again.
All right. Well, okay, let me look now. Let me look. I want to finish this fast. We just have 2 papers to do after this. Now we do. Hey, how much papers is that, boy?
11.
Hey, wait, boy, everybody. This is why Mark 5 is the best. You know what I
You
mean?
don't know.
Yeah,
Why Mark
so
5 is the best.
that's why they have to like and subscribe and
Oh,
support
just
this.
subscribe now. Subscribe now. Let me get 6K.
All this dedication and now you're not subscribing.
Like,
No.
what is
700 to 6K.
right? To 6K, how much more? Let me check.
So that don't matter, so just go more. Just go more. That don't even matter how much we reach to 6K. We are past that.
We are 34. Wait, no, I do maths wrong there. We are 54 more. 54 more. Alright, let me go. Mass is kg. Acceleration is ms minus 2. What's your answer?
That'll be D. So
D. Bam. SI unit for temperature is
Kelvin.
Kelvin.
Big K Kelvin.
Who does use Fahrenheit, bro? Who does use Fahrenheit?
The Americans. Americans.
America. In carrying out an experiment to locate a real image using a converging lens, the image can be placed what?
Between the focal point and lens.
It could be
And
put at the focal
At the
point as
focal
well.
point as well.
Wait, sir?
I think it's no, not D.
Number 4 is C
Yeah.
because number 1 wrong.
Right. So let me read it back one more time. In carrying out an experiment to locate a real image using a convergent lens. Alright, let me just do a quick sketcheroo. Give me a second. Right, so if I place it between the focal point and the lens, let me see what happens. Oh, did that work out?
No.
Awesome.
No, that's not gonna work out. I'm not gonna end that. Not seeing any intersection there, you know. So no, I wouldn't place it between the focal point and the lens. If I place it at the let me see what happens if I place it at the focal point. Okay, that look like it could work.
Yes, so that will meet eventually.
I feel like it wouldn't meet eventually, but there's one of the rules that says like it would have like an infinitely large
image,
and it would meet at infinity. I don't know if you know what I'm talking about.
Oh yeah, yes, sir.
So I would not say 2. I would not say 2. I wouldn't say that. In the context of this, I wouldn't do that because like if it meets at infinity and if it's gonna be nah, I would not use this one. I would not use this one, right? If you want to see like the like very, very accurate thing, here's like the accurate thing. I did this like on my form 4 class the other day. So like between F and O, there's no image, right? At F, image is infinitely large, image formed at infinity. I technically wouldn't use that, right?
Yeah, no.
Between F and 2F though, our image is formed. So between the focal length and a point at twice the focal length, I would do that.
So it's three only.
Yeah, 3 only. Yeah, check it out, right? If I place it over here, let's see what's gonna happen. Oh, let's see, you know what I see?
Intersection.
Yes, sir.
Cha-ching. Answer is 3.
Yes, sir.
Would you okay with
what
that?
is C only?
Yeah. 3.
Ah, okay.
3. I wouldn't say because you wanna locate a real image using a convergent lens. Let me ask you a question. If you put it over here, will you be able to locate this real image?
No.
No.
If it's formed at infinity, how are you gonna locate infinity? It's my question to you. So the answer is 3. I hope you'll understand that.
Yeah.
Yes, sir.
I place it between F and 2F. Cool. 4. Remember this one. If this come, between the focal point and a point at twice the focal length. So F and 2F. Okay, move on. Keep it rolling. The moment of a force. The answer is C, right?
Yes, sir.
Right, cool. What's the answer for this one?
To the left, to the
X
left.
plus Y to the
Yeah.
To the left, to the left.
I was going to say
Nisha,
that.
boy.
I was saying I was asleep. Right. This I repeat. What's the answer?
L plus 2x. I mean, X plus 2. So
L,
my bad.
L plus X over 2.
Because if I half my force, I would half my extension, right?
Yes, sir.
Yes.
So
Cool. 7B.
Mm-hmm.
What's the
N
answer for
squared
this
is
one?
equal to L squared plus M squared.
Right? So what's the answer?
B.
That be, yeah.
Right? Because N would have to be equal to L squared plus M squared for it to like balance off. Right? Cool. Let's move on. Keep it rolling. The answer for this one is
1 Newton.
1.
E.
A.
right. You can get 18, you can get 9, you can get 2. What's the answer for this one?
Steady speed.
Steady.
I'm a little unsteady. You know that song?
No.
Oh,
Yeah.
yeah. Little unsteady. Oh, little unsteady.
Right. 11. What's the answer for 11? It falling freely towards the ground.
Convert to kinetic energy.
D, because it's in motion.
It's in motion, right? It's in motion and accelerating. So it's going to gain kinetic energy. Two smooth pairs A and B collide head on. Which of the following statements is or are true? The momentum
The
of A
total
is.
momentum.
If you ask me, three is the answer for sure. The total momentum of A and B is the same after the collision as it was before.
Yeah, total momentum before, total momentum after.
That's why I would strongly say that. The momentum of A is the same after a collision as it was before. I wouldn't say that.
Mm-hmm.
Because like one of the balls could stop.
It's
If you
just
understand what
really.
I would say that. I would say that.
So when
Let
I
me
read
just
it, I thought about Newton's the law for every reaction has an equal and opposite reaction. That's what I thought about. So I went with the third one.
yeah, the third one is the only one that makes sense because here what I say. We don't know if the momentum of A gonna be the same after the collision. Maybe it might sort of move slower. Maybe the momentum might be transferred onto the other one. I don't know that. The only one that I do know is true is that the total momentum of A and B is the same after collision as it was before. That's why I know.
It's not the
So,
principle and your
Yeah.
momentum.
right, everybody okay with 3 only?
Yes,
Yes,
sir.
sir.
Yes, sir.
Right. We know how this is going. It's gonna be from O to C. And it's gonna
Square root of
be
A squared
Was it
plus
A?
square root of B squared.
Direction of OC.
D.
the answer.
Oh, it was
D.
D. Yeah,
D.
because it's square root.
Square root, yes. Nikolai, don't get that wrong tomorrow, you know. Don't get that wrong tomorrow.
Nah. I go watch it over.
Alright. The height of a liquid in a vessel is h and its density p. If the atmospheric pressure is x and the acceleration due to gravity is g, what is the pressure on the base? Alright, let me explain this. Imagine I have a liquid over here, right?
Yeah.
And over here you'll have the pressure as a result of there being a fluid there.
Yes,
Yeah.
sir.
And then you would also have the atmospheric pressure pressing down on it too.
Yeah.
Sir.
So the atmospheric pressure is x, and to find this pressure, it's going to be height by rho by gravity. So the total pressure going to be what?
X plus height by so that is C.
C. Yeah, C.
Everybody okay with that, right?
Yes, sir.
Yes, sir.
Because
You
the
use
atmospheric
all these
pressure,
symbols to mix it up.
yeah, the atmospheric pressure is pressing down on the liquid, and you also have the liquid pressing down on the base of the vessel. Shania, you okay with this one?
Yes, sir.
Right, cool. So remember this x plus h rho g. Right, let's move on. This I repeat, what's the answer?
A,
A.
sir.
A.
right? Because if you're going from water to steam, you have to absorb heat. And we talk about this 10 to the power 6 by 10 to the power negative to 10 to the power 4. Right. Absorb.
Is it 600 for 16?
So again?
Oh, never mind, never mind.
All right, let me read three options. A body weighs 60 newtons on Earth. When taken to the moon, the body weighs 10 newtons. Which of the following will be the main reasons for this factor? Let me ask a last question quickly. Where is gravity less? On the moon or on Earth?
Moon.
Honeymoon.
Right.
Would it be just 3?
On the moon there is no atmosphere. Wait, if something has a has a larger mass, I believe the gravity would be stronger. But let me just verify this. Yeah, I
Yes,
don't
sir,
want to tell
because
you.
if it have a larger mass, you told us this stuff, it would take the gravity would be more to actually bring it down.
Correct. So I feel like I know that 2 is correct for sure. I know 2 is correct. The Earth has a larger mass than the moon.
Yeah.
So oh yeah, that's actually the answer. That's actually the answer. Yeah. Yeah. Trust my instinct. Right, so let me explain this. The bigger a planet is, the greater the gravity. What do you think is bigger, the Earth or the moon?
The Earth.
Earth. So the
Yeah.
gravity on Earth would be what?
More.
Heavier.
It'll be larger.
Right, the gravity on Earth will be stronger. So the bigger the size, greater the gravity. Smaller the size, weaker the gravity.
Yes, sir.
But questions like this don't come anymore.
Nah.
Right?
Yeah. And this is in 2015?
16.
2016.
16.
Right. These are repeat. What's the answer?
38.8.
38.8.
Right. Remember this, right? The Earth rotates more slowly than the moon. How we don't know that. On the moon, there is no atmosphere. We don't know that, right? What is a fact is that the Earth has a larger mass than the moon. And if it has a larger mass than the moon, then the moon will have a weaker gravity. All right. Under what conditions may we apply the following gas formula to solve problems?
A is correct. No.
The mass of the gas must be constant.
Yeah.
The units of the product P1 and V1 must be the same as units of the product of P2 and V2. Yeah, that's correct. Units gotta be the
Well,
same.
2 is wrong. Because where they get
P1 and
mercury
P2?
from?
Yeah, two
What?
is wrong.
Where they get
So I
mercury
was-
from P1 and P2 and
So
it's
I
pressure?
think that one needs a little sticker.
Let me
Yeah,
just
for
verify.
real.
I think it's one
Pretty granny, sir.
pretty good.
It should have been the dog. We just pass.
The classic granny way.
Right? The mass always has to remain constant. That's a fact. Where does mercury come from? Where does mercury come from? Right? The units has to be consistent. So I would say 1 and 3. So C.
Yes, sir.
Yes, sir.
Because think about it, when you're doing these gas law questions, units will be different, or it'll be like the same units for like pressure and
Same.
volume.
But the same.
Same thing.
The only change is the temperature.
Temperature are in Kelvin. Who was responsible for arriving at the conclusion that measured amount is a repeat? Was the answer?
Joule.
Joules.
A.
Joules was the man.
Once you see energy.
Energy. And so the African man was like, power! Or something like that. Or like, more power.
More
More
power.
power. Or something.
Wakanda forever.
Which of the
C.
following methods is the most suitable for heating a brass bulb? C, right?
sir.
I repeat.
D.
Place it in boiling water for 10 minutes.
So somebody said D.
Nah. 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 It's C. It's C.
Whoever it is, I catch oil lacking. Walk in.
The energy, this I repeat, doubled.
B.
Right? It would be doubled.
I feel for some doubles, boy.
Doubles. Ah, boy. Yes. This is that was 22. 22.
It's not, eh? If it's only A that falls.
A.
A. All the
Evaporation.
false.
Evaporation can happen at any temperature. Oh, listen, A don't fall asleep.
Yeah.
Nah.
I think so.
We here, we still here.
Okay, good.
Whoever doubt the king.
You know, you see, I had trust. I trust here. You see. Everybody say I was sleeping.
I was meditating.
I sound like sleeping now.
I was hibernating.
Nah, he was just taking some long blinks,
Exactly. Nah, you know the thing. You know the
Right,
code.
23. Most refrigerators are painted white because a white surface is
The
easily
reflector.
Like
The
that.
Easy.
reflector.
No, how does it make any sense? If it's white,
Exactly.
wouldn't it get dirtier faster?
Telling you.
Yes,
Put the
sir.
Jerry on that, sir.
So that should be the dog, sir. That should be the dog one.
How don't make any sense, boy? They're thinking.
Yeah.
What are you talking about, bro? What are you talking about? Right? I would say the answer is B.
Yeah, good reflector to my radiation.
I don't want my fridge to be absorbing heat earlier. I don't want that.
True too.
I don't want that.
Anybody fridge doing that right now?
No.
Right? And
I feel
that's
like
also why wait,
I feel
that's
so
also
that
why most fridges is silver. But I realize most fridges be silver.
Yes,
Yes,
sir.
Yeah.
sir.
Yeah, that's
I could do
why.
it. I could do it a hot box of KFC right now, boy.
Yeah, when you get through, let me know now. 1 o'clock. Wait.
Everybody's
Yeah, one
kind of
o'clock in the
hungry
morning.
right now,
Let
but
me know if you get through now. Don't make me see you on the news getting locked off, eh?
Nah. Hell no.
Wait, eh?
It's 12:13 here.
Something still gonna do with KFC, you know. Send it virtually or something, you know.
You know, I always have all your back. Come on, man.
Big
So we
deal.
going
You
out in
don't know.
2014 for real?
Good looking, sir. Good looking, sir.
You go. Hey, my mouth.
Hungry, sir.
Hey, I swear to God, I whole set of water no for my mouth just now.
You welcome. You
Yeah.
welcome. All
It's
right. What's
finger
the answer
So
for
looking
this?
good.
fucking
B,
B.
sir.
What's the
B,
answer?
B, B,
B.
B.
Up and
Yeah.
out.
That sounds like a soca song or something. Up and up.
Convection.
Up and up. Yeah,
What?
convection.
Convection.
No,
Wait.
conduction.
Whoa.
Let's show.
radiation. All you're not paying
Radiation.
attention.
Radiation.
Let's show.
Radiation.
Ready?
Yeah.
Whoa.
Anything Shania say goes.
Oh, yeah.
Oi, don't start
If it's
that.
a fire, wouldn't the fire radiate the heat in the
Yeah.
atmosphere?
Yes, sir.
You smart enough,
Convection.
sir. I'll take your word for
Convection.
it.
No, like okay, if you had like the fire in like a closed environment, like a closed space, like a dome or something,
Yeah.
yeah, convection.
Who
But like
said
if it's
anything, man?
say that again?
Who said anything, man? This is supposed to be radiation.
Yeah, but I'll catch all back in.
Up and up. Up and up.
Never.
Right? Everybody okay with the answer being
Of
D?
course.
Yes, sir.
Yes, sir.
Radiation,
Yes, sir.
radiation, right? And because the infrared rays from like, the heat, from the fire, radiation, right? Think about it. Think about
Yes,
it.
sir.
I had to change the black question. Bad boy. Eh, sir. Eh.
Yeah.
Yeah.
Right.
Black.
Metal. Paint the black.
My skin color.
You know, if there's something else, then I'll question you, you know.
Right, 28. Let's 28.
You don't know, you don't. That what we talk
Unknown.
about.
Proper.
Unknown. You
Unknown.
don't know.
And we
Unknown.
doing it proper.
You don't know.
20
20 hertz or 20 kilohertz.
20 kilohertz. I remember mentioned this earlier.
Load up the matic and
Why
knock it
using
and
my
crack it
brain,
on
boy?
So
there.
which one is the dog? Was it D? If it had been the dog?
Nah, the dog is 65 to 45,000.
Ah.
Yeah.
Like 40 amplitude is 4.
Wait, so who is these set of people, boy?
I don't know, boy.
Amplitude is 4.
Abuse 4.
Oh.
8 divided by 2.
Oh, bam.
Run it.
Food.
Physics
Yes,
something.
A.
Repeats galore.
We are not Homelander. This don't make any sense. Right? Alright, cool. Okay. Newish kind of question.
Whoa.
From the diagram.
Slow down.
It can be easy. From the diagram above, the refractive index of glass can be determined from the ratio. Alright, so we are going from air to glass. Right? Remember, the angle of incidence is always measured with respect to the incident ray and the
Refracted ray.
No, the normal or the normal.
Sorry.
Oh. So I thought it was the corresponding angle.
Nah. This is the incident, and these are refracted. The angular refraction is measured with respect to the what?
The normal.
Normal, yes.
Yeah.
So here what? I can use Ni sin I is equal to Nr sin R.
So what was the I about, sir?
Eh?
Next to the M. What was that for?
This is a tie up. Because they know for a fact someone only gonna use this.
Ah.
But it's always with respect to the normal. So here what? We're going from air to glass, right? Air to glass. If it's air to glass, then your refractive index at A. The incident ray will be in A, so that's gonna be 1.
1.
The angular incidence is M.
Yeah.
We go into glass. We're actually trying to find the refractive index at glass, which is NR. We don't know what that is. Leave that blank. And then it's gonna be sin R. What's the angular refraction?
N.
N, right?
N.
So you end up with sin M is equal to NR sin N. So to find for NR, we could do
Divide sin M.
Divide, sir.
so what's the answer?
Sin M is equals over sin N.
Yeah. What option is that, boy?
That
It'll
was
be option
easy.
B.
Option
Easy. I tell you it wasn't hard. We went from A to glass.
Sir,
Right?
the reason why it looked difficult is the amount of stuff they had in the graph.
I bet it is
Yes.
not uncle.
I bet you. But if it does come, we have it. We have it unlocked.
Yes, sir.
Remember, sin M over sin N. Sin M over sin N. Sin M over sin. Alright, wait. Give me a second. Alright. Come, guys. Sin M over sin N. Sin M over sin N. Sin M over sin N.
Look it in.
So them aliens look weird, sir.
Eh?
Them aliens look weird.
I find you looking like one of them aliens, right? Low-key.
I swear I was now going and say that. I was just about to say that.
He take on the hoodie.
That's mean. That's mean.
Because the funny thing is, Sir tell him this last time.
Yeah, I remember that. Saturday.
I look, you forget about that.
Ole, come, let me go.
Let's
Sin
go.
M over sin N. Sin M over sin N. Right.
MN.
Look at in.
Right. The focal length of the lens is. Alright, so the focal length is where the lens is going to converge. So after it passed through the lens, where did they converge to, chat?
65.
60.5.
You gotta be careful, you gotta be more careful.
65.
Yeah, that was 65. I just say.
Yeah, 65. That is
Wait, I tired, boy.
No, you gotta be real careful, Very, very careful.
Yes, sir.
Very, very careful.
Very.
Very sticky here. This is not actually 65,
Huh?
That's not actually 65.
Excuse
me.
And it'll be 60.
No, it's gonna be 50 minus 65.
Well, yeah, I guess.
What's he done now, boy?
The answer is A.
But
Well, let me explain. Let me explain why, though. Let me explain why.
Sir, I do it the long way.
What long way? What long way?
50, the 50 minus 30, so you get the distance, which was 20. Then 110 minus 50, you get 60. And then you just use the formula, and you'll get back the 15.
What?
Excuse me?
Why you doing that to yourself?
Excuse me, bro.
Ole, it don't have to be hard.
So it didn't take long. Trust me, I do it in my calculator.
Excuse
Ole,
me.
it don't have to be hard, Nikolai. Talk to me.
Is it because it's at the 50 while we minus in it?
Yes, because, okay, Nikolai, enter your custom with questions. Okay, let me show you what you are custom with, right? Enter your custom with, like, here being 0. Wait, let me show you.
Yeah. Yes, sir.
Oh, I understand now.
All the questions we just do, the optical center is usually treated as 0. So like this could be 0, this could be 1, this could be 1. However, when you look at this question, 0 is over here.
Oh, yes, I see. Also.
If you want to find the actual distance, it's going to be from 50 to 65, which is just 15. Or like 15. Are they okay with
Oh,
that?
so also is the distance from the lens, sir?
Yeah.
Yeah, because it's not 0, it's 50.
That makes sense.
Oh. So
So-
65 minus 50.
Yeah.
So just out of topic, right? You should really start up a shop with your merch. So, like get them cups with Mac vibes, get them t-shirts, some
Get the
jackets.
hoodies, yes,
Yeah.
those sticks.
I want to get one with Fat Man Bob, like Fat Man Bob. You know what I mean?
Yes,
So,
sir.
Wait
so
And
while
until
you
after
doing,
my
so while
exams,
you
we go
doing,
work on some logos.
like
For
seriously,
sure.
while you doing your teaching, somebody or your family members could be selling all them merches. So it's like
I don't trust that. I don't trust that. I don't trust that.
Trust you, don't
So I go
trust your
selling
family.
which
I talk
Yeah.
about your family members, not some outsider,
I don't trust that.
so I go
Anyway,
selling which, sir.
right. So I hope all you understand this. Like, if you
Yes.
want to find the actual distance, like, okay, typically, you are accustomed with, like, this being 0, and then, like, it counting the same on either side. But if you wanted to find the actual distance, you would treat this as 0, but it's really 50 here, and to find the difference, it will be 15. So, as you can see, it converged 15 centimeters away from the optical center. So that is the focal length. The focal length is 15. Remember that, right?
Yes, sir.
Yes, sir.
And not
Yes, sir.
65.
Yeah.
I know how to see real new questions. I didn't expect some way.
And like, let me explain something now, blow all your mind too. Check this out, right? Check this out. Check this out. If this is 15 here, then 15 minus 50 is what? What's 15 minus 15?
35.
35. 35 will be over here.
Yes, sir.
So
Yeah.
I place the object between F and what?
The focal point. I mean the optical center.
No, this is the optical center over here.
F and
This is the
2F.
focal. Yeah, F and 2F.
Right.
And if I place the
Ah.
object between F and 2F, let me see what happens. If I play it, what's the answer? Right, between F and 2F, watch.
It will
Image is
converge.
larger than the object. Image is larger than the object. Tell me that's what you see in here. Tell you see that?
So I see it
Yeah.
also. Yeah.
It's essentially the same thing. Watch. It's like the same thing. Yeah. Physics. Physics vibe. There we go. But the answer is 15. I know they was going to put 65 and move on. I know they was going to do that. I know they was going to do that.
So I
But that's
didn't
wrong.
thought of minusing the 50 from the 65 because as usual we would assume it was 0.
Yeah, but nah, it's not. It's 50 over there. Right? What's the answer for this one?
A.
Yeah.
Roy G.
It
Biv.
has to be Roy G. Biv. Has to be Roy G. Biv. Has to split and give you a Roy G. Biv. This is wrong. You're not splitting. So supposed to split in the middle. Right?
Split in the middle.
That's in your side also.
This is wrong.
Big
Because
thing.
where's VibG or what?
Utter nonsense.
You're
Utter
laughing.
nonsense.
And 36. What's the answer for 36?
C.
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 Really?
36, right? It's
Yes.
laterally displaced.
Yeah.
37. Points PQ on are in phase. That's a lie.
No.
Points
That's
S and
a
T are
repeat.
out of phase. That's true.
Yeah.
The wavelength of the wave is theta r. That's true.
So it's 2 and 3.
2 and 3.
D.
1, 3.
So
Right.
you're not doing that D thing, right?
Right.
Nah,
In
boy,
which
cause
in which of the following would a change be detected if sounds of different frequencies? Right, different frequencies.
pitch.
Pitch.
Yeah, pitch.
What's timber?
Timber, I don't know.
I think that's our music thing.
And timber is not wood or something.
No, that
I was thinking of the same thing too.
they R-E. I think that's our music thing, you know.
No, but
Yeah,
and it's called like long.
When the
Wait,
tree
wait.
fall,
Yeah, when they
when
cut
the
down
tree
a
It does
tree.
have a
fall,
word
When
called timber.
when they hack down the tree,
No,
go
but
ahead.
and just call it Shiver me timbers.
That is crossing.
Look, we're playing up,
Timber.
we're playing up. Let me move on.
Come, let me roll.
Magnetic induction. What's the answer for magnetic
The
induction?
iron nails.
Iron nails, you don't know it, then. Big up yourself.
Right, what's the answer for this one? Shortest way.
Gamma.
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 Ah,
What's the answer for 41?
C.
E.
C.
Remember, I had to go from north. It's gonna create
I
a, it's gonna
realize.
a North
Induce.
Pole, so C.
Yeah, and just remember the iron nails. The iron nails are one nice answer on time.
right 41C, right? Because this is magnetic induction. You're gonna induce a north pole here, so north to south.
Yes, sir.
Right. This answer is D.
D.
Right?
Yep.
It's D.
D.
Clockwise.
So now I finish paper, yes, Shana?
All right,
If
let me keep it rolling. Let me keep it rolling. Shania, go finish it with us, right?
What is 40?
Shania, what was the answer for X? X again,
Resistor.
like what?
Resistor.
A resistor? No.
Nah. I saw solenoid, sir.
Diode.
Diode.
So you know,
What?
so you know, I guess that just now, but I doubt
What is
myself just now.
John?
A
Hold
diode?
on. Let me explain, right? As you can see, we have our alternating waveform over here, AC. AC. If it is AC, right? Remember, our AC waveform does typically look like this. Watch.
Oh, yeah. Understood.
Oh.
Understood.
But when you put a diode, it
It'll
will only
convert
conduct in one of the positive or the, like it. Let me just say it only conduct in any positive cycle, right? So here what I was saying. Over here is positive, then it changed direction to negative. Let me just say that in a positive cycle, it was, I just can't put the positive half cycle as green, right? And the negative half cycle, we call that pink.
So isn't this half-wave rectification?
Yeah. Oliver, watch this, right? Stay with me. In the positive half cycle, anything going through the diode?
Yeah.
Yes, sir.
Yeah, but when you then direction of the current change, it can't go through.
No.
So, you know what happened? Every time we go to the negative half cycle, we cut that off. So it's just this. Everybody okay with that?
Yes, sir.
yes, sir.
Diode. A resistor, it wouldn't change anything. It will look the same. A solenoid, you have like some peak regions. A solenoid is like, okay, not really like do unit 2 physics, you understand what solenoid is do, hopefully. A solenoid is an inductor. And what solenoid is do is like it is store energy in a magnetic field. And when you like collapse the circuit, that energy that's stored is like released as a spike. A transformer, well, you know what a transformer does do. It's not
I don't think solenoid in our syllabus.
nah. But a solenoid, what do you know about solenoids? You just use a solenoid to make an electromagnet.
Yeah, we learned about solenoids.
Like a solenoid is just like a coil of wire, you know, guys. That's all. A coil of wire.
And I think it's like if you increase the amount it seems on the solenoid, it could like increase the strength of the electromagnet or something like that.
It would.
Yeah.
And it would also increase the amount of magnetic energy it could store. It could increase the amount of energy it would store in the magnetic field as an inductor. Alright. Item 44 refers to the following diagrams about 1, 2, and 3. Which of the following diagrams above correctly shows the magnetic fields created? Bro. Alright, 2 permanent magnets. 1 is definitely correct, right?
Yeah, that's okay.
Yes, sir.
Right? Parallel wires carrying equal current in the same direction into the paper.
No, I don't think that's wrong.
Those supposed to have arrows.
If it do have the arrows, would it be wrong?
No, it wouldn't be wrong, but I'm thinking.
I don't think it would be wrong because they tell it going into the paper, so you already know the direction roughly.
You right.
So, wait, no, the third one looking like it wrong.
Not necessarily.
I'd say D correct because it's looking like it going north to south.
So what's the solenoid mean?
The solenoid, okay. You have a coil here. When you supply current through the coil, it's going to generate a magnetic field, it's an electromagnet.
Ah, okay, well then
Yeah.
that's correct then. That correct.
Let me just verify this. None of them looking particularly wrong. But if I had to go, I would say one is like the answer for sure.
Wait, so N is supposed to leave from the north and go to the south?
Yeah.
Oh no, yeah. The
Yeah,
two
all of them
Americans
doing
are.
it.
Yeah, all of
All
them
right, doing it
looking
correctly.
correct. Yeah.
I'm
This
very
is then the answer is probably like D.
I'm gonna verify with Claude.
You understand?
But the safest answer is like A, one only. But none of them looking particularly wrong.
Always one. I mean one correct, but
To answer the question, no, I have not finished the paper. I reached 50 and I stopped because I'm waiting.
Take him a second. Asking
sounds,
Claude.
that sounds like a challenge for saying.
Nobody else tired? I feel
No,
like it's only me
I
tired.
can't be real
Nah,
though.
nah. I tired too though. Don't worry.
Yeah,
I can't be real
the answer
though.
is D. All of them are correct. All of them correct.
Yeah.
All of them correct.
Light up, sketches.
The answer is D.
I like
Right?
Nika Charm. She
You
like
If
like
there's like
me, my Gucci
extra C,
shoes.
I see in
this
our
look,
face.
yeah, this is correct. All are correct.
I
Also,
see
you
her
want
Right?
one
face
tree.
too. Two eyes, a nose,
I
and a
think I'll
mouth.
need sleep.
That's
But
scary,
I
boy.
seen
That
it.
is
I
scary.
seen it,
You
but I
know,
think I'll need sleep.
so you
Oh,
know
they
the
just looking like
robot.
a skeleton. They're looking like a skeleton.
Yeah,
Yeah. So
boy.
you know the
Yes.
robot monkey.
And the robot monkey
Yeah, the
from Toy
robot monkey.
Story.
Like
Yes,
the
Yeah.
it's looking
yeah,
like
that
the
was my
robot.
fancy.
One that is like
That's the
clap
robot.
the
Yeah,
two.
Yeah,
the
the
two
two point.
the two
Yeah,
I don't even know how to
yeah.
spell it.
Yes.
I get any creeps. Kalani, have focus.
Kilani, relax yourself, boy. Relax yourself, boy.
Nah.
Not right now,
Okay,
Kilani.
give me your energy, bro.
Yeah, where Kalani getting all his energy from?
Oh
Are you
yeah, Kilani is still taking them drugs. That way.
Whoa. PG-13 rule.
YouTube,
Yes,
YouTube, we're
that's
not talking about anything
Bro,
bad.
OMG.
look
Kilani,
just
I
like
thought
it? Oh my god.
Kilani.
Oh
Lamau.
my god. Oh
LOL,
But
my
I
god.
think we need
Lamau.
to
Yes,
make it
sir.
smaller and leave it there.
That was definitely purposefully
So,
done,
but
bro.
Kilani, I thought you stopped them thing, boy.
Hey, we talk about these steroids talk already, Nikolai.
Yeah, but I thought you stopped, boy.
What are we
Don't
talking
leave
No.
about?
so much energy now.
All right, let me lock in. Let me lock back in, right? So the answer for 44 is 1, 2, and 3.
2 and
This real,
3.
this real quick.
So, so
All
nobody
right,
can tell me that was a
45.
coincidence.
Soft iron
Tough
core.
iron.
Hey
Buying
boy,
scrap iron, old battery buying.
a fuse B.
A
These are
fuse
two.
B.
That man.
All right. An
Rolling.
amateur has a very low resistance, so it can be placed in series. That's
That
Series.
does not affect the
Mm.
circuit.
Does not affect.
3
right.
amps, 3 amps. For the next one, 3 amps.
3 amps.
3 arms.
Yeah,
Repeat.
3.
Oh my days.
3.
So they try to trick it in. Instead of put 2 zeros, they put 1. Normally it had 3.00 amps.
Same thing.
I
Same thing.
remember. Whatever.
Right, north to south. North to south is correct. North and north is correct. A repel. And
Yeah,
north to south.
that
All looking
correct.
correct.
So it's
1, 2, and
B.
3.
Yes,
Right,
it
Nice,
should
Naya.
because my watch. North to south. If it's north and north, it repel. It repel. They would want to touch each other.
Yeah.
And it's north to south here. Yeah.
Yes, sir.
And let's move on. So 49 was D. Which of the following voltage time graph represents an AC voltage?
D.
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 Yeah, D. Like going positive,
Because
negative, positive, negative.
part of
Positive
the
and
positive.
negative.
What
Yeah,
is
positive and
this?
negative.
What is this?
Utter
Oh, so
madness. Utter madness.
That's
That's
the
the
ocean
doctor's
waves.
signature.
Real.
Real talk, boy.
Brother,
I wonder if that's actually something we'll never know, yes?
brother,
Right? So the answer is D. All the other options are staying above the time axis, suggesting that they are always positive.
DC.
Mm-hmm.
Would
Dog,
they be considered as
if I
DC, sir?
electrical engineer don't know what it is, that means that real madness, boy.
So would they be considered as a DC?
Yeah, all of these are technically direct current.
Yes, sir. All right. Definitely
Technically,
D. Definitely not C. B. Looking like B.
Yeah, B, Batman.
Yeah, B.
B.
Sometimes I just like ask myself, what should I just do a degree in maths? You know what I mean? But I do like
Nah,
electrical
so
engineering just
so I would tell you, sir, don't have any regrets because your regrets is what led you to where it is today.
I suppose.
So I mean,
Sir,
illogical
I feel like
engineering
I
can
tripping,
define
but
us.
why not? Sir, I feel like I tripping, but why not E?
Why not A?
Because
Yeah.
the
No problem.
port, the battery.
Oh, maybe because how
Close.
it was far. That's why I was watching it. I was
Look at
like,
that.
why
Because
looking at?
positive to negative, right? Positive to negative. That's how the current is going to flow. When it reaches the diode, it's gonna block it. It's gonna block the flow of current. So will the
Okay.
circuit be complete? Will the circuit be complete?
No.
Sure.
No, but over here, positive to negative. It passes through the diode and it completes the circuit. So it will light up sketches.
Sir. What is D? How we have two positives?
To
No, no.
reactivate Kalani.
Nice chippings. This is the vibes. This is where the vibes coming out. It has a 52.
3142, you don't know. You don't know.
Wow.
I put the durr on it, just I put the durr on it.
Excuse, sir. I feel like at a certain hour, everybody just start to go crazy, sir. Like,
I done going
I don't know.
crazy there.
Rob is my lover. And I
Hey,
don't
hey,
care.
don't go that crazy. Don't go that crazy, please.
PG.
Next thing parents, I influence in insurance, drink all that.
Nah.
We
I
cannot
mean,
mention R Union M.
and
Nangi, sir, Nangi, you don't know.
Nangate.
We are abstaining from our union M, right?
Of course.
All right, cool.
That's
Given that the
impossible.
following truth, hey, you relax yourself. Which one is it?
A and none.
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 Yeah, because I'm seeing this one is none, right?
Yeah.
Is that repeat? What's the answer?
Is
The
it
the nuclear charge and mass are concentrated in a small volume.
D.
Really shabby.
She wake up.
She out like
She
light.
dreaming about physics right now. Kalani, she's sending class, because she's dreaming about physics.
Well, like she
Take a video, take a video,
nice.
take a video, take a video, take a video.
Hey, Venetia.
Take off the camera. Take off the camera.
But sir, this recorded, so we automatic. Oh no, you can't see the faces.
Yeah, we'll be able to see it on YouTube.
All right. So which of the following cannot be deflected by a magnetic field?
Gamma rays.
Gamma.
I feel like Hulk.
Rah.
Which of the following are the definitions of the half-life? The time taken for the activity of any given sample to fall to half its original value. This is correct.
Yeah, correct.
Time taken for half the nuclei present in any nuclei sample to decay.
Yes.
Yeah, correct.
Not 3.
Yeah, not 3.
So 1 and 2.
1 and 2. Yeah.
Let me take your time. You're saying the time taken for half the nuclei present.
Nah, something wrong with that.
It's 1 and 3. Because 2, what happened with it in a scene? Oh, no, it's in half.
I wouldn't. Okay,
Time taken for half the nuclei present in any given sample to decay.
It's not something wrong. It's just
it's not wrong.
It's something partially correct.
All brings us out to tweak. So
Because when I read it back, they say the time taken, they say half of the nuclei, and they say the sample to decay. That's the 3 main points for half-life.
Yeah, half the nuclei to decay. Half nuclei to decay. That is half-life. Right? You're looking for half of something to decay, right? Half of something. Like you're looking for like something to drop. Half its original amount. So 1 and 2. 3, it is half the average. What?
Nah.
Exactly.
No.
Fire go burn them.
Fire go burn them.
Oh.
I can't remember the
How does song relate? So how does song relate to Half-Life now? How does that song relate to Half-Life now?
Just let brother sing, Nikolai. Just let brother sing.
We really going mad in here, boy.
What do you call it? Okay with that? 56A.
Yes, I okay.
Yes, sir. I okay for sure. Once you okay, I okay.
I fully understand. Real good.
I think you're fully gone.
Let me
So
run it.
Nah,
I
sir,
think
wait,
all
just
of
wait,
us
once
gone
sure,
at
sure.
some
Let me
once
run
you
point.
good,
57
once you good,
one
sir, I
time.
good.
Pass through.
So you see the true colors after a certain hour, right?
I see you true
No, let me lock in.
colors.
Let's stop singing
Hey,
and
90 protons and 144 neutrons, you don't know.
right? All right. 56 is 1 and 2, right? The time taken for activity of any given sample to fall to half solution value, that's 1. And the time taken for half the nuclear present in any given sample to decay, 1 and 2.
90
Good.
protons,
So
144
yeah,
neutrons. You
good,
don't
good, good.
know. You don't know.
C.
You
Repeat.
don't know. C for the
90 protons, 144 neutrons.
144. I can't take it anymore.
Tell on you, that's just the point.
So put many waiting rooms there.
I will how to do that just now.
I've been there, done that.
Right. 34 minus 90, 144, bam.
You
So
don't know.
90 protons and 144 neutrons.
144 neutrons.
Which are the following statements describe the nature of 3 types of emissions from radioactive substances?
D.
Alpha radiation is a stream of helium nuclei. That's true. Beta radiation is a stream of electrons. That's true.
Yeah.
Gamma radiation is an electromagnetic radiation, very high frequency. That's true.
So it's D.
Yeah.
So
D.
Correct, mundo.
Muy bueno.
Right, 59. Albert Einstein.
Albert Einstein.
Big up Einstein one time again.
Yeah.
Albert.
And Oppenheimer.
Is it alpha? No.
C.
C. This is
Right, 4-2. Easy.
You don't know. You
It
don't
was
know.
amazing.
no.
Let me move on to the other one. Oh, we nearly finished. Like,
We doing more?
Hey, 2 more papers though. 2 more papers.
No more.
Hey,
Oh,
Renisha, you
God,
don't know.
sir.
Renisha, wake up you.
Renisha, do not check the chat. I repeat.
Don't check the group chat, Renisha. Don't leave the group chat alone.
Are you telling somebody not to do something they can't do it?
I am going to do it.
Well,
That's clear.
let me go.
What are we doing?
Mega
10 to the power
wait,
6.
white hat 10 to cheese wise. Anyways.
No, that don't make no sense.
Is that trap? Is that a scam?
Wait, what you gonna do on the line? You gonna say B and C?
If I were wrong.
Right?
Oh, Lord.
1D. Everybody okay with that? Mega means 10 to the power 6.
Yes, sir. You remember
This is
my
mass
song,
center
guys.
acceleration. Mass will be kg ms minus 2 d.
ID.
You don't know.
D.
The base unit of temperature.
Kelvin, big K.
Which of the following is fundamental?
Mass and length and time and current.
Yeah, 2 and 3.
So I feel like I call that I didn't.
Alright, no problem. Take care.
Yeah.
Like that depends.
You can fall asleep on the Zoom. What's the answer?
The mass. No. Length. You don't know.
Pendulum.
Right. What's the answer for this one?
Just now, SI.
All right.
Temperature.
Temperature. Kelvin.
What?
I was thinking.
Oh, yeah.
Well,
What?
I guess.
Waiter. Which of
No.
the following quantities is defined in terms of SI units?
Charge.
So here what, right? Here what? Read this carefully. They're saying SI units.
It has to be derived.
Units. Oh, yeah, units is what? Singular or plural?
Plural.
Right. So my charge Q is
Q equal IT.
Yeah.
IT.
That is amperes by time seconds. Real sneaky, no? Real sneaky, boy.
Is a trap.
Whoa.
That is a real trap. It's
Please
SI because if you realize current is a SI unit, length is a SI unit, temperature is a SI unit, but only one is SI units. Charge.
So I feel we take the time instead of just rushing through because apparently rushing through and fixing it.
Next one is a repeat though, right? A.
Yeah, A.
A.
Pretty sick. Are they okay with this one though?
Yes.
Good.
So I thought when I say SI units. So when I saw
because not only that current is just amperes, length is just meters, and time is just second. You can't really get those.
Also, what's I trying to say, guys, is by the process of elimination, all of them is just 1 unit, so it had to be charged. I don't know.
Right. All right. Which of the following measurements has 3 significant figures?
E.
1, 2, 3, bam.
A for the apple and B for the bat.
Nah, yo,
D.
Kalani, what's going
don't,
on?
Don't consider this one,
don't,
Kelani.
don't,
Don't
don't,
consider
hey,
this one.
hey, hey. Don't finish that. Do not finish that. Do not finish that.
Moment of a force.
Tell meter is the unit
Is it
used
D?
to measure
Renisha?
Yeah,
moment
that
of
Up.
force.
Renisha,
Yeah.
just watch back the live. Just watch back the live. You know how to fight a
No,
piss out to
no,
do
no,
this.
no, 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 no. I'm not giving up. No.
1
A.
Newton, so 1 Newton,
You
1
give
Newton.
up
Yeah,
long
one
time
Newton, one
already. You
Newton.
don't. Hey, we answering
Hey,
questions.
you
You
feel
don't
like
Anyway,
thing
answer
where
it.
you put in your
anyway.
chat, you know. If you know what good for you, you're going to
Steady
stay
speed, steady
quiet.
speed, steady
B.
speed, steady speed, steady speed.
Steady
Steady
speed.
speed B.
So only laughing.
A body moving with a constant acceleration has applied to.
Constant force, and
Oh yeah, taking a long day, but that bad.
Yeah, because the acceleration is constant, that means the force will also be constant.
Proper, Shania, proper.
Yes.
The mass not changing, so the force don't change. Acceleration will remain the same.
Oh yeah, true. Welcome back, Aidan. Welcome back, Aidan.
I changed
Right.
my mind.
I like that. I like that.
talk
Okay,
about
one
two
more
more
paper
bit,
after this.
come on.
No, one more paper after this, and we would
B.
have done. How much years
You
is
see
that
that
boy?
wickedness
Much
don't
years?
do
I don't know.
money? You see that wickedness don't do money? I changed my mind and going back and no blast. Let's see.
You leave your camera on, you know. You leave your camera on.
Yeah, you fall
Hey,
asleep
it's not
anymore.
my fault. My brain was saying no more. Time to take a sleep.
Nah, well,
That's
your brain
okay.
should have
That's
tried to
why
Now
I
take
you're
off
ready
the
sleep.
to work.
camera. Your brain should have tried. Hey, who you think is the first person notice you sleeping?
Yeah, it was no, it
Nigga,
was
like, oh
also it was
god.
somebody else.
But I need group chat now.
That wasn't funny.
Tree only.
Alright, let me lucky. Let me go.
Let me go,
Two
let me go.
sports shares A and
Three
B
only.
correct.
Tree
Three
only,
alone,
sir.
sir.
Tree
Three
only.
alone, sir.
True only.
These are repeat, right? Three only.
Yeah.
Yeah.
What?
Yeah.
Relax on yourself now.
Alright,
So
let me go, let me
this,
go.
this is B.
Hydroelectric power station uses a renewable source of energy X. This energy raises water to the top of a mountain so that it has gravitational potential energy. As the water runs down the mountain, it turns a turbine which converts Y energy into Z energy.
C. Isn't it C?
No, here
Wait,
why?
wait, wait.
Entry paper 2 had this question.
Yes.
Yes, it
But
did.
in
Yes, it
a
did.
diagram form.
Yeah.
Right.
So it was B.
Okay, let's stay with me, right? So, a hydroelectric power station uses a renewable source of energy, X,
Mm-hmm.
and it's a hydroelectric power station. Okay, this energy raises water to the top of a mountain so that it has gravitational potential energy. Okay. As the water runs down the mountain, it turns the turbine, which converts Y. Oh, we know the final thing had to be electrical, right? The final
Yes,
thing
sir.
is electrical.
Yeah,
Now,
electrical.
So, and the turn in the turbine thing, that wouldn't be kinetic.
Mm-hmm. So it's
if
motion.
it's a nine, but it's a hydroelectric power station, I'm gonna ask Claude. Because I find okay, like electric don't make sense. Like the first one don't make sense.
Yeah, the first one definitely, the picture.
What is geothermal?
That is
Geothermal is what?
and that is so
Water.
good, boy. I know it isn't.
I think it's
forget.
energy from water.
Claude having a heart attack.
Oh, not Geo.
Wait, let me reread
Hey,
carefully.
why?
Action,
Wait.
C. No, let me trace the energy chain.
Yeah.
But like, here what messing me up. Here what messing me up. They say in a hydroelectric power station. I looking for something with water in it, you know.
Yeah, so I seen
Yeah.
anything.
Yes, sir.
I
But then,
guess
why would not make sense?
So I was thinking renewable and put solar.
That's why I went
At
with.
first, I
was
thought the same thing.
solar too.
But
I
when I
was
say hydroelectric, hydro means like it could be
Hold on,
water.
I think it was in one of the papers I had done while I was waiting. So I had to look
In
back.
a C. I say in a
Well,
C.
Claude saying B. Claude saying B.
When they
No,
say
but
hydroelectric, it could potentially mean solar power.
it is B, but I can't remember the
Hydroelectric
reason
means
why.
water.
So okay, they're saying that X is solar. So a hydroelectric power station uses a renewable source of energy. So if it's a renewable source of energy,
So
here,
I
let me
have it.
forget. Let me forget about the hydroelectric power station for a bit. It using a renewable source of energy. So maybe it using solar. Okay. This energy raises. Oh, so that energy, the solar, it's going to raise water to the top of the mountain. So what happening is we're using this renewable source of energy to actually raise the water to the top. So maybe we're using that energy for a pump to raise it to bring the water to the top or something like that.
Yeah,
So
so
they
that
use
was basically it because this had something similar had come for the paper too. And I went and I Googled it. And they say because X, even though it was hydro, it would be solar and then Y to Z because it falling would be connected, kinetic, and then convert to electrical.
So but you see how is a trap? Because
This is a
this
trap. This is a trap. This is a
because
trap.
they skip the part where the water would be falling with the potential energy, and they just leave the solar, so they went straight to kinetic after.
Real evil
Trap
boy.
to
So,
me.
Lab question, bro.
So what year is this?
But they ain't bringing this though, so don't worry, guys.
2014. So Nikolai, I'm gonna run it back again, right? So they're using some energy, some renewable energy to raise the water to the top of the mountain. So they're using solar energy, apparently.
Apparently.
As the water runs down the mountain, it would turn the turbine. If it turns the turbine, what kind of energy is that?
It would be kinetic because it's motion.
Right, they're moving, and that would be converted to electrical energy. So we're going with B. But I find I can ask this question.
Yeah, but that
Look
paragraph
into.
where it was stating those kinetic energy changes made no sense.
Real sus question.
The
This is a
paper two
sus question.
question, the paper two question was easier.
Yeah.
Okay, sing the song, sing the song, sing the song.
So say goodbye, goodbye.
Alright, let me look back here. A glass marble X
So
moving
you
with
use the wrong sticker for that question.
No, I use the correct one. Now you continue. Fast. A glass marble X moving with a speed of 6 meters per second collides head-on with an identical stationary glass marble. If it's identical, it's just gonna it's gonna hit the marble, it's gonna stay still, and the other marble gonna go on forth.
Yeah.
Every reaction has an equal and opposite
Also, this
reaction.
is like
Yeah.
kind of like Newton's cradle.
It is Newton's cradle. It is Newton's cradle. But this is a repeat. This is actually a repeat.
You don't know.
In which of the following features is the pressure at a point, density here, depth from the surface here?
Yeah, 1 and 2.
Right, 15C, bam. Which of the following implements are designed to take advantage of a large movement? Claw hammer, yes.
Crowbar.
And a pair of wire cutters, yes.
Yeah.
1, 2, and 4.
So this question is repeated plenty in the old layers.
Wow.
Yeah,
And
for
well,
real.
at some point they remove this one. At some point they remove this.
Yes.
And it was just
Question like that. A
They want
question
to
like
read some
that come
papers,
last
they
year.
remove
Depth of the water.
Question like that come
Depth of
last
the
year.
water.
Depth of the water.
right. A piece of string was the answer.
C.
Repeat.
Less than the weight of the
the
stone.
weight of the stone.
Less than the weight of the stone, right? Less than the weight of the stone. Because the
35 to
thrust
44.
because the upthrust will lift it up. Which of the following following would explain why an ordinary 0 to 110 degrees Celsius laboratory thermometer is not used to measure the human body?
1 and 2.
Yeah, 1 and 2.
Wait, the reading would change when the thermometer is taken from the patient's mouth. Yeah, because like it don't have the constriction. Don't have the constriction.
The wrong answers you're choosing. Okay, my bad.
These are just wrong for sure. It does have the range. It is not sensitive enough to measure small changes in temperature. That's not wrong.
Should be
But a
one.
laboratory thermometer is accurate though.
So it's
accurate.
I think anyone alone.
So it could
Yes,
be
I
one
think
alone, yeah.
I marks my good friend Claude, but I feel like the answer is 1 though. But like, because like a laboratory thermometer is very accurate. I mean, obviously using it in the lab for a reason, right? So I think the answer is 1. Okay, Claude is saying 1 and 2.
I was thinking 1 and 2 because a clinical thermometer is actually maintain whatever temperature.
Well, that's for sure because clinical thermometer have a constriction. That's and yeah, 2 would work as well because it like okay, you're gonna have a bunch of small gradations from 0 to 110, so it might be harder to get like a pinpoint accurate reading. So 1 and 2. 19B. 19B. Right? 19B.
Hey, all you need to do, forget to subscribe.
Yes,
Don't forget
like,
to subscribe.
subscribe, turn on those
35.
notifications. We don't want
Yeah.
a red subscribe button.
35 to
Make sure
40.
the bell goes ding-a-ling.
Follow,
Ding-a-ling-a-ling, school
forward
bell
this,
ring.
forward this channel to everybody across the nation who you know. Aunt,
Correct.
uncle, granny, grandfather, father, mother, brother,
Nana
sister,
and everybody.
Share to your ancestors.
your uncle,
Oh,
your
Indian
uncle,
arrival, Indian arrival,
your,
they will just hear they share it to your ancestors.
your brother, uncle, cousin, sister, mother, cousin, brother, sister, uncle.
the
What?
Tell
family
them.
tree at this point.
Nephew, everybody.
Just share
Right.
it to the
Let,
family
let,
tree.
let me continue. Let me continue. Conduction. What's the conduction?
D.
The
D.
on the stove, so on the stove, you don't know.
Right. D. When illuminated, smoke is viewed through a microscope. Small bright specks can be seen moving in a jerky, haphazard manner. These specks are
C.
smoke particles.
That's not. I didn't
Yeah,
read.
because it's
I
actually
didn't.
isn't actually not bright specks, it's actually smoke.
So now I know your thing, girl.
I tired but my brain working.
But
And you do
you
all of these papers.
Nah, I ain't actually doing this one with Ollie.
Okay.
Oh.
The answer is smoke particles. Yeah. Right?
I just like to read.
Yeah, because it okay, if it's smoke particles, it's like in a gas, and they're gonna be moving in like a haphazard manner all over the place.
Mm-hmm.
Right? Yeah, so smoke particles.
Oh
And
yeah.
no, atoms don't make sense. Molecules, no, like
Even with the
particles.
process of elimination, you could guess that.
Yeah.
Yeah.
Because atoms,
Right?
molecules, and light particles are in a fix. They don't move in. They don't move haphazardly.
Correct.
Not only that, if you watch it, none of them giving you bright specks, like bright.
You're not
Oh.
gonna even see an atom. How you gonna see an atom? How you
Yeah, they're
gonna
too
see an
small.
atom?
They're too small. They're too small. Yeah.
How you gonna see a molecule? How you gonna see a light particle? How you gonna see a light particle, Ollie? How you gonna see a light particle? Tell me
You
that.
can't
Tell me that.
even see it.
Is light even a particle?
Nah.
Hold
No.
on though,
No.
hold on. They did say through a microscope, eh?
Let's see it through a microscope
Yeah,
though.
you need an electron microscope or like microscope. Let's forget the name of the other microscope, but you know a regular
telescope.
Nah, no, what? Can't see a telescope. No, you need like a electron microscope or something to see like atom. Even that, like, nah. A regular microscope not gonna cut it. But what I understand, atoms, you can't even see atoms with a microscope. How you gonna see
Mm-hmm.
molecules with a microscope? And light isn't even a particle. Light is EM radiation.
Exactly.
23. Most reflectors are repeat. What's the answer?
Good
B.
reflector of thermal
Good reflector.
radiation.
Right.
B.
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 24B.
B for Bunsen burner. Convection.
Radiation.
No. Radiation.
Why I keep
Radiation.
Wait,
saying
radiation.
convection?
Because we are accustomed saying convection.
But read.
Oh my God, I'm sorry, Shania. I'm sorry. Don't kill me.
A
That's a
flask,
mark you could lose.
a flask contains air under pressure. Some of the air is let out slowly over a period of 10 seconds. When the flask is closed, what happens?
D.
The number of molecules striking the wall will decrease.
Yes, so D.
Yeah.
Okay, if you let out the air, if you let
It
out
would
the air,
have fewer air molecules in the flask.
Yeah, it's
So
true.
it means
Actually.
less molecules striking the wall.
okay,
But wouldn't it be
okay,
B
let's-
though?
I mean,
Because they say
whoa.
over a 10-second period, when the flask was closed, it had all the air molecules. Now you open it and you let air out for 10 seconds. So we're going with seconds, 0 to 10. Now the air is out, so we have less. We close it back. So because we have less, that means the collision gonna be less because it have less air molecules.
Oh, so
that's true.
the time will not affect the volume then.
No, like, okay, the point is, like Shania said, if you let somebody air out, you're gonna have more air molecules or less air molecules.
No, less.
Or
You're
less.
gonna have less air molecules. If you have less air molecules, right, what's gonna happen? So you have
Less
less air
collision
molecules.
because
okay, it under pressure, right? And they have less air molecules now. So like you're gonna have less molecules striking the wall, right?
Say ask Claude this
Oh,
one.
no, I could visualize it now, no.
Yeah, Claude said B as well.
Obviously, if you take out some of the air, well, I mean, D kind of makes sense. It does make sense.
So let me
And
tell you why.
we know particles in our gas does move around and it would collide, but if we're taking it out, that means we have a less mass of the air molecules, and it means because it have less, the collision will also decrease.
That's correct. I want to go over the other options so you understand what the other options wrong. They say the pressure of the air in the flask will have increased. Will it have increased or will it drop?
Nah, decrease.
Because
Decrease.
I let air molecules out, right? If I let air molecules out, it wouldn't increase, it would decrease. Pressure would drop. Think about it. When you want to form a vacuum, and you just like remove all the air particles.
Yeah, but that means
Yes,
the
sir.
volume of the air would decrease as well.
Yeah. So this is wrong. If I remove an air particles, I'm dropping the pressure. B, volume of air in the flask will have decreased. Is a lie. Let me
Yes,
explain
sir.
something. Can the volume of the flask change?
No,
No.
sir.
Assume
No, the
no.
flask is like okay, and this flask is a glass.
Yeah.
Yes, sir.
Yeah, the amount of volume, the volume the air is occupying is not going to change. So that's a lie. Because like the flask is like a fixed bottle kind of thing, right? The temperature in the flask will have increased. No,
That one just didn't make sense.
still makes sense, right? Yeah. So 26D. All right, then move on. The
See,
answer
oh
is
my God, our favorite question.
love that question.
Yeah,
And then we have this one,
what is a pot conductor of heat?
A.
A.
longitudinal waves.
A.
Sound and
Yeah, one only.
radio. No?
No,
Radio is
One in
transverse.
Oh yeah, radio is transverse. Yeah, my bad, my bad.
all of the both of these are transfers.
Yeah.
Oh,
These
one
are
and a
Some
half.
people might
One and a half.
accidentally put water though.
31 is 4 as well.
Big up
30
Simon,
is
boy.
1.5, right?
Yeah.
Yeah, one and a
Yeah.
half.
Because
Oh,
from here to here is one wavelength, and here to here is a half a wavelength.
4 for the second one.
Yeah.
Right? 4 for the other one.
So
Speed.
Um,
speed.
the
Whoa.
figure above shows the profile of a water wave using the same scale, which diagram below represents a wave twice the frequency and half the amplitude in the same tank of water. So I'm asking that
I
question.
think it's A.
Yeah, A.
You didn't even see the other options.
Wait, take all the time. I don't think
It's
it'd be.
twice. It's
Guys,
not
if this is
half.
twice the frequency, then it would be more frequent. It'd be more
Yes,
It's
sir.
frequent.
closer.
look like a look and it could be
Oh.
shorter.
If you're seeing four crests here, we're looking for a diagram with 8 crests,
Yeah,
right?
it can be
And
A
then they're
or
saying
B.
half the amplitude. So like maybe here to
It'll
here
be a
is
little lower.
Yes, it's not A, it's not
B.
B. It's
It's
C.
D. It look like
Oh.
D.
no, it would
Nice
not
D.
be right. It half the amplitude, half the amplitude, half the amplitude.
Is it? No, it can be C. C look
The
like this
D,
is
sir.
right.
D.
Oh, I don't see what going on there. Twice
Let me
the
see. 1, 2,
That
3,
8.
5, 6, 7.
Oh, that's 7.
Okay.
Is
I
either
think
they
I know
drew it
September.
wrong or they gave me no other choice but to
Even if you watch it and you wanna count, D is the one that has the most amount of, like, you could say collisions because it's more coily compared to the rest. And they tell you that the frequency was twice. So even if you wasn't sure about the half, we check in the frequency. D is the only one that actually show more.
Very sus question. Very sus question.
Yeah, really.
So they
Claude
didn't do it
AI fit.
properly. I feel they didn't draw it properly because it's supposed to be 8. They said twice.
Yeah, they did. I'm asked
Another
Claude, but
try.
like I think
But
the answer is I think the answer is
technically, if I think about it, you remember on this booklet they say everything not during the scale. So
Yeah, that is true.
Oh,
There
yeah,
is
yeah, yeah.
mention the things not drawn the skin. And it does put it in bone print too. So you can see.
Mm-hmm.
He didn't drop his sleeper.
Yeah, the answer is D. The answer is D. Yeah, we are correct. We are correct in our reasoning.
Right, right.
Right? Because this is the only one where you're seeing like 2 times the amount of oscillations in the same time period.
And
And
it
as you
shows
can see,
it's half.
digit was halved. This over here is actually half the frequency of this.
Mm-hmm.
Which of the following statements provides a reason why the diffraction of light is not usually observed? The answer is because the wavelength is too small.
Yeah.
For diffraction to
Fun
happen,
fact.
for
Fun
diffraction,
fact.
for diffraction to happen, the width of the slit, it needs to be smaller than the wavelength to happen. Well, like, like the wavelength for light is like really, really small. So you need like a very small slit for to see diffraction. Are you okay with that?
Yes,
So yeah,
sir.
that's
And
why they
so
were
to
to
put, go ahead.
like bend, because like I could visually see it in my head, but I can't really think it too good.
And so to put into perspective how small it actually is roughly 4 by 10 to the power minus 7.
Yeah. We do a question on this like with the bee and the snake. I don't know if I remember that. With the bee and the snake.
Yes,
Yeah, I
sir.
think so.
The one that
With the
had two
rattlesnake
answers.
and the
Yes, sir.
honey. With the rattlesnake and the honeybee, and then I had to calculate wavelength.
Mm-hmm.
And there was like 10 to the power negative 7. Right. On which of the following would the position of an image form? What was the answer?
B.
B.
D, sir. Oh, sorry, my bad. I was
Oh, you get D
so
from by?
nah, like, hey, I know I tweaking it a little.
Right.
B as well. B
Divergent.
as well.
The
Yeah.
region.
The
C.
answer for this C.
C, sir.
From here, you're just going to see repeat.
You
A.
All right.
sure? You sure? You
A.
sure? You
Answer
sure?
is A.
Some repeat.
Okay.
Waves is
Example
short.
38. The answer is D.
D.
They were pretty sure, boy.
Yeah, and I was
Really, so
sleeping.
really,
Well,
so
I
you,
was
you needed
sleeping,
you,
but
need-
I
you needed
still
that
jump out.
you needed that
That
power nap here.
rest was a little,
That power nap was needed.
yes.
What's the answer,
Small.
guys?
Small
A.
amplitude.
Small amplitude.
Was it
A.
quieter, right? Quieter.
I don't know.
40 was the answer.
Gamma.
A.
Gamma rays.
A.
Gamma had the shortest wavelength, right? Which one of the biggest wavelength?
Gamma,
Which one of the biggest wavelength?
gamma,
Which one of the
Radio
gamma.
biggest
waves.
wavelength?
Radio.
Radio waves.
Radio. Right.
She had me
Photographic.
balling.
X-ray.
B.
Photographic film.
You don't know.
42. Which of the following is not one of the ways in which the strength of a magnetic okay, like A.
Oh, there's a nice question. There's a
A.
nice
Is
question.
A. Is A. All the
There's a
rest
nice
is
question.
increasing it.
Yeah.
If you increase any current, you're gonna increase the strength of the magnetic fields around the wire. If you increase the number of turns per unit length, then you're gonna have more instances where it would cut the magnetic flux, so the induced EMF is gonna be higher. And D, placing a soft iron core, that would allow it to channel the magnetic flux and condense it. So like the BC and DR would make increase the strength of the magnetic field. Yeah. Right? 42A. 42A is the only one that don't make sense. Why would you want to increase the resistance of the coil?
That is technically just slowing it down, basically.
No, that's like if you increase the voltage of the coil, you're gonna have a greater voltage drop across the coil. And you might also have greater heat too. That just don't make any sense. And if you increase the resistance of the coil, you're gonna impede the flow of the current. Really don't make sense. Right, 43. Which of the following statements is a true about the image formed by a plane mirror?
It is
It
visual.
is
1
visual.
and 2.
1 and 2 only. 1 and 2 only.
It is not magnified. It's like real life. 1 and 2. Which of the label parts A, B, C, or D in the diagram is correct for the ray X, Y?
I would say
I'm not sure if
B.
you're correct, but
I
I'd
would
put
say
C.
B looking like B is it a B or
No,
C?
draw the normal, sir. Draw the normal on the which part the X
So
is,
draw
and
the
we're gonna
normal, and then I'll know which one I chose.
Wait, D looking wrong because it's just going straight through. That's sus.
yeah.
Mm-hmm.
Dental
Yeah,
looking like
like the same
dental
thing.
looking. That's sus question, boy. That's a sus question
I wasn't sure about this one,
because
So
like
the
B.
but I had put C.
No, but C
Okay,
looking like it's straight though. Watch it.
okay. Let
From
me show you
front.
an easy way to figure this out, right? Wouldn't the normal be like over here?
Yes, sir.
Now, if you're going from glass to air, you would bend away or bend towards.
Bend away.
that way, so
It bend that way, right?
Mm-hmm.
That makes sense. I'll put B. I'll put B.
Yeah, that was saying because C had a straight line already.
Because like we know that if it going from glass to air, it needs to bend away from the normal.
Yes, sir.
Like over here, if you draw the normal, it kind of like in the same.
Yeah, and plus
Yes,
two from
sir.
the X as well, sir. Like if you see it, like if you watch from which part it is, it's looking like it passing through it straight as well.
It's not supposed to pass through straight though.
Yeah, that was saying C, so C wrong.
Yeah, it's not supposed to pass through straight. It's supposed to bend. Yeah. So I would say B. I would say B. It's a sus question.
Yeah, that catch a lot of people.
What do you B?
gamma, gamma, gamma.
Total internal reflection in glass
B,
occurs when you cross the critical
B.
angle.
B.
Right, B.
B.
Right, Glani join back. Right. Which of the following circuit symbols is
B.
a fuse?
B,
B.
Batman.
B.
B. I
An
already
ammeter has a
recognize
very low
it.
resistance, so it can be placed in series. And that's like
Yeah, the big circuit.
Yeah.
which of the following materials is the answer?
Sophion, Sophion.
Top iron.
The answer for this one is
C, C,
B.
C.
C. It retains its magnetism well, and it's easily magnetized.
You don't know Renisha proper.
which of the following shows the magnetic field. You gotta go from
C, 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 C.
see, right? North to south. You go induce some North Pole in the iron.
No. Next one is C again. No.
Yeah, you don't get time for it. Like,
No, I was just saying transformer.
No, that's the next one. Next one.
Steel is not
E.
suitable because it's too difficult to
Difficult to do.
magnetize.
Yeah.
Right?
Yeah.
What
It's not
happened?
even C for the other one.
Yeah, Miss Moore
It's
from
a
Easy.
step up.
Emphasize
Yeah.
step up easy.
Easy.
Step
don't
up,
know, you don't know.
Step up easy.
alternating input.
Right? Cool. And move on.
Yeah, don't fast.
Slip ring.
Right.
Which of the following is true when a magnet is moved relative to a coil? The induced current is in the same direction as the charge causing it. I wouldn't really say that.
That's so incorrect.
Yes, you find something?
Read it again, please.
Founding. Never said it was true.
That's not gonna be sus. I wouldn't say that.
The induced current in this, the induced current is in the same direction. Nah, because you had to think about a transformer.
Not quite. The induced current is in the same direction. No. Like the reason why I would, because it has something called Lenz's law. And Lenz's law says that if you induce a current in a coil, the direction of the, okay. You know how like, you know about inertia, right? You would want to
Yeah.
resist the
Yeah.
motion. Like, so let me explain what I'm trying to say. We gotta look at this before. If I induce a current, I would want to oppose that change in current. So when I induce the current, I would actually want to induce a current such that it produced a magnetic field that would oppose the magnetic field going in. And we're gonna look at this question with the magnet. And if I remember the magnet and the coil, and I said that, when you put any magnet in, if it's a north here, it
Oh
generates
yeah, I
a north
remember
pole
the
here.
little animation.
Oh, yeah.
So that does part one is wrong because it has something called Lenz's law.
So, do we learn that in our curriculum?
I think so.
I don't think so.
But you learn it from me though,
Don't know.
right?
Very true. I remember with telling me the little animation.
Yeah. So like the induced current needs to produce a magnetic flux that opposes the magnetic flux that's coming in. So that part one is wrong. The greater the number of turns of coil, the smaller. That's a lie. It's a lie. It's a
Nope.
lie. If you increase the number of turns, you're gonna have more instances where the magnetic flux gonna cut the coil, and that's gonna increase the EMF. The faster the magnetic moves relative to the coil, yeah, because you're gonna have a greater change in magnetic flux. The stronger the magnetic field, the greater the induced EMF. This is true. So 3 and 4,
3 and 4.
D.
right?
Yes, sir.
Electrical engineering, boy. Badness. So this is wrong because Lenz's law exists. And this would want to resist the change in magnetic field.
So I think you gave us this already, you know. It's just I don't remember.
I did. When you do the crash course, I explained Lenz's law.
Yeah.
So 54 was D, 3 and 4. Remember that. So the faster the magnet moves relative to the coil, induced EMF is going to be greater. The stronger the magnetic field, the greater the induced EMF. Right? 1 and 2 is wrong. Which of the following is true for the relative charges on the neutron, proton, and electron? The neutron is not charged. So this one is wrong.
Yes.
Proton is positively charged and electron is negatively charged. So E. I look here, all right?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Cool. Which element follows 7-3 Li in the periodic table?
So I could say how I get us.
Wait, let me guess. I really like chemistry.
That's why I asked.
Let me see if I can figure this out. So 7, hydrogen, helium, lithium, beryllium. I know it's beryllium.
But trust me, it have a maths way and you don't even need all the chemistry, trust me.
Well, I see in 7 and 3.
Configuration you're talking about?
What? Is it P?
Mm-mm.
No, it's not P. Like we're looking for like
We're
proton.
trying to figure out which element. Mm-hmm.
Like a proton of 4. So like I would say Q. I'd say Q.
Right. Very good, sir. Very good.
Yeah.
Isn't
That's
it
basically it.
the electron configuration?
You could have do that.
So here I figure it out, right? Q, it have an atomic mass of 13. What am I saying, boy? Yeah, it have an
So
atomic mass of 13.
you're correct.
And the neutron number is 9. Remember, the 13 is P plus N. So if I take away N from this, what will remain with?
4.
Nikolai, no, asking Nikolai. If 13 is a proton plus a neutron, and then tell me the neutron number is 9. If I take away 9 from this, what would that tell me? What would that tell
9
me?
from
The number
13?
point.
9 from 13, you say?
No, what would it tell me? What would it tell me? Like 9 is a
Oh,
neutron number. If I take away the neutron from this, what I will leave me with?
the protons.
Right. So when I take away 9 from 13, that will leave me with 4. So the amount of protons is 4. Now recall that when you're dealing with the periodic table, it's typically the atomic number here. And so if lithium is here, then after lithium, okay, so if lithium is 3 here, then the one after lithium, which is beryllium, I think beryllium is Be. It should be 4. The atomic number should be 4. And the atomic number is just a proton number. So we're looking for one that has a proton number of 4, which is like Q, right? Because 9 from 13 is 4.
Yes, sir.
I'm sure if I put in the effort in chem, I'll be good in chem again. Because I was good in chem at some point.
Yes,
I
sir.
just lose my interest for it. I really just lose my interest for it completely.
Sir, hey, if you didn't lose your interest, I'd be coming for them crash courses in Canada.
Don't worry.
In
That's why
my
I have
mind, I was now
Cassidy.
saying that.
That's why I have Cassidy. So I have Cassidy. Yeah. I had to give some room for the future generation. Granted, I'm young, and I'm part of the future generation. I'm not old. But Contrary to all the
Absolutely.
beliefs, I'm not a hunk. Like what Aidan was saying, I'm not a hunk.
1 and 3 for
Who
50.
would say that? I never
Look
say
at
that.
you alive, look at you alive.
Hey,
Watch it,
look
watch it,
here.
watch it.
What's your
He wrap up like a little roti.
Oh no.
Wait, but I was trying to my Zoom crash. I think my Zoom crashed earlier.
Like I wrote yes.
With your Zoom.
Wait,
Don't.
my Zoom crash.
Well, you
You
don't think
know,
there's a sign? There's a
So we
sign to
made
stop?
so we made the Zoom.
Wait, where am Aidan? Aidan.
I'm
Aidan.
telling you,
Invisible.
Ian wrap up like a little roti.
Aidan, fun. Let me see you now. Let me see you now, Aidan.
Wanna see?
I don't got my light.
He-
You better don't sleep there, you know. I'm
Renisha,
afraid
you
you're
want to talk?
taking up pictures. I
Take a
know,
picture,
like,
bro. Take a picture.
I'm telling him.
Wait. Don't take out no pictures yet.
He going for the sunglasses.
Why you sticking out your tongue for, boy? What are you doing that for? Why what? Oh my god. Alicia,
Check the group chat though. Check the group chat.
Oh, you know,
So
sir.
you was the first person to send the picture on the group chat. Yes, I
That
saw.
was me. That was me just now.
let me
Sir,
lock back in, or let me lock back in. We still have a paper
Boss.
too.
sir. You know how to say about that? What you don't just do, sir? You
What's
remember
that?
my parents before now, sir? They say when your mouth open, fire is flying.
Right.
Whoa.
They think
Just
I fly,
warning you.
gonna fly in him out.
Just warning you. Just warning you. You know how them old people is how the sayings and sentences be true.
The app like it's starting to give some trouble, guys.
Yeah, that's a
I
sign
thought
as
it was
Renisha
I
say,
thought it was
right?
my
I tell you,
I thought
it's
it was
a
my data.
sign.
Sir, no sign, sir.
Renisha,
Zero.
burn your signs, girl.
Sir, no
It's
sign,
not
sir.
my sign.
Work, work,
So
work, work now, work now, work
say
now.
your
Alright, let me lock
iPad,
it.
your iPad hot sir.
All right, never mind. Don't
We
bother.
back.
Let's continue.
We're so back. We're so back, man.
Guess who's
Alright,
back?
back again.
See,
Shay's
90
back.
protons,
10
144
144
friends.
neutrons.
The
neutrons.
answer is C. 90 protons and 144 neutrons.
What
There
really
you
shot
go.
gets in that sleep, boy? What really shot gets in
Knowledge. Knowledge,
My brain
strength, and
does only
integrity.
work once I take in knowledge and I take a rest and I get back up. My brain does work that
One and
way.
three, one and three, one and three.
1 and 3.
Yeah, 1 and 3.
badness?
Albert Einstein.
Albert
Einstein. Big up
Einstein.
Einstein once again.
Alright, cool. Only one more paper. And how much papers we do, boy? We do 2025
A
all the way
lot.
to 2014.
I lost count.
It's crazy, boy. Hey, this
Yeah, I
is
lost count.
okay,
this is
sir, there's 11. There's 11 past papers we do.
yeah, they include the year we start, so that's 12.
Yeah,
All right.
12.
Oh, no, I want to do this paper in 20 minutes. 20
Wait,
minutes.
sir, you finished the
So
one
you
just
didn't
now?
answer 60?
Sir, you didn't answer the
So
last
you
one?
never answer 60, so
Hey,
you get
so
so
we're
bad.
gonna
But
do.
so you
Boy.
get happy there, you know.
Sir, ready to jump, yes?
So yeah, they're jumping the gun this.
Are they happy? Are they
The,
happy?
the, the,
Don't,
the,
don't,
the,
don't
the,
like all of us can answer that.
Exponentially came.
Don't like all of us didn't know what the answer was, you know what I mean?
Oh my God.
You know, literally, I was sitting down by my desk and I fall asleep. And then I went to my bed and I just call my name and I jump back to life.
A.
Alright,
So
okay.
once you say
20 minutes. What's the answer? Fast, fast, fast.
Yeah.
So A.
A is the answer. 1, 2, 3, 4, 5. 5, yeah? Cool. Alright. 1 gram is equal to?
C.
C,
see.
sir.
D.
Right. 1000 and milli is 10 to the power negative 3, right?
Yes,
Yeah.
So
sir.
Yes, sir.
you have 10 to the power 3 and you have 10 to the power negative 3. That would give you 10 to the power 0, which is 1. 1 gram.
Yeah.
Cool. Let's repeat. What's the answer?
10, 10, 10.
10.
10.
Whoa.
A,
A.
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 A, yeah.
A.
Mass.
A.
Oh.
C.
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 C,
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 sir,
C, C,
yeah.
C. Half MV squared.
Yeah,
P.
MV squared
MV
over
squared
P
over
over 2.
2.
Steady.
Steady
Steady.
speed.
Steady
B.
pace. Well, steady speed.
Just now,
A.
read this one carefully.
A.
You sure?
Yeah.
Oh,
It
yeah,
reads
yeah, yeah,
terminal
it is,
velocity.
yeah.
It reads
Yes, it
terminal
is.
velocity.
Yeah,
You
there's
know
no
about
force.
terminal velocity, Shana?
But you said so?
You know about terminal velocity?
No.
And
Oh.
and there's like the max velocity, sir.
But even if you read it, so the other ones not really making sense.
Okay, terminal velocity is when an object can no longer accelerate. Like it reaches maximum acceleration. Like, okay, it's not accelerating anymore because it reaches maximum velocity.
Big
And it
up
just fall.
for that,
So
bye.
I understand.
So like here what? If it reaches constant speed, is it accelerating?
No.
Nah.
No.
Nah. So there's no net force acting on it. Because I'm gonna show you something. You know F is equal to ma, right?
Yes.
And we know
So
acceleration is equal to F over m. If no net force is acting on it, what is F?
Constant.
F
Constant.
is 0. If no net force, if it's no net force, what I mean? What's the force?
Zero.
0.
So acceleration is 0, and that makes sense because if it's at constant speed, what's the acceleration?
Well,
Zero?
0.
0.
Yeah, I wish I
Because
wasn't so tired, you
it
know.
can't
It make
exceed
real
it.
sense. It make real sense.
So I understand.
Makes sense.
look, look at Devon, son, man.
Oh my.
Oh yeah, because Iran still spotlighted. Oh,
Oh,
oh my days. Oh, it just cracked me up, yes.
First
So
we study in the paper.
if it reaches a constant speed, it's no longer accelerating. So the acceleration due to gravity is now 0. So the force will be 0. 0 over m is 0. Acceleration is 0. Bam. The answer is E.
Yeah.
Net force acting on it. Bam. The answer is E. 10.
E.
Right?
A.
Right. 11. What's the answer?
X
D.
plus 2.
D.
X over 2. X
Yo,
over 2.
D,
I
D,
keep
D.
making
X
a
over 2.
mistake, boy.
L plus X over 2.
Proper,
Right. What's the
Renisha.
answer for
Proper.
this? Momentum.
B, 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 B,
D.
B. It's always
brr,
KGM
brr,
S
brr, brr.
-1.
Right? B. Right. When two
D, D, D,
bodies
D, D,
collide.
D, 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 D.
D.
B.
D.
D.
14.
C. E.
C.
Right.
Work
I
done
can only
over
see the
time.
future or something, or
C.
Potential energy.
What's the answer for this
B,
one?
B, 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 brr, brr, brr. B, B,
B.
B, 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 B,
B.
brr, brr, brr. B, 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 brr, brr, brr.
What's the answer for this one?
B.
D.
Right.
B.
You
The
don't know.
upthrust, the force pushing on the bubble is more than the weight. So it will cause it to rise because it have a net upward force. 17B.
Yes, sir.
You don't know.
Boyle's law. What remain constant?
1 and 4.
Right?
4.
Temperature, mass,
Density is noted.
Density is
And
not
pressure,
it, neither is
inverse.
pressure.
Since pressure inversely proportional to the volume, not constant.
Or we could just write back the
exactly.
formula.
Right?
Yeah.
P1 is P1 V1 is equal to P2 V2. Let me ask you that question. If the volume is changing and you know density is equal to mass over volume, do you think
Yeah.
density is remaining constant?
No.
It's
No.
definitely going to change.
No. Right? So the answer is 1 and 4.
So C.
What's the answer for this
60
one?
over 293 by P.
It's 360 over 293 times P.
Right. We have this one locked into our memory. 360 over 293 by P. What's the answer for this one?
35 to 44.
35 to 44.
35 to 44. This is
But
the
if we
question
talking
that still
Mrs.
keep on
Macbeth, we know which one.
Yeah, we know which
Right.
one.
I figure about that, you know.
The specific heat capacity of a material. We're talking specific.
D, so D.
D, sir, D.
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 1
Change
kg
the
by
temperature
by
of
1
1 kg of a
Right.
material by
In
1
the pressure
Kelvin.
law, which is true.
1 and 2, sir.
1 and
1 and 2.
1 and 2.
yeah, 1 and 2.
3 is
Yeah, 1 and 2.
Pressure is not
irrelevant.
constant.
Pressure is never constant. So we
Because it's
could
the
move
pressure
on.
law. It's the pressure law.
Mm-hmm.
Right? We answer 23.
Dark.
2 and 3. 2 and 3.
Yeah,
2 and 3. When you hear dark, dull surfaces, they're talking about black.
It literally says.
Wow, wow. Look, I did not know that. I did not know that. Thanks for that information. I did not know that.
Convection. You see Shania?
Convection.
Shania, you
No,
see what I'm
this
talking
one is
about?
convection.
That's what I'm
Right.
talking
I
about.
just want to say
Gas.
convection.
Yes.
Gas.
No, Renisha, you're sleeping
27.
and you missed out.
27 degrees,
27.
27 degrees.
27 degrees.
F is equal to V over lambda.
Way, you be blitzing. Yeah, keep that going.
Hey boy, Kilani dread boy. F is
Absorbing the
equal
knowledge right now.
to lambda.
You ain't even no gas for air for we to breathe in here, boy. No, man.
Some of it.
Right, 28.
Which of the following? Oh, sound wave.
Sound
Yeah,
waves.
yeah,
Sound
that's
wave.
C.
Waves.
Waves are what type of waves?
Longitudinal.
Right.
Longitudinal.
29. What's the answer for 29?
2 and 3, sir.
2 and 3, yeah.
You don't know. Q is
Right?
louder than P, but P has a higher pitch.
Yeah, E.
You see in the future way.
I see.
Right?
Yeah, the pathway pan just going straight with we, you know.
Probably.
Nah,
So-
I swear to God, I just know the answer though.
Right. Wave Q is louder. Right? But P have a higher pitch.
Yes, sir.
So the answer is C. Q is louder than P, but P has a higher pitch. I don't know who say A.
Me, I didn't read it. I'm tired.
No, it's Shania. Hey, don't do
I'm
that. Eh?
tired now. Let me be
The
fair, this
answer
is the
is
only mess
the
up
answer
so
is C,
far.
right? Answer is C.
Focus.
Right, C. Everybody okay with that, right? C?
Whoa,
Yes,
what
sir.
is
It was the
B.
20
It
hertz?
was 20 hertz to
Oh,
20,000
yeah,
hertz.
Or sometimes it is for the kilo. So all you
Yeah,
The other
now
one?
I
You
get
gotta
it.
kill it. Whoa.
Whoa,
New
where's this?
thing.
Where's this?
Hey,
New
look,
question.
look,
New
Velma from
question.
Oh
Scooby-Doo.
my
Yeah,
god.
Oh,
the
Lord.
uncanny valley
Don't
done.
insult Velma like that. Don't insult Velma like that.
That
It's
Don't
uncanny valley.
insult Velma like that. This
excuse
looking like some scary, creepy. Like, where the eyes? Why the eyes empty, chat? Why the eyes empty?
And it
No,
just
no,
has
but just
trees and I know
it's
air,
Brand
so
new
it just has
question, but
space.
That's them people and them from the 20s, 1920s.
oh yeah.
With the mullet.
3.75.
It's real easy, boy.
3.75.
Yeah, 3.75.
So they're saying, how far from her is the image of the waves? Oh, I gotta take all the time, right?
Isn't it
Wait,
4.25?
wait, I take all the time. Take all the time. So, here what? She's looking at a plane mirror and is 0.25 meters away from her there. So, like, when she's looking at it over here, you got the flower here, and she gonna be over here. I ain't gonna do all that.
7.75.
I know for sure that's not a lady.
Lydia.
Troy.
OMG.
Is
That's looking like
3.75 plus 4.
Right, so how
Is
far
it?
from her is the image of the vase?
Oh, wait,
So,
no.
so like, here what? If here to here is 4 and here is 0.25, then I
Yeah,
know
the
for a
minus
fact
it.
it's gonna be 3.75, right?
yeah.
That'll be 3.75 here, right? So
Oh, okay.
Gotta add up everything, you will get 7.75.
yeah.
Yeah,
Alright,
7.75.
that makes
Yeah.
sense.
Yeah.
Whoa, I would
See,
get that one wrong for sure.
Telling you.
me too. I would have
I
jumped to
said A,
conclusion.
and then when I rethink it quickly, I was like, it had to be C.
I remember doing this question on our paper.
I'll just need to draw back the lady.
Yeah.
So now I
Right?
look at like old lady, now. I
All
look
there.
at like if the dog had if the dog was standing on 2 feet.
That looking like she went by
So
she
that's a
hairdresser.
magnified image.
I'll
And she
just hating the vision, dog. I'll just
And
hating
she
the vision.
hairdresser.
You?
Like
So
when I
my
had
It's
version,
a issue on justice.
I think we
Hold
should
on, when I
continue with
say
the rest
this,
of the questions.
when I
telling you.
say this, everybody gonna agree. Sir was hating on the lady and saying, oh, she eye dead. But sir, where your eye in the drawing?
Oh, I see what you're talking about.
Hey, you know what they say? An eye for an eye does make the whole world blind.
OMG.
A guy tell me that
Okay,
time.
okay.
Yeah.
I knew.
Right. So
Feeling hot.
So tell your lady move out the way. She blocking the question.
That's how she name.
Hey.
Hey, don't sing no cocotte here. We focusing on physics
23,
here.
where's the answer?
Just no, let's hold on. Which of the following events does not suggest that light travels in straight lines? Yeah,
B,
a
B,
rainbow.
B.
Yeah. Yeah, correct.
B, a rainbow formation in the sky.
You
That is
don't
diffraction.
know.
That is diffraction. That is
Diffraction, yeah, diffraction.
Mm-hmm.
The bending of the wave.
right.
34 is D, sir. D for dog.
D.
Yeah, it's already 340,
Because
and you're just
we're
multiplying
going
by
from hot
10,
to
and you get
The course, we will lose
3400.
energy. We will give out
So
energy.
true.
Exactly.
Badness,
And heat
badness.
is
Yo,
being
we
given
cooking,
out.
we cooking.
Right.
We looking at Shania.
Yes, yes.
So
Wait,
this
sir.
is all the options, yes, sir.
We know what the answer is. The answer is C.
C, yeah,
Yes.
C.
This,
C.
this
It
into
had
the
to
Roy G.
split
No,
Biv
but
in,
sir,
thing.
split into.
no, but sir, C looking like the next one have a straight line though.
Yeah, that's true.
Yeah, that's true.
Well, I don't think any of the other ones correct.
No,
So the AI fit.
No, like you don't have to use Claude AI. Like the answer is literally C. The answer is
Yeah.
literally C.
Have a
sure.
slight bend, but you know.
So,
I know
so
the, I know
you
the
see how
answer is.
B have a two leg up in the air?
I'm missing
Oh,
my
I
Roy
really
G.
sure.
Biv.
Really sure.
Where my Roy G. Biv?
And battle anyway.
Earlier, the answer is clearly C. Like
Yes, sir.
this don't make any sense. That don't make any
Yeah, we know that
sense.
not making
You're
sense.
This not
manipulating.
making any sense, right? No. Just no. This is the only one not making sense as I see.
Yeah,
Alright.
that's the new one that
And
making
it's all
sense.
supposed to split. So it's supposed to split. It's not split in any middle.
It was
So
supposed to
Sir,
split in the middle. Yes.
this is
sir, you
something wrong.
literally set
So we
yourself
taking up
up.
time. I
You
do we
set
say we
yourself
finish
up.
this
Look,
in 20
let me
minutes.
continue. Continue. Right? So
Yeah.
35C. Everybody okay with that? 35C?
Yes,
Yeah.
sir. Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Magnifying
Right.
glass.
And the fine
Yeah,
glass.
Yeah,
magnifying glass.
Because the image getting bigger than the object, right? And we can see that.
Mm-hmm.
See that.
Yeah.
We could see that.
Split in the middle.
All right. If FL is the focal length of the lens and GF is equal to FL, then where should an object be placed so as to produce a virtual
Between
magnified
between
image?
L and G.
D.
Between L and F, sir?
Between L and F.
Because you have to place it between the optical center, which is L, and the principal focus, which would be F for the diagram.
You
Shania, how
answer
you
the
so,
question for
but how
you.
Shania so smart right now, though?
I'm tired. I'm telling you, my brain working.
I feel like Shania went and sleep and come back on.
Probably.
Nah.
I bring us work backwards.
But you don't sleep to go the exam tomorrow. You gotta stay up.
That is actually fun.
That why I do for the paper too.
That's what I was
No,
always
that
looking like.
all they gotta do that for you still.
No.
Yeah.
The test in the
Are
evening.
they going to see for paper one?
Nah, the
Are they
test
not
in the evening,
serious?
Paulus.
Are they not serious? Are they going to see for paper one,
Nah,
guys?
sir, nah. I
Nah.
take my
As soon as
well
so
deserved
done,
We go
you're
rest.
see.
taking my
We go
8
see.
hours rest.
Are they can't be serious? Like if I physics paper one, the
Nah,
easiest.
sir. The
Double
plan is
following
tomorrow.
schedule.
I go into sleep. Then I'll wake up. Get ready in 5 minutes. Go do an exam in 5 minutes.
That press.
5 minutes, you don't know.
So you
Come
say
home.
like
That my last exam, sir. So I hop in on the game one time.
excuse sir.
Yeah.
You saying this physics easier and you have me looking at every tiny thing in the diagram, sir?
This is easy. The answer is D, between L and F.
Nicola,
Yeah, because if they didn't tell you, if they didn't tell you GF is equal to FL, it would have been harder. But when you watch it, you know it had to be between the center and the focus.
Mm-hmm.
Let me explain why, right? Let me explain why. Check this out, right, guys? If I place an object over here, stay with me. Let me cook, right? Let me cook. Right? Oh yeah, we have this. It's really easy. Physics is very easy. And Shania, physics is really easy.
Yes, sir.
Physics is kick. So they're looking like 2.6. So I just gonna do a gosh man, massacre.
No, that looking like 1.6. We get 2.6 wrong.
No, like 0, 2.6.
Oh, I thought this was talking about the blue line, sir. My bad.
Here what I'm gonna do, right? Check this. Stay with me. Stay with me. Let me just say I have a object over there, right? The first rule is gonna pass through the optical center undeviated, yeah?
Yes, sir.
This is gonna make so much sense, eh? After it passes through the optical center, Right, that's what's gonna happen. As it stands right now, is it ever going to converge?
No.
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 If I want it to converge though, what I need to do, I need to extend this backwards. Let me cook, right? Let me cook.
Sir, the floor is yours.
Let's see, I see it?
Yeah.
Yes,
Let's see
sir.
that, right? Let's see that intersection there.
Yes, sir.
Yeah, I see that intersection here. So that'll be real or virtual.
Virtual.
No, virtual, my bad.
That'll be virtual because it's behind the lens, and
That'll be virtual.
it would be real. Okay, which just says virtual, right? And it'll be magnified. Seen as magnified.
So they literally wanted you to draw over the same thing that they placed like right before it.
Right above. Watch, Olivia, like object right here. Like, come on, guys, come on. The answer is between L and F. L and
Even
F.
I couldn't recognize that because look, they put back the same kind of leaf thing.
Because okay, if you had put it between F and G, you would have got intersection over here, in front of the lens. The answer is between L and F, right? Remember that, between L and F. Cool. I'll move on there. A ray of light is the answer. That's the answer. Come on, fast.
Undeviated.
Undeviated. Oh my god.
What's the answer? Tell me, kill on it. Tell me fast.
Negatively charged by gaining electrons, sir.
Right. Badness. Which are the following statements? Everybody sure about this one, right?
Yeah.
Yes, sir.
Yeah.
Right. Which are the following statements what insulators are true?
One
One
correct.
and
It's a lie.
1 and
1 and 4?
Yeah.
An insulator cannot be charged by rubbing. There's a lie. A good insulator retains its charge better than a conductor.
because
Probably say one
conductors
right now.
pass in it. Because conductors letting it flow through.
So if 2 and 3 wrong, so 1 and 4 are the answer.
How to be. Must be. Right? So an insulator, all electrons are bound firmly to that. That's true. There's no more mobile electrons in sight. How to be 1 and 4? How to be 1 and 4, chat?
Yeah, because it didn't give you an option for one only.
I'm gonna verify with Claude, but I think it's 1 and 4. I'm confident of that.
Me too.
3.
Yeah, it's 1 and 4. Claude agreed. It's 1 and 4.
I call on
Yeah,
time.
correct. Bad. Charge can flow through an insulator. Any charge deposited on it stays put. A conductor would allow the charge to redistribute or leak away quickly.
That's what I said.
Badness. So a good insulator retains its charge better than a conductor because a conductor would allow, most conductors are metals, right? And metals have mobile electrons, right? They have mobile electrons and they can move about. All right, 40, 1 and 4. Let's repeat with the answer. I'm fast.
B.
Yeah, B.
What's the answer for 42?
Is it Q?
Q.
Q, right?
So and just say remember the answer itself and not the letter.
Yeah, do that. Q.
Okay.
What's the answer for this one?
Just now, eh?
I want to measure the resistance of a resistor.
Now it's not A.
Looking like C.
Not B.
Yeah, well, let me ask you that question. Do I measure current in parallel?
B.
Do I measure current in parallel?
No.
No.
Do I measure voltage in
No.
series?
No, sir.
No.
This is wrong.
That's wrong.
That wrong.
You sure?
No, that's
Oh, my bad.
No,
my bad,
that's
my bad.
correct.
Because you could
They're
put
wrong.
voltmeter in parallel.
They're wrong.
Right? The voltmeter is measuring the voltage across the resistor, and you're measuring the current through the resistor. So if you have V and you have I, you could find for R. So C. And then again, D would also be wrong because you're not going to measure voltage in series. Right? The answer is it's definitely C. Yeah?
Yes, sir.
Yes, sir.
The refractive index of what, just I repeat, what's the answer?
Sin 90 over sin C.
Sin 90 over sin C, right?
You don't know.
Set up production. Any domestics, I repeat, with the answer.
1, 2, and 3.
1, 2, and 3.
All of the
Partners.
above.
A
The
for
answer
this
is
one.
The
A.
answer is A. Because
Right?
they say P and Q in series and R is parallel, so it have to be P, Q, and then R on the
Renisha, I was someone where you get when you went and sleep, yes?
That's just how my brain does with Gail, and I ain't even drink no coffee.
I find Risha just get up and she's a different person now, boy. Like,
Why I get hot, it melt, and then current cut to size A.
A.
Proper.
A.
alright, the wire gets hot, the wire melts, current is cut off. That makes sense. 48. A semiconductor diode produces half-wave rectification of alternating current. Which of the following statements is true? The current obtained has a constant value, and the current
No.
obtained flows only in one direction. This is true. It doesn't have a constant value because you know what I'm saying? Let me show you what it will look like. Let me show you what it will look like. It will look like
So it's 1 and 2. Because 3 looking like it wrong.
there are periods when no current flows from the source. This is true.
Also,
I'll just
what?
Because watch the graph that Sir drew.
Yeah.
Wait, so the graph was number 3 we was talking about then?
No, the graph is just to explain the thing. Watch. Alright, so
yeah.
Because I tell you half wave rectification.
alright, they tell you.
Makes sense.
Nikolai, let me explain it here, right? So they're saying the current obtained has a constant value. That's a lie. That's a lie. Because Nikolai, does the current remain the same? Does it at the same level?
No.
No, so this is a lie. Number 2, the current obtained flows in one direction. That is true. It remains above the x-axis, so it's going to remain positive.
Yes, sir.
And watch, there are periods when no current flows from the source. Like what happened in here, Nikolai?
Nothing there, sir.
And then in there, so like 2 and 3 is correct. So 40/80. Right?
Yes, sir.
Right, what's the answer for 49?
Magnetic.
Electrostatic.
Electrostatic.
Nikolai, electrostatic. Electrostatic.
Yeah, sir, I gotta look over the past papers.
Good, good. Which of the following statements about alternating current is true?
It is used to transmit electrical energy because of its high frequency.
No.
B.
Oh my god, what was
With
my
B?
brain, boy?
Wait, you read all of that so quick and you get that wrong?
No, I could have swear I had that correct, boy.
Hey, sir, the man was confident, you know. The man was
I was
confident.
real confident.
Yeah,
You
yeah.
know, is he sleep? Is he sleep?
The man was very, very confident. Like, and we know it could be rectified using a semiconductor diode, and we know that.
Yes, yes, literally.
Yes,
We know
sir.
just
You
now.
even draw your semiconductor diode to explain it
Yes.
more.
Right, what's the answer 51?
All.
1, 2, and 3.
All of the above.
North, south.
Nah, it's just
Yeah.
one and
Oh, one and wait.
Oh,
There's
1 and
all
2 and
2.
3.
Watch, north
Kalani,
to south, north to south. And then
Yeah.
repelling over here because there's no
Nikolai,
north and
I'm
there's
tweaking,
north.
but tweaking.
Then there's north to south. Yeah. Right, 51D. A transformer is used to what?
Also the voltage, sir.
Yeah.
Yeah.
Alter the voltage.
Step up or
Yeah,
step up, step up or step down. Step up or step down, right? These are lie. These are lie. Both of them is a lie. If you want to convert alternating current to direct current, use a diode. If you want to convert direct current to alternating current, you use a alternator. It's an alternator. You'd have to use a bunch of transistors and whatnot. Alternating frequency. No, this is not a frequency generator.
No.
Right? Rectification
So
can
here's
be
the answer.
Diode.
Diode, yes.
I don't know.
Yep. Can't forget that.
4 times the mass of a proton. What's that,
Alpha
guys?
particle.
Alpha particle.
Alpha particle.
We've been knowing that, right? Because
Been
remember,
there,
this
done that.
is HE2. Cool, let me move on.
Renisha, you did that, Matt?
No.
Right,
Not doing that
55.
much.
J.J.
Chadwick.
Thompson discovered
Oh,
the
the
Chadwick.
proton,
electron.
the proton. Wait.
Oh, the
hold on.
proton. Wait, hold on.
Wait, and that is Rutherford?
Rutherford.
I don't forget. Let me ask Claude. I don't forget.
Yeah,
I
boy.
can't remember because this
Chadwick was
question,
your
how would it
neutron.
I know
do you?
Chadwick is the neutron, yeah.
1
Chadwick is
minute is
neutron.
actually the neutron, 1 minute is
Rutherford.
actually proton.
The answer is Rutherford. The answer is Rutherford.
Rutherford.
It's Rutherford. What kind of, you know what? Never mind.
That's an
Rutherford.
horrible name.
5 more questions. 5 more.
You're
5
still
more.
up here on.
Yes.
Right.
Oh, there are 5 more though.
So
Hey,
you're not serious.
So, so
So shame.
too
And
early
too
in the
early in
morning.
the
Right.
morning for
Right.
Feel
that
like they had a
nonsense.
cancer.
Light up sketches.
Atomic nuclei. Isotope looking for the same proton number.
thank you.
P and R.
No,
PNR.
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 Bye.
Right. Same amount of protons, different number of neutrons, right? So P and R. This was easy. 56C.
Shut it out like you again.
You see what no sleepless do to a man?
57. Which two elements could occupy adjacent positions in the periodic table?
What? Whoa. Chemistry
Q
students supposed to know
and
They
this.
have
Q and S.
the
Okay, let
mass
me see.
the mass
P and
number
Q.
will be
I like the line
Where,
P and
what are
Q.
they
P and
doing
Q.
to us?
I like the
the
line P
mass
and Q.
numbers will be
Thank
P
you.
and
juxtaposed.
Q.
So
P
it'll
and
be
Q. Like they're right next to each other.
yes, so it'll be
Yeah,
juxtaposed.
Okay.
literally.
Okay.
So the
Literally.
atomic number. Okay. Like you list the elements in the
It
periodic
increase in
table.
atomic mass.
Right, in atomic number, atomic mass, right? So, and the atomic mass, atomic number is just a proton. Just a proton. And the apple pencil just fly out. But the answer is P and Q, is P and
Q
Q.
will be right next to
It just
P.
fly out there, sir.
Yeah, boy, just fly out. It was like, that's
Hey.
Wait, sir, I answered the wrong thing in the wrong question, but the second one is correct.
you're special, Nikolai. Nikolai is specialist. I will tell you, he's special, he's special.
OMG. How disrespectful.
No, I don't get like that son.
Marie Curie.
Marie Curie.
That was son, that was son.
Curie Marie.
Big
Curie
MC.
Marie.
Big
Curry
MC.
Marie. Curry Marie.
I remember from Big Bang Theory.
I wonder if it have 108 people on YouTube.
Big up them.
Listen,
And don't forget to
Don't
subscribe.
forget to subscribe.
sir, that's the dedicated people there, you know.
That is.
For
The
real.
boost in the chat for these people. Right? Let me just get them a little boost of morale.
Sir, early part of this live here, them was saying the thing was dry, you know.
They were saying what?
The chat was dry.
Hey boy, but I see like live day. Let me finish this. X, lie. Random, yes. Due to changes in nuclei, yes. 2 and
2 and
3.
3.
The answer is 2 and 3. C. Next question.
Which are the following statements considering an alpha particle are true?
1 and
That
3.
is
1
wrong.
and 3.
1 and 3, 2 wrong. So if 2,
1 and 3, yeah.
no.
Wait,
2 and
wait,
3. Wait,
wait.
hold.
These are lie. These are lie. It actually has 4 times the mass of a proton.
Yeah,
Yeah.
there's
1
1
and
and
3.
3.
1
It
and
has
3.
1 and
twice the
3.
charge. That's true.
And the same
Because
time charging.
it's literally 4 2 each E, right? So it literally have 2 protons. So it'll be plus 2. And it has the same sign, yeah, both of them positive. So 1 and 3. But you okay with that?
And that
Yes,
there, my
sir.
friends, is the end.
Yes, sir.
Wait. Let me just cement this in absolute cinema. Wait.
Actually, guys, I sorry to breaking news to you, but
Why are you looking so pixelated?
But I say no.
Too much aura, sir. Too much aura.
What
Yes.
do you think that they say? And with that, the
With
two-
that,
With
season
that,
is
the
Yeah.
2014 paper comes to an end.
So what I'm saying is, right, this paper we do was actually 2015, you know.
yeah, we 2015 and 2015 won't mix up. But like, let me just say this earlier. We do 179 pages at work, dog.
Yeah, boy. Big up we.
It was so much. We
So you
read
gotta make a
papers.
tick
Can't
for
tell
that.
you.
focus.
We
10
out and
papers.
bad for them tomorrow.
Right. So let me make a little TikTok video now.
We made the TikTok.
Right.
So I would say that's the end of the episode for physics, people one.
I agree.
Oh, so sad.
So, hello, we're gonna do 179 pages of paper ones for CSEC physics. I'm gonna do the maths today. Like, let me just say one page are like 5 questions. That will be 5 by 179. We do like approximately 900. I feel like it's more, honestly. I feel like we do more than 900. I feel so. We do like 900 questions. Big up all the survivors. Let me wait. Mazakan. Gallery. Big them up. Big up Renisha, Henry. Big up
Finally,
Nikolai
somebody
McCord.
put a handle on my name. Amen.
Big up Eden, Sleepy Eden, big up Shania one time, big up Crazy Man Kelani, big up Marshall,
Marshall
boy,
Montano. Marshall Montano.
big up Lani, big up Joshua, big up Mia, big up Devani, big up Shanti, Kimaya,
Big up, big
like
up.
some more people, but
Sir, one thing to say. Like
what's
and
that?
subscribe, people. On TikTok,
Like
on
and
YouTube,
subscribe,
we
everybody.
good.
No.
Watch
If you
Kelani
like and
now. Watch him, watch him, watch him, watch,
hey, wait,
watch.
Olive, if you like and subscribe, you will be in the same mood Kelani is right now. So you should like and subscribe.
Yeah,
Kalani, I
we're
agree,
missing out.
boy. Boy.
We're missing out on a lot of information. The amount of work
Telling
we
you.
do already. And I miss out because I like and subscribe. Turn on them
You could have been thinking.
notifications. Share up the live. Oh yeah, doing them thing. Come on.
Make that subscribe button go ding a ling ling.
Ding a ding ling.
Sir, thank you for the dedication, sir, because I find like you're the only teacher that would have go this sex sensor. Like I swear when I see Aiden camera was on and he curtain was like in that color, I can I swear it was morning already, boy. I had to look at my window
Nah,
twice.
it's my garage lights. It's my garage lights. There's always been
This
on.
man cut his
Nah, but
motivational speech
nah,
to
but
talk about daybreak.
I do.
sir, on a serious note, I thanking you, sir. Like I
Oh,
have the
Yeah,
confidence now to
true.
go outside there to do that paper one. I hope I have enough energy to do so. But
you will. That exam is in the evening. That exam is in the evening, so
hey,
you
sir, I feel like I just get like 9 hours sleep or something like that. I don't even know. But sir,
And I
get
wanna
some
thank
sleep.
you.
It is good that you do it because the amount of work we just do right now, sir. I ain't gonna lie.
ridiculous.
Yeah.
Yeah.
Ridiculous.
And
That's
you
the
don't
Renisha
move on
ratio.
until everybody understands. So, yeah.
Mm-hmm.
That's the Renisha ratio. I don't know if she for you.
Yes, I want to say thank you, sir. From since the start of the journey for CSEC, you have been there to help me. And for that, I'm so grateful. Thank you very much.
Not a problem.
So you
My
see,
Sir,
time,
sir. The real dedicated people is me and Kalani, you know. Two people going to
I,
sleep already, you know.
Hey, why you don't hush your mouth? I
Hey,
I
still here.
dedicated, bro,
hey,
dog.
you went
I
and sleep.
dedicated.
You went and did
So,
that
Boy.
power sleep. I up
Listen,
still.
still,
I
the
never
power
sleep.
sleep
Right,
up might get the
right.
answers though.
Renisha
I
been
up.
sleeping, bro. Renisha been
Ah, we're
sleeping.
cheating.
Gosh,
We're
you too,
cheating.
Marshall. Why
Eh,
you
eh,
so girl?
you lie. You
Nikolai, you know we up.
lie.
We always up. One
All you're
maths
talking
vibes,
about sleep.
never
Watch,
two.
watch my light. It's bright
Ah,
here.
now we're all who? All of them
right? Like a
sleeping.
diamond.
Now we're
hey, but
all who
sir,
sleeping or you're
you know,
cheating.
the journey coming to an end with CSEC, we was able to get all we all we studying done. It would not have been possible without you, sir. So from the bottom of your heart, we're eternally grateful.
So don't
Sir,
cry,
and
don't
one more
cry.
thing, sir.
Don't cry
And
yet.
Sir,
I
one more.
wanna I wanna thank Sir for having the patience that he has with us and that he's genuinely willing. If we don't understand something, if he had explained it like 10 times, he would do it just to make sure we understand. And you don't find that type of patience in a lot of people, especially young people. So I wanna
Real talk,
thank Sir
real
for
talk.
that.
Sir,
Real
and one
talk.
more thing.
Big up.
Sir,
This
I
is
have
not the
something
end
to
of
say.
us, sir. This is
Especially
not
for
the
free
end.
to well, it's free.
Sir, you go expect we in some of them lives, you could come and support you and everything. This is not the
Yeah,
end.
sure. Yeah, sure.
Like this is not the final season. This is just the beginning, sir.
It's
Sir,
the
I have
beginning
something
of
to
a
say,
new
sir.
chapter.
I have something to say. I have something to
Yes,
say.
sir.
All right, listen to me. I took my power nap before the class start, and I come in. It's at the end, almost to the end. I started to crash out. Okay, Nikolai. So mind your manners. Okay, I was here. I was here. At least I never leave the meeting or I never get kicked out. Hinting at you,
It's
Aidan.
the
I don't know
side
what you
Whoa,
accent,
do.
Nikolai,
whoa. Who
bye.
got kicked out? I remember what happened.
But
Chill.
anyway, besides that, I was
Manisha,
here. Okay,
Manisha,
case and
what was
point.
some of them questions we just do? Hey, what?
Boy,
Sir,
boy,
sir,
I
sir,
was
sir,
asleep.
sir,
Leave me
sir,
alone.
But if,
Leave me alone.
sir,
Leave
for
I,
me
my
alone.
proof.
but if I love my children, they gonna mash up that exam tomorrow, boy. Peace and love. Best of luck in the exam tomorrow. People on TikTok,
Yes,
YouTube,
sir.
whatever. But yeah, guys.
Yes, sir,
Hey,
you
hey,
need your sleep, boy.
Yes, sir.
Ollie,
Get some sleep.
I wake up. I'm not even joking. I hibernate today, boy. I wake up 3 o'clock.
Say what?
Yeah. I wake up 3 o'clock today. So
This
I read
morning?
it today, this evening. I wake up 3 o'clock this
Yeah,
evening.
that was the had tell us he had gotten up around 3 and he went to eat.
I thought you mean in the morning.
I thought he was talking about morning too. I was like, you hibernate at 3
Yeah.
o'clock.
No, he
I
literally
hibernate
say
at 3 in the morning.
he was like, guys,
Exactly.
I'll let you know when class start. I was hibernating whole day. I get up like 3 and I go and eat something.
Oh, right, yeah. Hey, I was
At
still
least
in school.
somebody
I
just pay
didn't see that
attention.
message.
Somebody just pay
So
attention.
I
at least
didn't
I
reach
have
home
good
yet.
memory.
I didn't reach home yet, but I saw the message.
So you know last year, right? So last year I did CSEC add maths and thing, right? So I was like my teacher literally, he abandoned us like with almost half the syllabus to complete and was like, I don't know how well you're going to complete this. You're gonna have to figure it out for yourselves. And I literally left the school. So we literally had no contact with this guy. So and I've been lying to tell you. Like probably the night before AdMat, that was the first time I came on your Zoom, and that just changed everything. So pop off in maths and AdMat with distinctions, and I know the code. But just want to say thanks.
No problem. Don't mention it, guys.
So look how much lives you changed now, sir. Look how much lives. And
Yes,
so much more
sir.
you could do.
From last year to this year, you outdone yourself. And you
From
should be
since
proud.
Christmas lives.
Yeah.
I wasn't there.
Yeah. I was there. That was
Nikolai
absolute cinema.
All I know is Nikolai was here since the inception of this thing. Boy. Nikolai was here for a while. Boy.
I watched the videos since last year with like his original AdMaths class.
That's true.
Yeah. But I really appreciate you guys. Sometimes I just feel like I'm not really making that much of an impact. Like I go leave my house and I feel like I didn't really do much.
Now, sir, it does. Don't tell yourself that it does.
Yes, sir, it does. What
So
you're
I will
telling
say it
yourself.
again, sir.
Cutie tears,
I-
cutie tears, cutie
Sir,
tears.
I'll say it again, sir. I found out about you on off of a whim. I wasn't
whim?
even honestly. It was during April, right?
Hmm.
For the crash course. I didn't even know about you.
Yeah.
And then when I started to do these classes and thing, big help, huge help, amazing. He used to go so in depth with every single detail of every lesson and really open my mind to maths, even to physics and all. And so I would like to thank you for that. Also, you gained you gained a reoccurring character, is in order for Eden.
But I'm happy
Yeah.
to hear. I'm happy to hear that.
Well, you know how I met you to help me with physics and maths is through my best friend, right?
What's your best friend?
Arcadia Patrick. I don't know if you remember her.
Yeah, I remember Patrick.
Yes, it's through her. She showed me your lives, and from there, the constant watching and asking for help to understand. Yeah, I feel good this time.
Two things, sir. One, you impact so many lives. I even recommend Form 4s and Form 3s who coming up to Form 4s to go to your Mac Vibe, sir. Like,
Well,
Real.
as
I
soon
was
as they say maths, I say go Math Vibes. That is all.
Yeah, I
I
go
mean,
recommend my sister.
I appreciate. I want to be tell you right. Like this whole season, I didn't make a single dollar. I gotta be honest. Like this whole exam season, I didn't make a single cent. But from the other than the crash course or something, but like I just hoping when I advertise my classes or something, I'll get a little students or something. Yeah,
Sir,
boy.
expect a lot, sir. Expect a lot. We gonna advertise for you, sir. Don't worry yourself. I say,
Yeah,
sir, like I say, this is just the beginning, sir. This is not the end,
I hope so.
Trust
Right?
it. Trust
I want my
it.
classes to be filled up. Yeah, boy. I manifest on that.
Yes, sir. You go have so much that you had to open the real school academy.
Right,
Bet on
So
that.
this is why it's important for you to get your merch. This is why
Yeah,
it's
boy.
important. Like
So why
official
can't you trust your
uniform.
family though? Why can't you trust your family though?
This is so only live. This is only live. I can't speak about these things only live.
Too personal, but too personal.
Yeah.
Too personal, boy. What can I take you doing the man, boy? What do you,
No,
boy?
But sir, normal.
It's no family
Everybody
in
have the thing.
business, bro. I no family in
Correct is
business.
right. It have no family in business. Just like how there's
Now,
no
so
I in
everybody had a
team.
thing. Yeah. It's cool.
But I really appreciate you guys though. Thank you for supporting me. I definitely would not make it this far without you guys. And I'm glad I could have such an impact. I genuinely
Of
am.
course.
Grateful that I
Sir,
could have such an
thank
impact.
you. We thanking you. Well, we say thank you.
It's
Thank
like
you.
commensalism, guys. It's like commensalism.
You
You
the
know what I
real
mean?
goat.
Oh, yeah, we benefiting.
It's given biology.
It's giving
Like
biology, period.
I feeling like I might do a physics if I want live, you know. I joking. No. I'll stick in my lane. I'll stay in my lane. Wait, let me show you how much work we do. All together, this is how much work we do.
Whoa.
Damn. Wait,
Whoa.
196
196.
pages.
That's crazy, dude. Oh
Crazy.
my god.
But it's worth it. It will be worth it.
Now I can listen to the Drake album and sleep.
That's crazy, guys. That's ridiculous. Wow. I can believe that.
Look at how much work we push.
So shout out to your barber. They bad looking cripsy.
Yeah,
Link me to that barber now.
So, is it wrong to be feeling to do admats next year? I'm okay feeling to do admats, you know.
You relax yourself. You relax yourself. Renisha, you relax yourself. Whoa.
So why she can't do admats,
Just
sir?
kidding,
So we don't know.
just kidding.
We don't
I
know
could
what
have
I
if I
see
wanted
here,
to, but
Anisha.
Oh, let's see. This look like Nikolai, Loki.
So what? So
Sure,
what?
like I said,
I look at this for a second and I could have swear that was Nikolai. It was
It's
funny.
sleep. It's sleep.
Hey,
Yeah,
this
boy.
document gonna take you through all the questions in the dog.
Real.
Wheel.
So I wouldn't want to waste any more of your time. So go and
Yeah,
get the rest.
I gotta head to bed.
Good
I give
luck.
everybody
Good
a
luck,
hug. Take a
everybody.
hug, guys. Take a hug, guys. Take a hug.
Oh, that's so
Group
Come on.
hug, group
sweet.
hug.
Yeah, boy.
So don't
Yeah,
make people cry,
boy.
now, man.
Yes.
Thank
Yeah,
you so much, sir.
everybody, good luck in our
They're
exam.
gonna get
All the
60 out of
best.
60. 60 out of 60.
60
We
out
do
of
all the
60.
questions that could have come. Every single question that could have come. Right? 60 out of 60. Take care,
So
guys.
you really believe in me like that? Oh my God,
Yes.
that's okay.
Just make sure I get another. I just can't make sure I get another sleep, right? Because like I don't know what sleep doing for you.
You
But that's doing real good things for you, girl.
Yeah, man, God
I want
working in my
sleep like that. I
favor.
want sleep that gonna make me feel to study astrology tomorrow. Come on, guys. Let's go.
Take care, guys. We will
Yeah,
talk
we'll
about it
definitely.
after the exam.
Yes, sir.
So
Good talk.
bye.
Yes,